Hello everyone and greetings on the occasion of the National Science Day. It is my pleasure to welcome all of you to all the events that we have planned around National Science Day today. All these events have been put together by the Science Activities Center at IISER Pune, and they have worked hard for the last one and a half months to put together all these events, and it's for you to enjoy all these events today. Before I say anything about some of the events that you're going to watch, I'll not take much time, but maybe I'll just say a few things about the Science Activities Center itself. The Science Activities Center, or as we call SAC right here inside our campus at IISER Pune, was actually started about 5 years back. It's one of the unique sort of institutions in the country, in the sense that here is a place where you learn about science. Science is disseminated, not through the usual medium of theories and like writing mathematics on blackboards and so on, but actually through activities. Everything here is an activity. Whatever complex theory that you can think of, or whatever complex or very difficult concept that you might encounter in your science books, or even in newspapers, or in any such literature, you will most probably find a simple science toy that will explain it in a very simple way. In fact, these toys are the sort of things for which you won't need very expensive gadgets. All you need is, you will actually find the raw material for this right probably inside your home, or maybe at best in the shops around your home. All you need to do is to fire up your imagination, and to start off, just visit the Science Activity Center here. And we are hoping that now that the pandemic is hopefully receding, we'll be able to welcome all of you to visit physically here, see the kind of toys and gadgets here which exemplify a whole lot of science theories, and you can repeat it yourself. You don't need our help as well. And in fact, once your imagination is fired up, you can go beyond what is done here at the Science Activities Center. And we'll welcome any new ideas that you will have. We'll be happy to adopt them and show it to the rest of the world. In fact, we've hosted almost close to 75,000 visitors since the center itself was started. And unfortunately, in the last 2 years, there had been the pandemic, but the activities of the center did not stop. We just went online, and we totally received almost as much as 35 lakh visitors in this time. It's been teachers, students, and even ordinary citizens who are just curious. You don't need science background. You don't need to have any such experience with science. All you need is interest and just some curiosity. And the events planned today, the kind of things that you're going to see, are also very similar. For instance, I'm sure all of you know that the National Science Day itself is celebrated on this particular day, 28th of February, to commemorate the discovery of Raman Effect by C.V. Raman. The first of the programs that you're going to see is about the life history of C.V. Raman by Dr. Pawan Kumar, who is a faculty at IISER Pune. And many of these events are put together by faculty of science, faculty at IISER Pune, along with the Science Activities Center team. And then there are whole lots of hands-on activities in mathematics and science. You must have heard about fossils. There is a talk about fossils. Even if you don't know what it is, here is a chance for you to know about it. And you must have more recently heard about this James Webb Space Telescope, an IR specialized telescope which is going to benefit astronomy and cosmology. And you're going to get a very specialist's talk who is going to explain in very simple terms what the James Webb Space Telescope is about. It's not just science, it is also one of the greatest engineering marvels. You will learn about it from my colleague Ramana Athreya. There is a talk on paleoclimate, and there's a talk about data science, something that you keep hearing all the time these days. You see products built around data science, artificial intelligence. A whole lot of things are today based on data science and artificial intelligence. Again, here is a chance to get to know what it is from my colleague Amit Apte. There's a talk on DNA sequencing, talk on probability. Often for many students, probability is sort of a nightmare. again, if you listen to it, once you understand and get the hang of it, you will realize that you don't really have to sweat it out to understand probability. And then there is a talk on millets, an important component of food which nowadays we often miss out, but this is something that you should hear as to why we should take this route. There is a talk on Large Hadron Collider, one of the, again, both an engineering marvel and one of the biggest scientific experiments that's still running today. And to top it all, we have something called Toyfest 2022. So you're going to see a showcase of science toys. And finally, this is for everyone's participation. There is a science quiz. I invite all of you to participate in it. More than that, there are prizes to be won. And so there is, the prize itself is a mystery. I'm not going to reveal it. I think you should wait and see it. Clearly, there is a great lineup of events for the day. It's my pleasure to invite you to see all these events. But more importantly, we are soon hoping that we will be able to open our gates for you to visit. And when that opportunity comes, I invite all of you to visit IISER Pune and the Science Activities Center at the IISER Pune. And hopefully next year when National Science Day comes, you can actually be here right in the campus to enjoy all the goodies. Thank you and welcome. It is one of those unexpected and happy coincidences that on the occasion of Science Day, there is also the happy news that one of our colleagues at IISER Pune, Professor Deepak Dhar, has been awarded the Boltzmann Medal. It's one of the coveted medals given to scientists who have contributed quite a lot in terms of fundamental understanding of physics, in particular statistical physics. And it's given out once in 3 years by the International Union of Pure and Applied Physics. This year, Professor Deepak Dhar has got the award, and the people who got this earlier include many Nobel laureates as well. And it's also a special honor that this is the first time an Indian is getting this award. We are very happy that he has agreed to give an interview on this occasion.
From the Science Media Center, we are very happy to conduct an interview of Professor Deepak Dhar. Professor Srijit GJ from Physics Department has carried out the interview. You can see a small teaser of it right now, and for the full video, please see the link below or go to the YouTube channel of Science Media Center.
In one of your papers, I noticed this idea of Pico canonical ensemble. What is that?
Okay, so actually the idea was not very new. The idea has been around for a very long time. But the name Pico canonical we did invent. A Pico canonical ensemble is smaller than a micro canonical ensemble. That is the reason for the name. Well, I think it's a good name, but it is not very popular.
How about the teaching aspect?
The teaching I like. I mean, I think I'm able to adjust, but with a little bit of effort. I think my very interesting part was that all the faculty here was much younger than me, at least 25 years younger, maybe more. And so when I came here, I would go in for a morning walk, and one of the people caught me and said, "Whose daddy are you?" Because they didn't think that I would be a faculty member, but I would be the father of a faculty member. As an engineer or as an experimental physicist, you will realize that there is no perfect circle anywhere in the universe. Okay, if you draw it by pencil, then it has some thickness and some jitter, and if you can draw a finer pencil, it will still have always some thickness and some jitter. So there is nothing called a perfect circle. So what is the validity of the theorem? So Galileo in his book said that the nature's book is written in mathematical symbols. But there are no circles and triangles, they are constructs. They are constructs made by people. If we accept the fact that this idea of being able to generalize to the notion of a perfect circle is made by humans, then one says that we have peeked into the book of nature and it is full of our own scribblings. Okay, it is not written by God, it is written by us. The patterns we see are the patterns we can recognize, which we are making up ourselves in some sense, because we invent the notion of a perfect circle and then we can describe the notion of planets in terms of perfect circles.
Hello everyone. Today we are going to discuss about one of the greatest scientists India has ever produced, that is C.V. Raman. This talk is going to give an overview of the life and times of C.V. Raman in the form of a brief history and talk a little bit more about the way he did science and also the interesting aspects of his life. 28th February every year in India we celebrate National Science Day. This we do in order to commemorate the discovery of the Raman Effect. An important observation confirming Raman Effect was done on 28 February 1928 by Raman and his students, and this has had a very important implication in physics and various different disciplines of science. Chandrasekhar Venkat Raman, short form C.V. Raman, went on to win the Nobel Prize in Physics in 1930 for the discovery of the Raman Effect. For this particular talk, I have used three sources, essentially three books. One is the pictorial biography on Raman. The other one is a fantastic biography on Raman written by G. Venkat Raman. It's called Journey into Light. And also a popular science book written by the same author, G. Venkat Raman, which is called as the Raman and His Effect. So if you are interested, I would urge you to have a look at these books. They are really excellent references. The pictorial biography has many authors, but mainly driven by Professor Ramaseshan, and it has some very interesting discussion not only about life and science of Raman, but also some research papers written by C.V. Raman. Now, for this talk, we actually can look at C.V. Raman's life as 5 time periods. The first is the childhood, education and undergraduate research, dates back from 1888 to 1907. The second period is when C.V. Raman actually becomes an administrator in the Indian Financial Service and also a part-time scientist at the Indian Association of Cultivation of Science, which is IISER, which was then called Calcutta, but now it's called as Kolkata, as you probably would be aware. The third period is Raman becomes a Polit professor, a very reputed position in Calcutta University, and also continues to do his research at IISER. And this period between 1917 to 1933 is the main time when the great discovery happens, which I am going to talk a little bit more about. The fourth period is about initially as a director and then as a professor at Indian Institute of Science, Bangalore, where he also did some very fantastic work and really built some very important networks within the international science community. And the last period is the foundation of the Raman Research Institute, where he spent the last 20-22 years of his life in building and also nurturing science in that particular institute. So, I am going to go one by one across these 5 time periods. The first one is the childhood, education and the undergraduate research. Raman was born on 7th November 1888, a village near Tiruchinappalli in southern part of India. His parents, as you can see, they are the ones who actually were also very encouraging, who gave him a lot of push towards exploring what is interesting in science. His father, R. Chandrasekhar Iyer, was also as a teacher, and he encouraged him with a lot of interesting books. And his mother, Parvati Ammal, very ably supported Raman's interest in science and various different activities related to this. In 1903, Raman joins Presidency College in Madras, which is now current day Chennai, and he obtains a BA degree with a gold medal in physics and English with flying colors, and he's rated as one of the top students in that particular college, has been already doing research. And interestingly, as early as 1906, Raman publishes his first research paper, and that particular research paper happens to be on oblique illumination of light onto a particular slit and the diffraction pattern one can obtain from that slit. It's a very neat piece of work, and it actually has some very interesting implications, and these are the questions Raman was basically interested. So you can see his very first research paper was on an optics topic, which actually continued until his death, and it is a very fascinating aspect of his work. Next, he obtained his Master in Arts in Physics in 1907, where he again did very well. Interestingly, his teachers actually were telling him to go abroad to England especially and perform research there, and fortunately or unfortunately, Raman did not qualify the health checkup which was necessary for him to actually go abroad, and therefore the plans to go abroad to do further higher studies and research did not actually realize. So therefore he decided to stay back in India. At that particular point of time, a reputed career was to take up a government job. So what Raman did was write a specific examination, and simultaneously also he got married. In fact, in those times you could see that people got married, especially in India, in their late teens, and Raman was no exception, and he married Lokasundari Ammal on 6th May 1907. And in the same year, he also cracked the financial service examination, which is essentially a civil service examination, and he stood first in that particular examination, and everything was a cakewalk because he was too brilliant for that particular position. But mind you, at that particular point of time, this was a very lucrative job. At that instance, the government of British India was giving a salary of as high as 1400 rupees. Okay, we are talking about 1907, and that is actually an extremely large amount of money, which also included perks and other kind of support, including a marriage allowance. So there is a joke by wife of Raman, who was also later called as Lady Raman, who used to tell that Raman married because he could actually get that extra perks. Nevertheless, Raman actually got into this financial civil service, and being a married man, now this is how he looked like, and he was all set to become an accountant general, an assistant accountant general who will be working in Kolkata. Now the second phase of Raman's life starts, where he moves to Kolkata in June 1907, where he actually joins this financial civil service. And in the same year, it happens so that during the commute to his work, he always used to see a board on his way, which was written as Indian Association for Cultivation of Science, which has the IISER, and he visits that particular location for the first time, and he meets Amrita Sarkar, who was the son of Mahendralal Sarkar, who established IISER, and he expresses his interest in performing research outside the time of his normal work, and Amritlal Sarkar and various different people are pleasantly astonished to see that somebody has such a keen interest in pursuing science. So they right away agree to allow him to do research in the off hours, and Raman did actually have two jobs in that way. One was the Indian Financial Service job, and in his other times he used to actually do research. So that is the commitment of Raman. As he progressed in that particular place, as early as within 8 years or so, the University of Calcutta started assigning scholars to Raman so that they can actually register themselves for PhD. And remember, Raman did not have any PhD. Okay, he actually was a master's in physics, but his knowledge and his drive and the amount of research he did, even handling the financial service work and also doing research, he ended up publishing some very interesting work. In this particular time period, he wrote a lot of interesting papers on acoustics, especially on Indian musical instruments and acoustics of Indian musical instruments. There is a fascinating amount of research what he has done, and a very interesting topic which Raman had kept very keen interest on. Now, important things happened roughly around 1915-16, where Ashutosh Mukherjee, who was also one of the kind of founders behind the IISER, who was then also the High Court Judge of Calcutta, and he also became the Vice Chancellor of Calcutta University. So, Ashutosh Mukherjee always kept a keen eye on C.V. Raman, and he always thought that this particular person has huge amount of enthusiasm and interest in doing research. So, he immediately asked him to join Raja Bazar Science College, which is part of the University of Calcutta, so that he gets an association with the university and simultaneously do research in IISER. And 1917 was also an important year because University of Calcutta actually offered Palit professorship to Raman, so that he actually could pursue research full time. Now, interesting thing is this was a tenured position where he could actually stay back up to 60 years of his life, of his age, and importantly, if he had to take that particular position, he had to also leave the financial service. And as I told, financial services then was very lucrative job, and he had to take a huge pay cut where his salary was as less as 600 rupees or something as a Palit professor, which was less than half of what he was earning. And nevertheless, Raman took the job. He quit the financial service for good and became a full-time researcher, which is kind of a remarkable story by itself. Now, in the same year, Raman also conceptualized the establishment of Calcutta Physical Society, where he established a kind of association of various different physicists to pursue science and discuss various different topics. Now, the next phase, 1917 to 1963, where Raman now becomes a Palit professor and teaches at Calcutta University and does research at IISER, and he does both very efficiently. And in 1919, Amritlal Sarkar, who offered the job at IISER, unfortunately dies, and Raman becomes the honorary professor and secretary of IISER. So, he essentially takes over the IISER in terms of the functioning there. And he starts the very important chapter of his research life, where he starts exploring various different aspects of light scattering. Mainly, he has been motivated now by reading some of the great papers written by Rayleigh, Lord Rayleigh. And also, I should mention that Raman was deeply influenced by the German researcher Helmholtz. So, he actually really had great admiration towards these classical physicists, and he had a very strong foundation in classical physics, and you will see that that foundation not only helped him to connect the classical mechanics to quantum mechanics, but also made him a very good researcher. Now, at the same time, around 1921, Raman, remember, did not have a PhD, but University of Calcutta offered him an honorary DSc degree. This was again arranged by Sir Ashutosh Mukherjee, whom I just mentioned earlier, and it was very important because then it gave him a specific kind of a stature, and further it also helped him to embark upon a very important journey abroad, and this was for the first time he was going abroad in his life. And he visited England, where he studied some of the aspects of Rayleigh Whispering Gallery modes at St. Paul Cathedral, and he also visited various different researchers. The most important event which happens is on the ship called SS Narakunda, where he is now traveling back from England to India, and he has to spend a lot of time on the deck of the sea. And a particular question always is in his mind, and that question is, why is the sea blue? Okay, the question is very simple. This question is also kind of connected and motivated to the why is the sky blue, because Rayleigh had already answered this very interesting question, and with the phenomenal success, because he was able to actually explain the blue of the sky, whereas Rayleigh actually had just extrapolated, telling that the same principles may also hold good in water, and therefore the sea is also blue just because of the reflection of water. Raman kind of did not agree on this particular aspect. So, therefore, he still wanted to explore this question in greater detail, and he started actually slowly thinking about the problem. And by the time he actually reached India, he already had written a paper on the ship. Okay, he sent this particular paper to Nature and the Color of the Sea, which actually is a very famous paper of C.V. Raman, where he hypothesizes that the kind of scattering which happens due to the molecules in the air can also lead to some very interesting consequences due to the scattering of light from molecules in water, which leads to some interesting colors and other aspects of it. Now, the aspect which is further interesting in this particular time is that he culminates all the knowledge he has gained thinking about this question in an extremely famous essay titled Molecular Diffraction of Light. In fact, if you look at it very closely, this will also be the title of his Nobel Prize winning lecture later on. But this essay really kind of gave a very nice overview of the kind of problems Raman was interested in, and it laid a very good foundation for his students also to explore the phenomena in great detail. Now, in order to understand the interaction of light with the molecules in a liquid, his students also started looking at various different processes of interaction of light with molecules, of which one of the consistent observations from his student was something called as feeble fluorescence. Now, interesting aspect of feeble fluorescence is that unlike the conventional fluorescence, the feeble fluorescence was polarized in nature. So, according to the conventional classical mechanic theory, the light which was scattered, and if it were to be fluorescent in nature, should not be polarized. Whereas, Krishnan and other students of Raman performed an exhaustive amount of experiments, as much as 50 to 60 liquids, and they consistently observed that no matter how pure the liquid you are interrogating, they always showed this feeble fluorescence, and they also showed polarization, which actually was kind of a signature indicating that the process what they were looking at was not a conventional fluorescence process. During the same time, around 1925, Kramer and Heisenberg published one of the very important theoretical paper on the scattering of light by atoms, where they also referred to the work done by Smeckel, where Kramer and Heisenberg actually had mentioned that there can be another kind of scattering which can happen because of some interesting exchange of energy between light and atoms. And mind you, this is still pre-quantum mechanics era, so the quantum mechanical arguments were still kind of coming into the forefront, and this was one of the hypotheses which was laid by Kramer and Heisenberg with excellent references to Smeckel. And you will see that this is going to become an important reference going further. So, this gave a direction telling that the feeble fluorescence what Raman and his students were looking at was not something conventional fluorescence, but had some kind of quantum nature to that particular interaction. So, therefore, in one shot, Raman and his students actually took a catapult kind of from classical observations right to the heart of the quantum mechanics. And within a couple of years, 1927, Compton received a Nobel Prize for studying the scattering of X-rays from electrons, free electrons, which actually showed inelastic scattering of X-rays, and already laid a very important foundation, which forms actually kind of a basis for Raman to take the leap of faith in proposing the quantum mechanical interaction between light and matter. So, Dirac's QED is also in the air, 1928. So, there is also now the foundation for this particular argument is becoming stronger and stronger, and still Raman and his students are observing this feeble fluorescence. Now, this is the year 1928 is the time where the tremendous discovery happens. What I am going to now show you is the extract from the diary of K.S. Krishnan, where Krishnan actually talks about what happened during those days where this particular excitement was happening. So, here he actually mentions that the fluorescence could explain even the outstanding facts, because there is no theory of fluorescence which could explain everything what they were observing. And he also mentions that Other particular molecules have been studied, and one of the important consequences is that the light which has been scattered is strongly polarized, as you can see it is written here. Now, here is where the connection is made. On February 7th, Tuesday 1928, Raman actually kind of comes back to the hostel where Krishnan and another student Venkateshwaran after the meals, and they are actually chatting in their rooms about 9 o'clock in the at night, and Raman comes to the hostel and and knocks on the doors of Krishnan and Venkateshwaran and asks them to come down for a discussion. And when they went down, Raman is very excited, and he keeps telling that that what they are essentially observing is the Kramers-Heisenberg effect, which I just told you in the couple of slides ago. And what he calls this as the effect as a modified scattering effect and not a conventional fluorescence. So, this is the first time where the modified scattering actually is put forth, and this is a very important step in going further. So, with this a kind of hypothesis and understanding, all his students and Raman further explore, and this is the most important event. On February 28 Tuesday, Krishnan writes that went to the association only in the afternoon. Professor was there, and we proceeded to examine the influence of the incident wavelength on phenomena. Use the usual blue violet filter coupled with uranium glass. That is the kind of filters they were using. The range of wavelengths transmitted, which is essentially the scattered light, by combinations of these transmitted filters alone. On examining the track with different vision spectroscope, which is the instrument they were using to visualize this scattered light, and they found to their great surprise that the modified scattering was separated from the scattering correspond to the incident light to a dark region, which means that they actually were seeing this as a very, very clear scattering signature, which was an inelastic scattering process. This particular event is now considered as the day of the discovery of Raman scattering, and this is the reason why India celebrates the Science Day, because this important discovery was made on February 28th, Tuesday, and 1928, and this is a kind of remarkable day, and therefore we do commemorate this as an important day in the history of Indian science. And Raman was enthusiastic. You could see this very beautiful picture of Raman with his spectrometer, and this instrument is still preserved till date at IISER Kolkata, and towards the right side you will also see the first ever Raman spectra photographed using that kind of an instrument. And this is the famous Nature paper which forms the basis on which even the Nobel Prize is awarded, and you can see that they are also making a comparison with the Compton effect, and also call this particular new radiation as a modified scattering from the case of ordinary light. Two types of scattering also occurs, and they distinguish this particular scattering, and you can clearly see Raman and Krishnan are the authors of this paper, and the address is in the famous Bow Bazaar Street at Kolkata. Now, this is one of the earliest spectra recorded by Raman and his students, the Raman spectra of carbon tetrachloride, and it is a beautiful spectroscopic signature of that particular thing. And later on between 1917 to 1933, furthermore, he continued to do this effect. So, discovery happened on 1928. Raman actually was extremely well networked. So, immediately he called a press conference with the Associate Press of India, released the news, and they published that particular news right away on the next day, because this was confirming, and mind you, he has already sent the paper in early February. So, he was doing all the things in the right direction. And 1928 16th March he gave a detailed lecture in Bangalore to the South India Science Association, where he gave all the evidence for this particular effect. Here he gave, and this particular lecture was also published in the Indian Journal of Physics. And 31st March, as I mentioned, the Nature article appears, which actually establishes this effect with significant kind of effect. The whole world actually takes notice of this particular important discovery. 1928, I should mention, in the July issue, two Russians, Landsberg and Medelstam, also report independently the Raman scattering effect. Okay, but they actually observed this in a solid state. Nevertheless, they also were in contention for the Nobel Prize, but for some specific reason they did not actually end up getting the Nobel Prize. So, Raman actually got the complete credit of this particular discovery, but there was also some French researchers who also were working on that particular area, and they also had observed similar effect. And within a few months, various different researchers could repeat Raman's experiment, and it was confirmed. So, 1929, Peter Prigeschm in Germany coined the term Raman effect and lined as Raman effects. This is the first time when Raman effect was explicitly mentioned in the literature with the coinage terms, with the terms coined to that particular effect. And 1929, Rutherford, who was one of the most influential physicists in the world then, made a reference in his presidential address of Royal Society to the effect what Raman had observed, and within a year Raman got the Nobel Prize in physics. Raman actually was anticipating. He had booked his tickets to his Stockholm much earlier to the date of the announcement. So much was his confidence that he wanted to actually emulate that and then go there. And in the same year he also was knighted. And interesting event happens after the Nobel Prize around 1932 and 33. Raman falls out of a goodwill of various different people in Kolkata. He actually has a lot of differences of opinion with the people, and unfortunately he gets sacked from IISER from the honorary secretary position. So he is very disappointed now, and simultaneously there will be an announcement for the directorship of Indian Institute of Science in Bangalore, and when people are scouting for a new director in British India, Rutherford actually gets to know about this, and Rutherford tells why should you have somebody else other than Raman himself, who is already available there. So they offer the position, Raman takes it, and Raman becomes the fourth director of Indian Institute of Science. And these are some of the photographs of the Nobel Prize ceremony. You can see to the left Raman is receiving the Nobel Prize from the King of Sweden, and Lokasundari Ammal, the wife of Raman, and Raman actually are in the photograph, and there is also a photograph of Lady Raman also interacting with dignitaries in the banquet ceremony. So, 1933 to 1948, Raman stays as a professor at Indian Institute of Science. Here he becomes the director at IISc. He is the fourth director and the first Indian to become a director of IISc. And Max Born, the famous Max Born, visits IISc between October to March 1934. There is a long story, very interesting interaction between Raman and Max Born, and there is also very interesting argument on crystal dynamics, which Max Born and Raman had different opinions on that particular theory, where Max Born's theory ended as the winner because that turned out to be accurate compared to the Raman. So, Indian Academy of Science was established in 1934 during the period of Raman. Raman took the initiative for that, but unfortunately again because of various different controversies, Raman had to resign as the director of IISc, but he still kept the position of a professor in that same place. And Homi Bhabha came to India around 1939, and there are very interesting interactions between Bhabha and also IISc and other particular dignitaries. Now, Raman was not only a very enthusiastic researcher. In order to raise funds, he also actually established industries. So, Travancore Chemical and Manufacturing Industry, which he helped establish with one of his students, P. Krishnamurthy, and he actually did raise some money for some specific research funds and things like that. He also became in 1947 first national professor by the government of India, and this is a time period where he also was studying the crystal dynamics, which is a very interesting area, and he had some very interesting ideas. And with Max Born also he had a very long argument regarding this, and it is part of history in physics. Now, 1948 he retires from IISc, he completes his position, And then these are some of the interesting photographs. You can see he's spending time and having nice kind of laughter with greats like Heisenberg, and also he here towards the right side he is talking to Dirac. Heisenberg, Dirac, all these people played a very important role in establishing a Raman effect on a very strong footing, because their theories actually helped them for Raman to go ahead and hypothesize further all the effects what he was observing. He is also now photographed with Wolfgang Pauli and Yukawa, and these are all photographs probably taken at Lindau meeting, which is the meeting of the Nobel laureates, and there are some very fascinating photographs. Here you will also see he is photographed with Max Born, and also Mirza Ismail is also towards his right, and the other photo what you see towards the right side is the Millikan and Raman in the same photograph. Millikan, as you probably would be knowing from oil drop experiment, was also a very famous physicist. Raman actually would have visited Millikan in Caltech in 1920s, and Millikan actually kind of comes back to Bangalore and he makes a visit to Raman then. So, the last phase of Raman is in the Raman Research Institute. In 1948, Raman lays the foundation for the Raman Research Institute. He also gets the Bharata Ratna in 1954 along with Rajagopalachari and Sarvapalli Radhakrishnan. And in 1960s, he works extensively on color of flowers, human vision. He was a person who was mainly driven by aesthetics and connecting those aesthetics to physical phenomena, and he does some very fascinating work. Even when he was at IISc, he does some very interesting work on Raman-Nath effect and other things, but I have not kind of talked on that in detail. So, Raman actually was a very keen experimentalist. He also was very enthusiastic in showing his work to others. He always encouraged questions and had very nice interactions. And he also was an excellent lecturer and a narrator and a speaker. And here towards the left you are seeing him giving a talk on crystal dynamics. You can probably see the dispersion relationship also drawn on the board, and towards the right side he is giving a talk. The most important thing about Raman is that he enjoyed interacting with children. He was a very big hit with small children. In fact, he was an excellent communicator of science. He really, it seems, enjoyed extensively interacting with children, really aroused their interest. There are so many of the people from that generation of children whom you see here have told that they got really inspired to do science because of the interaction with Raman. So, this is something which is very good and very important as part of being a scientist. Finally, 1970s, he is already about 82. Unfortunately, he had a cardiac arrest in his lab and he falls ill. He recovers a little bit, but on 21st of November 1970, unfortunately, C.V. Raman passes away peacefully without any specific element, but he kind of a person who has created history and suddenly one day he is no more. So, that was actually a big loss for the Indian research community. This is the last photograph of Raman taken, probably on the day of October 2nd, Gandhi Jayanti in 1970, if I am correct. So, what I have now talked about is just a brief history of a great man who dedicated his life to science, and his journey through this whole era from being an undergraduate very interested in science all the way to making an important discovery and eventually winning a Nobel Prize, and also establishing center of excellences at a few places. Raman left his footprint at every place wherever he actually walked. He also made a very important contribution to science, and I will end with the words of C.V. Raman: what India needs is science and more science. Thank you.
and I'm a science communicator at IISER Pune. During my integrated masters, I studied and explored fossils for a semester, summer, and my 5th year thesis project. And I studied its intersection with biology, which is called paleobiology. But what intrigued me the most were these simple questions like, what is the likelihood of finding a fossil at the place that I'm standing right now? To dig deeper into such curiosities, let's talk to an expert in paleobiology. Hi Devapriya, thank you for joining us today.
Hi.
So, do we randomly look for fossils in rock sections? If not, what is the method to go about it?
Well, the answer to that would be pretty low if you just randomly go to a place and try to look for fossils. Fossils are remnants of ancient organisms and they do not get preserved everywhere and anywhere. Specifically, we are finding them in rocks that have formed in relatively low temperature and pressure. We call them sedimentary rocks. So you can only expect to find fossils in sedimentary rocks in general. So the first challenge is to go to places where there are good sedimentary rocks. Not all the sedimentary rocks are going to give you fossils, but other kinds of rocks such as igneous rocks and metamorphic rocks, they are never going to give you fossils. So our first job is to look at geologic map which tells us how the rocks are distributed in a particular place.
So we need to study the geology to look for fossils.
Yes.
Also, we usually see these illustrations of fossils buried deep underground. So, in order to excavate these fossils, do we always have to dig deeper?
No, it is not always the case. Well, it is true to some extent that if the fossils are not buried, or in other words, if the life forms, the ancient creatures were never buried, they are never going to get preserved. But once buried, once they get preserved, these rocks can be uplifted and brought to the superficial level. So not always you have to dig deep. And sometimes this digging can be done by natural processes such as rivers. The rivers can cut through rocks, exposing older rocks, and some of these older rocks can have fossils. So in that case, you don't even have to dig. You simply have to locate those areas where things are exposed at the level of the ground, and you simply are going to walk on those grounds where the fossils are exposed.
So if we find fossils in a rock section, is it more likely to find more fossils in the same or surrounding outcrops?
Yes, we try to find areas which qualify all these things, such as they have sedimentary rocks, and depending on what kind of fossils I'm interested in, I try to look at that sort of sedimentary rock. Just to give you an example, let's say I'm interested in the ancient marine organisms, creatures that lived in the sea. In that case, I would try to look at the sedimentary rocks which form underwater. And to locate those, I will again look at the geologic map and try to find out which are the places where these limestones or shales are predominantly there. And then once we go there, often we try to look for these river cut sections which exposed older rocks and track some of these things to find out some fossils. Once we found one fossil, we try to locate nearby areas and try to search more thoroughly to check for fossils.
You mentioned marine fossils. The first thought that comes to the mind is you would need to dive deep to find this ancient floor and then excavate fossils from it. Is that how it's done?
It's a very interesting question, and the answer is always no. In fact, very rarely marine seafloor are preserved under the ocean of today. In fact, most of the ocean floor are not that old, and majority of the marine fossils as part of the marine seafloor are often preserved in the land. So they have been uplifted and now they are part of the land record and we find them. And for that we don't really have to dive down in the water. In fact, we can walk on the ocean floor just by walking on the fossilized ocean floor that we find on the land.
For these marine fossils which can be found on the surface, can you quote an Indian example for it? Maybe a location where these are more likely to be found.
Well, there are many, but I would like to talk about one where we go almost regularly, and that is in the western part of India, in Gujarat. There is a place called the Kutch, and in Kutch you do find marine fossils on the land. And in fact, many of these places, they show a variety of marine organismal fossils of different ages in this barren land of Kutch. So it was once upon a time, it was a shallow sea floor where it was thriving with life, and now we only have these rocks full of life.
How do we recognize that the part of the rock that we see was part of the seafloor once?
Well, the fossils are really helpful in that. So I can actually show you a rock. This is a rock, and I think from a distance it looks quite nondescript. But if you actually look at the sediments look very similar to the sediments that you find in today's seafloor. So if you compare the sediments that you find from today's seafloor and look at this rock, you are going to see that they are made up of same sediments. On top of that, you also get to see organisms like that. So these are marine seashells, fossils of seashells, and these seashells are clear indication that this was underneath the seawater at some point of time.
Also, is Kutch the only place in India where you would find marine fossils?
No. So we do find quite a bit of marine fossils all over India. In fact, long ago there was an ocean at the northern part of India, and it used to be called Tethys, and this remnant of this Tethian ocean and the creatures which lived on the ocean floor are found in the northern part of India, where we find the Himalayas today. The rocks of Himalayas, a significant portion of the rocks of Himalayas are actually marine rocks, and they do contain a diverse amount of fossils. Similarly, if we look at the southern part of India, there are places in Kerala, in Tamil Nadu, where we do find quite a bit of sea fossils and marine rocks. But my interest in Kutch is because of a completely different reason. You see, in earth and climate science, especially when we are talking about geological experiments, rarely do we get a chance to do an experiment. Unlike other disciplines, here the experiment has already been done, and we are looking at the outcome in order to understand what went on during the vast span of time. Now, the Kutch actually gives us a natural experiment where a seaway changed its course. So if we go back in time, there was a time when the Tethian Sea, starting from the northern part of India, went all the way to Mediterranean. It was a continuous seaway. So if one is to take a boat and sail towards the west, he or she could actually go all the way to Mediterranean without taking a break. But then something changed. The Arabian Peninsula, where we see it, it moved, and finally we see a land which emerged and connecting Africa, Arabian Peninsula and Europe. And during this time, the Mediterranean got disconnected from the water body, what we call the Arabian Sea. Now the question is, if we want to know what happens to marine organisms when you change the seaway, what happens if you disconnect them, what happens if they are segregated, all of these questions can be addressed by looking at the fossil record of before and after this formation of this land bridge, as it's called.
When you say studying fossils for research purposes, I imagine it's something continuous, like a record and not isolated specimen. So can you elaborate a little on that?
Yes, I think many of the cases we simply look at it as from a collector's point of view, where we look at a nice little tiny fossil and we get excited. But in order to use them as data points, we need a lot of them. And what we try to go for is a place where there is a sequential arrangement of these fossils, and we collect it sequentially to look at how groups changed over time, especially in this specific time when we are talking about the sea level, the seaway have closed, and therefore Kutch is another very nice place because it has these sequential preservation of fossils ranging from somewhere around 25 million years to all the way 15 million years, which is relevant for addressing this particular question. When the land bridge happened and the seaway got disconnected, all of these things happened around 19 million years ago. So it gives us the flexibility to check how the fauna was before 19 million years ago and after 19 million years ago. And in order to do that, we need to collect a lot of specimens. And along with my students, I go there every year to collect specimens and finally to reconstruct what is called a stratigraphy and to see how things are changing with time, although that time has long passed.
As a nerd, I understand the curiosity to study fossils. But why explore and study fossils so extensively? What are the possibilities of studying them?
I think the understanding that the fossils provide us is a valuable one. Very importantly, because many of the changes that the biology experiences are in the larger time scale or in time scale larger than human time scale. And there is no way we can record it or we can understand it, how a group evolves, how a group changes when the change is taking place in really large time scale. And the only way to study it is to look back and look at the fossil record, because those are the testaments of how groups changed in response to the environmental change. And with the modern perspective of imminent environmental changes and the changes in climate, it becomes even more critical to understand how groups changed as a response to the changes in their environment. So one way to think about it is it's essential to look back in order to understand our present and to plan for the future.
So studying the past helps us predict the future scenarios.
Absolutely, that is the theme for conservation paleobiology.
Thank you, Devapriya, for your time in addressing some of our curiosities about fossils. We have done another hour-long video addressing more questions and other aspects of studying fossils. So you can find it in the description box with the title Knowing Long Lost Life Through Fossils. The link is provided in the description box. Thank you. Wish you a happy Science Day.
हेलो एवरीवन। क्लास में गणित सीखने के 3 तरीके होते हैं। पहला एब्स्ट्रैक्ट या अमूर्त, दूसरा पिक्टोरियल या चित्रों की मदद से, तीसरा कॉन्क्रीट या ठोस वस्तुओं के सहारे गणित सीखा जाता है। आमतौर पर देखा गया है कि एब्स्ट्रैक्ट तरीके से जब बच्चों को गणित सिखाया जाता है तो उन्हें उन अमूर्त कल्पनाओं को करने में आसानी नहीं होती, उनको मुश्किल लगता है। इसी तरह जब ज्योमेट्री के बहुत सारे कॉन्सेप्ट्स बच्चों को समझाए जाते हैं तो एब्स्ट्रैक्ट तरीके से समझना उनके लिए इतना आसान नहीं होता। इसी के कारण हम यहाँ पर कुछ बोर्ड और चीजें लेकर आए हैं और एक्टिविटीज लेकर आए हैं जिनके सहारे बच्चे इन बोर्ड्स पर उन गणित के कॉन्सेप्ट को कर सकते हैं, हाइपोथेसाइज करेंगे, उनको वेरीफाई करेंगे, कुछ मेजरमेंट्स करेंगे और गणित को समझने में उनको आसानी होगी और वो गणित में रुचि ले पाएंगे। रोजमर्रा के व्यवहार के उदाहरण और कहानियां भी बच्चों को गणित से जोड़े रखती हैं, तो जिससे बच्चे इन बोर्ड्स पर जब एक्टिविटी करेंगे तो अपनी एक्टिविटी करके लर्निंग बाय डूइंग मेथड से या खुद कर सीख सकेंगे। तो चलिए करते हैं शुरुआत। आज हम यहाँ पर खेल खेल में नंबर ऑपरेशंस करने वाले हैं। इन नंबर ऑपरेशंस को करने के लिए हमारे पास एक बोर्ड है। इस बोर्ड पे एक नंबर लाइन है जिसके सेंटर में 0 है और लेफ्ट साइड में नेगेटिव इंटीजर्स है और राइट साइड में पॉजिटिव इंटीजर्स है। इन नंबर ऑपरेशंस को करने के लिए हमें 2 ट्रैफिक मैन मदद करने वाले हैं, मिस्टर पॉजिटिव जो नीले रंग के हैं और मिस्टर नेगेटिव जो लाल रंग के हैं, और इनकी हाथों की दिशा से हमें बताएंगे कि हमें किस दिशा में चलना है। साथ ही हमारे पास ये एक येलो लाइट है। हमारे सारे नंबर ऑपरेशंस की शुरुआत हम इस येलो लाइट से करेंगे और जैसे ही एक ऑपरेशन हो जाएगा हम येलो लाइट पर आकर रुक जाएंगे। हमारे खेल के 2 नियम हैं। नियम पहला, जब भी हम कोई नंबर ऑपरेशन करेंगे तो जो भी साइन हमारे सामने आएगा उस साइन के हिसाब से, अगर पॉजिटिव साइन आएगा तो मिस्टर पॉजिटिव सामने आएंगे और वो हमें बताएंगे कि किस दिशा में जाना है। अगर निगेटिव साइन आएगा तो मिस्टर निगेटिव सामने आएंगे और वो हमें बताएंगे कि किस दिशा में जाना है। और दूसरा खेल का नियम यह है कि जब भी कोई ट्रैफिक मैन सामने आ गए और उसके बाद अगर फिर से निगेटिव साइन सामने आता है तो उस ट्रैफिक मैन को अपना चांस खोना पड़ता है और उन्हें अपना चांस दूसरे ट्रैफिक मैन को देना पड़ता है। तो चलिए करें खेल की शुरुआत। हमारी पहली केस है 5 + -3 की। तो खेल की शुरुआत में हम येलो लाइट पे रहेंगे। यहां से हम पहला नंबर है 5, तो मिस्टर पॉजिटिव को सामने आना होगा। मिस्टर पॉजिटिव हमें बताते हैं कि इस राइट डायरेक्शन में 5 कदम चलना है। 1 2 3 4 5 और हम फिर येलो लाइट पर आकर रुक जाएंगे। उसके बाद 5 के बाद फिर एक पॉजिटिव आता है तो मिस्टर पॉजिटिव फिर सामने आ जाएंगे। लेकिन ये क्या, उसके बाद तो निगेटिव साइन है तो मिस्टर पॉजिटिव को अपना चांस खो देना पड़ेगा और मिस्टर निगेटिव को चांस मिल जाएगा। और उसके बाद मिस्टर निगेटिव हमें बताएंगे कि 3 कदम लेफ्ट साइड में चलना है। तो 1 2 3 हम यहां आकर रुक गए और यहां पे पहुंच गए हैं। तो हम पहुंच गए हैं +2 पे। हमारा अगला केस है -4 + 6। फिर से हम 0 पे पहुंच जाएंगे। -4 तो निगेटिव साइन आने के कारण मिस्टर निगेटिव सामने आ गए और मिस्टर निगेटिव ने हमें बताया कि लेफ्ट साइड में 4 कदम आगे जाना है। 1 2 3 4। खेल के नियम के हिसाब से हम फिर यहां आकर रुक गए तो येलो लाइट सामने आ गया और उसके बाद है +6 तो पॉजिटिव साइन होने के कारण मिस्टर पॉजिटिव सामने आ गए और अब 6 कदम राइट साइड में जाएंगे। 1 2 3 4 5 6 और यहाँ आने के बाद हम रुक जाएंगे, तो हम फिर +2 पर आकर पहुंच गए। अगली केस है -3 -2, फिर 0 पे पहुंच गए, येलो लाइट पे -3। सो मिस्टर नेगेटिव सामने आ गए और हम 3 कदम लेफ्ट साइड में पहुंच गए, 1 2 3। यहां आने के बाद फिर हम येलो लाइट पे रुक गए, उसके बाद नेगेटिव साइन आता है, नेगेटिव साइन के कारण फिर मिस्टर नेगेटिव सामने आ गए। लेकिन जैसे ही अगला नेगेटिव सामने आ गया, मिस्टर नेगेटिव को अपनी चांस छोड़नी पड़ेगी और मिस्टर नेगेटिव को यह चांस मिस्टर पॉजिटिव को देनी पड़ेगी। यहां आने के बाद मिस्टर पॉजिटिव ने हमें बताया कि 2 कदम राइट साइड में जाइए, तो हम यहां आ गए, -1। तो इस तरह हम -1 पर पहुंच गए। यहां आने के बाद हम देखेंगे कि मिस्टर पॉजिटिव और मिस्टर नेगेटिव की मदद से हमने इन मैथमेटिकल ऑपरेशंस को सॉल्व कर लिया। अगर हम बोर्ड पे इन ऑपरेशंस को सॉल्व करेंगे तो हम देखेंगे कि मिस्टर नेगेटिव और मिस्टर पॉजिटिव ने हमारी बहुत बढ़िया मदद की और हमें सही आंसर्स तक पहुंचा दिया। मुझे उम्मीद है कि आपको ये मिस्टर पॉजिटिव और मिस्टर नेगेटिव की मदद से ये नंबर ऑपरेशन समझ में आ गए होंगे।
Hello everyone, my name is Sushant Pawar and I work here in Science Activity Center of IISER Pune. आज एक एक्टिविटी जो आपके साथ करने वाला हूं, देखते हैं वो एक्टिविटी क्या है। उसमें शायद मैजिक दिख रहा है, शायद मैथ्स दिख रहा है, चलो फिगर आउट करते हैं क्या है। मेरी स्लाइड जो है वो 2 लैंग्वेजेस में है, जैसे कि मराठी में है और इंग्लिश में है, और मैं जो आपसे बात करूंगा, इंटरैक्ट करूंगा, तभी मैं हिंदी में बात करूंगा, सो दैट ये जो एक्टिविटी है, ये वीडियो है, वो सारे ज्यादा से ज्यादा लोगों तक पहुंच सके, ज्यादा से ज्यादा लोग इसे समझ सकें। चलिए स्टार्ट करते हैं। तो अभी जैसे आपको नाम दिख रहा है मैजिक नंबर, अंकांची जादू, मैं कहना चाहता हूं कि अभी जो आप जहां पे भी है वहां पे आप एक पेपर और पेन लेके साथ में बैठिए, क्योंकि हम कुछ नंबर न्यूमेरिकल ऑपरेशंस करने वाले हैं इसके साथ। तो देखिए, जो जैसे कहा गया है कि नंबर है, तो आपको पहले तो कोई एक नंबर कंसिडर करना है आपके माइंड में, और मुझे बताना नहीं है। वैसे भी आप मुझे बता नहीं पाएंगे क्योंकि हम ऑनलाइन मोड में हैं। आप चैट में भी टाइप मत कीजिए, लेकिन अपने पास लिख के रखिए। और जैसे कि आपको नीचे दिख रहा है, यहाँ पे एक टाइमर चालू है। वो टाइमर जो है वो आपको एक टाइम लिमिट दिया जाएगा और तब तक आपको वो नंबर कंसिडर करना है। मैं कहूंगा कि थोड़ा सिंपल नंबर कंसिडर कीजिए, क्योंकि आपको इस पे ऑपरेशंस करने हैं, राइट। आई होप आप में से बहुत सारे लोगों का नंबर फिक्स हो चुका होगा। मोस्टली इंटीजर कीजिए, नहीं बड़ा कर रहे हैं तो भी ठीक है, आप कैलकुलेशंस में अच्छे रहिए। अभी इस नंबर को आपको 3 से मल्टीप्लाई करना है। देखिए, जो भी नंबर आपने कंसिडर किया है उसे 3 से मल्टीप्लाई कीजिए, 3 गुना कीजिए, तिप्पट जिसे मराठी में कहते हैं वो कीजिए। और मैं यूजुअली हर ऑपरेशन के लिए 20 सेकेंड्स का टाइम दे रहा हूं कि आपके 20 सेकेंड्स कंप्लीट हुए। अभी इसमें हमें जो नया नंबर मिला है, 3 गुना करने के बाद, ट्रिपल करने के बाद उसमें 6 ऐड करना है। जैसे कि आपको आपके स्क्रीन पे दिख रहा है, आपको ये नंबर में 6 ऐड करना है, राइट। आई होप सारे लोग ये स्पीड से कर पा रहे हैं। ठीक है, चलिए 6 ऐड हो गया होगा, आगे बढ़ते हैं। अभी ये जो नया नंबर मिला है आपको, वो नंबर को आपको 3 से डिवाइड करना है। पहले आपने नंबर लिया, उसे 3 गुना किया, उसमें 6 ऐड किए। अभी जो है आपको ये नंबर को 3 से डिवाइड करने कह रहा हूं, और 10 सेकेंड दे रहा हूं, क्योंकि डिवीजन में कभी कभी टाइम लग जाता है। देखिए, आई होप सारे लोग ये इंस्ट्रक्शंस फॉलो कर रहे हैं। चलते हैं आगे। अभी जो आपको 3 से डिवाइड करने के बाद जो नया नंबर मिला है, ओके, वो नंबर में से आपका जो ओरिजिनल नंबर था, जो आपने कंसिडर किया था, वो नंबर सब्ट्रैक्ट कीजिए। जैसे कि समझिए मैंने ओरिजिनल नंबर कंसिडर किया था 5 और मुझे अब तक के प्रोसेस में फॉलो करने के बाद मुझे अगर 20 मिल रहा है तो मुझे 20 में से 5 सब्ट्रैक्ट करने हैं, राइट? चलिए कर दीजिए। आई होप आपका कैलकुलेशन हो गया होगा। अभी आपको एक नंबर मिला है। ये सारे प्रोसेस के बाद क्या किया आपने? पहले तो एक नंबर अज्यूम किया, उसे 3 से मल्टीप्लाई किया, उसमें 6 ऐड किए, फिर उसको 3 से डिवाइड किया, फिर उसमें से हमारे ये प्रोसेस के बाद जो नंबर मिला उसमें से ओरिजिनल नंबर को सब्ट्रैक्ट किया, राइट? शायद आप सबने यही प्रोसेस किया है, ठीक है। तो आगे जो है आपको स्लाइड्स में एक टेबल दिखने वाला है। वो टेबल में अभी जो आपको ये सारा प्रोसेस करने के बाद आपको जो नंबर मिला है वो नंबर के सामने एक सिंबल असाइंड है। वो सिंबल की तरफ आपको 30 सेकेंड्स के लिए देखना है। इज दैट सिंपल? चलिए देखिए। सो आपके 30 सेकेंड्स तो शुरू हो गए हैं। आपको ये सारे कैलकुलेशंस करने के बाद जो भी नंबर मिला है उसी सिंबल की तरफ 30 सेकेंड्स के लिए दिखने हैं। सो आपके ऑलमोस्ट 20 सेकेंड्स अभी हो रहे हैं। आई होप आपने सभी ने ये एक्टिविटी की है। लास्ट कुछ सेकेंड्स बचे हैं। केयरफुली देखिए अपने सिंबल की तरफ। 3, 2, 1। ओके, सो आप मैजिक देखने के लिए तैयार हैं? आपको नंबर याद है आपको सारे प्रोसेस के बाद मिला हुआ नंबर, और आपका सिंबल है स्टार। क्या हुआ? आपका भी यही सिंबल था? ऐसा कैसे हुआ? और मुझे कैसे पता चला कि स्टार ही आने वाला है? क्या किया मैंने? मैजिक? इज इट मैजिक? और शायद नहीं। अगर मैं आपको कहूं कि इसमें कोई मैजिक नहीं है और प्योरली मैथमेटिक्स है तो आपको कैसे लगेगा? चलिए देखते हैं कौन सा मैथमेटिक्स है तो क्या है। सो आपको मैंने बताया पहला स्टेप कि आपको कोई एक नंबर अज्यूम करना है, और जब भी हमें कोई भी अननोन नंबर, अभी मेरे लिए तो वो नंबर अननोन था, राइट? तो यहां पे आपके स्क्रीन पे जो स्टेप दिख रहा है उसके नीचे एक एक्सप्लेनेशन दिख रहा है जो मैंने किया, ठीक है? जो अभी आपने नंबर अज्यूम किया उसे मैंने x अज्यूम कर लिया। हम अलजेब्रा में बहुत बार x अज्यूम करते हैं अननोन क्वांटिटी के लिए, वैसे ही मैंने x उसे नाम दे दिया। सेकेंड स्टेप में मैंने कहा कि वो नंबर को ट्रिपल कीजिए। आपने वो नंबर को जब भी ट्रिपल किया होगा वो नंबर 3 into x ये फॉर्मेट में बन गया मेरे लिए, है ना? ट्रिपल है 3x x के। उसके बाद के स्टेप में, स्टेप 3 में आपको मैंने कहा कि उसमें 6 ऐड कीजिए। आपने 6 ऐड किए होंगे, आपको कोई आपके नंबर के हिसाब से नंबर मिला होगा, लेकिन मुझे जो है आपका नंबर तो पता नहीं था, तो मैंने जैसे एक एल्गोरिथम फॉलो किया उसमें 3x तक पहुंचा था ट्रिपल करने के बाद। अभी 6 ऐड करने के बाद मैं पहुंचाऊंगा 3x + 6। सो आपका जो नंबर होगा वो 3x + 6 फॉर्मेट में होगा। आगे मैंने कहा इस पूरे नंबर को जो ये स्टेप 3 के बाद आपको मिला है 3x + 6 फॉर्मेट का, उसे 3 से डिवाइड कीजिए। आपने वो नंबर को जब भी 3 से डिवाइड किया तो आपको एक नंबर मिला होगा, लेकिन मेरे प्रोसेस में वो नंबर x + 2 फॉर्मेट का था। आपका नंबर भी x + 2 फॉर्मेट का है, कैसे वो आगे देखते हैं। सो आपका जो नंबर 3x + 6 फॉर्मेट में था उसको डिवाइड जब भी हम 3 से कर रहे हैं, जैसे आपके स्क्रीन पे दिख रहा है, वो हमें आंसर मिलेगा x + 2। अभी इसमें से लास्ट स्टेप में मैंने कहा कि आपको जो नंबर मिला है अभी, वो नंबर में से आपका जो ओरिजिनल नंबर आपने जो कंसिडर किया था वो ओरिजिनल नंबर आपको सब्ट्रैक्ट करना है। इसका मतलब मेरे लिए तो वो x + 2 फॉर्मेट में आ गया था अभी तक, उसमें से अगर मैंने x सब्ट्रैक्ट कर दिया तो देखिए x + 2 में से x अगर निकाल देंगे, सब्ट्रैक्ट करेंगे, मराठी में वजा करूया, तो देखिए क्या मिल रहा है हमें। x + 2 में से x निकाल दिया तो आंसर 2 मिलेगा। सो नो मैटर व्हाट, आप कोई भी नंबर अज्यूम करते, पर ये अल्गोरिदम, ये स्टेप्स फॉलो करने के बाद, ये प्रोसेस फॉलो करने के बाद, अगर आप सही प्रोसेस फॉलो कर रहे हैं, आपके कैलकुलेशन सही है, तो आपको 2 ये आंसर ही मिलता है एंड में। और 2 के लिए मैंने सिंबल असाइन किया था स्टार। सो इसीलिए जब भी आपने वो सिंबल की तरफ देखा और मैंने आपके स्क्रीन पे सिंबल प्रोजेक्ट की, तभी आपको स्टार ये सिंबल दिखा। और जैसे कि आपने देखा कि जो प्रोसेस हमने की वो दिखने के लिए मैजिक की तरह दिख रही थी, लेकिन उसके पीछे काफी गणित छुपा हुआ था, बीजगणित था, जो अलजेब्रा हम कहेंगे। अलजेब्राइकली काफी हमने कैलकुलेशंस किए यहाँ पे। तो वैसे ही मैं चाहता हूं कि आप भी कोई एक एक्टिविटी ढूंढे, आप भी ऐसे कोई एक अल्गोरिदम बनाए, ये प्रोसेस कीजिए और अपने दोस्तों के साथ, अपने पेरेंट्स के साथ, अपने टीचर्स के साथ, अपने क्लासमेट्स के साथ ये ट्राई कीजिए और हमें लिखिए कमेंट्स में कि आपको ये कैसे लगा। सो थैंक यू।
नमस्कार, मेरा नाम संकेत राउत है। मैं इंद्रानी बालन साइंस सेंटर से बोल रहा हूँ और नेशनल साइंस डे के इस अवसर पे मैं आप सभी का स्वागत करता हूँ। इस मौके पर आज मैं आपको एक मैथमेटिक्स के एक रिवॉल्विंग नंबर के बारे में बात करना चाहता हूँ। वैसे तो हम देखते हैं कि मतलब जब हम मैजिक नंबर्स की बात करते हैं तो बहुत सारे नंबर्स होते हैं कि मतलब 9 को लेकर बहुत सारी एक्टिविटीज़ की जाती है। उसके साथ साथ गोल्डन रेशो की हम बात करते हैं और 0 से लेकर 9 तक कई सारे ऑपरेशंस जो है वो हम करते हैं और उसकी मैजिक जो है वो दिखाते हैं। लेकिन मैजिक जो है वो क्या सिर्फ गोल्डन रेशो में ही है या ये 0 से 9 तक लेकर जो छोटे छोटे नंबर से उसी में है? तो ये ज़रूरी नहीं है। मैथमेटिक्स जो है वो काफ़ी बड़ा विषय है और इसमें कई सारे नंबर्स जो है वो हमें चौंकाते हैं। तो आज ऐसे ही एक नंबर पे हम बात करेंगे और इससे मैं आपको बताना चाहूँगा एक कंसेप्ट जिसको कहते हैं रिवॉल्विंग नंबर्स। ठीक है, तो आज हम एक रिवॉल्विंग नंबर की बात करेंगे। तो यहाँ पर आपको एक नंबर जो वो दिख रहा है 1,42,857। तो इस वीडियो के लिए मैं इसको 142857 इस प्रकार से ही बोलूँगा। यहाँ पर देखिए कि हर नंबर जो है तो उसको एक कलर है और उसमें एक सीक्वेंस है। अब हम इसके ऑपरेशन जो है वो करना शुरू करते हैं। ठीक है, फिर हमें पता चलेगा कि क्या मैजिक जो है वो इस नंबर में हमें हम देख रहे हैं। हाँ, तो जैसे कि 142857 इसको जब हम 1 से जब मल्टीप्लाई करते हैं तो वही नंबर हमको मिलता है। लेकिन जब हम इसको 2 से मल्टीप्लाई करते हो तो आप देख सकते हो कि यहाँ पर जो नंबर हमें मिल रहा है तो उसका सीक्वेंस जो है तो वो 285714। तो यहाँ पर भी देखें 285714। तो वही नंबर जो है वो हमें एक सीक्वेंस में मिल रहा है, बस उसके जो स्थान जो है तो उसमें थोड़ा सा बदलाव हो रहा है। अब यही नंबर को हम 3 से मल्टीप्लाई करते हैं तो हमें देखिएगा कि 428571 ये नंबर मिल रहा है। इसको हम 4 से मल्टीप्लाई करते हैं तो फिर देखिएगा कि हमें 571428 ये नंबर मिल रहा है। इसको हम 5 से मल्टीप्लाई करते हैं। 5 से मल्टीप्लाई करने के बाद जो नंबर हमें मिलता है वो है 714285। इसके बाद हमने उसको 6 से मल्टीप्लाई करके देखा, हमें वापस जो नंबर मिला है वो है 857142। तो देखिएगा कि मतलब इस नंबर को 142857 को जब हमने 1 से लेकर 6 तक मल्टीप्लाई किया तो वही संख्या जो है वो हमें वापस मिल रही है, बस उसका सीक्वेंस जो है वो चेंज हो रहा है। तो क्या ये फैसिनेटिंग नहीं लग रहा है आपको? अब आपके दिमाग में होगा कि मतलब इससे ज़्यादा अगर हम ऑपरेशन करते हैं, इसको अगर हम और नंबर से मल्टीप्लाई करते हैं तो क्या हो सकता है। तो चलिए हम उसको 7 से मल्टीप्लाई करके देखते हैं। अब थोड़ी कहानी में हमें बदलाव आता हुआ नज़र आता है, क्योंकि जब हम इसको 7 से मल्टीप्लाई कर रहे हैं तो हमारा आंसर जो है वो 999999 ये है। ठीक है, तो अब यहाँ तक आकर ये मैजिक जो है वो ख़त्म हो जाता है। और अब हम सोचेंगे कि मतलब क्या है, मतलब कि क्यों 1 से 6 तक मल्टीप्लाई करते हैं तभी ये नंबर रिवॉल्व हो रहा है और 7 से मल्टीप्लाई कर रहे हैं तो इसका आंसर जो है वो 999999 ये आ रहा है। तो इसका जवाब मैं आपको नहीं दे रहा हूँ, मैं आप चाहूँगा कि आप इसके बारे में सोचो और आपके जो जवाब जो है वो हमें आप हमको दे दीजिएगा। लेकिन एक हिंट मैं इससे पहले आपको देना चाहूँगा कि जैसे कि एक और 7 ये एक मतलब दोनों भी प्राइम नंबर है, तो एक को जब मैं 7 से डिवाइड करता हूँ तो उसका आंसर जो है वो आप देख पाओगे कि 142857, 142857, 142857, 142857 और ये ऐसे ही निरंतर चलता रहेगा। तो एक ये जो है कि मतलब निरंतर चलने वाला रिवॉल्विंग नंबर जो है, तो वो हमें यहाँ पर भी जब हम एक को 7 से डिवाइड कर रहे हैं तो हमें दिखाई दे रहा है। ठीक है, तो हो सकता है कि मतलब इसी के कारण कि जब मैं 7 से इस नंबर को मल्टीप्लाई कर रहा हूँ तो मुझे नंबर जो है वो 99999 ये ऐसे इस प्रकार से मिल रहा है। ठीक है, तो आपके लिए एक और नंबर जो है उसके साथ इसको हम ट्राई कर देते हैं। तो एक और प्राइम नंबर लेकर हम आगे जाने की कोशिश करेंगे। अब यहाँ पर हमने प्राइम नंबर जो है वो लिया है 13, और एक से जब 13 को हम डिवाइड करते हैं तो आप देख पाओगे कि ये जो नंबर जो है अगेन हमें रिवॉल्विंग नंबर मिल रहा है 76923 और 07693। तो इस प्रकार से नंबर जो है वो रिवॉल्व होता रहेगा। तो यहाँ पर हमने 07693, तो ये नंबर जो है क्योंकि ये बाद में जो है वो रिवॉल्विंग होता रहेगा, इसलिए मैंने ये जो पहला नंबर जो है तो वहाँ पर भी मैंने 0 रख लिया है। वैसे आंसर में वैसे आपको अगर कैलकुलेटर से इस्तेमाल करता तो ये नहीं दिखेगा। तो अब ये रिवॉल्विंग नंबर जो है तो उसका भी हम पहले जैसे ही मल्टीप्लिकेशन ऑपरेशन जो है वो करके देखते हैं। तो जैसे ही मैंने इसको 1 से मल्टीप्लाई किया तो वही नंबर आना है। 2 से जब हम मल्टीप्लाई करते हैं तो यहाँ पे एक नंबर जो है वो अलग अलग दिख रहा है हमें 153846, तो ये वो नंबर है। ठीक है, तो इस नंबर को भी आप ध्यान में रखिएगा। अब जब मैं उसको 3 से मल्टीप्लाई कर रहा हूँ तो हमारा नंबर जो है वो देखिएगा कि आंसर में 307692, अगेन रिवॉल्व हुआ नंबर। 4 से जब मैं मल्टीप्लाई कर रहा हूँ 230769, रिवॉल्व हुआ नंबर। 5 से जब मल्टीप्लाई कर रहा हूँ तो हमें ये जो आंसर जो है वो 384615 जो है वो मिल रहा है। लेकिन अगर हम ध्यान से देखेंगे तो यहाँ पे 384615 ये वही नंबर रिवॉल्व हो रहा है कि जब हमने ये 076923 को मल्टीप्लाई किया था 2 से। ठीक है, तो अब आगे हम बस यही देखते हैं कि मतलब नंबर जो है वो कौन कौन सा जो है वो रिवॉल्व हो रहा है। तो 5 तक हमने ऑपरेशन करे, 6 से जब हमने किए तो हमने जो 2 से मल्टीप्लाई किया था नंबर वो रिवॉल्व हो रहा है। 7 के साथ भी वही मल्टीप्लाई बाय 2 वाला नंबर जो है वो रिवॉल्व हो रहा है। 8 के साथ भी मल्टीप्लाई बाय 2 वाला नंबर रिवॉल्व हो रहा है। देन 9 के साथ अगेन ये जो पहला वाला जो रिवॉल्विंग नंबर था तो वो है 307692 6923। जब हम इसको 9 से मल्टीप्लाई कर रहे हैं तो हमें जो नंबर मिल रहा है वो है 692307। तो अगेन पहले वाला जो नंबर है वही रिवॉल्व हुआ। 10 से जब मल्टीप्लाई कर रहे हैं तो 769230 वही रिवॉल्व हुआ नंबर। देन 11, 12 और मतलब 11 से जब हम मल्टीप्लाई कर रहे हैं उसको तो हमें जो दूसरा वाला कॉम्बिनेशन था वो रिवॉल्व होता हुआ नज़र आ रहा है। 12 से जब हम इसको मल्टीप्लाई कर रहे हैं तो हमें 307692 वही नंबर रिवॉल्व होता हुआ नज़र आ रहा है। तो ये था। अब अगर हम सोचेंगे कि ये जो नंबर जो है मतलब 1 से जब 13 को हमने डिवाइड किया था तब हमें ये नंबर जो है वो मिला था रिवॉल्विंग नंबर। तो इस नंबर को जब हम 13 से मल्टीप्लाई करते हैं तो क्या होता है, तो अगेन आपके सारे डिजिट जो है आंसर के वो आपको 9 ही मिलने वाले हैं। तो यहाँ पर हमने देखा कि ये जो नंबर 1 जो है तो उसको जब हमने 7 और उसके बाद जब 13 से जब हमने डिवाइड किया तो हमें कुछ एक नंबर मिला, और वो जो नंबर जो है उसके जब हमने मल्टीप्लिकेशन ऑपरेशन किए तो हमें एक रिवॉल्विंग नंबर मिला कि वही नंबर जो मल्टीप्लिकेशन में बार बार रिवॉल्व हो रहा है। 7 के साथ जब हमने किया तो हमें एक ही रिवॉल्विंग नंबर मिला। 13 के साथ जब हमने किया तो हमें 2 कॉम्बिनेशन जो है वो मिले। तो अब मैं चाहूँगा आपसे कि आपको भी बहुत सारे प्राइम नंबर्स पता है, आप भी मल्टीप्लिकेशंस करना जानते हो, डिवीजन करना जानते हो, तो ऐसे ही रिवॉल्विंग नंबर अगर आप खोज पाओ तो हमें ज़रूर बताइएगा। आपकी खोज जो है वो देखने में हमें काफ़ी खुशी होगी। धन्यवाद।
Welcome to the National Science Day. I am Ramana Athreya, an astronomer at the Indian Institute of Science Education and Research, Pune. I will introduce you to an exciting event which happened a couple of months ago, which is the launch of the James Webb Space Telescope. I will first give you an overview. It is a space telescope, it is a 6.5 meter diameter mirror, it is an infrared telescope. Infrared is not quite the same as the visible electromagnetic radiation that we use to see the objects in the universe around us. This telescope is named after an administrator at NASA who led the organization in the 1960s. The telescope was first proposed in 1980s, but it was only launched 41 years later in 2021. The estimated final cost is 10 billion US dollars. And towards the end, I will take you through some of the astrophysical goals that astronomers are very excited about pursuing with this telescope. It will look at the oldest and the most distant objects in the universe. It will also look at some of the coldest objects, cosmic gas and dust, which is where stars are born in the universe, and it will help us understand a bit more about exoplanets. Exoplanets are extrasolar planets, that is, planets which are found outside our solar system. This gives you a picture of all the different telescopes which are in space. There are dozens and dozens of them, and that immediately brings us to the question of why we want to put telescopes up in space. The primary reason why astronomers want to have telescopes in space, even though it is very expensive, I gave you a price of $10 billion that this telescope has cost. The same telescope, had it been installed on Earth, would have cost about a tenth perhaps. But the reason why astronomers want such telescopes in space, if they can manage to do so, is because of the atmosphere. The atmosphere of Earth consists of largely nitrogen, some amount of oxygen and trace amount of other chemicals, but these atoms and molecules in the atmosphere, they absorb photons, they scatter photons, and then they smudge the image. All of these processes reduce our ability to detect faint objects and also to get high quality images. These are actually not different processes. All these processes are related to how photons and matter interact with each other when they collide, and that is what we will look at next. But before that, I will introduce you to something called the electromagnetic spectrum, which many of you may already know of. What we understand as light is that part of the electromagnetic spectrum which is used by the human eye to see the world around us. That is just this very narrow part of it. Electromagnetic spectrum or electromagnetic radiation, which covers the entire spectrum, is distinguished by the frequency of the radiation. You can have electromagnetic radiation which extends from 10 to the power of 6 hertz all the way to 10 to the power of 20 hertz. Hertz is a unit that physicists use to indicate how many times does a wave oscillates in a second, right. These electromagnetic radiations are actually waves of electricity and magnetism, and the number of times they oscillate per second, whether it is 1 million times or whether it is 100 billion times, decides what kind of a radiation it is. We are normally familiar with two kinds of electromagnetic radiation. One is the visible that I already talked to you about. The other is the radio radiation or radio waves or radio photons, and that is used in your communication networks, whether your mobile phones or television signals or radio signals and so on. But the full range of electromagnetic radiation, which is what is called the electromagnetic spectrum, is much wider, and astronomers would like to study objects using telescopes across the entire electromagnetic spectrum. The frequency of the electromagnetic radiation is inversely proportional to its wavelength. Also, the energy of the electromagnetic radiation is proportional to its frequency. So, as the frequency increases, the wavelength of the electromagnetic radiation reduces and the energy of the electromagnetic radiation increases. Let us take a look at some of the interactions which occurs between matter and photon, because of which the atmosphere comes in the way of astronomical observations. First of all, any atom, as you know, consists of a nucleus which consists of protons and neutrons and electrons which are circling around it. When a photon of whatever energy collides with such an atom, it passes on its energy to the electron and gives it a little kick, right. So, when such a thing happens, if the photon transfers all of its energy to the electron, then that photon is no longer available to be detected by a telescope on the surface of the earth. Since the atmosphere is very large, the probability that such a photon would collide with an atom is high, and therefore, the atmosphere attenuates a lot of the photons because of these collisions. What I have shown you here is the hydrogen atom. It consists of a single proton in the nucleus, and there are these different rings that you see out here, which are indicated by something called a quantum number, n is equal to 1, n is equal to 2, 3, 4, 5, 6 and all the way to n is equal to infinity. These are at different distances from the nucleus, and electrons in them have different levels of energy. So, when a photon collides with an electron, it gets kicked upwards, and if the amount of energy transferred is sufficient, then it completely escapes from the clutches of the nucleus. And in such a situation, we say that the electron has become free and left behind an ionized atom behind, which is just a positive charge here, and the electron has broken away. This happens when the radiation energy, that is the energy of the photon, is at least 13.6 electron volts, which corresponds to photons whose wavelength is smaller than 912 angstroms. So, all those photons whose wavelength is shorter than this will be efficiently absorbed by atoms in the atmosphere. We also have other ways in which photons and matter interact. For example, you may have heard of something called the ionosphere, which is found as a layer of ionized material or plasma some distance above the Earth's surface, and any plasma has something called a plasma frequency depending on its density of electrons. And if there is any radiation which is passing or impinges on the plasma below the plasma frequency, for the ionosphere it is about 10 to 30 megahertz, when the frequency is less than the plasma frequency, the plasma does not allow the radiation to pass through it. It gets reflected back from where it came from, in the direction that it came from. This is somewhat analogous to the total internal reflection that we have come across perhaps in a swimming pool, if you have seen it there. Only those radiations which have frequencies above the plasma frequencies will be able to go through, right. In fact, this is why your mobile phones and your TV signals, which have frequencies much higher than the plasma frequency of the ionosphere, cannot be seen unless we are somewhere along the line of sight to them. So, if you have one antenna here, your receiver antenna here and your transmitting antenna on the other side, because of curvature of Earth, these higher frequencies cannot actually be detected here, because they will just pass through the ionosphere. On the other hand, if you ever heard a radio, radios have frequencies which are lower than 10 to 30 megahertz, which is less than the plasma frequency, and since they get bounced back by the ionosphere, you can detect them and listen to your radio programs even if you are on the other side of the Earth. For astronomers, this situation is actually reversed. We can only, if you put a telescope on Earth, you can only see those frequencies which are higher than the plasma frequencies, because the cosmic signal has to pass through the ionosphere and come to the terrestrial surface where the telescope is situated. So, any lower frequency radiation coming from cosmic objects will not be able to pass through the ionosphere. They will get bounced upwards and we will never be able to detect them. There are other ways in which molecules and atoms can absorb photons. These are the vibrational and rotational modes of molecules, which I have shown here. Just like electrons in orbits around the nucleus can absorb energy and go to higher levels of activity or higher levels of energy, molecules can absorb such photons and start rotating faster or start vibrating faster, resulting in fewer photons available to see on the surface of Earth. The net result of all this is that the atmosphere is largely opaque across most of the electromagnetic spectrum. If you go to very low wavelengths, which is very high frequencies, your gamma ray, X-ray and ultraviolet, almost no photons come through. Only a small fraction of ultraviolet photons come through, and no photons come through in the very long wavelength radio regime. There is only this one large window in the radio regime between wavelengths of about 1 centimeter to about 10 meters, where the atmosphere is more or less opaque. And then there are these narrow windows in the optical or infrared, especially in the optical, where the photons largely come through unattenuated. There is a 10% loss in the visible photons, that is, these are the photons that we see with our eye, and there are a few narrow wavelengths where the infrared photon comes through, but by and large the atmosphere is opaque. So, what happens when photons come through the atmosphere and most of them get absorbed? So, that process of absorption is called atmospheric attenuation, because the number of photons coming through reduces. When this happens, our ability to detect sources in the sky and to get a good image of their structure reduces. For example, all images that we take with a telescope has two components. There is something called the background noise, which is called the instrumental noise, and then the signal from the target. The instrumental noise or the background noise is this black and white pepper texture that you see here, right. It is random pattern here, and the signal that we actually see are these bright spots. These are the stars and those are galaxies, and we see there is a range of brightness in these objects that we are trying to study. What matters for the quality of the image is the relative strength of the objects that we are trying to study and the background. And you see here that when the background is high, many of the objects that are visible in this part of the image where the background is low are no longer visible, and that is what happens because of attenuation. Attenuation reduces the signal coming through the atmosphere of these objects that we are trying to study, and because of that we lose detail in the image and we lose the faint sources. It is very obvious here that the number of sources which are seen on this image where the background is high is much smaller. Also, this diffuse gas which is found around the stars are no longer visible or only very faintly visible on this part of the image. So, this is the first problem of atmospheric attenuation. Then this is something we are familiar with. The atmosphere scatters incoming visible light. This happens in the daytime. The sun is so bright that even if a small fraction of its light is scattered in different directions, the brightness of the sky increases so much that we do not see any of the stars. Even though the stars are actually there, we cannot see it because of the scattered light due to the atmosphere, right. But not only does the atmosphere scatter sunlight, but it also scatters starlight. Even though the amount of starlight coming through is very small, that is sufficient to obscure the even fainter objects that we are generally trying to detect. A third thing which happens because of the atmosphere is that the earth that we live on and the lower atmosphere has a temperature of about 300 Kelvin. 300 Kelvin does not sound like a very hot temperature, but we are trying to actually detect objects which are a few tens of Kelvin, which is a 10 times fainter. And just like in the case of the sun, when you have a very bright object, you can't see any other object close to it because your eyes are sort of blinded. Similarly, telescopes also get blinded when there is a very bright background here. So, this fact that this sky has a background of 300 Kelvin means that we cannot see some of the fainter objects, especially in the infrared. In any case, you can ask, look, there is this broad window in the radio and few windows in the infrared and this visible window, why do not we confine our telescopes to observing in just these parts of the electromagnetic spectrum? Why do we need to have telescopes all across the spectrum? And the reason why we want to observe right across the electromagnetic spectrum is because objects can look very different at different wavelengths, right. Because different astrophysical phenomena result in radiation coming at different wavebands, and studies across the entire spectrum is necessary for a comprehensive understanding of the object. For example, I have shown you here what is called the ring nebula. The image on the right is the optical image, and it is the same object on the left, which is an infrared image. This entire bright thing that we see in the optical image is actually just the central part of it. And in the infrared image, you also see a lot of shells of dust. It is almost like there has been an explosion and shells of dust are being thrown outwards from the central objects. We would never have understood the complete nature of this object, but for this infrared image. Similarly, there is this very famous object called the Crab Nebula. This is one of those things which have been known to humanity for many centuries, almost for 1,000 years, and these are the different images of that single object in different wave bands. This is the visible light, ultraviolet light, X-rays, gamma rays and radio. And what you see here is the X-ray that we are looking at is only occupying a small portion of what can be seen in the visible part of the spectrum. This is the infrared image. Therefore, we want to have telescopes which can provide you information right across the electromagnetic spectrum in order to understand the complete astrophysical phenomenon of that object. Apart from the issue of the atmosphere itself, any telescope on Earth is contaminated by signals that human societies generate. You have street lights which brighten the sky. The sky in the cities seem to have far fewer stars than the sky in the wilderness. That is because the street lights increase the background and you do not see too many faint objects. Similarly, many of the light sources that we use like sodium vapor lamp and mercury vapor lamp provide you spectral lines which interfere with what the telescope is trying to observe. If you have any hot object like for example an industrial zone near an infrared telescope, it will reduce the sensitivity of the telescope considerably. Furthermore, in the radio, as I told you, your mobiles, handsets, your TV stations are all radiating electromagnetic radiation. Also high tension wires radiate electromagnetic waves. Any sparking, we all have sparking when you have two high tension wires coming close to each other. All such phenomenon will result in very bright emission of electromagnetic radiation. The problem is that the telescopes that astronomers build are used to measure cosmic signals which are very faint. In fact, the cosmic signals are so faint that we measure the strength of the signal in terms of 10 to the power of minus 26 watts per meter square per hertz. In fact, my favorite way of demonstrating how small the signal is that telescopes detect is that if you collected all the radio photons which have been received by all the radio telescopes in this world for the last 80 years since radio astronomy first started, the total amount of energy collected during this entire time by all the telescope is less than the amount of energy it takes to turn one sheet of paper. That is how faint the signals are that astronomers use to understand all that large variety of phenomenon. And you can see that when there are these very strong signals coming from man-made sources, your telescopes would be pretty much useless. Finally, one major problem of the atmosphere is that it reduces the detail with which one can observe the sky. The amount of detail in an image that a telescope can provide is called as diffraction limit. This is a theoretical limit, comes from basic physics principles, but this detail, the amount of detail that you can get, it is called its resolution. Actually, that is a technical term, but I will use the word detail here. The amount of detail you can get in an image increases with the size of the telescope. The larger the telescope you have, theoretically you should get more detail, and it decreases with the wavelength of operation, right. For the same size of the telescope, a visible or optical telescope will give you more detail than an infrared telescope, which will give you much more detail than a radio telescope. To give you some perspective, the moon subtends an angle of 31 arc minutes on the sky. On the other hand, our eye can see a detail at about 1 arc minute. 1 arc minute is 1/60th of a degree, right. These are very small numbers, and typically ground based telescopes give you detail at the level of about 1/25th to 300 times the detail that you can get with the human eye, right. So, this is what you want to aim for, But the problem with this is, this limit is not set by the size of the telescope. This limit is actually set by the turbulence in the atmosphere. You come across turbulence in the atmosphere, it is what causes the stars to twinkle. Twinkling of a star is basically instability of its position and structure as seen from Earth, and you can see that if there is very high degree of twinkling, your image will dance around on your telescope camera and you will not see much detail. The atmosphere smudges out the detail. In fact, the twinkling in the atmosphere limits the detail to what you can see with a 20 centimeter telescope. We have now telescopes which go up to 10 meters on Earth or even larger. This is optical telescopes, but any telescope larger than 20 centimeter does not gain the increase in detail that we want. So, your bigger telescopes, 4 meters, 6 meters, 8 meters or 10 meter telescope can detect fainter objects, but we cannot get finer details because of this turbulence in the atmosphere. So, here is an example that if you put a telescope in space, you have a comparison of the same image, same object imaged using a ground based telescope. Subaru is a Japanese telescope of size 8 meters, the size of its mirror is 8 meters, and it is one of the finest telescopes on Earth, and this is the Hubble Space Telescope that you might all have heard of, and this is only a 2.4 meter telescope, but you can see that the amount of detail that you can see with a telescope in space is much higher than the amount of detail in the ground based telescope, even though the ground based telescope is much larger. That is because of turbulence in the atmosphere. So, for all these reasons, astronomers like to send their telescopes into space because it gives you much crisper images and more sensitive images. Now, the question comes up, if you send it into space, as you know space is very large, what would be the best location to put it? I will not go into a huge detail on this. There is a favorite place of astronomers to put really big and expensive telescopes, and that is something called the L2 Lagrangian point. Suppose you have two bodies interacting with each other gravitationally, like for example, the sun and the earth. You know that the gravitational attraction of the sun causes the earth to go around it, right, because the gravitational attraction of the sun is very powerful. But you can see that if you are at a point which is sufficiently close to earth, because the gravitational attraction not only depends on the mass, of which the sun has a huge amount, but also depends on the square of the distance, inverse square of the distance. So, if you go to a place which is sufficiently close to earth, you will find a point where the gravitational attraction of the sun and the earth cancels each other out exactly. That is called the first Lagrangian point, right. So, even though the earth's mass itself is so much smaller. So, there are several other Lagrangian points. The important one for us is this L2. I will not go into the others, but you can go to a Wikipedia page and learn more about this. At this location L2, which lies just beyond the earth, well, just beyond is in astronomical terms, it is about 1,000,000 kilometers beyond the earth, but it is on the line joining the sun to the earth, sun L1, earth L2. The speciality of this point is that any object which is placed at L2 will rotate around the sun at the same speed as earth. It will take exactly 365 days. Why is that important? It is important because if you keep the your telescope right at that L2 point, it will always be at a fixed position relative to the sun earth axis. It will be revolving around the sun in exactly the same speed as the earth, which is 1 year, and therefore effectively that telescope is fixed. There are many things that you can do with a space telescope which makes things convenient. For example, communication with the earth to send data back to earth, because you want the telescope to be able to send the data back to earth. So, you want it to be in a fixed place, that makes it much more convenient. So, the James Webb telescope has been put at this L2 Lagrangian point. This is what the telescope looks like. It has got a primary mirror which is actually made up of beryllium. It consists of 18 panels and the total diameter is 6.5 meters, and the coating on this mirror is actually of gold. Gold is much better than aluminum. Your terrestrial telescopes of visible light have coatings of aluminum, but this has gold because gold has much better infrared reflection properties. So, this is what the telescope looks like. There is signal coming from outer space, from cosmic objects, it gets reflected from this gold plated large mirror, it is called the primary mirror. It gets reflected back into something called the secondary mirror, which is again reflects it into the instrumentation. There is instrumentation sitting inside this central block that you see here. So, this is what it looks like. Apart from this, there is something called the sun shield, because there is an infrared telescope which can be seriously contaminated or damaged or made less effective by heat, and the sun is a very hot object. So, you want to make sure that the radiation from the sun does not come and heat up your electronics. So, this sun shield is the protection against the radiation from the sun. This whole structure needs to be kept at a temperature of 50 degrees Kelvin. It is very, very cold, and the amount of sunlight is high enough to heat it up. That is the other advantage of sitting at the L2 Lagrangian point, because all you have to do is to put the sun shield on one side and it will forever be obscuring the sun and stopping it from heating the telescope. These are some of the details I already talked about. I will not go into it. You can go to the Wikipedia page and get more details of that. And these are the instruments that astronomers have put in there. So, this is the secondary mirror. This structure, this gray structure you see, is the primary mirror, and just behind the primary mirror, which is behind this black block that you see here, are the instrumentation. And the instrument consists of a near infrared imager and spectrograph. We will come to the meaning of what a spectrograph is. The imager is whatever gives you images like this. It takes a photograph of the sky. And there is a mid infrared imager. As I told you, this is an infrared telescope. The near infrared imager gives you images between 0.6 and 5 microns, and the mid infrared imager gives you images between 5 and 27 microns. And there are a couple of other sensors which are used to point the telescope in the right direction for whatever object you want to study. This again is the rest of the structure. It consists of a command structure which tells the telescope where to point, how long to point. Then there is computation, because you want to be able to control the telescope, data handling, communication back to Earth, and there is a cooler which keeps the, even at outer space which is very cold, detectors can heat up because of the electronic current in the electronics itself, the electric current in the electronics. So, there is a cryo cooler which cools it to below 50 Kelvin. Then there is a solar panel which generates small amount of energy to move the telescope whenever is required, and so on. And there are radiators. These panels are radiators. The green panel is a solar panel, and these gray panels are radiators which eliminate heat. So, I will quickly go through some of the interesting aspects here. This telescope project was first discussed in 1980. That is a long time ago. That is 42 years ago. The detailed planning started in 96. The proposed budget was $500 million US, and it was scheduled for launch in 2007. But the assembly itself was only completed in 2016. The final launch was 2 months ago, and the final cost was $10 billion. There is a large difference between the numbers proposed initially and the numbers later. Part of the problem is that for a space telescope, you have to make sure everything is working perfectly. You have to make sure that even small problems do not occur, because you can't send a mechanic out to space to make the correction. So, in fact, between 2016 and 2022, they spent 5 or 6 years just testing the telescope for all kinds of things which can go wrong, and they had to make the instrument extremely robust. One of the problems with telescopes like this, because they take 10, 20, 30, 40 years to build, is that you have to freeze the technology sometime. You have to freeze the design and the plans and say, I shall build it with whatever technology is available today. But it also means that since technology is changing very rapidly, the technology today is not what it was 5 years ago, it is progressing very rapidly. In some sense, most telescopes are already obsolete by the time you send them up, because you are working with technology which is already 10 or 20 years old, right. That is part of the problem, but that is what it is with telescopes, because they take such a long time to build and send up. They are usually using the previous generation electronics and technology. Other aspects, it was an international effort, though largely driven by US funding. It is a technology demonstrator. Many people ask, what is the point of building telescopes like this which cost such a lot of money? But a lot of the technology developed for telescopes usually find commercial use subsequently. It has been criticized for various reasons. One is the enormous increase of time and cost, consumed a lot of funding which could perhaps have supported other astronomy research. And one other aspect is that James Webb was not a scientist. He is actually the head of the programs of NASA. He was a senior administrator of the Apollo space program, which put people into on the moon, Americans on the moon. But the reason they named it after him, because he was one of those administrators who strongly pushed the research orientation of that organization. And in his honor, because he understood 60 years ago how important research is to be part of the space program, they named this telescope after him. So now let us take a look at the science with the James Webb telescope. As I told you, it is an infrared telescope, and the importance of infrared telescopes is that it probes a different set of astrophysical phenomena compared to visible light, X-ray and radio telescopes. For example, you see on the panel on the right here that this is a optical image of a galaxy, and just above the galaxy you practically see nothing. It is an empty hole out there, and this was a even though this optical image has much higher resolution and sensitivity than the infrared image. You can see that this galaxy itself in the infrared images, it looks a lot more smudged. You do not see that much of detail, and there are not that many other objects visible in these infrared images. But on the other hand, you see that this object which has been circled is bright in these infrared images, but not seen in the optical image at all. This was the point I was making. I made it earlier also, that different objects radiate differently in different bands, and all of it is necessary for a comprehensive understanding of the object. Secondly, infrared telescopes are wonderful for looking through obscuring gas and dust, and that is seen here. This is an optical image and this is an infrared image. In the optical image, you just see these clouds of gas and dust and nothing else, but whereas when you look at the infrared image, you see large number of stars which are sitting inside these clouds, and you would have never known it if you had not observed this cloud with the infrared telescope. In fact, we now know because of these infrared images that such clouds of gas which look dark, do not have much light, you can see in the outer regions, are actually the nurseries in which stars are born. So, this is how you can actually study the birth of stars only through these infrared telescopes, otherwise you would not have even known that there was star formation going on there. Then there is that other thing that we are all very interested in as human beings. We want to understand how the universe was formed. As you may have heard, in the case of the universe, because it takes light a finite amount of time to come from far away to close to you, the farthest objects in the universe are also being seen when they were very young in the age of the universe, right. So, if you want to understand how the universe looked when it was very young, you see very far away. But there is also this phenomenon called the cosmological redshift, in which any radiation which was emitted by an object which was very far away at the time when the universe was very young, by the time such a radiation reaches us, its frequency goes on decreasing or its wavelength goes on increasing. In analogy with the rainbow, where the red part of the rainbow has lower frequency of radiation compared to the blue part of the rainbow, this transformation of a higher energy or higher frequency photon into a lower energy or lower frequency photon is called a redshift. And in fact, astronomers use the redshift of an object to understand how far it is away from us, right. So, this is what is actually seen by astronomers when they are using the redshift. What I have shown you here is how radiation intensity changes as a function of wavelength, right, in this image for example. If you took a typical galaxy and observed it at various frequencies within the optical, its intensity, which is on the y axis, changes in this manner. It starts at some low level at very high wavelengths and becomes higher and higher, and then it suddenly abruptly drops and becomes very low, right. But if you observe this galaxy far away, what you would see is that this spectrum is shifted to higher and higher wavelengths or lower and lower frequency. That is why it is called redshift, because blue is on this side and red is on this side in this wavelength scale, right. So, shown here are three identical galaxies, but at redshift is equal to 0, 0.4 and 0.8. So, the redshift, it is indicated using the letter Z. Its redshift 0.8 means it's a very distant object and a very young object, because it is being observed at a time when the universe was very young, and you can see that the same spectrum is being shifted to higher and higher wavelengths, longer and longer wavelengths or lower frequencies. You can see why, if we want to study the early universe or the distant universe, we need a very good infrared telescope, because as the redshift becomes higher and higher, all those phenomena which were giving you radiation at high frequencies, the same photons will now be detectable only at low frequencies. That is, all the ultraviolet and optical photons will only be detectable at infrared frequencies, which is why you need a very sensitive infrared telescope. That is what being shown here. If these are the three spectral lines, you know what spectral lines are. These are characteristic lines emitted by chemical species, atoms and molecules at particular frequencies, and by measuring the wavelength at which they are coming, we know what chemical species they are. This is how people find out what is there in the distant objects, galaxies and stars. So, in this, if such an object was close to us, you would have seen those emission lines at these frequencies or these wavelengths, but the same object found far away would be at much higher longer wavelengths, right. This is infrared, this is visible light, and that is the reason, if you want to study the universe at an early stage or the distant universe, you need a very sensitive infrared instrument. The James Webb telescope is also expected to provide us a lot of information about extrasolar planets. It is one of the things which many people are excited about, because apart from astronomers, the public also wants to know if there is life outside our own solar system. And you remember all the problems that we talked about, complaints that we had about what the atmosphere does to radiation, right, can be inverted to study the interaction between matter and photons in the atmospheres of distant planets, and this is the way people are looking at it. Here is some star around which there is this planet which is moving round and round, and when the planet is right in front of the star, of course the planet blocks the light from the star in the region where the planet is solid, but then the planet also has an atmosphere, and because the light from the star is passing through the atmosphere, all the absorption processes, the scattering process that I talked to you about at an earlier stage, you will see the same interaction between the light of this star and the planetary atmosphere. And by analyzing the spectrum, we can actually figure out what kind of material, what kind of chemical species are there in these planets. This is a very powerful way of finding out the composition of the atmosphere of these planets, because planets by themselves do not emit much light, and therefore detecting their chemical species is very difficult, but for this phenomenon. What is shown in this panel is the spectrum of the planet when it is going just behind the star, just before it goes behind the star on the upper panel, and what is shown below is the spectrum that is seen when the planet is in front of the star, and the difference between these two gives you the signature of the presence of many organic molecules, including methane, CH2, CH3 radicals, water and so on. And one of the quest is to ask if there are planets in which there could be chemical species which are essential for our kind of life on Earth. Then I will end with this final one, which is also related in some way to planets. What I have shown you here is observations from the space of stars which have a disk around them. What has been done is actually the stars have been removed from this image. They mask the star, because if you have the star also in the field, it will be so bright that you can't see the disk. They have subtracted the star, which is found at the location of these plus symbols out here, both in this object and this object, and when you subtract the light of the star, what is left behind is a disk like object, right, and that is shown as a model here. that there is this bright star here and a disk around it. This is only detected in infrared, you can't see this in the optical. So, this is one star with a disk and another star with a disk, and the belief is that such disks around stars, which are typically found in young stars, may have been the precursor of planetary systems. So, basically the James Webb Space Telescope, the infrared telescope, has been sent up with two major broad fields of inquiry. One is to know the origins of the universe, the high redshift universe, cosmological redshift of the distant early universe, and our own origins in terms of can we find life or life-like conditions in other planets outside our own solar system. So, I will stop with that. I will only say that I wish with this exciting telescope going up, I wish I were 30 years younger, but this is a wonderful resource for all of you wanting to become astronomers, to be able to take human knowledge of the cosmos to much greater heights with a telescope like the James Webb Space Telescope. Thank you very much.
So welcome everyone to this very beautiful session on the occasion of National Science Day. This particular session has been organized by IISER Pune, and I'm really gladful that I have been given an opportunity to talk about the most important and crucial topic of plastic pollution. And that is why we are going to throw light on the specific topic. And the title today is Tackling Plastic Pollution. This particular topic actually is, in consensus with the theme of the National Science Day, which is the integrated approach in science and development for a sustainable future. We all think about sustainability, and I think plastic pollution is something that we all need to act on so that, we have a sustainable future. So let's start today's session and, learn a lot more about plastics, how to recycle them, what is plastic, and why there is plastic pollution, and what you can do at your level to minimize it. So let's focus on understanding a little bit about plastic and its applications, and whether it's a green material or not. So what is plastic? For all of you who are watching this video, Plastic is a very generic term that's being used. Obviously, under that, you have so many different grades, so many different chemistries, so many different applications. But we'll just talk about the basic chemistry of how any plastic is formed. So you have a single unit, which is called as a monomer, which is a single chemical molecule. It can be anything. And once it's linked together, it forms a chain, and that is called as a polymer. So polymer is a chemical name for plastic. Plastic is a more general name that's being used globally and for everybody who understands the specific material. So all different single monomers will link together to form a polymer. And every plastic is a chain of different monomers. It has a different chemistry. It has a different application. It has a different look. It has a different flow. It has different properties. So all of this particular, particular aspects of these monomers define the final outcome of the plastic. And obviously, it's varies application. Let's focus on what are the sectors in which application it's being used. First and foremost, it's used heavily in medical and healthcare. I think during the pandemic, I believe a lot more plastic was spotted than it could be ever in any of the decades. People wearing PPEs, people wearing masks, plastic sheets being used everywhere. As a precaution measure to avoid contamination, and obviously for the reason to protect that nothing is contagious. So medical and healthcare are one of the biggest sectors that consume a lot more plastic, and then obviously is followed by electronic waste, agriculture, defense, textiles, automotive, food and beverage, and specialty applications, like you can see an airplane here, or a train, or a bus. All of these are actually made out of plastic. So the application is really, really huge, and you will be thrilled to know that about 4 million people are employed in India on the plastics industry. So you can relate that it is a really important sector, and its applications and its properties are so unique that it has found way into every domain that you come across. I think maybe if you get a chance, you can just do a little plastic analysis in your own house and find out how much plastic you actually have in your particular house. So a lot of people ask me whether plastic is green or plastic is a bad material. It's a negative material. It only creates pollution. Is that really the right information? So I think the fact that somebody can check if a material is green is basically based on the life cycle analysis. So, for example, you have to see from the time the particular material is made, whether it's glass or material, glass or metal, or wood, from the time it's extracted from the environment to a product that's being made, and to the fact that it's disposed and recycled and used again. The entire life cycle analysis is evaluated to decide whether a material is green. And you will be thrilled to know that, in fact, plastic is much more greener than paper, steel, aluminium, and glass. So, because obviously the energy that it consumes throughout its life cycle analysis is lesser than the respective materials. So, despite plastic being greener, it's still a really problematic issue, because it lacks value. People don't understand how to dispose it, and so on. Now, why there is plastic pollution? Now, I did mention that plastic is a much greener material than than metal or glass, or than metal or glass or paper, and still ends up being the most talked about material and the most talked about plastic pollution issue. So here are some of the reasons why plastic pollution is a problem. First of all, littering. Like I told you, that we end up throwing plastic waste everywhere. We don't have proper waste segregation. We do not separate out the plastic in our house. We don't know where to dispose it. Even if I think a lot of people ask me that, I segregate all my plastic, but where do I give? What do I do about it? So that knowledge is lacking. Lack of monitoring and implementation of government policies, though there is a lot more being talked about plastic being taken back for recycling. That this particular implementation at the grassroots level is still weak and needs much more push to have a complete plastic take back. A lack of sensitization among the consumers, and obviously lack of infrastructure for collection and disposal. When I say lack of sensitization among the consumers is that they do not understand the implication, they do not understand the problem that it is going to give them, and they just end up disposing the way they want. And obviously the infrastructure for collection and disposal is also weak, because like I told you that it has entered in the most remotest corner of India, but people don't know where I should dispose, or there is no the local bodies also lack knowledge in collection and its disposal. So obviously all of this results into this plastic being leaked into the environment. So it goes into the land, water, and obviously then ends up harming the marine life and the wildlife. So these are some of the reasons why plastic pollution is happening. So how to reduce it? Is there a very scientific and a technological way at your own at your own home that you can do? I think that is something you don't really need to do. You probably need to take very basic steps in reducing your own plastic pollution. First of all of you should start segregating waste efficiently. You should have 3 bins instead of 1 dustbin. One goes to organic waste, one goes to dry waste, under which all types of plastic, paper, metal, glass, wood, rubber, everything comes. And then obviously the last is rejected waste, where there is any cotton, blood-stained cotton, sanitary waste, all of this that can be infectious and hazardous can go into that dustbin. So waste segregation is must and is extremely important, and I think everybody should follow it. It should be a rule rather than an option. You need to create awareness about this as well. Basically, I think this particular cause needs much more talking, much more education. And I think wherever you are in this country, please explain this to your family, friends, and peers that they should start acting on, plastic recycling and waste segregation at source. You can tie up with your local recycler, whoever it is, and, ask them questions, whether what type of waste you can give. All of these things you can, discuss with them and have a good system of, donating your plastic waste to them, and obviously stop littering. And the last but not the least is to follow the 5 R's. First of all, we all should actually focus on reducing and the waste. We should focus that there should be least waste that goes out of my house. So for that, you can refuse, have reusable bags that you can use for shopping. Then reduce, whatever you're buying in small, portions, go for a bulk consumption. Reuse certain things. I think we all are a good fit example of reuse, especially when you stay in India, where your clothes, your toys, your books are all passed down to your siblings. So this particular habit is already ingrained to us. So all we need to do is also extend that to a lot of things that we use in our daily lives. If you have a musical instrument that you don't want to use anymore, instead of throwing it, you can just pass it on or donate it to somebody, and they can have they can reuse it, and have that particular life of the product is extended. Then repurpose. Obviously, if you are a person who is very good at craft, then you can convert a lot more plastic waste into very beautiful art and craft products. Compost your organic waste, and you can repurpose it into a very good fertilizer and a very good a compost or a manure for your plants. And when all of these R's are over and you still have your waste left, that's the last thing you do is recycle. And for that, you will need to tie up with your local recycler. So have the focus on thinking that how much I am generating, how I can reduce, how I can bring this particular value down, and and then in the end I do also do responsible recycling. So why recycle plastic? I think everybody talks that stop using it. Why you should even recycling it? It is difficult to live without it because it has become a very ingrained part of our life. So some of the applications or some of the things in your life, like for example medicine strips or any medical products, or in fact your folders, your stationery, are something that you just use in and out and you cannot live without it. So definitely we should stop and minimize wherever we can. But if we are able to recycle, then how it is going to help us? Recycling plastic leads to a clean environment. you will not spot it into the environment, into the, into the beach or into the land or into the soil. So when you recycle, all of that is then put to use into making different products. So it stops leaking into the environment, and obviously, it leads to a much more clean nature. Boost the economy. We obviously, it's a very good revenue generating stream, and obviously it does add to the economy of the country. Now we don't need to import a lot more plastic, but we can reuse and recycle and have our own plastic waste being a very valuable resource and bringing us much more revenue to the country. Less carbon footprint. Like I told you, that plastic is green, so obviously recycling is greener than even manufacturing. So that obviously leads to a much more lesser energy intensive process when it comes to recycling. Generates employments. Obviously, when we started 5-hour cycle, we had only 2 people who were working, myself, and there was one girl who had joined who would help me in the waste segregation. But now it has expanded to a team of 8 people. And I'm really glad, and I really feel that this particular venture and any particular recycling venture will always be a great opportunity for a lot more people to have to earn their livelihood. And we feel proud that at least from the staff of 2, today we have multiplied the 8, and we are able to support the livelihood of 8 people. So obviously it's a good employment generating stream. And the last and not the least, it's conservation of natural resources. We are extracting and mining all the petroleum out of, and obviously the plastic is definitely made out of that. So if we recycle it, we have to be less dependent on all these resources, and we can pretty much just keep using them into our own particular circle, and have less dependency, and stop giving less damage to the environment. Just to tell you what are the type of plastics that you will find around, and what's a recycling code. So a recycling code is a number that pretty much indicates the type of plastic that's used to manufacture a particular plastic product. So you will see different numbers, 1, 2, 3, 4, 5, 6, 7. And remember that the particular number doesn't stand for the number of times it's recycled. It's actually indicating the type of plastic used. So, for example, your bottles are made of PET. The shampoo bottles or Harpic bottles or oil cans are made out of HDP. Your milk bags are made out of LDP. So you will, find this triangle, and the number actually indicates the type of plastic that's used. And also one of the questions that people also ask me is that, is this plastic that's being used for my food, it's going to leak into the food or something like that? But that's not absolutely true, because all the plastic, especially used in food and beverage, are certified for food application. So they are being tested so that, you are safe and there's no chemical or anything leaching into your food or beverage. So, like we told you, plastic recycling helps, or, plastic recycling is important. Watch the codes. I tried to understand the types of plastic. So what is actually all this recycling, or what is the word recycling? So basically, recycling is a process where you can convert the plastic waste into a same value product, or a low value product, or a high value product. And that's why it's actually bifurcated into recycling, downcycling, and upcycling. So the processes are dependent on what you make out of that plastic waste, and what value you add to that. So let's talk to specifically recycling. So in recycling, you actually collect all the plastic, clean it, and then melt it, or pressurize it to make t-shirts, benches, bottles, or any kind of lumber product that you can see in the slide. And the t-shirt that I am wearing is actually made out of 12 plastic bottles. So it's a resource, right? You've converted this plastic waste into a resource and created such beautiful products. And these are of similar value, because obviously when you convert it, it definitely has some reduction in properties, and that's why the products that are made out of it obviously have to be mixed with a little bit the virgin plastic to have that particular good quality for the specific application. Then upcycling. Upcycling is where you add value to your plastic waste. So if you are a person who is good at craft, like I told you before, you all can make so many different types of high value products out of it. Like you can see there is a bird feeder, or people make nice plant potters and so many other things. And also plastic wrappers have been also used to create some beautiful products like bags and bottles, where they make the plastic fabric out of it, and or diary covers or laptop sleeves, etc. So many different types of new products are coming out, especially of plastic waste. And obviously this process adds a lot more value, so now your waste is converted into something that's of high value. Now downcycling. Downcycling is where you convert the plastic into its own, back to its chemical form, and it's no more, it will not be found anymore, and it has gone into a certain application. So we all know that it's being used for roads, it's being used for making eco bricks, it's being used for generating energy and for fuel, and one of the reasons why plastic is also used for fuel or for energy, it's because it has really high calorific value, and burning of that generates good amount of energy that can be used in cement kilns or or factories. So now you have converted this particular plastic waste to a form of energy, which can be in the form of electricity or which can be in the form of a fuel. How can you contribute? Obviously, through practicing the 5 R's, like I told you. Segregate your waste, do not litter, take care of your surroundings wherever you go. And the most important thing is educate people. I think every day we should have a target of educating only one person. Make sure that their habits are changed, especially in terms of waste segregation, and tell them the importance of plastic recycling, tell them the importance of electronic waste recycling, or in fact tell them that every resource that you extract from the environment is extremely important, and we all are indebted to that, and we all should use them wisely and responsibly. So thank you everyone for listening to me, especially IISER Pune, who gave me the platform to talk about this really important and crucial topic, which is the need of the hour. And all the attendees who are watching this, I think a very deep and personal message from my side would be to practice the 5 R's, which is the refuse, reduce, reuse, repurpose, and recycle. All of these small steps and small contributions can create a huge change for our environment. Remember that there is no planet B. The earth is our only planet. It has been really generous to give us all these different type of resources and make our life convenient, make our life beautiful. So we owe a lot to it, especially. And I think this particular small action of waste segregation and practicing the 5 R's can definitely be a token of gratitude towards this earth, our own way of giving back to the environment. So do start thinking about waste. Stick to this theme, do this beautiful theme of National Science Day, which is really concrete because we all think about a sustainable future. And I think if we act today, we will definitely have a great vision of sustainable future.
हेलो फ्रेंड, विश यू अ वेरी वेरी हैप्पी साइंस डे। आज हम पूरे देश में साइंस डे मना रहे हैं और हम आईसर में भी बहुत अलग अलग प्रोग्राम आपके लिए रखे हैं। और आज का जो सेशन है, अभी का जो सेशन है, बिल्कुल है हैंड्स ऑन साइंस। और मुझे मालूम है जितने भी हमारे बच्चे हैं, टीचर्स हैं, पेरेंट्स हैं, सभी को ये सेशन में बहुत मजा भी आ जाएगा और आपको बहुत आइडिया मिल जाएगा हाउ टू एक्चुअली लर्न साइंस एंड मैथमेटिक्स कंसेप्ट बाय यूजिंग द एक्टिविटी। तो मैं ज्यादा से ज्यादा आपको एक्टिविटी दिखाऊंगा और उसके पीछे क्या साइंस है, क्या मैथमेटिक्स है, तो उसके बारे में आपको बोलूंगा। तो चलो हम शुरू करते हैं फन विद हैंड्स ऑन साइंस। अभी देखिए, आज के प्रोग्राम की मैं शुरुआत ऐसी करता हूं, काइंड ऑफ द इनॉग्रल एक्सपेरिमेंट। और वो एक्सपेरिमेंट क्या हो सकता है आपको गेस करना है और बाद में आपको पता चलेगा और ये एक्सपेरिमेंट मैं घर में भी कर सकता हूं। इट इज वेरी वेरी इजी एक्सपेरिमेंट। अभी देखिए, मैं बाद में बताऊंगा इसके अंदर क्या है। एक तो क्या है, बॉटल है, इतना तो पता चला। बलून है और बलून के अंदर क्या है आपको बाद में मैं बताऊंगा। एक लिक्विड बॉटल के अंदर और बलून जो है, बलून में के अंदर कुछ पाउडर है और वो पाउडर क्या है, अभी देखो वो क्या रिएक्शन करने वाली है। सो इनॉग्रल एक्सपेरिमेंट इज रिएक्शन विद लिक्विड विद दिस पाउडर। अभी देखिए क्या हो रहा है, अभी देखिए क्या हो रहा है। मैं ऐसा इसमें डाल रहा हूं, देखिए मैंने डाल दिया है और अभी देखिए देखिए क्या हो रहा है। यहां मैंने एक लेटर भी लिखा है, अभी देखते हैं क्या हो रहा है इसका। देख रहे, आपके लिए थोड़ा सा उल्टा होगा ये, क्योंकि मैंने तो यस लिखा है। वेरी नाइस। अभी मैं थोड़ा हिलाता हूं इसे, उसके ऊपर यस है। और अभी मैं दूसरा बॉटल हाथ में लेता हूं, वही उसमें भी वही है। देखिए अभी ये भी मैं बॉटल हाथ में लेता हूं। हाँ, अभी आपके लिए थोड़ा सा उल्टा होगा। विश यू हैप्पी साइंस डे। एक के बलून के ऊपर मैंने एस लिखा है और दूसरे बलून के ऊपर मैंने डी लिखा है, मतलब साइंस डे। ये मुझे लिखाना था। तो ये जो है अंदर, ये विनेगर, इसके अंदर विनेगर है और इसमें भी विनेगर है। और जो मैंने बलून में जो डाल दिया था वो था पाउडर बेकिंग सोडा। तो अभी दोनों की रिएक्शन हो जाएगी, ये तो आपको मालूम है। और रिएक्शन के बाद क्या बन जाएगा, कार्बन डाइऑक्साइड। ये मतलब इसके दोनों के भी अंदर कार्बन डाइऑक्साइड है। अब ये कार्बन डाइऑक्साइड से ये बलून इन्फ्लेट हो गया। सो दिस इज द बेसिकली प्रोडक्शन ऑफ द कार्बन डाइऑक्साइड बाय यूजिंग द विनेगर अँड द बेकिंग सोडा। मला खात्री आहे की हा एक्सपेरिमेंट तुम्हाला नक्की आवडला असेल आणि तुम्ही पण घरी जरूर करून पहा की तुम्हाला फक्त विनेगर, त्याला आपण म्हणतो ऍसिटिक ऍसिड, डायल्यूट ऍसिटिक ऍसिड असतं, आणि पावडर जी होती ती बेकिंग सोडा किंवा आपण त्याला म्हणतो खाण्याचा सोडा, या दोघांची रिएक्शन होऊन इथे CO2 कार्बन डायऑक्साइड बनलेला आहे। हा आपला इनॉग्रल एक्सपेरिमेंट होता। किती मजेची गोष्ट आहे। आणि याच्यानंतर पुढे तुम्हाला आणखी गमती जमती करता येतात। तुम्हाला काय गमती जमती करता येतात पहा, इसके अंदर जो गैस है CO2 है, बाद में आप निकाल सकते हैं। और निकालने के बाद आपको क्या करना है, यहां एक ऐसा मैं निकाल के देखिए आपको दिखाता हूं। निकाल के, या अभी मेरे हाथ में जो बलून है, अभी मैं दूसरा भी बलून ले लूंगा। अभी इसके अंदर देखिए ये CO2 है, अभी CO2 से भरा हुआ है। ओके, अभी मैं दूसरा एक बलून लेता हूं, बिल्कुल एक ही पैकेट के, कलर थोड़ा अलग है लेकिन एक ही पैकेट के हैं। मैं थोड़ा सा बाजू में देता हूं, तब तक ये भी इन्फ्लेट करता हूं। अब दोनों भी बलून में एक साइड, मतलब एक साइज के बनाता हूं। अभी देखिए, एक में क्या है, मेरी रेगुलर जो अंदर से हवा आ गई वो है, इसमें CO2 है। आप घर में करके देखिए, थोड़ा सा ये रेजिस्टेंस और होना नहीं चाहिए। ये रेजिस्टेंस तो होगा ही, मतलब जो मतलब फैन का हवा नहीं होना चाहिए, बाहर नहीं करना चाहिए। और दोनों एक साथ यदि मैं छोड़ता हूं तो आपको ये देखना है कि कौन सा बलून जल्दी नीचे जाता है। अभी और एक बार मैं आपको दिखाता हूं। रेड बलून में CO2 है और येलो बलून में जो है क्या है, मेरी हवा जो मैंने ब्लो किया था। अभी देखिए एक साथ देखो, दोनों भी कौन सा जल्दी जा रहा है नीचे। आपको फ्रैक्शन ऑफ सेकंड में देखना है, क्योंकि इतना ज्यादा डिस्टेंस नहीं है, मैं ज्यादा और ऊपर भी नहीं कर सकता। देखिए रेड जो है ना, वो जल्दी नीचे जा रहा था। यू नो द CO2 इज हेवियर देन, क्या, किससे हेवियर, हवा से। जो हवा का जो मिक्सचर है CO2, उसमें एक छोटा सा पार्ट है, लेकिन हवा में मेनली नाइट्रोजन एंड ऑक्सीजन होता है और बाकी के भी कंपोनेंट हैं। लेकिन CO2
कैसा हेवी होता है एज कंपेयर टू द होल एयर, ये आपको पता चलता है कि CO2 इज हेवियर देन द एयर, और इसीलिए वो जल्दी जा रहा था। और ये छोटा सा एक्सपेरिमेंट मैं बाद में बताता हूँ मेरे साथी को। अभी ये CO2 जो है मैं ये ग्लास में भरूंगा ना बाद में, और उसके अंदर यदि मैं कैंडल भी छोड़ता हूं तो आपको पता चलेगा कि ये कैसा कैंडल एक्सटिंग्विशर है। तो मैं मेरे साथी को रिक्वेस्ट करता हूं, तो बाद में इसमें जो है CO2 हमें कैंडल कैसी पूछ सकते हैं वो लास्ट में हम दिखाएंगे, लगभग 15 मिनट के बाद हम दिखाएंगे। ये जाएगा ग्लास में और उसके अंदर आप कैंडल छोड़ दो, मतलब कैंडल की फ्लेम छोड़ दो। दिस इज वन एक्सपेरिमेंट। नाउ द अनदर सिंपल एक्सपेरिमेंट। आज मैं थोड़ा सा आपको ग्लिम्स ऑफ द एक्सपेरिमेंट दिखाने वाला हूं। थोड़े से फिजिक्स के होंगे, थोड़े से केमिस्ट्री के होंगे, थोड़े से बायोलॉजी के होंगे, और मैथमेटिक्स की भी कुछ एक्टिविटी होंगी, तो ये मैं आपको कोशिश करूंगा। अभी देखिए, दिस इज सिंपलेस्ट वन। अभी मैं क्या करूंगा, आपको एक सिंपलेस्ट जनरेटर कैसा हो सकता है वो दिखाने की कोशिश करूंगा। अभी देखिए, आई हैव हियर सिरिंज, और सिरिंज में जो है ना बेसिकली आई हैव वाउंड 1000 टन्स ऑफ द इंसुलेटेड कॉपर वायर, मतलब तांबे के जो तार है ना उसके ऊपर हमने लपेट दिया है 1000 टन्स, और उसके जो दो एंड्स हैं यहाँ अपने एक छोटे से बल्ब को जोड़ दिए हैं। दिस इज वेरी वेरी सिंपल। अभी जो मैग्नेट है मेरे हाथ में, दिस इज वेरी वेरी स्ट्रॉन्ग मैग्नेट, इसके अंदर मैं डालता हूं। मैग्नेट डाल दिया मैंने अंदर, और अभी देखिए मैं थोड़ा सा इसे दिखाता हूं। अभी देखिए अंदर क्या है, मैग्नेट बस, और अभी इसके अंदर देखिए मैग्नेट एंड द सिरिंज। मैं थोड़ा सा नजदीक आके आपको दिखाता हूं, कोशिश करता हूं। देखिए, कैन यू सी द लाइट? अभी देखिए कुछ नहीं अंदर, खाली मैग्नेट है और कॉपर कॉइल, ये दोनों का जो इंटरेक्शन मैं आपको दिखा रहा हूं। एंड यू कैन सी द लाइट। बेसिकली दिस इज द सिंपलेस्ट जनरेटर मैं आपको दिखा रहा हूं। तो इलेक्ट्रिसिटी कैसी प्रोड्यूस होती है, तो इसका एग्जांपल है ये। क्या एग्जांपल? इलेक्ट्रिसिटी जनरेटर का एग्जांपल मैग्नेट एंड द कॉपर कॉइल। अभी देखिए, अभी देख रखिएगा, फ्रेम रेट का थोड़ा सा ही होता है, इसलिए मैं आपको ज्यादा जल्दी दिखा रहा हूं ये। यस, वेरी गुड, आपने देखा होगा ये। सो दिस इज द प्रोबेबली सिंपलेस्ट जनरेटर वी हैव मेड यूजिंग द कॉपर कॉइल एंड द मैग्नेट। और इसकी मजा देखिए, इसकी मजा क्या हो सकती है। देखिए, मतलब हर पावर स्टेशन, मतलब जहाँ हाइड्रो पावर स्टेशन हो सकता है, एटॉमिक पावर स्टेशन हो सकता है जो जहाँ इलेक्ट्रिसिटी बनती है, या कोल पावर स्टेशन हो सकता है, विंड पावर स्टेशन हो सकता है। तो इसमें जो इलेक्ट्रिसिटी जो बनते हैं ना, दिस इज द बेसिक प्रिंसिपल behind that. You need magnet, you need copper coil, and there should be the interaction between these two. तो ये तो मैंने सिंपलेस्ट दिखा दिया, लेकिन उसका मैं आपको और एक एग्जांपल दिखाता हूं यहाँ। तो बेसिकली दिस बॅकवर्ड अँड फॉरवर्ड मोशन इज व्हेरी व्हेरी डिफिकल्ट. आपण जेव्हा असं मागे पुढे करतो ना तेव्हा ती मोशन फार निसर्गामध्ये अवघड असते. तर रोटेशन ही सगळ्यात सोपी पद्धत आहे पहा. आता त्यासाठी एक आपण वेगळं मॉडेल बनवलं. काय बनवलंय पहा, इथे एक मोठासा स्पूल केलेला आहे 2 सीडीच्या साह्यानं. इथं तुम्ही पाहू शकता हा मध्ये गॅप आहे आणि रबर बँड लावलेला आहे त्याला आणि ते छोटी पुली. आणि त्याच्यानंतर इथे जे आहे ना, इथे बघा तुम्ही मॅग्नेट पाहत आहात, इथे मॅग्नेट पाहत आहात आतमध्ये. आता मी याला फिरवणार आहे आणि फिरवताना मुद्दाम थोडंसं असं दिसतो, म्हणजे तुम्हाला दिसायला सोपं होईल. कॅन यू सी द लाईट ना? सी व्हेरी नाइस, एक्चुअली यू कॅन सी द लाईट. तो बेसिकली दिस इज द बेसिक प्रिंसिपल बिहाइंड हाइड्रो पावर स्टेशन. ऐसा समझो, मतलब ये जो मेरा चक्का है, ये जो व्हील है, ये टर्बाइन समझो. अभी वहां पानी से वो घूमता है, यहाँ आई एम रोटेटिंग विथ हेल्प ऑफ माय मस्कुलर पावर. मेरे हाथ का जो पावर, मतलब मस्कुलर जो पावर है, उससे मैं रोटेट कर रहा हूं. लेकिन एक्चुअल केस में क्या होता है, पानी उसके ऊपर गिर जाता है, पानी, और ये पानी से घुमाता है. ओके, और ये बाद में किसे कपल किया है, ये छोटे से पुली को. और ये छोटे से पुली को हमने क्या जोड़ दिया है, देखिए यहाँ मैग्नेट है. और ये मैग्नेट जो है ना, ये जो मैग्नेट है, अभी देखिए इसका क्या हो रहा है, अब ये घूम रहा है अंदर, देखिए ऐसा घूम रहा है. और बाद में देखिए इफ आई रोटेट इट, कैन यू सी? अभी थोड़ा सा मैं ऐसा नजदीक आपको दिखाता हूं, यू कैन सी. Very nice, actually. This is the basic principle behind the hydro power station. और उसका और एक मैं आपको एग्जांपल बताता हूं, वो होता है विंड पावर स्टेशन. अभी विंड पावर स्टेशन में क्या होता है, सी द मैग्नेट्स, यहाँ मैग्नेट्स है, अंदर मैग्नेट्स है. ओके, कॉपर कॉइल तो आपने देखा है, द एंड्स ऑफ दिस कॉपर कॉइल वी जॉइन टू दिस एलईडी. और ये रोटेशन का जो तरीका है, ये हवा से होता है. यहाँ तो मैं अभी हाथ से करने वाला हूँ, लेकिन हवा से होता है. एंड यू कैन सी द, यहाँ अभी मैं हाथ से करूंगा. कैन यू सी द लाइट ना? देखिए थोड़ा सा हल्का सा, अभी जोर से मैं यहाँ ब्लो करूंगा, यू विल गेट द आइडिया ना. Can you see the light? So this is the simplest basically, yes, simplest basically जो होता है ना कि wind power station जो होता है ना, इसका एक example है. तो I am rotating the magnet in the coil. मतलब coil के अंदर जो है ना magnetic field change हो रहा है. मतलब जब magnet rotate होगा तो magnetic field copper coil के लिए कम ज्यादा, and that is nothing but basically normally we say changing magnetic field for the copper coil. And if you change the magnetic field in the copper coil, you get the electricity. And this is an example of the kind of the wind power usage station या windmill generator. मतलब हवा का रोल ये घुमाना, लेकिन अल्टीमेटली दिस पार्ट इज वेरी वेरी इंपॉर्टेंट. अभी मैं क्या करूंगा, वो जो कैंडल वाला जो पहला था ना, मैं आपको अभी भी दिखाता हूँ आपको, उसके दो मिनट में, तब तक उसमें CO2 भर दो तब तक. अभी देखिए, ये आप देखने के बाद what I am doing now, अभी ये देखो, ये जो क्या है, फिजिट स्पिनर है, और यहाँ हमने मैग्नेट जोड़ दिए. देखिए मैग्नेट जोड़ दिए. I will do in front of the camera. Okay, this is basically ये मैग्नेट है और ये तुम्हारा कॉइल है. और कॉइल के जो दो एंड्स हैं बेसिकली यहाँ जो है ये लेडी को जोड़ दिए हैं. अभी देखिए मैं थोड़ा सा जोर से घुमाता हूँ इसे. कैन यू सी लाइट ना? थोड़ा सा मैं जरा आपको अंधेरा करके दिखाता हूँ तो आपको ज्यादा अच्छा दिखाई पड़ेगा. कैन यू स्विच ऑफ दैट लाइट सो यू विल गेट द आइडिया. यस, वेरी नाइस. यस, यू कैन सी क्लियरली नाउ. Yes, they got the idea. This is the basic principle behind the, and this is a multi generator basically. मतलब इसके अंदर कितने कॉइल है? तो 4 हैं. ओके, 4 कॉइल अभी यहाँ चल रहे थे. अब लाइट फिर हम ऑन करेंगे, एक बार हम ऑन करेंगे. और अभी ये जो था, जितने अभी मैंने यहाँ 4 कॉइल क्यों लगाए थे, जस्ट आई वांट टू टेल यू, जितने नंबर ऑफ टर्न्स इन द कॉइल, जितना स्ट्रॉन्ग मैग्नेट, जितना स्पीड ऑफ रोटेशन ज्यादा, उतना आपको इलेक्ट्रिसिटी ज्यादा मिलेगी. मतलब अमाउंट ऑफ द इलेक्ट्रिसिटी व्हाट यू गेट ओवर हियर डिपेंड अपॉन मेनली 3 फैक्टर्स. 1, स्ट्रेंथ ऑफ द मैग्नेट, number of turns in the copper coil, and the speed of the rotation. So this is very very interesting. अभी चलो मैं वो कैंडल वाला एक्सपेरिमेंट आपके सामने करता हूँ. अभी मुझे मेरे हाथ में बलून दिया तो भी चलेगा, मैं करता हूँ कैमरे के सामने. दिस इज वेरी वेरी इंटरेस्टिंग एक्सपेरिमेंट. अभी दे दो मेरे हाथ में. अभी मैं क्या करता हूँ, यस, दिस इज वेरी नाइस एक्चुअली. ये देखिए इसमें CO2 था. अभी मैं वो CO2 जो है वो ग्लास में लेता हूँ, एक एम्प्टी ग्लास में लेता हूँ. अभी एम्प्टी ग्लास में CO2 कैसा लेना, देखिए हल्का हल्का यहाँ छोड़ना. CO2 से ये भर गया. और अभी जो दूसरा कैंडल जो है उसके ऊपर देखिए मैं ये लगाता हूं. अभी देखिए छोड़ता हूं, गया कैंडल. देखिए इसके अंदर तो कुछ नहीं था. द कैंडल इज मतलब क्यों एक्सटिंग्विश हो गया? CO2 से. मतलब CO2 कैसा फायर एक्सटिंग्विशर है ये भी आपको पता चला. और आपको लगा कि उसने क्या डाला था, कुछ नहीं डाला, CO2 डाला. यू कांट सी द CO2. तो CO2 आप देख नहीं सकते थे ना, इसलिए आपको दिखाई नहीं पड़ा. लेकिन ये CO2 से भरा था आपके सामने. और हाउ इट इज कैंडल एक्सटिंग्विशर या फायर एक्सटिंग्विशर, ये मैं आपको यहाँ दिखाना चाहता था. थैंक यू वेरी मच, मेरे दो साथी ने मुझे हेल्प किया. वेरी नाइस एक्चुअली, दिस इज वेरी वेरी नाइस एक्सपेरिमेंट. अभी थोड़े से जरा अलग अलग, मैं जैसे मैंने आपको बोल दिया था ना, कुछ अलग अलग एक्सपेरिमेंट दिखाऊंगा. थोड़े सब्जेक्ट थोड़े से अलग अलग हो सकते हैं. मैं थोड़ा सा फिजिक्स, थोड़ा सा केमिस्ट्री ये दिखाने की आपको कोशिश करूंगा. वन एक्सपेरिमेंट इज वेरी वेरी इंटरेस्टिंग. अभी मेरे सामने देखिए एक मैं बॉटल लेता हूँ और एक बलून भी लेता हूँ. देखिए अरेंजमेंट देखिए क्या है. इसमें देखिए एक बेंड स्ट्रॉ है, एक बेंड स्ट्रॉ, और इसमें हमने पानी डाल दिया है. और आपको देखने के लिए वी आर युझिंग हियर द कलर वॉटर. पाणी रंगीत फक्त वापरलंय तुम्हाला दिसावं म्हणून कॅमेरामध्ये, पण साधं पाणी चालेल आपल्याला. आणि इथे पाण्याने भरलेली बाटली आहे आणि हा जो स्ट्रॉ आहे इथपर्यंत गेलेला आहे पहा, म्हणजे याच्यामध्ये स्ट्रॉ आहे. आता मी माझ्या सहकार्याची मदत घेतो आणि हा फुगा फुगवतो पहा. हा फुगा फुगवतो आणि बघा गंमत काय होते. आपण त्याचं झाकण काढूया आणि त्याच्यावरती फुगा बसवून टाकूया. आता मी इथे फुगा थोड्या वेळ असा बंद करून ठेवतोय. आणि बघा आता मी रिक्वेस्ट करतो त्यांना की याचा आता याला फुगा बसवा तुम्ही. हे असं बसवून टाका याला. यस, व्हेरी नाईस. आता गंमत जी अशी आहे ना, तर याच्यावरती आपण फुगा बसवत आहोत. यस, व्हेरी नाईस. सगळ्याच बाजूने छान छान. इकडची बाजू आमची छान थोडी खाली गेली पाहिजे. तर आता आपण याच्यावरती फुगा बसवलेला आहे आणि एक मी भांड घेतोय पहा पाण्याचं. आता होत आहे का, तुम्ही जर नीट असेंब्ली इथे बघितली ना, पाणी आहे, पाण्यामध्ये आपण स्ट्रॉ घातलेला आहे तळापर्यंत बाटलीमध्ये आणि त्याच्यावरती फुगा लावलेला आहे. तर एयर प्रेशर हा जो कॉन्सेप्ट आहे, ये जो एयर प्रेशर जो कॉन्सेप्ट होता है, हम कितना इजीली सीख सकते हैं। अभी मैं थोड़ा चार्ट में आपको पूछता हूँ, रोहित, हनुमंत, ये जो लोग कुछ कमेंट कर रहे हैं ना, तो बता दो अभी, इफ आई रिमूव द हैंड, मेरा हाथ निकालूंगा यहां से, तो क्या होगा पानी का? स्ट्रॉ से क्या होने वाला है? कैन यू राइट इन द चार्ट? मैं अभी देख रहा हूँ चार्ट, ज्योति जी है और राजेश भी है यहाँ, अनीस भी है, प्रज्वल भी है। मैं सभी को पूछता हूं कि ये इसमें क्या होने वाला है। इफ आई रिमूव द हैंड, चलो अभी कमेंट आना वो शुरू भी हो जाएंगे, तो थोड़ा सा कमेंट आने तक मुझे एक 8 सेकंड का लैग होता है, लेकिन आपको आंसर देना है। इफ यू रिमूव माय हैंड, मेरा हाथ मैं निकाल देता हूं, मतलब बलून में जो हवा है वो बॉटल में जाने वाली है, तो क्या होने वाला है? भूषण बोल रहा है कि पानी आएगा। चलो, भूषण ने बोला है कि पानी आएगा। सुजल बोल रहे कि वाटर, मतलब पानी बाहर आ जाएगा। वाटर विल फ्लो, चलो वाटर विल फ्लो। यस, वाटर विल स्पिल इन द बोल। चलो जो कुछ जो है अभी देखिए, 1 2 3, आई एम शोइंग यू। अभी देखिए, कैन यू सी दिस वेरी वेरी नाइस फाउंटेन। बस मैं यहाँ पकड़ता हूँ, ऐसा दबाता नहीं मैं, देखिए बॉटल को कुछ नहीं दबा रहा। So this is a very very interesting actually water fountain you can create just with help of the balloon and balloon pressure. Very nice actually. Yes. अब देखिए एंड में क्या होगा, ध्यान से देखो एंड में क्या होने वाला है, ध्यान से देखो। देखिए बिल्कुल खाली हो गया। So this is a very very nice experiment, ये जो मैं आपको बताना चाहता था, क्योंकि देखिए इसके अंदर हवा थी, प्रेशर की हवा, ये जिसमें प्रेशर था। मतलब देखिए जब कौन से भी बलून में हम हवा डालते हैं, तो ऐसा समझो अंदर का जो प्रेशर है थोड़ा सा ज्यादा होता है कंपेयर टू द आउटसाइड प्रेशर। तो मतलब ये ज्यादा प्रेशर की हवा है अंदर, और यही हवा यदि ज्यादा प्रेशर की है, तो व्हाट इज द रोल ऑफ दैट एयर? वो बॉटल में जाने की कोशिश करेंगी प्रेशर मिनिमाइज करने के लिए। तो बॉटल में तो ऑलरेडी पानी है, तो बॉटल में क्या हो जाएगा, एक प्रेशर बन जाएगा ड्यू टू दिस एयर, और ये प्रेशर पानी के ऊपर ही गिरेगा। तो पानी के लिए जाने के लिए कहाँ रास्ता नहीं था, तो बिल्कुल यहां से पानी यहां बाहर निकला। सो दिस इज अ वेरी वेरी पॉपुलर एक्सपेरिमेंट, नॉर्मली वी शो फॉर स्टूडेंट एंड द टीचर्स। अभी देखिए मुझे बहुत कमेंट आ रहे हैं, वाटर विल कम आउट, बिल्कुल वाटर विल कम आउट। बहुत मुझे कुलदीप ने भी मुझे आंसर दिया है, कुलदीप पाटिल, आरती ने भी उत्तर दिया है मुझे, प्राजक्ता ने उत्तर दिया है। चलो वेरी गुड। तो ये आपको अभी मैं थोड़ा सा आपको ट्रिकी क्वेश्चन पूछता हूं, अभी मैं करके दिखाऊंगा नहीं, लेकिन दिस इज द होमवर्क फॉर यू। वही एक्सपेरिमेंट देखिए, व्हाट वी डिड विथ हेल्प ऑफ द 3 बॉटल, आपको करना है, यहां मैं दिखाऊंगा नहीं, जस्ट आई एम गिविंग यू द आइडिया। वो आइडिया क्या हो सकता है, यू हैव द 3 बॉटल्स, 3 बॉटल्स है देखिए आपको, और ये तीनों बॉटल के अंदर एक स्ट्रॉ है, और आपको देखिए बलून के लिए तो ये कौन सा ना कौन सा बॉटल आपको ओपन ही चाहिए, चाहे आप मिडल वाला भी ले सकते हो, चाहे आप ये भी ले सकते हो, और यहाँ बिटवीन दीज बॉटल्स पाइप है ये, और ये पाइप से तो हवा इधर उधर जा सकती है, देयर इज अ पाथ, हवा जाने के लिए पाथ है। तो आपको ये क्वेश्चन है, क्या क्वेश्चन है, यदि मैं यहाँ बलून बिठाऊंगा और समझ लो कि इसके अंदर पानी है, तो क्या होने वाला है, क्या हो सकता है? मतलब जिस बॉटल को बलून है वही बॉटल से पानी बाहर आएगा, या दूसरे बॉटल से भी आएगा? मतलब एक से पानी बाहर आएगा, या 2 से आएगा, या 2 से आएगा, या तीनों से भी आएगा, एंड यू हैव टू डू इट। लेकिन ऑल दीज 3 बॉटल्स कनेक्टेड विथ हेल्प ऑफ द पाइप, इसलिए मैं आपको ऐसे में दिखा रहा हूं। ये आपको घर में करके देखो, दिस इज वेरी वेरी एक्सपेरिमेंट, नाइस एक्सपेरिमेंट। और दूसरा, उसमें क्या मॉडिफाई करना है, ये आपने यहां पाइप लगा दिए हैं 2, ये 2, अभी समझ लो कि आप यहां पाइप लगाओगे, बॉटम में पाइप लगाओगे, तो क्या होगा? ट्रिक है, मतलब आप जितने जैसे सोचते हैं ना वैसा होगा, ऐसा नहीं, यू जस्ट डू इट। मतलब ये पाइप तो अभी ऊपर है, लेकिन दूसरे एक मॉडल में मैंने क्या किया है, पाइप नीचे लगा दिए है, एंड देन व्हाट वुड हैपन इन दैट केस, ये आपको बताना है। तो मुझे बहुत चार्ट में आंसर भी मिल रहे अभी। अभिषेक बोल रहा है नीलिमा, वाटर विल कम आउट साइमल्टेनियसली जो है ना, नीलिमा माने बोल रहे हैं कि वाटर विल फ्लो आउट साइमल्टेनियसली। मतलब ऐसे ही आंसर है बाकी के लोगों के, अभी थोड़ा मुझे रीड करने के लिए दूर है मेरे पास से मशीन, लेकिन वाटर विल कम आउट फ्रॉम ऑल 3 बॉटल्स, ये परी बोल रही है। गुड। तो अभी मैं देख रहा हूं यहाँ कि ये इसमें पाइप यहां लगा दिया है और बाद में एंड में लगा दिया, तो क्या होगा आप करके देखो, तीनों से कब आएगा या एक से कब आएगा और या 2 से कब आएगा, यू विल गेट द आंसर थ्रू एक्सपेरिमेंट। इसलिए मैं अभी ये बताऊंगा नहीं आपको, ये करने के लिए बोलता हूं, लेकिन बिल्कुल यहां प्रेशर क्रिएट हो जाएगा, यहां ट्रांसफर हो जाएगा वो, लेकिन कैसा होगा यदि इफ यू चेंज द पोजीशन ऑफ द पाइप्स, इंटरकनेक्टेड पाइप्स, तो आपको ये सोचना है। तो ये थोड़ा सा मैं बाजू में देता हूं और बॉटल से और मैं 2-3 आपको सिंपल एक्सपेरिमेंट दिखाता हूं, आप ये करके देखो, जब आप करोगे ना तो ही आपको पता चलेगा। अभी देखिए ये मेरे पास 2 है बॉटल, बिल्कुल मैंने 2 करके रख दिया था आपके लिए, लेकिन चलो मैं आपको एक दिखाता हूँ, पूरा असेंबली में आपको समझाता हूँ इसमें क्या है। इसमें कुछ नहीं, देखिए एक पाइप है स्ट्रॉ और यहाँ ढक्कन में डाल दिया है, देखिए ढक्कन में, और इसमें कलर पानी है, मैं पानी ही इस्तेमाल कर रहा हूँ, टैप वाटर ही मैं इस्तेमाल कर रहा हूं, लेकिन कलरफुल क्यों लिया मैंने, दिस इज फॉर कैमरा पर्पज ओनली, नहीं तो आप देख नहीं सकते थे यदि मैं ट्रांसपेरेंट मतलब रेगुलर पानी लेता तो। अभी बस इसमें ये डालता हूं, लेकिन ये स्ट्रॉ का लेंथ कितना होना चाहिए, इसके अंदर वो डीप होना चाहिए पानी के अंदर, बस ये कंडीशन है, बाकी कुछ नहीं। और आपको हाथ को अभी यहाँ टच करना है, अभी मैं थोड़ा सा इसे आपको बताता हूँ। पानी अभी थोड़ा सा मैं लेवल ऐसा शायद पकड़ूंगा कि आप देख सकते हैं आराम से। अभी देखिए वाटर लेवल का क्या हो रहा है, बता दो क्या हो रहा है, आप देख रहे हैं ना, मैं थोड़ा सामने आ जाऊं, यस वेरी गुड। अभी वाटर लेवल का क्या हो रहा है, बॉटल के अंदर स्ट्रॉ जो है उसमें क्या हो रहा है, मैं अभी चार्ट देख रहा हूं यहाँ, अभी देखता हूं, अब बताना है आपको, ये स्ट्रॉ में पानी तो ऊपर गया, आपने देखा, देखिए कितना हाइट का पानी, अभी मैं थोड़ा सा एंगल बदल दिया तो आपको क्लियरली पता चल रहा है इतना पानी ऊपर क्यों गया। कैन यू राइट योर आंसर इन द चार्ट, रिजल्ट तो आपको मिल गया, पानी तो ऊपर गया, लेकिन इफ यू एक्सप्लेन इसके पीछे क्या कारण हो सकता है। देखिए अभी आपको लग रहा होगा कि मैंने दबा दिया है, कुछ नहीं, देखिए वैसा ही मैंने पकड़ दिया, कुछ दबा नहीं, इतना हाइट का पानी है, देखिए इतना, आप कैमरा में भी अच्छा देख सकते हैं। तो अभी वो लेवल कम होता जा रहा है, देखिए ओरिजिनली ज्यादा था, इट्स राइजिंग, इट्स इंक्रीजिंग, यस सर आपने जो बोला है, वाटर विल कम अपसाइड। चलो ये मुझे वाटर विल कम अपसाइड जयश्री बोल रही है, हाँ बाहर आ रहा है, हर्षा बोल रही है, कैपिलरी एक्शन कौन बोल रहा है, साइनी बोल रही है कैपिलरी एक्शन। चलो मैं अब देख रहा हूं कि चलो राधे क्या बोल रहा है, तो वो इट्स इंक्रीजिंग, ये लोगों का, आदित्य का इट्स इंक्रीजिंग, प्राजक्ता क्या बोल रही है, हीट का वजह से। हाँ थोड़ा सा भी मुझे आंसर मिल गया, अभी आपका थोड़ा सा क्लू मिल गया, वजह भी आपने बता दिया, कारण भी बता दिया। अभी मैं आपको एक क्वेश्चन पूछता हूं, अक्सर आपको सभी को शायद मालूम भी हो सकता है, किसी को मालूम नहीं तो मैं बताऊंगा। हमारे बॉडी का टेम्परेचर, व्हाट इज आवर बॉडी टेम्परेचर, हमारी जो बॉडी है तो बॉडी का टेम्परेचर क्या है, जरा चार्ट में लिखो। देखिए अभी मुझे थोड़े 8 सेकंड डिले होता है, आई एम आस्किंग यू द क्वेश्चन व्हाट इज द टेम्परेचर ऑफ द ह्यूमन बॉडी, और मैं एवरेज टेम्परेचर की बात कर रहा हूं। चलो अभी आंसर आने से पहले मैं आपको बताता हूं, ये प्लास्टिक का बॉटल है और मैंने यह बिल्कुल दबाया नहीं था, बस मैंने टच किया था मेरे हाथ से, हाँ। और अभी देखिए लेवल कैसा कम होता जा रहा है। अभी हीट तो कारण आ गया, लेकिन मैंने क्वेश्चन पूछा था आपको व्हाट इज द टेम्परेचर ऑफ द आवर ह्यूमन बॉडी, एवरेज टेम्परेचर में बात कर रहा हूं। चलो 37 डिग्री बिकॉज ऑफ हीट, शक्ति बोल रही है, साक्षी बोल रही है 37, सुपरस्टार कोई वो बोल रहे 36, अमव बोल रहे 36, ज्योति बोल रही है 37, आयुष 37, आयुष ने फिर 2-4 बार तो लिखा है, कुंदन पाटिल बोल रहे हैं अपर आ रहा है, पहले एक्सपेरिमेंट का शायद आंसर हो सकता है। चलो फ़ारेनहाइट में कोई बोल रहा है 98.6 फ़ारेनहाइट, यस भी कोई बोल रहा है, चलो वेरी गुड। तो 37 डिग्री जो टेम्परेचर हमारा ह्यूमन बॉडी का जो है, हम तो ये मैं टेम्परेचर यहाँ बेसिकली दे रहा था, बस यहाँ यदि मैं टेम्परेचर देता हूं तो क्या हो रहा था, ड्यू टू माय बॉडी का जो टेम्परेचर है तो उसे हीट मिल रहा था, और ये हीट मिलने के बाद अंदर जो है हवा जो है वो एक्सपांड हो रही थी, एंड दैट एक्सपांडेड जो एयर होता है ना, क्योंकि बॉटल का तो वॉल्यूम फिक्स है तो वो अंदर प्रेशर क्रिएट करेगा, एंड दैट प्रेशर एक्चुअली पानी के ऊपर जाएगा, and that pressure try to push the water upside in the straw. इस straw के अंदर पानी क्यों गया? तो क्योंकि अंदर मैंने यहाँ ये बनाया था प्रेशर, क्योंकि मेरा बॉडी का जो टेम्परेचर है रूम टेम्परेचर से ज्यादा है, इसलिए अंदर की हवा एक्सपांड हो रही थी ड्यू टू माय बॉडी टेम्परेचर। और ये आपको ये तो कारण तो पता चला, लेकिन मैं आपको बोल रहा हूं कि ये बेसिक प्रिन्सिपल बिहाइंड द थर्मोमीटर होता है। तापमापी जे आपली असते ना, त्याला खाली मर्क्युरी असतो पहा छोटा, आता आजकाल तर आपण इन्फ्रारेड थर्मोमीटर वापरतो टेम्परेचर चेक करायला, डॉक्टर सुद्धा आपलं इन्फ्रारेड थर्मोमीटरने चेक करतात टेम्परेचर, लेकिन पूर्वी आपण तोंडात ठेवून किंवा इथे असं ठेवून असं एक थर्मोमीटर वापरायचो, आणि तो जो होता एकतर अल्कोहोल किंवा मर्क्युरी थर्मोमीटर। तर बेसिक प्रिन्सिपल काय, तो जो बल्ब असेल ना त्याला आपण टच केलं म्हणजे आपण त्याला टेम्परेचर आपल्या बॉडीचं देतोय, आणि त्यामुळे तो एक्सपांड होणार ते लिक्विड किंवा मर्क्युरी असेल त्याच्यामध्ये देतोय, आणि मग ते एक्सपांड होऊन त्या कॅपिलरी मध्ये जाणार, आणि मग त्याच्यानुसार करणार की तुम्हाला किती ताप आलाय, आपको कितना टेम्परेचर है, कितना बुखार है, और कितना वो रेज हो जाएगा। सो दिस इज अ वेरी वेरी सिंपल एक्सपेरिमेंट यू कैन डू इन द होम। ये मैं छोटे छोटे एक्सपेरिमेंट आपको क्यों दिखा रहा हूँ, क्योंकि इससे आपको पता चलेगा कि क्या मजे की चीज है। ये तो यहाँ अंदर प्रेशर बन रहा था, अभी मैं थोड़ी सी प्रेशर की बात कर रहा हूँ। अभी मैंने 2 बॉटल लिए हैं, अब ये 2 बॉटल है, मैं आपको, और दोनों में भी मैंने पानी डाल दिया, बस अपना टैप वाटर। थोड़ा सा कलर क्यों डाला है, खाली देखने के लिए। रोल ऑफ द कलर वाटर इज मतलब आपको देखने के लिए। अभी देखिए मैं असेंबली आपको बताता हूँ, मेरे साथी मुझे हेल्प करेंगे इस एक्सपेरिमेंट के लिए। तो अभी देखिए इसके अंदर जो है, मैं असेंबली कैसी है आपको बताता हूँ, बस ये खोल के दिखाता हूँ। 2 स्ट्रॉ हैं, ये छोटा है ये बड़ा है, और ये 2 हैं, और इस केस में भी 2 हैं, लेकिन इसमें फर्क क्या है, ये लंबा है ये छोटा है, लेकिन 2 छोटे सेम ही हैं। 2 छोटे स्ट्रॉ सेम हाइट के हैं, उनका डायमीटर भी सेम है, 2 छोटे जो है, इंटरनल डायमीटर सेम, लंबाई भी सेम। लेकिन ये और ये जो मेरे हाथ में पकड़ा है ना, ये दोनों में फर्क है, आप बिल्कुल देख रहे हैं, ये ज्यादा हाइट वाला, ये कम हाइट वाला, देखिए लंबाई वाला बोलो यहाँ। ओके, वेरी गुड। अभी असेंबली तो आपको पता चला। अभी मैं क्या करने वाला हूं, अभी इसको जो बिल्कुल जो है ना, मैं इसे ढक्कन लगाता हूं, ढक्कन लगाता हूं। और अभी दिस इज अ वेरी वेरी इंटरेस्टिंग एक्सपेरिमेंट है, आपको आंसर देना है। अभी देखिए मेरे नीचे एक बर्तन मैंने रख दिया है, क्वेश्चन सुनिए, अच्छी तरह से सुनिए, और आपको बस लॉन्ग या शॉर्ट इतना आंसर देना है, या सेम आंसर देना है, या वाटर विल नॉट फॉल इतना आंसर। नॉट भी दिया, यस भी दिया, लॉन्ग भी दिया, शॉर्ट भी दिया, तुम्हें समझ में आएगा। तो देखिए क्वेश्चन क्या है। अभी दोनों भी बॉटल मैं एक ही साथ एक ही हाइट से इसमें उल्टा करूंगा, मतलब ऐसा इन्वर्ट करूंगा, तो विच बॉटल विल गेट एम्प्टी फर्स्ट, कौन से बॉटल का पानी जल्दी खत्म होगा। ओके, ये क्वेश्चन है। तो पहला ये भी हो सकता है कि वाटर विल नॉट कम आउट, मतलब नॉट लिखो उस टाइम, वाटर कम आउट, वाटर विल कम आउट, वाटर विल कम आउट, मतलब उसका क्या हो सकता है आंसर, यस। दूसरा अभी क्या है, अभी आपको लगता है कि नेक्स्ट पार्ट ऑफ द क्वेश्चन इज विच बॉटल वुड गेट एम्प्टी, कौन सी बॉटल पहले जल्दी खत्म हो जाएगी, मतलब उसका पानी जल्दी खत्म हो जाएगा। देखिए दोनों बॉटल का वॉल्यूम सेम है, अंदर का पानी भी सेम है, ओनली चेंज इन द लेंथ ऑफ द स्ट्रॉ। तो कौन सी बॉटल जल्दी एम्प्टी हो जाएगी, ये क्वेश्चन जब मैं उसे इन्वर्ट करूंगा बिल्कुल 180 डिग्री में, मतलब बिल्कुल आर को जैसा अभी वही ऐसा पकड़ा है ना, बिल्कुल 180 डिग्री में उसे टर्न करूंगा। तो देखिए शॉर्ट, लॉन्ग स्ट्रॉ, स्मॉल वन, बिग वन, शॉर्ट स्ट्रॉ, ऐसे आंसर। वंदना बोल रही है स्मॉल, चलो मुमताज बोल रही है बिग, संजीवनी बोल रही है लॉन्ग, चलो मुझे समझ में आ रहा है आपका आंसर, क्योंकि लिखने में टाइम जाएगा। गणेश पवार बोल रहे हैं शॉर्ट, अश्विनी निपानी बोल रही है शॉर्ट, चलो तो बहुत लोगों का शॉर्ट आंसर है, कुछ लोगों का लंबा भी है। चलो मैं देखता हूं, अभी आपके तो 4 तो आ रहे थे मुझे, अभी 1 2, अभी देखिए मैं स्टार्ट करता हूं, 1 2 3 स्टार्ट। अभी देखिए, और आपके सामने है ये, मैं ऐसा ही पकड़ता हूं, आप देख सकते हैं आराम से, और कुछ दबाऊंगा नहीं, ये नेचुरली चल रहा है। देखिए तो दिस इज अ वेरी वेरी इंटरेस्टिंग एक्सपेरिमेंट, और आप घर में कर सकते हैं। जयश्री का आंसर है स्मॉल स्ट्रॉ, रीवा पाटिल का है स्मॉल, गार्गी का है लॉन्ग, बाद में सुपरस्टार कोई है बोथ बोल दिया है, ऑफिशियल किरण बोल रहा है लॉग। चलो अभी देखो, ध्यान से देखो यहाँ क्या हो रहा है, ध्यान से देखो। अभी लेवल में तो फर्क आ गया, देखिए लेवल में तो फर्क आ गया, लेवल में तो बिल्कुल फर्क आ गया, देखिए। वेरी नाइस। अभी देखिए इसमें पानी बचा है लेकिन इसमें खत्म हो गया, बिल्कुल खत्म हो गया, आप देख सकते हैं यहाँ। तो बेसिकली इसमें पानी क्यों बचा है और ये जल्दी क्यों खत्म हो गया, मैं थोड़ा सा उल्टा करके आपको एक बार फिर बताता हूं। अभी देखिए यदि मैं ऐसा पकड़ता हूं तो समझ लो कि देखिए यहां से जो पानी बाहर आ रहा था उसके लिए इतना हाइट है, और यहां से जो पानी बाहर आ रहा था उसके लिए इतना हाइट है। तो हाइट इज वेरी वेरी इंपॉर्टेंट। स्ट्रॉ का डायमीटर सेम है अंदर का, तो बेसिकली तो ये जल्दी क्यों खत्म हो गया, लेकिन बहुत लोगों का आंसर ये था, लेकिन एक्चुअली हुआ इसका। तर प्रेशर का मैं बात करता हूं तो प्रेशर का बात ऐसा है, तो ये मैं बताऊंगा। देखिए प्रेशर मेनली डिपेंड अपॉन P इक्वल टू रो जी एच, दिस इज द फॉर्मूला। P इक्वल टू रो जी एच, P मतलब प्रेशर, इक्वल टू रो मतलब उसका डेंसिटी, G ऑफकोर्स एक्सेलरेशन ड्यू टू ग्रेविटी, H मींस हाइट। तो इसमें क्या है ना, P इक्वल टू रो जी एच, हाइट ज्यादा है, H ज्यादा है, तो H ज्यादा इसलिए प्रेशर ज्यादा, इसलिए वो जल्दी जल्दी पानी बाहर यहां से निकला एज कंपेयर टू द छोटा स्ट्रॉ। ओके, दिस इज वेरी वेरी इंटरेस्टिंग एक्सपेरिमेंट। और ये छोटा मैंने क्यों लगाया था, बस हवा जाने के लिए। आप यहाँ भी होल्ड कर सकते हैं दूसरे साइड से, लेकिन यदि ऐसा रखोगे ना तो आपको टेम्पररी बंद करना पड़ेगा। हाँ, तो बस ये दूसरा स्ट्रॉ का जो छोटा जो स्ट्रॉ है ना उसका रोल बस उतना ही था, क्या था, बस अंदर हवा जाने के लिए जगह। तो दिस इज वेरी वेरी इंटरेस्टिंग एक्सपेरिमेंट। अभी मैं थोड़ा सा आपको है ना अलग टाइप के एक्सपेरिमेंट दिखाता हूँ। अभी एक मेरे हाथ में मैं एक स्ट्रॉ लेता हूँ। अभी देखिए मेरे हाथ में एक स्ट्रॉ है, और स्ट्रॉ में मैं क्या करूंगा, देखिए 2 कट लगाऊंगा, एक छोटा पीस बनाऊंगा एंड एक बड़ा, 2 स्ट्रॉ। बस एक ही स्ट्रॉ के 2 पीसेस हैं, ये छोटा ये बड़ा। अभी मैं क्या करूंगा, देखिए ये एक स्ट्रॉ हाथ में लेता हूं और कट कैसे लगाना है आप और एक बार आपको दिखाता हूं। ये देखिए ऐसा फ्लैटन करना है। अभी मैं एक बार दिखाता हूं, फ्लैटन करना है। और देखिए ये कट ऐसा लगा दो और बाद में दूसरा कट आपको ऐसा लगाना है। ओके, तो ये जो स्ट्रॉ में जो कट जो है ना, ये देखिए ये कट जो है ना, देखिए आप देख रहे हैं कि उसमें इतना गैप है, बिल्कुल इतना गैप है। ओके, वेरी नाइस। अभी मैं क्या करूंगा, दूसरा स्ट्रॉ का वही मैं कट लगाता हूं। अभी देखिए यहाँ एक कट लगाऊंगा एंड आई विल मेक 1 मोर कट। तो 2 कट्स मेरे हो गए ऐसे। अभी इसमें खाली आपको ब्लो करना है। अभी दिस इज अ वेरी वेरी एक्साइटिंग एक्सपेरिमेंट एंड आल्सो वेरी इजी, क्योंकि स्ट्रॉ आपको मिल जाएगा, आजकल पेपर के भी स्ट्रॉ मिलते हैं। देखिए ये ऐसा कर दो, दबाना है, नजदीक आ जाएगा, एंड इफ आई ब्लो फ्रॉम हियर, ये आवाज आप ध्यान में रखो, ये ध्यान में रखो। और मुझे चार्ट में भी बहुत आंसर आ रहे हैं, इट्स ओके। अभी ठीक है, थोड़ा सा फ्रोजन हुआ था शायद साउंड का, क्योंकि कुछ हो सकता है, मैं थोड़ा सा पीछे जाके करता हूं। अभी आ रहा है आवाज चार्ट में, देखो, यस बोलो मुझे। हाँ, अभी दूसरा मैं लेता हूं, देखिए। और कुछ मेरा फ्रेम फ्रोजन होता है, थोड़ा नेट का कनेक्टिविटी का प्रॉब्लम भी हो सकता है आपके साइड से। हमारा तो यहाँ अच्छा चल रहा है, क्योंकि मेरे साथी देख रहे हैं, कुछ प्रॉब्लम होता है वो मुझे बताएंगे बिल्कुल। लेकिन देखिए छोटा स्ट्रॉ, और दोनों में फर्क देखिए, छोटा स्ट्रॉ, बड़ा स्ट्रॉ, छोटा स्ट्रॉ। चलो, दिस इज वेरी वेरी इंटरेस्टिंग बेसिकली। अब ये इसका एक मजा मैं दिखाता हूं। ये जो मेरे मुंह के अंदर था, यू कांट सी व्हाट इज हैपनिंग इनसाइड माय माउथ, क्योंकि अंदर है। अभी मैं थोड़ा सा उल्टा करके यहाँ देखो क्या हो रहा है, मैं थोड़ा नजदीक आके आपको दिखाता हूँ, या थोड़ा नजदीक आके, और या यू जस्ट ऑब्जर्व ओवर हियर। Can you see the vibrations? Means vibration is the base of the sound. वाइब्रेशन से ही, मतलब कंपन से ही आवाज बनती है, ध्वनि बनती है, ये आपको यहाँ पता चला। किती मस्त गोष्ट आहे आपल्याला समजण्यासाठी। मला जाणवतं while blowing I feel that vibrations. तो ये vibrations is very very essential for getting the sound, ये पता चला। अभी फर्क क्या है, क्योंकि यहाँ तो साउंड बन रहा है, लेकिन यहाँ इतना लंबा, मतलब अंदर की जो हवा है कम होने के लिए, वाइब्रेट होने के लिए इतनी जगह है, और इस केस में इतनी जगह है, कम जगह है। तो बेसिकली क्वालिटी ऑफ द साउंड या टाइप ऑफ द साउंड, साइंटिफिक लैंग्वेज में हम उसे पिच बोलते हैं। पिच ऑफ द साउंड मेनली डिपेंड अपॉन कितना लंबा है ये। अभी मैं यहां से ब्लो करूंगा, यह आवाज, दिस इज अ वेरी वेरी लो पिच एज कंपेयर टू दिस हाई पिच, बहुत हाई पिच। इससे मतलब घर में हम बात करेंगे ना, तो घर में हमारी मदर है, फादर है, तो यदि फादर का आवाज कंपेयर करना है ऐसा हो सकता है, यदि मदर का आवाज कंपेयर करना है ऐसा हो सकता है, वेरी वेरी हाई पिच। मदर का जो हमारा आवाज होता है, मम्मी का जो आवाज है बहुत हाई पिच होता है। अभी देखिए एज कंपेयर टू फादर, चलो अभी देखिए यहाँ मैं दो से होल बनाता हूँ थोड़ा सा आइडिया आने के लिए। वाइब्रेशन से आपने देखा, लेकिन आई एम टेलिंग यू द बेसिक प्रिंसिपल बिहाइंड द फ्लूट। फ्लूट हमारा कैसा काम चलता है, बांसुरी हमारे कैसे काम करते हैं, अभी मैं बांसुरी आपको बताऊंगा। यहाँ अभी देखिए, यहाँ मैंने आपके लिए दो होल्स बना दिए, दो होल्स है बेसिकली। और अभी यहाँ जो है, और ये एक्सपेरिमेंट मैं बोलता हूँ कि लगभग 25 ईयर से हम कर रहे हैं, लेकिन इसमें इतने वेरिएशंस भी हो सकते हैं बाद में। बस मैंने अभी यहाँ दो होल किए, यू कैन मेक मोर होल्स, ये दो, लेकिन ये भी ओपनिंग है, ये होल समझो। तो अभी देखिए कितने टाइप्स के साउंड आ रहे हैं, आपको चार्ट में बताना है। ये 1 2 3 4 5 ऐसा नंबर लिखा तो भी मुझे चलेगा। अभी ध्यान से देखो, मैं अभी करूंगा एक्सपेरिमेंट एंड देन यू हैव टू राइट इन द चार्ट। अभी देखिए, लिखो चार्ट में। अभी तब तक मैं दूसरी एक्टिविटी दिखाता हूं। तो देखिए और एक बार दिखाता हूं, देखिए कितने आ गए आपको, कितने टाइप्स के साउंड आ गए, आवाज आ गए। अभी मैं दिखाता यहाँ और एक बार दिखाता हूँ। चलो वेरी गुड, अभी थैंक यू पिनिंग, ओके सो अमेजिंग सर। लेकिन नंबर बता दो अभी मुझे, ग्रेट जॉब। चलो मैं अभी सुन रहा हूँ 1 2 3 4, किसी ने 1 2 3 4 लिखा है, अर्नव बोल रहा है 4। चलो अभी देखता हूँ कितने नंबर आते हैं, और एक बार अभी। चलो संजीवनी बोल रही है, संजीवनी कुलकर्णी 3 31, तृष्णा 3, नीलिमा 4 बोल रही है, परी 3 बोल रही है, फिर गार्गी 3 बोल रही है, अमन 4, गणेश 3, अर्नव 4, परी 3। चलो और नेक्स्ट वर्जन, वेरी गुड, सिद्धि 3। 3 ही आएगी ना, क्योंकि 1 2 3 ये दो होल तो है, लेकिन दिस इज ऑल्सो वन मोर होल। तो अभी देखिए 3 ही आ जाएंगे। इफ यू मेक मोर होल्स, जितने होल है उससे एक ज्यादा, क्योंकि ये है ऑलरेडी, तो उतने आ जाएंगे। अभी देखिए उसका और एक बांसुरी जैसा, थोड़ा सा देखिए थोड़ी सी बेसुरी लगेगी आपको, लेकिन बांसुरी है ऐसा समझो, क्योंकि आई एम चेंजिंग द लेंथ ऑफ द वाइब्रेटिंग कॉलम इनसाइड द, क्योंकि चेंज कैसा होगा, ये ओपन किया मैंने तो यहां से हवा निकलेगी, ये ओपन किया तो यहां से निकलेगी, दोनों बंद किया तो यहां से निकलेगी। तो दैट वे आई एम चेंजिंग द लेंथ ऑफ द वाइब्रेटिंग एयर कॉलम। और ये एक एक्सपेरिमेंट आपके लाइफ में आप कभी भी भूल नहीं सकते, वो मैं आपको बताना चाहता हूँ। यहाँ अभी देखिए मैं क्या करूंगा, ये मैंने स्ट्रॉ लिया, देखिए ये ऐसे 2 कट लगा दिए, और अभी देखिए जितना फर्क ज्यादा है लेंथ में, उतना पिच में कैसा फर्क है। देखो देखिए, ये तो ग्रैंडफादर का आवाज हो गया हमारा, और ये मदर का। अभी मैं मदर से ग्रैंडफादर तक सभी बीच में जो आवाज है ना वो आपको दिखाऊंगा। अभी इसमें क्या करूंगा मैं, आई विल कट इट। अभी ध्यान से देखो मैं क्या कर रहा हूं। मजा आ गया ना आपको, सप्त स्वरों का दर्शन एक ही स्वर में, वेरी नाइस। अभी देखिए आपका सभी का, जितने भी हमारे ऑडियंस है, जितने भी लोग अभी देख रहे हैं ना, सभी के आवाज बचपन के कैसे थे, मेरा भी खुद का। अभी देखिए पता चला ना। तो बेसिकली मैं क्या कर रहा था यहाँ, तो मैं आपको ये लेंथ बदल रहा था स्ट्रॉ की, मतलब वाइब्रेटिंग एयर कॉलम का ऐसा मैं लेंथ बदल रहा था। सो दिस इज वेरी वेरी इंटरेस्टिंग एक्सपेरिमेंट साउंड वाला। मैं आपको और एक दिखाता हूँ साउंड वाला एक्सपेरिमेंट, लेकिन उससे पहले एक दिखाता हूँ। अब ये घर में करके देखो वाइब्रेशंस कितने एसेंशियल होता है। अभी देखिए बहुत मुझे गौरी बोल रही है वाओ सुपर कूल, प्राजक्ता बोल रही है अर्नव क्या बोल, अमेजिंग बोल रहा है अर्नव। चलो वेरी गुड। अभी फिजिक्स 11th एंड 12th के भी बच्चे हैं महाराष्ट्र बोर्ड के, तो वो वाव बोल रहे हैं, वेरी गुड। और अमेजिंग अर्नव अय्यर बोल रहे हैं। चलो वेरी गुड वेरी गुड। एक्चुअली मुझे बहुत अच्छा, मतलब आप करके देखो, यही मैसेज है आईसर पुणे साइंस एक्टिविटी सेंटर से, यही मैसेज है। इस टाइप के एक्सपेरिमेंट आप घर में करके देखो। और भी मैं आपको कुछ एक्सपेरिमेंट दिखाऊंगा, लेकिन उससे पहले ड्यू टू पेंडेमिक दिस नेशनल साइंस डे वी आर सेलिब्रेटिंग ऑनलाइन। लेकिन शायद जब पेंडेमिक खत्म हो जाएगा तो थोड़े से रिस्ट्रिक्शंस कम हो जाएंगे, तो मैं रिक्वेस्ट करूंगा कि टीचर को, बच्चों को, तो यहाँ बिल्कुल आईसर कैंपस में आ जाइए। ऑफकोर्स यू नीड द परमिशन, तो हम वो सिंपल प्रोसेस होता है, हम वो पूरा करेंगे। लेकिन यू सी हियर what kind of the experiment we have, and you can learn many concept of the science and mathematics by using the simple activity. लगते समय बहुत सिंपल लगते हैं एक्सपेरिमेंट, लेकिन if you found out the answer, तो आपको पता चलेगा कि हर एक्सपेरिमेंट के पीछे बहुत गहरा साइंस है। चलो अभी आगे का एक्सपेरिमेंट देखिए। ये एक बलून है, और ये जो है छोटा सा नट, हेक्स नट। देखिए मैं हेक्स नट आपको दिखा रहा हूं, इसके अंदर डाल रहा हूं, बस बलून के अंदर एक नट है। अभी देखिए उसे जरा बड़ा करता हूं मैं। अभी देखिए इसे मैं यहां नॉट लगाता हूं। आपके सामने मैंने बलून इन्फ्लेट किया है। अभी इसके जो है ना, देखिए अभी देखिए ये जो है, और ये जो साइंस सेलिब्रेशन के लिए देखिए हमारी पूरी टीम 1 महीने से दिन रात काम कर रही है। मतलब हमारी आउटरीच की जो टीम है, और हमारे फैकल्टी इंचार्ज है, हमारे डीन आईआरओ है, हमारे एसोसिएट डीन है, ये सभी इंटायर टीम बिल्कुल 1 महीने से हम इसके पीछे हैं। मतलब 1 दिन का इवेंट, लेकिन 1 महीना हम ऐसा काम कर रहे हैं कि आपको कुछ अच्छा दे सके। साइंस और मैथमेटिक्स की जो ब्यूटी है वो आपको थोड़ा सा ग्लिम्स दे सके, इसलिए हम लगभग 1 महीने से आपके लिए काम कर रहे हैं। तो ये देखिए एक्सपेरिमेंट क्या है, इसके अंदर नट है। अभी मैं इसे घुमाता हूं, देखिए कैन यू हियर द साउंड? यस बोलो बस। देखिए अभी मैं थोड़ा कैमरा माइक्रोफोन के नजदीक आता हूं। यस बोलो या नो बोलो, आवाज आ रहा था आपको? वेरी नाइस। एक्चुअली दिस इज बस इसके अंदर नट है, बाकी कुछ नहीं है, ये नट था। अभी मैं थोड़ा सा मेरे साथी को रिक्वेस्ट करता हूँ, इसके अंदर जो मैंने कॉइन पहले डाल के रखा है, तो कॉइन वाला मुझे दे दो। और मैंने ट्रांसपेरेंट लिया है वो बलून। अभी देखिए ये बलून है, लेकिन नीचे कॉइन है। देखिए अपना 1 रुपी कॉइन, ये जो होता है ना, देखिए और एक बार दिखा दो आपको। दिस इज द 1 रुपी कॉइन। ओके, और अभी देखिए यदि 1 रुपी कॉइन है तो आप घर में ही सर्कस का मजा ले सकते हैं। सर्कस अभी देखिए, ये पहले देखो, बाद में दोनों का भी एक्सप्लेनेशन मैं बताऊंगा। कितना अच्छा चल रहा है देखिए। मतलब जो हम सर्कस में, जो हमारे बचपन में जो सर्कस आती थी ना, उसके अंदर केज होता था और मोटरसाइकिल, या आजकल मौत का कुआं भी होता है मेले में। ये थोड़ा सा धक्का देता हूं मैं इसे, देखिए कितना देर तक चलता है। लेकिन हियर यू विल नॉट गेट साउंड। देखिए धीरे 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 चल रहा है। देखिए तो बेसिकली ये मौत का कुआं होने दो जो खेल है बेसिकली। और ये केज इनसाइड द मोटरसाइकिल जो होता है ना, मतलब ये केज मतलब ऐसा गोला होता है वो, बेसिकली वो क्या होता है, स्पेरिकल होता है, लेकिन अंदर होलो है वो। तो इसके अंदर मोटरसाइकिल क्यों घूमती है, तो वो बहुत जोर से चलाते हैं। यू नो, इफ यू रोटेट एनीथिंग लाइक दिस, तो टेंडेंसी क्या होता है उसका, उस सेंटर से भाग जाती है, दूर जाने की कोशिश करती है। एंड दैट क्रिएट द वन टाइप ऑफ द फोर्स, एंड इट इज नथिंग बट द सेंट्रीफ्यूगल फोर्स। मतलब दूर जाने वाला फोर्स सेंटर से। तो मैं इसे घुमा रहा हूं तो सेंटर से दूर जाने की कोशिश कर रहा है, लेकिन बाहर तो जा नहीं सकता क्योंकि बलून मेम्ब्रेन का वॉल जैसा है। तो वही अंदर वो घूम रहा है, और वो स्मूथ भी है, तो बहुत देर तक चल रहा है। देखिए बहुत देर तक चलेगा। जब यदि मैं रोटेट करूंगा ना, लगभग वो 30 से 40 सेकंड तक चलता है। देखिए तो मैं इतना देर तक नहीं रुकूंगा, लेकिन आपको आइडिया आ जाएगा कि इतना लंबा तक चलेगा। देखिए इफ यू रोटेट इट वंस। लेकिन उसमें क्या हो रहा था, जो दूसरा जो था ना, उसमें ये हो रहा था, आवाज क्यों आ रहा था उसमें नट क्या है, हेक्सागोनल है। और नॉर्मली हमारा कॉइन क्या होता है, कॉइन का कुछ एज नहीं होता, देखिए ऐसा। लेकिन नट तो हेक्सागोनल है। अभी दोनों में फर्क मैं आपको दिखाता हूं। देखिए ये हेक्सागोनल नट है, तो ये जब मैं उसे घुमाऊंगा तो वो जोर से मतलब अंदर से टकराता है। स्ट्रेच्ड मेम्ब्रेन है बलून का, तो मल्टीपल हीट होने के बाद दैट्स क्रिएट द वाइब्रेशंस। एंड दैट वाइब्रेशन अगेन वेरी वेरी एसेंशियल फॉर गेटिंग द साउंड. और इसके ऊपर कितना टेंशन है, नट कितना बड़ा है, बलून का मेम्ब्रेन का थिकनेस कितना है, मतलब आप कितना इन्फ्लेट कर रहे हो उसको, दैट सो मेनी फैक्टर डिसाइड्स कि आवाज का टाइप का होगा. दिस इज वेरी वेरी इंटरेस्टिंग एक्सपेरिमेंट. अभी ये जो एक्सपेरिमेंट होते हैं ना, उससे हमारा दिमाग खुलता है कि अरे लगता है वेरी सिंपल, लेकिन उसके पीछे जो साइंस है बाद में हम ढूंढने की कोशिश करते हैं. मतलब एक्साइटमेंट से अल्टीमेटली साइंस की तरफ हमें जाना है, उसके पीछे मैथमेटिक्स क्या है उसके तरफ हमें जाना है. अभी और एक मैं थोड़ी सा अलग एक्सपेरिमेंट आपको दिखाता हूँ. अभी आवाज तो आपने देखा है, अभी आवाज देखा है. अभी ये देखिए, हर घर में ये पाइप है. अभी मुझे बता दो इस टाइप का पाइप घर में कहाँ होता है, चार्ट में लिखो. अभी फोर्स बोल रहा है, सेंट्रीफ्यूगल फोर्स बोल रहा है. आदित्य क्या बोल रहा है, थैंक यू सर. चलो फॉर गिविंग सच अ नाइस इंफॉर्मेशन. चलो आदित्य बोल रहा है, वैदेही बोल रही वाउच. पर लेकिन ये क्या, चलो अभी मेरा नेक्स्ट क्वेश्चन है आपके लिए, और क्वेश्चन बहुत सिंपल है. ये इस टाइप का कॉरुगेटेड पाइप आपके घर में कहाँ होता है, बस चार्ट में लिखो. वेरी नाइस. शीतल बहुत वाओ, इतना बड़ा वो लिखा है ना, मतलब उनको शी इज वेरी वेरी एक्साइटेड. आई थिंक कि उसको बहुत मजा आ रहा है कि इतना बड़ा वाओ लिखा है उसने. तो ये बता दो मुझे. और फिजिक्स 11th and 12 महाराष्ट्र स्टेट बोर्ड के स्टुडंट, चलो वॉशिंग मशीन मध्ये त्यांचं उत्तर आलं मला. फिजिक्स 11 12 महाराष्ट्र स्टेट बोर्ड वॉशिंग मशीन मध्ये. आणि मला आज हे तुम्हाला सांगतो, बऱ्याचशा शिक्षकांचा सकाळपासून फोन येत होते. आम्ही आमच्या शाळेमध्ये प्रोजेक्टर लावलेले आहेत आज, आणि प्रोजेक्ट वरती सगळे मुलं ह्या शोचा आनंद घेत आहेत. आमच्या दिवसभर जे प्रोग्राम चालू आहे ना त्याचा आनंद घेत आहेत. तर हे सर्व अशा शिक्षकांना आमच्या सायन्स ऍक्टिव्हिटी सेंटर आयसेर पुणेकडनं मनापासून धन्यवाद की तुम्ही एवढी मोठी सोय प्रोजेक्टर लावून तुमच्या शाळेमध्ये केलेली आहे ना. सॅल्यूट फॉर युअर दिस मतलब इफर्ट फॉर स्प्रेडिंग द अवेअरनेस ऑफ द सायन्स अमंग युअर चिल्ड्रन. चलो व्हेरी नाईस. तर वॉशिंग मशीन म्हणतात, बेसिन, व्हेरी गुड. मला आता बेसिन आणि वॉशिंग मशीन हे सर उत्तर. व्हॅक्यूम क्लीनर, यस, हे सेजलने जर वेगळं होतं तर व्हॅक्यूम क्लीनर, यस. त्याच्यानंतर वरड, यस, बाथरूम मध्ये. चलो कुठे ना कुठे बाथरूम मध्ये असेल. व्हेरी गुड. अमय बेसिनला म्हणतो, व्हेरी गुड. आता बघा असा पाईप, याच्या आत काही नाही. आता मी तुम्हाला दाखवू शकत नाही क्लिअर असं, पण आत काही नाही, याच्या मी काही बसवलेलं नाही. दिस इज पाईप. आणि आधी याच्यात मी फक्त ब्लो करतोय, जस्ट आय एम ब्लोइंग ओव्हर हिअर. ब्लो कर रहा हूं, बाद में खींच रहा हूं, ब्लो कर रहा हूं, मतलब ब्लोइंग एंड सेटिंग. बेसिकली व्हेन आई ब्लो थ्रू दिस पाइप, हवा यहां से जा रही है, एंड ड्यू टू दैट कोरिलेशंस इट्स गेट वाइब्रेट्स, एंड दैट वाइब्रेशंस क्रिएट द साउंड. तो साउंड के क्या क्या रीजन होते हैं ये मैं आपको बता रहा हूं. मतलब हवा का भी वाइब्रेशन हो सकता है, हवा भी कंपन पाती है इसके अंदर. लेकिन कौन सी हवा, जो मैं ब्लो कर रहा हूं वो हवा. अब मैं खींचा तो भी उल्टी दिशा से हवा आ जाएंगे. अब इसका और एक ब्यूटी देखिए, इसे मैंने घुमाया तो भी चलेगा. देखिए ऐसा, इतनी मजे की चीज है ना, इससे आपको बहुत मजा आ जाए. करके देखो तो वाइब्रेशंस के क्या क्या एक्सपेरिमेंट हो सकते हैं. तो ये मैं आपको दिखाना चाहता हूँ. साउंड के तो अभी 2-4 मैंने दिखा दिए, लेकिन और कुछ अलग मैं आपको दिखाता हूँ. शायद ना इस टाइप का टॉय आपने देखा होगा पहला. मैं आप थोड़ा सा हाथ में दिखाता हूँ आपको. ये देखिए, ये देखिए, ये ऐसा इस टाइप का डॉल है. देखिए ये डॉल है, लकड़ी का डॉल है. यहाँ एक छोटा सा होल किया है, यहाँ एक छोटा सा होल किया है, और ये नीचे पॉइंटेड है. अभी यहाँ यदि मैं ऐसा रखूंगा तो गिरेगी. देखिए ये रखा तो ऐसे गिरने वाली है, मतलब रखने के चांस ही नहीं, यहाँ वो गिर जाएगी. तो देखिए मेरे हाथ से गिर गई. अभी देखिए मतलब यदि मैं उसे ऐसी रखने की कोशिश करूंगा तो नॉट पॉसिबल. तो मैं क्या करूंगा, थोड़ा सा मॉडिफाई ऐसा करूंगा. एक वेट है यहाँ लगाऊंगा, देखिए, और दूसरा जो वेट है ना मैं दूसरे साइड से लगाता हूं ऐसा. अभी ये हो गया. नाउ यू कैन बैलेंस इट वेरी वेरी इजी. क्या कारण है देखिए, पता चला आपको. अभी तो बैलेंस हो गया, देखिए आराम से मैं बैलेंस कर सकता हूं यहाँ. अभी देखिए अभी मैं निकाल के एक बार फिर आपको बताता हूं. ये जो है दोनों भी, अभी देखिए ये बैलेंस होगी, लेकिन ऐसी बैलेंस होगी डॉल. देखिए ऐसी बैलेंस हो सकती है. तो ये बैलेंसिंग पॉइंट, मेरा मतलब हाथ के उंगली के ऊपर जो जगह है ना डॉल के सेंटर में, ऐसा समझो, दैट इज अ बैलेंसिंग पॉइंट. इन साइंटिफिक लैंग्वेज इट्स नोन एज अ सेंटर ऑफ ग्रेविटी. बैलेंसिंग पॉइंट होता है. लेकिन समझ लो कि ये बैलेंसिंग पॉइंट यहाँ है. तो ये देखिए, समझ लो यहाँ अर्थ है या टेबल है, टेबल से ऊपर है, ज्यादा हाइट पे है, तो अनस्टेबल है, तो गिरेगी ही. लेकिन इफ आई ऐड वेट, तो ड्यू टू दिस एक्स्ट्रा वेट ऑन बोथ साइड, तो क्या होगा, इसका जो टोटल बैलेंसिंग पॉइंट था सेंटर ऑफ ग्रेविटी, वो नीचे आ जाएगा. मतलब कहाँ है, देखिए अब इफ यू ड्रॉ द ट्रायंगल्स फ्रॉम हियर टू हियर टू हियर, एंड सपोज इफ यू हैव द यूनिफॉर्म वेट तीनों का, तो सेंटर में जो होगा बैलेंसिंग पॉइंट समवेयर हियर. और ये मेरा जो फुलक्रम जैसा है ये बैलेंसिंग पॉइंट के ऊपर है और वही डायरेक्शन में देखिए परपेंडिकुलर। यदि इफ आई बैलेंस इट देन आई कैन बैलेंस इट वेरी वेरी इजीली। मतलब सेंटर ऑफ ग्रेविटी कैसी काम करती है, बैलेंसिंग पॉइंट कैसा ढूंढना है, उसका पोजीशन कैसा बदलता है, ये सो मेनी फैक्टर यू कैन लर्न। अभी बैलेंस हो गई। और आप ये देखिए यदि इस टाइप का आपको बनाना जरा डिफिकल्ट है लकड़ी का तो आप ये बना दो। देखिए मैंने आपके लिए एक बना के दिखा, ये है मेरे हाथ में, मेरा स्टैंड जरा बाजू में एक करते हैं। अभी देखिए ये क्या है, ये कार्डबोर्ड का, देखिए कार्डबोर्ड है, कार्डबोर्ड का एक ऐसा आर्क है और यहाँ वेट है, आप नट भी लगा सकते हैं, 2 वेट हैं। अभी देखिए और ये डॉल है, ऐसा समझो कि हमारे जो डोंबारी होते हैं हाथ में एक बड़ी लंबी लकड़ी लेते हैं और वो तार के ऊपर एक रोप के ऊपर चलते हैं। रोप के ऊपर जो चलने वाले लोग वॉकर्स, हम उसे डोंबारी बोलते हैं। तो वो क्या करते हैं, वो बैलेंस कैसा करते हैं। एक तो देखिए कर्वेचर देखो कहाँ है, वेट भी इंपॉर्टेंट है क्योंकि हम सीधा रोप के ऊपर चल ही नहीं सकते। ऐसा देखिए, एक तो मैं चलने के लिए कैसा, एक तो ऐसा मुझे बैलेंस करना होता है, तो बेसिकली ऐसा बैलेंस करना होता है, ऐसा नहीं चल सकता हूँ बिल्कुल। तो वो हाथ में कुछ लंबा हो तो बेसिकली मुझे बैलेंसिंग के लिए इजी हो जाता है, और यदि कर्व हो तो और बेटर है। अभी मैं क्या करूंगा, देखिए वही कारण सीजी का इसके ऊपर मैं रखूंगा। देखिए ये अभी इसके ऊपर रोप के ऊपर रखूंगा। कैन यू सी द बैलेंसिंग नाउ, माय डॉल इज बैलेंस नाउ। और उसे धक्का भी दिया ना, देखिए डांस कर रहे हैं अभी। तो जो सीजी है, सीजी कहाँ यहाँ होगा ड्यू टू दिस एक्स्ट्रा वेट, और सीजी के ऊपर जो थ्रेड है, पैर को मैंने थोड़े से नॉचेस किए हैं तो यू कैन बैलेंस। अभी देखिए यहाँ भी मैं दूसरी भी साइड दिखाता हूँ मैं आपको। तो दिस इज वेरी वेरी इंटरेस्टिंग एक्चुअली डॉल। चलिए अभी ले लो, अभी थोड़े से मिनट्स बचे हैं, मैं टाइम भी देख रहा हूँ। हाँ, तो अभी मैं 2 एक्सपेरिमेंट आपको जल्दी जल्दी दिखाता हूँ। अभी देखिए आपने बोला कि बायोलॉजी का क्या है हमारे पास, मैं आपको दो चीजें खाली दिखाता हूँ। 2 चीजें ऐसी है। अभी क्या है देखिए, ये जो है ना ऐसा एक प्रिंट आउट है, हमारे डिस्क्रिप्शन बॉक्स में हम इसका प्रिंट भी रखेंगे। हाँ, और इसके हमने 2 पीसेस, देखिए ऐसे 2 होना लेफ्ट एंड राइट का, देखिए ऐसा हो सकता है, बस आपको काटना है। और काट के क्या करना है आपको बेसिकली, ये ऐसा देखिए उसके ऊपर मार्किंग है, ये ऐसा ऐसा काटना है, देखिए ऐसा काटना है। ये मतलब ऐसा है, ये काटना है। उसका प्रिंट हम मतलब प्रिंटेबल जो मटेरियल है उसका डिस्क्रिप्शन बॉक्स में डालेंगे। और बाद में जो है ये आपको जोड़ना है, दो जोड़ना है। तो ब्रेन के पार्ट्स कहाँ हैं, क्या नाम है उसका, कौन से सेंटर कहाँ है, इसके ऊपर लिखा है। शायद आपको कैमरे के अंदर पढ़ने को आता है मालूम नहीं, लेकिन देखिए फ्रंटल लोब, मैं आपको एक एग्जांपल दे रहा हूँ, यहाँ है। तो एक्चुअली एग्जैक्टली ये मैं वेयर करूंगा ऐसा, तो मेरा एक्चुअली ब्रेन में पोजीशन फ्रंटल लोब का कहाँ है, तो यहाँ है। आप साइड से देख सकते हैं कि क्या कौन से जो सेंटर्स है हमारे ब्रेन के, तो कौन से पोजीशन पे हैं, एटलीस्ट वो थोड़ा सा फीलिंग आ जाता है, इसलिए अभी इसका नाम दिया है ब्रेन कैप। तो ये बायोलॉजी की एक एक्टिविटी थी। और मैं थोड़ा सा अभी क्या करूंगा, मैं रिक्वेस्ट करूंगा थोड़ा लाइट कम करना है मेरे साथी को। तो जस्ट लेट मी, आई एम आस्किंग देम कि थोड़ा सा लाइट कम करेंगे ना, तो मेरे साथी को मैं बुलाता हूँ। और मेरे आप यहाँ से यहाँ जा सकते हो बंद करके, यहाँ से भी जा सकते हो, पीछे से चले जा सकते हैं। अभी मैं क्या करूंगा, ये भी लाइट बंद कर दो और ये भी लाइट बंद कर दो। देखिए हाँ, अभी देखिए 3 लाइट है आपके सामने। कितने लाइट है, 3 लाइट है। मैं थोड़ा सा ऐसा दिखाता हूँ आपको, थोड़ा सा लाइट मैंने कम किया है आपके लिए। 1 2 3 लाइट्स हैं, देखिए RGB, रेड ग्रीन एंड ब्लू, RGB। और ये RGB जो तीनों भी कलर हैं, हर हमारा जो कलरफुल डिस्प्ले होता है ना, चाहे मोबाइल का हो सकता है, चाहे हमारा लैपटॉप का हो सकता है, चाहे हमारा टीवी का हो सकता है, तो उसके जो कलर 3 ही है अंदर RGB। लेकिन यदि तीनों कलर यदि मैं वॉल के ऊपर डालूंगा, तो अभी देखिए व्हाइट कलर आ गया, व्हाइट कलर आ गया। लेकिन इसके अंदर देखिए मैंने उंगली रखा तो क्या है, ये तो RGB था, देखिए ये RGB है। लेकिन ये सेकेंडरी कलर कहां से आ गए, ये जो है ना सेकेंडरी कलर कहां से आ गए, येलो है, सायन है, मैजेंटा है, ये कहां से आ गए, तो ये बने हैं। दिस इज द प्राइमरी, नाउ आई एम क्रिएटिंग द सेकेंडरी कलर्स। और वो क्या होते हैं, देखिए येलो, सायन एंड मैजेंटा। तो देखा आपने, वेरी नाइस। अब ये मैंने आपको दिखा दिया यहाँ। और ये होने के बाद यदि मैं इसे क्लोज करूंगा, देखिए तो क्या, देखिए कौन सा कलर आ गया। और यदि मैं तीनों भी देता हूं तो 3 आ गए, और वो सेकेंडरी है। यदि मैं ये करता हूं, देखिए तो ये 2 आ गए। इफ आई क्लोज दिस वन तो ये आ गए। इफ आई, मतलब ये मैं बंद कर रहा हूं, मैं उंगली रख रहा हूं ऐसा, देखिए तो ये सेकेंडरी कलर बन रहे थे, आपको ये पता चला। और इसके पाथ में कौन सा भी चीज मैं रखूंगा तो उसका शैडो कैसा बनता है, यू नो शैडो इज ऑलवेज ब्लैक, ऐसा हमें लगता है। तो आई एम शोइंग यू द कलरफुल शैडो। अभी मैंने डायनासोर रख दिया है, देखिए, कैन यू सी द डायनासोर? यहाँ डायनासोर की कलर क्या है आप देख रहे हैं या मल्टी कलर डायनासोर आप देख रहे हैं। यदि मैं फिर एक बार हाथ में से अच्छा पकड़ता हूं, देखिए, ये देखिए, तो ये जो है तो कलर कॉम्बिनेशन कैसा होता है ये आपको पता चलेगा, चाहे मैं कौन सा भी ऑब्जेक्ट मेरे बीच में रखता हूं। देखिए मेरा खुद का शैडो देखो कैसा कलरफुल आ गया। ओके, अभी इसके अंदर यदि मैं ये स्केलेटन रखता हूं, देखिए ये स्केलेटन, तो स्केलेटन का भी शैडो आपको अलग मिल जाएगा। देखिए ये स्केलेटन है, कैन यू सी दैट? और जहां ब्लैक है मतलब वहां एब्सेंट ऑफ द, क्या बोलेंगे, एब्सेंट ऑफ द लाइट। और वो ग्रीन कब है, येलो कब है, साइन कब है, मैजेंटा कब है, दैट विल डिसाइड मतलब कौन सा कहां कॉम्बिनेशन आपको मिल रहा है। वेरी गुड। अभी इसके बाद जो है ना मैं थोड़ा सा आपको कलर कॉम्बिनेशन एक कार्ड से दिखाता हूं। ये मेरे हाथ में एक कार्ड है, उसे बस फोल्ड किया है तो आपको पता चलेगा। देखिए अभी मैं थोड़ा सा ऐसा करता हूं, येलो कब बन जाता है, रेड एंड ग्रीन। साइन कब बन जाता है, ग्रीन एंड ब्लू। और तीनों भी ऐड किए तो यू विल गेट द व्हाइट कलर। सी द सेंटर, व्हाइट कलर है, देखिए ये व्हाइट कलर है। अभी थोड़ा सा आपको कैमरे के सामने लेकिन जब आप देखते हो ना, रियल में देखते हो ना, बहुत बढ़िया लगता है। ये थोड़ा कैमरे का थोड़ा सा लिमिटेशन होता है, वर्चुअल का थोड़ा सा लिमिटेशन होता है, लेकिन व्हेन यू कम इन द सेंटर, हम आपको डायरेक्ट बाद में बताएंगे। लेकिन ड्यू टू दिस 3 कलर्स हमारे, अभी लाइट में ऑन करता हूं, ड्यू टू दिस 3 कलर्स, देखिए हमारे जिसमें जो होता है ना घर में, बस जो कुछ डिस्प्ले है 3 कलर से हम मिलियंस ऑफ द शेड बना सकते हैं, मिलियंस ऑफ द शेड। और ये मिलियंस ऑफ द जो शेड्स जो होते हैं ना, मतलब इसका इंटेंसिटी भी बदल सकते हैं, इसका नंबर भी बदल सकते हैं, इसका नंबर भी बदल सकते हैं। तो आपको पता चलेगा कि कैसा बेसिकली होता है ये कलर कॉम्बिनेशन। मतलब मिलियंस ऑफ द शेड विद इन 3 कलर्स, प्राइमरी कलर्स आपको मिल जाते हैं। और अभी एक्सपेरिमेंट जो मैं लास्ट में आपको बताने वाला हूं, जो लास्ट में जो है ना वो बाय बाय का एक्सपेरिमेंट है। लेकिन बाय बाय एक्सपेरिमेंट से पहले मैं ये अपन छोटे एक्सपेरिमेंट एक्टिविटी करता हूं जो आप घर में आप इजीली कर सकते हो। देखिए एक मैंने पेपर लिया, ये पेपर है, ये पेपर देखिए ऐसा आधा फोल्ड किया मैंने, और आधा फोल्ड करने के बाद देखिए उसे सेंटर चिपका दिया, बेसिकली बस यहाँ चिपका दिया, यहाँ चिपका दिया। और ये देखिए यहाँ एक होल है, देखिए मैं थोड़ा सा कैमरे के नजदीक आता हूँ, यहाँ एक होल है और डायमेट्रिकली अपोजिट यहाँ एक होल है, डायमेट्रिकली अपोजिट, और सेंटर में एक होल है। बस अब ये जो है ना, ये स्ट्रॉ को एक छोटा सा होल यहाँ बना दिया, छोटा सा, एंड यू कैन मेक वेरी नाइस पेपर स्पिनर। देख रहे हैं? तो थोड़ा सा फ्रेम रेट का हो सकता है हमेशा कैमरे के लिए, पर यू विल गेट द फीलिंग। ये बहुत आराम से घूम रहा है, देखिए बहुत आराम से। ओके, वेरी नाइस। और अभी ये जो है अलग अलग आप एक्सपेरिमेंट कर सकते हो, अलग अलग एक्सपेरिमेंट। अभी मैं आपको एक लास्ट एक्सपेरिमेंट जो दिखा रहा हूं ना, तो लास्ट एक्सपेरिमेंट मेरा जो है आप घर में भी कर सकते हैं। कोविड के पीरियड में हमने बहुत मतलब ये चीज इस्तेमाल की है। क्या है बता दो मेरे हाथ में, ये पर्पल कलर का क्या है, मैं इधर चार्ट में देखता हूँ ये क्या है, मैंने बॉटल को लगा दिया, तब तक मैं मेरा ये हाथ में देता हूँ। देखिए ये क्या चीज है, हाँ लिखिए। चलो सुपर वाव तो आप बोल रहे हैं, लेकिन मैं थोड़ा सा और भी देखना पूछना चाहता हूँ आपको, ये चीज क्या है, जब चार्ट में मुझे आने दो। तो चार्ट में जो है ना वो अभी शायद आने के लिए 8 सेकंड में रुकता हूँ। लवली प्रेजेंटेशन, तब तक मैं इधर पढ़ता हूँ। कुंदन का बोल रहा है वाओ, नहीं रियली लुकिंग फॉरवर्ड टू लर्न विथ यू सर। चलो हमारी टीम बिल्कुल आपको हेल्प करेंगे लर्निंग के लिए, और हम भी आपसे कुछ लर्न कर सीखेंगे। वेरी गुड। ये जो है ना ग्लोव्स आ गया, देखिए हैंड ग्लोव जो हमने कोविड के पीरियड में बहुत देखा है, नर्स डॉक्टर इस्तेमाल करते थे। बस बॉटल ले लो कौन सा भी, उसका बेस काटो, देखिए बेस काट दिया मैंने, हाँ? और बस यहाँ बिठा दिया एक हैंड ग्लोव्स। तो इतना तो बहुत इजी है। और इसके बाद जो आपको करना है ना, ये पानी ले लो। ये कलरफुल पानी मैं क्यों ले रहा हूं, क्योंकि कैमरे के लिए, नहीं तो अपना कौन सा भी पानी ले सकते हो अपना। और बाद में आपको सभी को मुझे जो बोलना है बाय बाय बोलना है। वो मैं बाय बाय कैसा बोल रहा हूं, अभी देखिए यहां मैं, देखिए सभी के लिए बाय बाय। देखिए और एक बार देखो, सभी के लिए मैं बाय बाय बोल रहा हूं। विश यू वेरी हैप्पी साइंस डे। और हमारे जो बाकी के भी बहुत अच्छे लेक्चर्स हैं, टॉयफेस्ट हैं, साइंस क्विज है शाम को, तो बहुत अलग अलग अच्छे प्रोग्राम हैं, तो बिल्कुल वो भी आप आनंद लीजिए। तब तक मैं बाय बाय बोलता हूं, लेकिन मैं फिर एक रिक्वेस्ट करता हूं, ये इसके पीछे जो हमारी पूरी आउटरीच की टीम है, तो उसने बहुत मेहनत लिया है। डॉक्टर अपर्णा देशपांडे असतील, आमचे डॉक्टर सौरभ दुबे असतील, आमचे डॉक्टर संथनम असतील, आमचे डिरेक्टर असतील आणि संपूर्ण टीम यांनी खरोखर तुम्हाला सांगतो की आपल्या मुलांच्या पर्यंत, आपल्या शिक्षकांपर्यंत काहीतरी नवीन माहिती गेली पाहिजे आपल्या सायन्स डेच्या निमित्तानं, याच्यासाठी भरपूर मेहनत घेतलेली आहे। तर सर्व टीमचं मी आभार मानतो आहे, आणि स्पेशली तुमचं, तुम्ही इतके छान चार्ट मध्ये जे रिस्पॉन्सेस आम्हाला देत आहेत त्याबद्दल तुमचं सर्वांचं मी मनापासून आभार मानतो। थँक्यू व्हेरी मच, आणि पुन्हा एकदा बाय बाय।
Welcome to the National Science Day program. I am Shreyas Mangave, faculty at IISER Pune. My research interest involves reconstructing past climate using tree rings. And in this lecture, I am going to introduce this subject to you. As a kid, you must have seen the cut section of a tree and determined age of the tree based on how many number of rings are there in it. But after completion of this lecture, I hope that you will be able to appreciate there is much more to it than just finding out age of a tree. In the beginning, I'll talk about why do we need to know about past climate, what is a climate proxy, and then I will introduce tree rings as a very useful climate proxy. In the end, I'll discuss some of the results that are obtained from the tree ring research data. You must have seen these dramatic pictures representing extreme weather-induced disasters. The top left picture shows the flood that occurred in 2005 in Mumbai, where it rained more than 1000 millimeters in a day. The top right picture shows recently occurred landslide in the Koyna Reservoir region of Maharashtra. The bottom left picture shows Badrinath flood that occurred in 2013 and Uttarakhand landslide that occurred on 7th February of 2021 is shown in the bottom right picture. When you look at these pictures, the question that comes into your mind is, are these disasters part of a natural climate variability, or human-induced climate change is responsible for this? To answer this question, we should look at available weather data. This graph shows number of meteorological stations in India. First meteorological station was established in 1792. Since 1813, we have a continuous weather record. By 1871, there were about 300 meteorological stations in India. And after 1952, the number of stations were more than 500, and it gave a good spatial coverage. But if you look at the spatial coverage of this data, we have a very good instrumental weather record from 1971. So that is last 150 years. But if you want to know the climate before 1971, we don't have any record with us. And whatever instrumental record we have, it is insufficient to reveal long-term climate variability. So how do we know climate variability before instrumental period? We rely on climate proxies, which gives indirect information about past climate. A good climate proxy must fulfill these three conditions. One, there should be a material evidence of the past, and that material could be wood, rock, or ice. The second criteria is material should give information about the climate present at that time. And the third one is we should be able to assign a calendar year to that material. That means there should be a way to find out when was this material formed. Let us look at examples of a few terrestrial proxies. Ice core is an important proxy. Scientists have taken ice cores from ice sheets. Those are present in Greenland and Antarctica. The material evidence in this case is ice. The ice layer thickness, isotopic composition of hydrogen in it, or the level of CO2 which is present in those bubbles tells us about past climate. And we can assign calendar year to these individual materials by layer counting. Another proxy is speleothems, which are cave deposits, and the top right picture shows a transverse section of a speleothem, and the bottom picture shows a longitudinal section of a speleothem, and you can clearly see the growth rings there. In the case of speleothems, the material evidence we have is calcium carbonate, and isotopic composition of oxygen, which is there in the CaCO3, that is, oxygen is there in the calcium carbonate, and the isotopic ratio of oxygen in it gives information about past climate. And again, we can assign calendar year to these individual rings by either layer counting or based on radioisotope dating. Tree rings are also very useful proxies, and a ring represents growth that accrued during a particular year. In this case, material evidence we have is wood, and the information such as ring width, ring density, isotopic composition of oxygen and carbon, which is of the material which is present inside the ring, gives us information about past climate. And again, we can assign calendar year to each rings by just ring counting. If we know the date or the year the tree was cut, we can assign that year to the outermost ring, and we can go on counting back and assign calendar year to individual rings. Now, as a climate proxy, tree rings has advantages. Trees are everywhere. In the case of ice cores, the ice cores are only available at high latitude and high altitude regions, but trees are everywhere. Tree rings are annually resolved. That means each year there is one ring. Because they are annually resolved, we can assign calendar year to each and every individual ring. And more importantly, it shows a continuous record. So there is no break in record. Even if there are some breaks, there is a way to find out those breaks. I can adjust the assigning age to individual rings accordingly. Now, tree can live for thousands of years. So this one picture shows a cross section of a giant tree, and the person on the left hand side is A. Douglas, and he is considered as a one who formalized this subject, dendrochronology. It is a science of tree rings. And how do we take the samples? We can take the samples, either take a cross section of a tree. For example, suppose tree is already fallen because of cyclonic activity, or it was cut for some other, for any reason. Then we can have a cross section of a tree and we can look at the tree rings. The most preferred way to take a sample is to take a tree ring core, and the corer is shown in this picture. So this is corer. The shaft goes inside and we can take a core out of this. And when you take this core and polish it, it looks something like this. So these are individual rings in a tree, and we can do all our analysis using this sample. Again, these three pictures shows various tree cores. On the right hand side there is a bark, and on the left hand side it goes towards center. So the area between two boundaries is one ring. Now only those trees which shows strong seasonal growth show tree rings. So not all trees show the tree rings. Now seasonality in growth could be due to soil moisture availability. In case of regions such as India, monsoonal region, where there is a wet phase and there is a dry phase. June, July, August, September is a wet phase where tree actively grows. But during dry season, because of lack of soil moisture availability, there is no growth. So this strong seasonality in growth induces rings in a tree. The tree rings could be also because of temperature variability in the region. For example, in high latitude regions or in high altitude area where temperature variability is drastic. So this range of temperature variability can induce tree rings. For example, in winter there is no growth, followed by then spring, summer and autumn. So summer and spring represents a time when tree grows maximally. So again, this differential growth gives rings, tree rings. Now if you look at trees such as teak, which is from Indian region, again from Indian region, it shows strong seasonal growth. During wet period it grows, and during dry season it is, because it is a deciduous plant, it is leafless. So it shows good tree rings. But if you look at trees such as banyan tree, where it is kind of evergreen and there is no very strong seasonal growth, so it doesn't show very good tree rings. Now not all trees are suitable for tree ring research, even though they show good tree ring patterns. The most suitable ones are one which are on upland, away from the source water region, like away from the stream or away from the river, and they are on a steep slope where soil is very thin. In such cases, individual trees can be as old as 5,000 years old. But if you look at a tree which looks very healthy, so even though it might show tree rings, it is not very suitable for past climate reconstruction, and the age of the tree may not be more than say few centuries, few hundred years. Now there is a technique called cross dating. What is done in this technique is you take a sample from a living tree. We also have a sample from a dead tree and also some samples from old archaeological sites where people have used the trunk of a tree in construction. When you take a cross section or when you take a core from these samples, you can see the tree ring patterns are there. And there could be a period where tree rings are very narrow, which is shown here in this slide. So you can match this pattern of tree ring width variation and you can create a continuous record, and by this way we can extend the time that is covered by tree ring record to a few thousand years. Even though individual tree is for only say 200 or 300 years, but this pattern matching and extending the record can create a very long chronologies. For example, these are some of the oldest chronologies which have been constructed in the world. So bristlecone pine trees from California, they gives a tree ring chronology which is 8,000 years old. The European oak are used to reconstruct tree ring chronologies or construct tree ring chronologies, and they cover a time span of more than 10,000 years. German pine again shows chronology of 12,000 years. In Indian region, one of the longest known chronologies, it is from 420 to 2003 CE, and it represents around 1500 years. Now let us see how climate information is preserved in tree ring, and we'll take example of tree ring width. Width of a ring represents growth during that particular year. When we find wider rings, so those wider rings represents conditions favorable for growth of a tree, and those conditions could be higher rainfall or less severe winter. Higher rainfall means if the soil moisture is a limiting parameter for tree growth, the year when it rains more, that year the width of a tree would be more. Or in case of a tree where temperature is a growth limiting factor, then less severe winter would show a broader rings. On the contrary, narrower ring represents conditions unfavorable for tree growth. For example, there could be drought that year, or there could be prolonged and severe winter. So width is a proxy for either rainfall or temperature variability. But if you look at the typical ring width variation in a tree, which is shown in this picture, again right hand side is towards the bark and left hand side is towards the center of the tree. You can clearly see that width of a ring is becoming smaller and smaller as we go from the center of the tree to the bark. That means width of the rings decreases as tree grows older. So this is a biological growth trend, and we cannot say that because there were narrow or broader rings near the center of a tree and narrower rings towards the bark side, the rainfall or the temperature has been systematically changing, and that does not mean the rainfall has been decreasing or winter has getting more and more severe with time. Before we use the ring width variation for reconstructing past climate, we need to remove this age related growth trend in the tree. We'll see this example here. So this is one teak sample which is collected by Indian Institute of Tropical Meteorology, Pune. You can clearly see that again left hand side is the older times and the most recent would be towards the right hand side. And this graph shows how ring width is changing with time. During earlier times, on an average the ring widths were more, but during later time the ring width reduces significantly. Now the fit line which is shown here, which is exponential fit, it represents the growth trend, and that trend needs to be removed. So there are various statistical ways of removing this trend. And when we detrend the tree ring width variation, we'll get a time series of ring width variation which are detrended. And that detrended ring width variation is used to reconstruct past climate. For example, in this case, the narrow rings which are present here, that year represents the year when the rainfall was less, and the year when the ring width indices are more, for example here, that year represents the year of higher rainfall. Now, in addition to tree ring width variation, the density of a tree ring is also an important proxy for past climate. Typically, it is observed that density of tree ring is sensitive to summer temperatures. Again, this picture shows a few rings. For example, the region between this border and this border is a ring, and that represents growth occurred during that year. Now, using various instruments, we can measure density of various parts of these rings. And the later part of the ring, that means which is synthesized during summer, which is represented by this darker patches here, those are the ones which shows higher density. And if you measure density of that represents the summer temperature. So a time series of a maximum late wood density is often used as a proxy for summer temperatures. In addition to tree ring width and density within that ring, there are some chemical proxies. For example, we can measure what is the isotopic composition of a material that represents this tree ring. And one of the ways of doing it is we extract cellulose from these individual rings, and this the photograph shows this extracted cellulose from these individual rings. And using sophisticated instruments such as mass spectrometers, we measure the oxygen isotopic composition of and carbon isotopic composition of cellulose from each individual rings, and that is a good proxy for past variability in rainfall. So we have a time series which represents the oxygen isotopic composition of a ring of every year, and that can be used to reconstruct past rainfall. So in addition to these proxies, there are some structures within the trees which are very useful in understanding past climate. One example is fire scars. So there are various regions in the world where forest fires are a menace. We have seen in recent years there are many very strong forest fires in European region and in American region. When forest fire occurs, part of a bark often gets burned. If you look at a cross section of that particular tree which has been suffered by this forest fire, we see the part of a tree is damaged and there are fire scars which are present here. So there is a way to, because we know each year there is one ring, so and we know the outermost edge of the outermost ring, we can find out the exact year during which there was a forest fire. And this forest fire chronology can also be built. So the picture on the right hand side shows these fire scars and individual years assigned to them. For example, there was a forest fire in 1245, then 1261, 1277, 1291, likewise. And there was a severe forest fire in 1329 as well. So in addition to this ring width chronology or tree ring isotope chronology, there could be fire scar chronology as well. And we can measure how this intensity and frequency of fire scar is changing with time. The one study which was published in 2006, the results of that study is shown here. So this graph shows the wildfire frequency, and these red bars indicate that. The black curve indicates temperature in that region. So you can clearly see that the forest fires in western United States, how it is changing with time. We can see from 1970 to 2000, the frequency of fire is increasing. Also, whenever there is a strong summer and spring temperature, the frequency of fires is more. So what this work establishes is warmer temperature and earlier spring are associated with frequent forest fires. Another useful structure that is observed in tree rings is related to volcanic eruptions or very strong winters. So this picture shows the map shows the position of Mount Pinatubo, and it erupted in 1991, and it was a very explosive volcano. What people observed is following that year, that is 1991, the average global temperature dropped by 0.4 degrees Celsius. So that is volcano-induced cooling or volcano-induced global cooling. When such cooling occurs in a region where the temperature is already very low, the further lowering of temperature can have a drastic effect on tree rings. You can again see a picture here where individual tree rings are there. This is one ring. The next ring is here. The third one is here. What you can clearly see is there is something unusual structure which is present in this ring, and that is called as a frostbite, and what it represents is a very low temperature during that time. And again, this particular picture is from Siberian pine tree in Mongolia. Drastic cooling due to massive volcanic eruption, and it caused freezing of the sap in the cells during the growing season in years 536 to 537 CE. So during that particular year, because of this volcanic eruption, temperatures were lowered significantly, and that induced this frostbite in a tree. So when we observe tree ring structure, especially from a tree where temperature is already very limiting parameter for tree growth, we can find out this frostbites, and we can talk about how temperature or very extreme temperature might have changed in the past. One such study was done in Argentina. Again, there is a particular tree species which is there in Argentina, and people measured the frequency and the recurrence of these frostbites, and what they observed is in this Argentinian region, whenever there was a La Nina year, it was associated with this frost ring record, and this frost structure or frost ring which was present can be used as a regional proxy for sub-freezing temperatures in that area. So again, it is a very useful structure to understand past climate variability. Now let us look at how various attributes of tree ring, for example ring width or ring density or isotopic composition, can be used to reconstruct past climate. We'll do with one particular example. What is shown in this picture is an indices from a tree, and it is a drought index. The top part of this figure shows tree ring data, and it covers a time span from 1146 to 2006. In the same region, based on instrumental data or meteorological stations in the same region, we have instrumental data, instrumental drought data from 1877 to 2006. So there is an overlapping period between tree ring record and instrumental record. Okay, so what is done is we calibrate the tree ring record with the instrument record, and this plot shows this calibration. So tree ring data is plotted on x-axis and drought index is plotted, instrumental drought index is plotted on the y-axis, and we find this correlation, and this correlation gives one equation. What is that equation? In this particular case, it is when we calibrate tree ring record with concurrent instrumental data record, we find out this equation, and drought index is correlated with tree ring data with this linear equation with a slope of minus 1.1275 and intercept of 0.2026. So we have now this equation, and if we have tree ring data using this equation, we can find out drought index in the past. Let us look at this example here. Again, we have tree ring data from 1146 to 2006, and we do not have any instrumental record from 1146 to 1877 because instrumental data is available only since 1877 onwards. So we don't have any climate record for that time. So what we can do for that period is use this calibration equation. Again, there is a tree ring record from one region and there is instrumental record from the same region. And this calibration or calibration equation can be used to reconstruct past climate variability. You can see the reconstructed climate here. Again, on the x-axis time is there, on the y-axis reconstructed drought is there. So we can see how drought index or how frequent were the droughts since 1146 to 2006. So this is how we reconstruct past climate. There are various rigorous statistical tests which are employed to find out what is the uncertainty in the reconstructed climate. And the error bar here shows uncertainty in the reconstructed climate. Now I'll present some of the results which are obtained using this kind of tree ring based reconstructions. We carried out one study in the Himalayan region, and the tree rings or the tree from the Kelong region were sampled, and this region receives very less rainfall and it is in the monsoon shadow region. So this place is there in the Western Himalaya. When we carried out oxygen isotopic analysis of the trees from this region and calibrated with concurrent climate, and using this calibration equation, we reconstructed past drought variability. And that reconstruction is shown here. The PDSI represents this is an index of drought, and how it changed in the past is shown here. What this study establishes is very important parameter, important fact, that whenever there was a little ice age, whenever the conditions were cooler, for example, the conditions those were there during little ice age, the climate in the Kelong region was wetter. When there was a medieval climate anomaly or medieval warm period, then the conditions in the Kelong region were drier. So during current warm period, where temperatures are increasing, there is an increasing aridity in this region. So what this study predicts, if the temperatures are going to increase in this region, there will be more and more droughts. So in a coming warm period, the Kelong region of Western Himalaya is going to suffer more and more droughts. Now this slide shows the places where various tree ring data are available. Mostly these data sets represents tree ring width variations, and there are many. Each dot here represents one site chronology. That means it represents a chronology which is prepared by combining individual trees, again by doing cross dating, and these data sets are used extensively to understand past climate variability. We look at some examples. The data set from Indian region is used to construct what is known as a Monsoon Asia Drought Index. It is MADA. Its short form is MADA, and it shows climate variability since 1300 CE. And green dots represents the places where tree ring chronologies are there, and the red crosses indicates where instrumental weather record or a gridded data set of drought is available there. So what this study has shown is whatever past severe droughts that occurred in this region, in Asian region, and those are reflected in the reconstructed climate record. That means the whatever climate record which has been reconstructed, it faithfully preserves the severe records which were severe drought which occurred in the past. For example, East India drought that occurred during 1790 and 1792 to 1796 is affected here. So what this work shows is it tells about historical droughts, known as well as unknown droughts. It also tells us about reasons for such droughts, and this can be understood by comparing the climate during that particular time and rainfall or spatial pattern of drought variability. And it also tells us how various phenomena such as ENSO affect the monsoon. So this is one important study which has been done. Similar study was done by reconstructing drought in South America, and the atlas which is produced is called SADA, South American Drought Atlas. This study establishes variation in return time of droughts and pluvials. This plot shows that on the x-axis there is a time, and on the y-axis return time for droughts and pluvials are shown here. What you can clearly see is the return period of droughts around 1400 years were typically 80 years. That means for every 80 years there was a drought. But since mid 20th century, this return period has drastically decreased. In the most recent years, the return period is 10 years. For example, then every 10 years there is a drought in this region. So this study clearly establishes an increase in the severe hydroclimatic events since mid 20th century. So such kind of important information has been obtained from this South American Drought Atlas. Similarly, North American Drought Atlas has also been generated, and this typical plot shows the Civil War drought which occurred from 1956 to 1965. So these kind of reconstructions, that is continental scale climate reconstructions, are very useful in various ways. One, it can help us to establish the reasons why a given drought pattern is there in the given area. It also gives an opportunity for various climate models to test their predictions. So climate models, there are various climate models, and how do we know that whatever the outcome of that climate model is there, whether it is true or not? And these kind of special patterns gives that opportunity. If a climate model successfully reproduces this past spatial variability in drought, then we can say that we can give more credence to that climate model. So this is one of the useful feature of past climate reconstructions. Now, this graph shows one of the most published graph regarding past climate variability. It shows temperature anomaly. So I'm talking about graph on the right hand side, temperature anomaly with time, and how temperature varied in past, say, 2000 years. And again, with such data sets are generated, tree ring data is one of the important data that goes into these reconstructions, and which can be seen in the left hand side. Now, in various continents or in various regions, different proxies are used to reconstruct this past climate variability. And in each region, you can see this dark green color represents the contribution of tree ring chronologies in that reconstruction. You can see in Asia, approximately everything is tree ring based. In Australia, more than 50% climate reconstruction is based on tree ring width variability. And in South America, it is almost, say, close to 75%. In North America, especially in the western part of North America, it is almost 100% tree ring. So tree rings is a very important archive, and it is used extensively to understand past climate, continental scale as well as global scale. Now this graph shows how climate varied in the past, and we can see till 1600 the temperatures were decreasing slowly, but post this 1600 there was a quiet period, but typically post 1800 there is a drastic increase in temperature, and this increasing temperature is again reflected in other data sets as well. So in summary, what I would like to say is tree rings are very important climate proxies, and it has significantly enhanced our understanding of the climate variability during past 2000 years. With this, I stop my presentation and I thank you for attending this lecture.
Welcome everybody. Today we will talk a bit about data science, making sense of uncertainty that we have in our life. And when I think about data science, I think of it as being a science that helps us to talk about, to discuss, to make sense of uncertainty, in the same way that science in general helps us to make sense of the world around us. So some of you may have seen these kind of headlines that are quite common nowadays. For example, artificial intelligence that controls nuclear fusion, or medicine, for example, personalized cancer treatments using machine learning methods, or even articles that can be written by computers which look almost they are as good as if a human has written it. So all of these headlines are things that in a way implicitly talk about data science, and this is what we will try to discuss, trying to go behind the scenes of these headlines, see what data science is, why do we want to talk about data science, what is data science in the first place, and some methods of what exactly goes into data science, where do they get used, who uses data science, for what purpose. And that's the main aim of this talk. Yeah? And since I said that artificial intelligence can do so many things, maybe, just maybe, artificial intelligence wrote this talk and is in fact giving it? I do not know. You will have to decide for yourself whether that is the case or not. Okay, just a small caveat, I will not focus much on, for example, data science in business or engineering, but I will talk more about the actual science behind data science, and that is partly because, well, I am at IISER, the Indian Institute of Science, Education and Research. So, let us focus on science. So, firstly, why do we want to talk about data science? Right? Let us start with the two words, data and science. So, what exactly are data? First thing, data is a plural, and hence I will talk of data are, or data have, not data has, and so on. And here is a list of things that we may come across in various places, a list of positions of, and we will just go through and figure out whether each of these can be called data or not. And in general, data are observations and measurements. When they get used in data science, we want to do something with it. So, for example, if you have a list of daily positions of stars, typically that is used for some quantitative purposes, so it is data. A number of children, if you want to study education in India, this will be an important piece of data set, and so that will be a useful data. That will be useful data, not a data. And then there are, for example, if you want to read poems, well, do you want to call that a data set? Not very clear. Of course, if you want to build a dictionary between Hindi and Sanskrit or Hindi and English, this could very well be a data set for you. Now, other things, for example, household items bought by people, that is clearly a data set. Next thing, songs. Again, songs can be used just for listening to it and enjoying the songs, or you may want to study psychology, you may want to study the effect of social effects of songs. In that case, again, it can become a data set if you wish. And so, it really depends on what you want to do with what is given to you, the piece of information, the observation or measurement that is given to you, whether to call it a data set or not depends on what you want to do with it. And this kind of uncertainty is of course quite prevalent in many aspects of science, many aspects of life as well. And so, one key lesson is uncertainty is a crucial important aspect, is inherent in everything, and a source of uncertainty is complexity, which is what we will come to in a minute. The world is complex. I hope all of you can appreciate that that actually is a statement that does not need too much of explanation, but maybe I will explain a little bit about what I mean by complexity. It is chaotic, which again we will talk a bit about, and uncertain, as I just illustrated. So, even something as simple as a pendulum, which we know nicely moves up, back and forth, that is a simple boring motion, maybe boring. But if you just attach a small thing to a pendulum and make it into what is called a double pendulum, then it shows a quite a complicated chaotic motion. And I am not going to define chaos precisely, but it is a motion that is irregular even for a simple system as essentially two sticks hanging from each other. So, that is one example of a simple looking system that is still chaotic. Moving on to something slightly more difficult, planets. So, planetary motion is in fact quite regular on a certain time scale. If you want to wait for a few million years, in fact it can be chaotic. That is a debate that is still ongoing. The answer is not yet, the last word has not been said. So, that is one, but then if you look at on much smaller scales of, if you have climate on a single planet, much smaller of course, but still it contains the atmosphere, the ocean, it has clouds and humans, unfortunately, maybe fortunately, who knows, and plants and all these things, that makes it quite complex because of interactions among all of these aspects, and that is one of the examples of a complex system. Lots of things interacting with each other in a way that makes it more difficult to study, and on top of it also chaotic. That occurs in many places. For example, even a single neuron is in fact chaotic, and you take millions to trillions of such neurons, put them together, that is what is supposed to be in my head, I guess, I am told, I have never opened it, but and that is a biological network of neurons, and again that is a very complex system and very difficult questions to answer about what exactly is the brain function, what is intelligence? Of course, it is very philosophically, scientifically, conceptually a very difficult question. So, to learn about all of these very different types of systems, even going from very simple to quite complex systems, what we really need are observations about this and methodology to gain knowledge about this system from these observations. And that in a nutshell is how I think about data science, what I would call my definition of data science, and why we need data science is in order to gain that knowledge from the observations about these systems. Now that we have discussed a bit about why we want to study data science, let us see what exactly is data science. And usually whenever I try to think of what is something, maybe it is useful to think of what something is not. So, what is not data science? This is just an attempt. Different people will have very, very different answers to this question, but an attempt is to also relate it to what exactly is science in the first place. So, important step in starting science, scientific investigation, is to ask a question, identify something that you are curious about, that you haven't fully understood, and then come up with a set of questions about that phenomena. Typically data science is not what comes up with these questions. The questions come from the innate human curiosity. Of course, data science is useful to refine these questions. Once you have some observations, how do you refine these questions? Once you have a question in mind, and if you have a sufficient theoretical background available to answer these type of questions, it may not necessarily be essential to capture observations, go around and look at what is happening in the world. You may be able to answer some of these questions purely based on theoretical considerations, and again data science may not be very useful. Of course, there are theoretical data science methods that may help you answer these questions, but going beyond this, if that kind of phenomena is something that you need observations for, then you start collecting the appropriate data set that you hope will help you answer that question. Either you do experiments or you take observations of the world, and all of this put together give you the data set that you want to now tackle. And again, typically identifying what data sets may be useful is not quite necessarily only data science related, though the methods of data science will help you design these experiments, will help you design what kind of observations to take and so on. So, once we have all these pieces together, the question of interest, the kind of observation that you want to use, that is when essentially the data science will begin. The caution at the bottom is for you to read and think about. I am not going to say anything more about it. Okay. So, then that brings us to the definition of what I will call a compact definition of data science. It is a set of methods, it is a methodology of extracting information and knowledge from data sets. So, if you just go to Wikipedia and find out about data science, this is what you will get. In fact, go to the web page for data science and go to the web page for statistics. Here are two pieces that I have copied from Wikipedia. Can you identify which one is which? Which one is data science, which one is statistics? I am not sure. Anyway, so this is where if the talk were interactive, it would have been wonderful to have a discussion, but anyway, let us go on. And so, the first one was the definition of Wikipedia for data science, and the second one was the statistics. Very, very similar, both of them in a way try to understand what to do with a data set. So, methods for processing, visualizing, analyzing, extracting information from data sets is what data science is concerned with, and statistics in a way is also really concerned with the same type of questions, very, very closely related fields. And data science is much more new in a way. I do not think that data science as a field existed more than 15-20 years ago. So it is still evolving, this definition will keep evolving, and you will come up with many different types of answers if you talk to many different people, and probably 50 years down the line there will be a well accepted compact definition of data science that everybody will be happy with, not right now. Anyway, so but in general essentially it is to do with how to extract knowledge, information from data sets. So, there are 3 key ingredients. Again, this list will change based on who you talk to. I think of 3 key ingredients that go into talking about data science: mathematics, statistics and computer science. So, the mathematical modeling, the analysis is extremely crucial for quantifying verifiable conclusions. So, you want to be sure of what you are saying, that is where mathematics comes in, and in particular the mathematics of uncertainty is what is called probability theory. And so, statistical and probabilistic modeling, which is the second key ingredient, is a way to incorporate uncertainty in a mathematically precise way, and that is pretty much the only way that we know of incorporating uncertainty in a scientific mathematical fashion. The other thing that is crucial, that maybe distinguishes only the statistics from data science as it is practiced now, is the last point, which is computational modeling, computer science. The data sets that are available are quite complex nowadays. We will come to examples of the data sets in maybe 5 minutes or so, and these kind of data sets are essentially impossible to deal with by simply using pencil and paper, or even slightly more calculators and so on. You need much larger computational modeling techniques in order to deal with data sets, and that is one of the things that distinguishes data science from statistics. And so, each of these pieces is crucial for data science. So, that is one aspect of data science. Now, we will move on to how do you actually do data science, what exactly goes into data science, what tools people use. Okay, so now we will hear from other people about their views of data science. So, first Leelavati Narwekar, who works on computational biology and machine learning, she will talk about what she thinks about data science.
Hi, my name is Leelavati Narwekar and I am a faculty member at the newly formed Department of Data Science at IISER Pune. You will notice that many places across the world are initiating such departments. Now, does that mean that this is a new area in science and technology? Well, data science combines concepts in statistics and mathematics and computing with observations or data to better understand different phenomena. So, in that sense, many famous scientists several centuries ago have also been data scientists. For example, in the 17th century, Johannes Kepler came up with his 3 laws of planetary motion using meticulous data that was collected by his mentor Tycho Brahe, right? And neither of them had any idea about gravity. So, Kepler fit the simplest curve that he could to explain the observations. He thought in the beginning that it would be a circle, but it was not. It proved to be an ellipse, and it ended up being right. He was right, although he knew nothing about gravity at that time. Similarly, in the middle of the 19th century, Mendel knew nothing about genes or DNA or genetics that we know now, but nevertheless could come up with his laws of inheritance based on data from careful crossbreeding experiments that he conducted with different strains of pea plants, right? And basically after every generation, every crossbreeding, he recorded the number of plants with each trait that he was measuring. So, here you can see that he was measuring the trait of the as height, whether the plants are tall or short, right. So, what has changed now? Why do we have this as a separate field at this point? Well, I think it is because of 2 reasons. First is the tremendous rise in data. Okay, there is lots and lots and lots of observations now. For example, you have satellites capturing Earth images every second, right. So, you can imagine how much data that is. You have weather stations recording real time temperature, humidity, rainfall, etc. So, that is also a lot of data across the world, right. You have these stations everywhere. Or even our web history, which is also data. Okay, it is being stored and often shared with companies, whether you like it or not. And also these videos on YouTube, which is presumably where you are watching this, all this is data. And of course, the natural question is, come on, not everything in here is useful, right? And that is absolutely right, which brings me to the second reason why data science as a field now is important. And that is because of advances in hardware technologies. So when used creatively, they can help us make sense of this often noisy data, right? And that's where maths, statistics, and computer science, which is what I mentioned early on, come into play. I'll give you an example. So have you heard of the Human Genome Project? This was a large multi-country effort, initiated I think in the 1980s. The goal was to find the sequence of all the DNA in the human cell. This is also called a human genome, okay, all the DNA in the human cell. Now, DNA is like a polymer. It is made of repeating units of A, C, G, and T, right? And our genome has about 3 billion of these characters. And the sequence of these characters, right, is what makes us human. So naturally, scientists wanted to know what the sequence was. But technology did not, and in fact, it still doesn't, let us find the full sequence in one shot. So it could only report the sequence of smaller pieces of the DNA, and that too with some error rate, right? So here's what we have, little pieces of DNA that you can measure, right, sequence. And scientists now had to look at these bag of sequences and develop special computer algorithms to put together these millions of smaller pieces together like a jigsaw puzzle. So eventually, after 15 years, we have these millions of smaller pieces put together, and we have the human genome sequence as a result of these data science efforts. But I don't think any of the people involved at that time called themselves data scientists. They were a diverse mix of computer scientists, statisticians, mathematicians, chemists, and of course biologists, right? So it was a collaborative effort, and a lot of science now is collaborative. Most complex problems in nature cannot be compartmentalized into physics, chemistry, or biology. And data science is by definition an interdisciplinary field, right, that tries to bridge the more traditional sciences with computer science and mathematics. So if you would like to know more about my work or about the department, please look us up. Thank you.
Anindya Goswami, who works on mathematical finance, stochastic processes control, fields that may not seem related to data science, but let's hear from him about what his views of data science are.
Hello, I'd like to talk about application of data science in quantitative finance. We must recall that in the financial market, individuals invest in several different assets. Prices of many such assets evolve over time in an unpredictable manner. Often, the fluctuation of the logarithm of these prices behave like the one in the animation what you can see on the screen. You can see 5 different realizations of the same dynamics which do not have any deterministic pattern. Not only for the investor's personal gain, but for the overall financial stability of the society, it is important to understand the statistical pattern hidden in the asset price data. While quantitative finance facilitates the derivation of financial strategies using the statistical pattern of the market data, the data science tools help to identify those hidden patterns. Okay, so thank you very much.
Arnab Mukherjee is a chemist. He works on computational chemistry and computational biophysics, and he will tell us about data science and how it is used in chemistry.
Chemistry is not far behind to use data science in its own application. You know, the chemistry is a subject which has application in everyday life. Now, primary focus of chemistry is finding out new energy sources, renewable energy sources, green energy we call it, and another major use of chemistry is healthcare, because one has to find out new drugs and drug resistance is coming up. So, one has to find out new design, and it has to be a drug like molecule. So, in this particular applications, data science has been really helpful, which I am going to talk about a little bit. However, you can see the recent surge in the number of publications in chemistry, and that is kind of commensurate with the total number of publications in AI itself, that is very difficult to give a comprehensive view. These accounts of chemical research is a special topic on data science meets chemistry. There are a lot of important applications of data science in chemistry has been published. So, therefore, and since accounts of chemical research is a frontier journal of chemistry, therefore, one can understand that how data science is finding its application in chemistry. You can see here I am reading from here that recent advances in computing power, software and algorithms as well as increases in data availability from experiment and computation have led to dramatic progress in the complexity of statistical techniques applied to chemistry. This kind of summarizes the uses of data science in chemistry. Now, renewable energy, there are great demand of that. For example, remove carbon emission to convert carbon dioxide to fuel, data science has found its application. I am again reading from here, the rapid increase in global energy demand and the need to replace carbon dioxide emitting fossil fuels with renewable energy sources have driven interest in chemical storage of intermittent solar and wind energy. Also, chemists try to find out different materials that has particular property. You want to find out a biodegradable polymer, or you want to find out a better application in solar cells. Data science has found its application in those areas as well. Catalysis is another important thing. For example, you want to convert water to hydrogen and oxygen, because then one can produce energy sources and you need a better catalyst for that. So, therefore, machine learning has again found its application in catalysis and is coming up in a big way. So, another major topic which is of my interest also is drug discovery. So, drug discovery essentially is basically finding out a molecule, how a molecule interacts with the receptor of or proteins or some other biomolecules, and that molecule has to be has to have certain property. For example, there is a property called adsorption, distribution, metabolism, excretion and toxicity. So, those properties the molecule has to satisfy, and at the same time it has to be very specifically interacting with the particular receptor. So, not only we have to know the structure of the receptor, we also have to know the interaction between the molecule and the receptor, and also we have to know whether the molecule can be drug or not. So, you can see here there are lots of studies are coming up in this particular field as well. Now, to solve this challenge of receptor, one has to find out the structure of the protein from sequence, and Google's AlphaFold program, now it is AlphaFold 2, later version of it, has been able to design protein structures or has been able to predict protein structure from sequence itself, which remained a challenge for several years. Imagine if you can find out the structure of a protein from sequence, then you will be able to decode a particular part of a genome which translates to protein, and then you will be able to find out the structure and its functions. And you can see here in this particular graph, there is this CASP competitions where people try to predict the structure because already the structure will be known by experiment which will not be released, and then different computer programs will try to predict the structure, and you can see that how Google's AlphaFold program recently has really surpassed the challenge and really did much better than any other programs. And of course, two examples I am showing here where the experimental and the computational design by data science, again applications of AI, and how beautifully they match. Now, synthesis is a major important aspects of chemistry, and predicting whether the molecule that you have designed, whether it is synthesizable or not. In effect, every molecule is synthesizable, but there is a cost involved and the number of steps are involved, then how much yield one gets, all that, right. So, data science again is helping to find out the synthesizability aspect of a particular molecule, which again greatly helps the design of a particular drug, right. And interaction. Let us say when I told before, right, that the particular molecule has to bind to the receptor. Now, how do we a priori design that? How do we know that whether the molecule will bind or not? So, therefore, we need some energy functions, or you need to predict whether the molecule will bind or not in the target. And again, the data science, with the help of available protein ligand structure and different sophisticated algorithm with great computational power, is again trying to address that problem as well. Another very interesting aspect of using of data science in chemistry is automated synthesis. So, as you can see here, this is a work from Cronin's group, where they design something called Chemputer. So, they write programs, synthesize actual molecules in the laboratory and test in an automated way whether the molecule has been synthesized or not. So, that will greatly enhance the number of synthesizable molecules, and it is again test in different systems. So, text mining again is an important aspect of machine learning. You know that text mining is used normally to understand let us say what people are thinking right now about the current situations and all that. People do Twitter analysis to get some sentiment analysis on certain things. Similarly, text mining has also been used to understand molecular structure in the context of biomedicine, and that will have a great implication, and this shows that this application is comparable to human professionals. So, when one has to understand whether a particular molecule is useful or not in the context of biomedicine, then a human being has to go through several papers and then find out its application, right. This task can be done by text mining, and that has been shown here. Basic chemistry, the theoretical chemistry, which hinges on fundamental topics like quantum chemistry, statistical mechanics, etc. So, here you can see that, and quantum mechanics is extremely expensive computationally. So, what this application tries to do is that it tries to learn the interaction between atoms at the level of sophisticated quantum chemistry calculations. So, therefore, you can see that one can surpass that computational demand to carry out a calculation by using machine learning once it learns that what kind of interaction it has. And therefore, this can be used further again to know about molecule receptor interactions and everywhere else, right. And you can see here people are not only trying to get the interactions, but they are trying to predict the wave functions, which is a fundamental thing in quantum chemistry. When you solve Schrödinger's equation, you try to get the wave function, and that people are trying to do using neural network and machine learning in general. Apart from quantum mechanics, another important topic of chemistry is statistical mechanics, which basically is dealing with the sampling of a particular configuration, essentially finding out the Boltzmann distributions of that particular system. For example, if you take a protein, the protein is not just one structure. At a room temperature, the protein will fluctuate between different energy states and different structures to create a Boltzmann distribution. And what if you can actually predict it in the first place just from the data or from the noise? This paper essentially did that. From the noise, from a random noise distribution of atoms, they could create this particular molecule, which is the Boltzmann weighted molecules in the first place. So, if you one has to get this particular structure, one has to run through a long molecular dynamic simulations to carry out different conformational sampling to get there. And machine learning, or rather deep learning, has been achieved to show that essentially they can get past all that and directly get to the Boltzmann weighted sample. So, which means that it not only predicts energy, it also kind of predicts the entropy of the system, which is kind of remarkable. So, this use in different topics of chemistry, the use of data science in different topics of chemistry will keep on growing, and that essentially will generate more data. As you can see, the growth has been bolstered by large freely accessible data sets, and this data set will keep on growing, and that growth in data set will again demand for more AI applications in chemistry. And with that, increase in computational power, with the increase in data science, I am sure that chemistry will find lot more applications in data science. Thank you.
So, after having heard a bit about different applications of data science, just a few other, there are many different applications. So, I have just listed a few that came to my mind, but this list can really be much longer. and depending on which experts you talk to, as I said, I haven't talked about engineering, I haven't talked about business and all of these various fields where data science is getting used, but at least for example, the fields that are represented in IISER contain mathematics, topology, geometry, and this goes both ways. Geometric and topological ideas are useful in data science and vice versa. The data science method help build new mathematical tools and mathematical techniques and new mathematics in that process. The same thing with the medicine, public health. I said a little bit about these headlines that we keep seeing, as well as fields such as particle physics, astronomy, astrophysics, where data science methods are becoming significantly more useful now that we have very, very large data sets coming, for example, from modern telescopes or particle accelerators or experiments from condensed matter physics and so on and so forth. So, there is a whole variety of different fields in physics that use data science, and biology, ecology, social sciences, biodiversity, climate change. In all of these fields, data science techniques are now becoming essentially indispensable. In fact, it is so much so that it is called now sometimes a fourth paradigm of doing scientific research. So, the quiz is for you to think about what were the first three paradigms. If data science is the fourth one, what was the first and the second and the third paradigm of scientific research? Anyway, I will leave it to you. So, let us just go back a little bit and talk about what is behind the kind of headlines that you keep seeing. Artificial intelligence, machine learning, which forms a huge part of data science these days. Artificial intelligence essentially are neural networks, not biological now, artificial neural networks that are motivated by the biological networks, and they have become particularly powerful methodology for use in data science. And two distinct reasons are that the data sets have become significantly vast and extremely large compared to even 10 years ago, 20 years ago. For example, here is the example of very recent result, a recent model that use about 500 billion tokens, data points in order to train it, which was completely unheard of or impossible to do even 4 years ago, 5 years ago. So, the availability of large data sets is crucial, and the second one is, if you want to handle such data sets, you need computing power. So, these powerful computational resources are crucial for making progress in data science, and that is also growing at a very, very fast rate. There are many other tools which of course I do not have much time to talk about, but you probably may have heard about some of these classification tasks, unsupervised or supervised learning. How this differs, for example, from learning in the human brain is itself a very big topic of research and a very exciting topic of research in fact. So, many of these tools are now being developed and it is not yet complete. This journey is just beginning in a way. Neural networks, classification tasks, learning, machine learning techniques. So, it is an exciting time to be in this field because all of these are so new and developing fields with very large number of applications, and that is what makes it exciting. So, quickly just an example from the kind of research that I do, and this is in the context of earth sciences. So, as I showed this picture earlier, earth is a complex system. It is a complex system, it is a high dimensional system because it has lots and lots of parts to this system, and in addition, as I said earlier, it is a chaotic system. Small changes will make very large changes very quickly. It is unpredictable in that sense, it is dynamical, it is evolving in time, and all of these aspects, interactions among many different parts of this system combined with the chaotic and high dimensional nature is what makes this system exciting as a scientific field, but also quite challenging. And then there is that little bit of a difficulty, which is that we have just one single earth, quite different from biology where you have a billion, well I am not sure if it is a billion, but very large number of cells that you can study, for example, and so on and so forth, but that is just one earth. That is important anyway. So, now we do have large amount of observational data and also computer simulation data about the earth system. This comes from satellites, from last 20 to 30 or 50 years worth of computer simulations that have been used to understand complex issues such as climate change, how weather is changing, or even just to how predict the weather for next 3 days or 5 days, or how to predict the monsoon say 1 month in advance, the total monsoon rainfall 1 month in advance. It is still extremely difficult question to answer, and we, even with this large amounts of data sets that are available, these questions remain very difficult to answer. And that is where the field that is called data assimilation, or the topic that I study, comes in. Essentially it can be called as data science for these kind of chaotic, complex, dynamical systems. As I said, what we have are complex observations, or which are noisy, partial, uncertain observations about the system. The system itself is chaotic, and we want to make predictions of this imperfect, in this kind of imperfect setting. The model is not perfect, the data have a lot of uncertainties, and we want to make predictions. And of course, the applications are in weather prediction, climate prediction, what the climate will be say in 70 years time. I probably won't be around to see what the prediction is true or not. And not just these, but it gets used in many other fields, in biological networks, in studying biology, in studying medicine, in studying industrial applications. And there are many scientific challenges which make it important. As I said, complexity is one, uncertainties in such complex system is another one, and the computational challenges of understanding such a high dimensional system is a third big challenge. So, that is one aspect of, in a way, data science that I find fascinating, and that is what I am working on. And just some few final thoughts to wrap up. As I said, this is an exciting time to be in this field because it is essentially just a beginning. There are quite a few successes of what is called data science. For example, understanding images, as I said, producing text, or in general analyzing text. Well, there are also the engineering topics which I didn't talk about, robotics, self-driving cars, and so on and so forth. So, that combines fantastic engineering systems with methods from data science in order to make this possible. Robots won't be possible without precise engineering that goes into it. Just the data science will not make it happen. Okay, so these are kind of successes, but still there is quite a bit lacking in terms of what you can understand of why these systems work so well. And that is one of the sense in which I said this is just a beginning, that we do not have the precise mathematical, theoretical terminology or framework in which to understand these topics. So, maybe we are somewhere at the beginning of the industrial revolution where a lot of things could be done, but there was no statistical physics to understand what goes behind the thermodynamics that goes to make the steam engines possible. Or maybe we are somewhere where Galileo was, trying to understand what exactly is science, and is data science at a similar stage? Who knows? Maybe an AI will tell after 20 years. So, just a word of caution, I thought this is important, so I will put it here, but I did not talk about it. It is a completely separate talk by itself. As with any other technology, this is not just data science, as with any other technique that is potentially so powerful, we have to use it very carefully. If you do not use prudence, if you do not use a judgment and discretion that is necessary for dealing with something that seems potentially extremely powerful, it can have undesirable or unexpected or both consequences, which we should be very, very careful about. But that is a whole different talk. We can discuss it at some point, hopefully. If all of you can visit IISER, we can have a discussion about this. That will be fun. But for now, just a word of caution. And then on a light note, as I said, these days a machine can write text. So here it is. This is probably not such a great example of what a machine can do. The best of the artificial intelligence networks can do much better than what I did, but essentially I gave a phrase, since I was not sure how to end this talk, ... and then the gray text which you see, it's something that was produced by these two different websites which have a example of a AI sitting behind. You decide whether this is artificial intelligence or not. I wouldn't have written any of this gray text for sure. So maybe I'm a bit more intelligent than the artificial intelligence, who knows. Okay, with that, thanks a lot for your attention, and this is the open invitation for all of you to come to IISER, talk to us, interact with us, maybe study with us, or maybe join us as researchers. So yeah, thank you.
Hello everyone, good afternoon and welcome to our live online Science Day celebration from IISER Pune. इस अभी का जो सेशन है उसमें हम DNA sequencing और genomes के बारे में चर्चा करेंगे. And in this session we will have Dr. Soumen, who is a project coordinator in genome facility at IISER Pune, and also Dr. Krishanpal Karmodiya, who is a faculty in IISER Pune in biology department, to help us understand about DNA furthermore. बट स्टार्टिंग में हम थोड़ा सा डीएनए के बारे में सोचेंगे और डीएनए के बारे में बात करेंगे कि whenever we say DNA, the first thing that comes to our mind is images like these, that DNA is the blueprint of life. It stores a lot of information, and usually if you ask anyone what DNA looks like, they will point at an image like this, that DNA looks like a double-stranded helix. And sometimes we all have seen these images that DNA looks like a double-stranded helix, but it also portrays a misconception कि हमें लगता है कि DNA एक रिबन जैसा है, एक डबल स्ट्रैंड, दो रिबन्स है जो एक दूसरे पे घूमते हुए जा रहे हैं. But actually DNA is not a ribbon, it's not a strand. DNA in theory is a very big chemical. Okay, so when we say chemical, we often think about these structures that we draw in a book, और हम chemical की तरह DNA को नहीं देखते, because we think that DNA stores, is the blueprint of life, it stores information. पर अगर हम डीएनए का असली स्ट्रक्चर देखें तो दिस विल बी मोर लाइक अ एक्चुअल स्ट्रक्चर और ओवरलैप ऑफ दैट डबल हेलिक्स स्ट्रक्चर एंड द केमिकल्स दैट एक्चुअली मेक अप द डीएनए. एंड इफ यू लुक एट द एक्चुअल केमिकल स्ट्रक्चर ऑफ डीएनए लुक्स समथिंग लाइक दिस, जहां पर हम देख सकते हैं कि जो अलग अलग एलिमेंट्स है, हाइड्रोजन, ऑक्सीजन, नाइट्रोजन, कार्बन, फॉस्फोरस, जिनसे डीएनए बना हुआ होता है, उसका एक मॉलिक्यूलर स्ट्रक्चर अभी आप स्क्रीन पे देख सकते हैं. और डीएनए की खासियत जो है दैट वी ऑलवेज नो अबाउट इट, दैट डीएनए स्टोर्स इंफॉर्मेशन. हाउ डज डीएनए स्टोर इंफॉर्मेशन? इज डीएनए के पास 4 तरह के केमिकल्स होते हैं, या फिर 4 तरह के केमिकल्स से डीएनए का इंफॉर्मेशन स्टोर करने वाली जगह बनी रहती है. These 4 chemicals are called adenine, guanine, cytosine and thymine. और ये जो 4 chemicals है ATGCB जिसे कहा जाता है, these chemicals actually are like letters of our English language or any other language. And as in language, how the letters may not have a meaning of their own, but जब आप कुछ letters को साथ में जोड़ते हो तो उसका एक meaning आ जाता है. If I just give a सिंपल एग्जाम्पल कि अगर हमने D, G और O ये 3 ही लेटर्स लिए तो उन्हें अरेंज करके मैं DOG डॉग भी बना सकता हूँ, या फिर उन्हें ही अरेंज करके मैं GOD गॉड भी बना सकता हूँ. सो लेटर्स बाय देमसेल्फ मे नॉट हैव अ लॉट ऑफ मीनिंग, बट सीक्वेंस ऑफ दीज लेटर्स एक्चुअली एंड्स अप हैविंग मीनिंग. और डीएनए का ये जो मीनिंग है ये पढ़ने का काम किस तरीके से होता है, तो उसके लिए हमें और एक चीज के बारे में जानकारी होना जरूरी है, जो कि डीएनए में ये जो 4 बेस पेयर्स है ATGC, they actually bind with each other. So A binds with T and G binds with C. तो इस तरीके से if we know sequence of one DNA strand or one DNA molecule, we can predict the sequence of what its complementary or what its partner DNA will be like. So अगर मेरे पास A ऐसा DNA है तो उसका sequence T ऐसा होगा, या फिर अगर मेरे पास AG ऐसा है तो उसका sequence TC ऐसा होगा. So just by knowing this idea that A pairs with G and A pairs with T and G pairs with C, we can get to this idea of how to know more about DNA. And we are talking about DNA as chemical and how we see DNA in textbooks, but in lab when people work with DNA it looks very different, and they do very different processes with DNA to understand more about it and learn the sequence of DNA. तो इसके बारे में जानने के लिए I will request Soumen to tell us more about it, that how does DNA actually look in a lab?
So obviously, I mean, you know, in textbooks you will find that DNA is a double helix structure, and it actually is. When you are looking at a very microscopic level, it is. But when we are working in the lab, we don't see it as a double helix. What we see is just a small container where there is a solution where your DNA is dissolved. So basically DNA is soluble in water. So we work with those kinds of things, and when you compare it with any other solution, say just water itself, you won't be able to tell the difference.
If the DNA looks more like a solution, how do we know कि जो सैंपल मेरे पास है उसमें DNA present है और उस DNA का साइज क्या हो सकता है, और how do we know more about this DNA which is present in a solution?
Right. So I mean, definitely you would want to know that the solution that you are working with actually has your DNA. So the principle that is exploited here is basically you have some kind of dyes which you can allow them to bind to DNA, and depending on the fluorescence they give out, you can understand. So what happens typically is DNA is negatively charged, and जब आप उसको जब आप उसको एक ऐसे एनवायरनमेंट में रखते हैं जहाँ पे पॉजिटिव चार्ज है, सो डीएनए ट्राइज टू मूव टुवर्ड्स द पॉजिटिव चार्ज. अभी डिपेंडिंग ऑन कि आपका डीएनए कितना बड़ा है या फिर छोटा है या फिर कैसे फ्रैगमेंट्स हैं आपको, और आप उसका कंपैरिजन कर सकते हैं एक लैडर के साथ, विच इज काइंड ऑफ शोन इन द फर्स्ट लेन हियर. एंड depending on where your DNA is found, if you see that it is found at the suitable length, then you can be sure that ये सही है DNA जिसके साथ आप काम कर रहे हैं.
Now that we have seen that DNA is present in my solution by this electrophoresis or gel electrophoresis method, how would we go about knowing the sequence of these nucleotides or actual sequence of the DNA?
Right. So obviously, I mean, ये अब तो काफ़ी साल हो गए हैं, but there is this particular technology which is the DNA sequencing technology. Now, one thing to make sure is that the basic principle is the same, कि DNA, which is, as you must already know, made up of 4 base pair: adenine, guanine, ATGC, guanine, thymine and cytosine. And जैसे हम जानते हैं कि A binds to T and G binds to C, right? तो अगर आपके पास सोचिए एक स्ट्रैंड ऑफ DNA है और आपको पता करना है कि इसका सीक्वेंस क्या है, सो व्हाट टिपिकली इज डन इज कि आपके पास ATGC मॉलिक्यूल्स होंगे जिसको सोचिए कुछ कलर के साथ अटैच कर दिया गया है. नाउ जैसे ही आप ये ATGC मॉलिक्यूल्स को आपके DNA पे डालेंगे, वो जो स्ट्रैंड है, फॉर एग्जांपल आपका स्ट्रैंड AAAA या फिर ATAA ऐसे है, तो उसके अगेंस्ट जाके T बैठेगा, A बैठेगा, C बैठेगा, G बैठेगा, ऐसे करके. सो यू विल गेट टू नो द ऑपोजिट स्ट्रैंड and you will have cameras which will functioning in a way so that जो भी कलर बैठ रहा है वो आउटपुट देगा. एंड जिस हिसाब से सोचिए रेड ब्लू ग्रीन येलो ऐसे कलर्स है, तो अगर रेड ब्लू ग्रीन येलो आया तो एक पर्टिकुलर सीक्वेंस होगा, कुछ और आया तो कुछ और होगा. सो इस तरह से आपको आपका जो DNA है उसका कॉम्प्लीमेंट्री बोलते हैं कि कॉम्प्लीमेंट्री स्ट्रैंड का सीक्वेंस पता चल जाएगा. एंड जैसे ही इसका सीक्वेंस पता चल जाएगा आपको आपके स्ट्रैंड का सीक्वेंस पता चल जाएगा.
So you mentioned there are these machines which actually do the DNA sequencing for us. What are these machines and what do they do exactly?
So this kind of technology, sequencing, the DNA sequencing technology, when you go deep into the mechanics of it, what happens is it has a camera and it has an automated system where it keeps on pumping your bases which go and attach to your DNA, and as and when they are attaching to your DNA, the camera keeps on capturing what kind of fluorescence are coming up. So depending on the sequence of the colored fluorescence that it captures, you are able to understand this DNA. And let me tell you that this is not just a very small length का thing, this is a very high throughput thing. मतलब आप मिलियंस एंड मिलियंस ऑफ सीक्वेंसेस को एक साथ एक ही बार में, आई मीन 5-6 घंटे में आपको पता चल सकता है कि क्या क्या सीक्वेंस था उसके साथ. सो दिस इज वेयर वी आर इन टर्म्स ऑफ टेक्नोलॉजी राइट नाउ.
So as you said that there are DNA sequences, so we can know the sequence of individual strands of DNA, but in our body a lot of DNA is present, and we have also seen that DNA makes up genes, and these genes are present inside the cell. So how do we know about knowing sequence of big DNA molecules?
ये जो पूरा स्ट्रक्चर बना हुआ है, इसका जो बेसिक एंटिटी सेल है, सेल के अंदर न्यूक्लियस है, न्यूक्लियस के अंदर DNA है, ठीक है. नाउ व्हेन यू आर सीक्वेंसिंग सम पार्ट्स ऑफ द DNA, धीरे धीरे यू कैन बी एबल टू अंडरस्टैंड कि आपका जो जीन का सीक्वेंस क्या है. फॉर एग्जांपल जो जीन स्किन बनाता है या फिर कोई और चीज़ बनाता है उसका सीक्वेंस क्या है. एंड ऐसे अगर आप सारे जीन्स का सीक्वेंस कर पाए तो आप जैसे हर एक इंसान का या फिर कोई एक दूसरे ऑर्गेनिज्म, बटरफ्लाई हो या फिर मॉथ हो या फिर कोई भी चीज़ हो, उसका आप जीनोम आर्किटेक्चर जो है आपको पता चल सकता है. एंड जीनोम आर्किटेक्चर से आप बहुत कुछ, I mean there is like just a wealth of information there in genome architecture. So उससे आपको काफ़ी सारी information मिलती है. So this is the reason why it's very important कि हम sequencing of DNA is very important for these particular reasons.
So since he mentioned the word genome, the idea is that the DNA, all of DNA present in an cell is called the cell's genome. And to know more about genome and how the DNA is stored in our cells and how do we know or what can we know about knowing the whole sequence of a genome, let's go to Dr. Krishanpal Karmodiya, and he will tell us more about the genome and how sequencing is done for the whole genome.
Right. So जो DNA है, as we know 4 न्यूक्लियोटाइड्स होते हैं A, T, C, G. उनका जो सीक्वेंस होता है जो जीनोम कॉन्स्टिट्यूट करता है इवेंचुअली, उसका जो arrangement है, that is what is actually an important aspect of genome and genome sequencing. Now ये जो information है, it's almost like a very detailed blueprint for our entire body, and it's, if I have to take some analogy, it's almost like a very detailed book. For example, this book, and it has incredibly detailed information of each and every cell type in our body. We can also use this book to actually go back. It can be also used as a history book, basically, which can narrate the journey of our speciation through time. and people who are interested in future, for them it has all the information of how our genome information can be used to decode how susceptible we are for some particular diseases. For example, by looking at this book and by going through the genome structure, we can find out if we are susceptible for a particular kind of cancer, and that is what can be read by genome sequencing. Interestingly, in our body, all cells have same genome, but they work differently based on how this genomic information is read.
So you mentioned all cells in our body have the same genome or the same set of DNA, but how do they differ? Like, how do they do different functions from each other?
In our body, there are like some 200 different kinds of cells. There are blood cells, there are eye cells, nerve cells. They all have same genome, but जो उनका पढ़ने का टाइमिंग है और जो तरीका है वो अलग होता है. फॉर एग्जाम्पल वी ऑल हैव सीन द बटरफ्लाई, राइट. बटरफ्लाई में एग्स होते हैं, कैटरपिलर होती है, प्यूपा एंड द बटरफ्लाई स्टेज. जो एग्स है उसके अंदर ऑल द इंफॉर्मेशन है कि हाउ द बटरफ्लाई विल फॉर्म, विच कलर इट विल हैव, बट दैट इंफॉर्मेशन इज केप्ट इन सप्रेस्ड फॉर्म. सो उसका जो डिकोडिंग ऑफ जेनेटिक इंफॉर्मेशन है एंड द टाइमिंग ऑफ द जो एक्सप्रेशन है इस इंफॉर्मेशन का, दैट इज व्हाट इज ऑल्सो कंट्रोल्ड by this particular book. So it has all the information, not about the present, not about the past. It has also information about the future and the timing of all this decoding of genetic information.
So with that book analogy, we can say that the genome is like a book which knows how to read itself. But how do we read the genome, or how do we sequence the genome and get the information from it?
So जो DNA sequencing है, it was developed long back in 1977 or so. It took really long time to learn page by page and single information. So for example, it took 17 years to sequence one human genome, and it cost us around $15 billion. But now with the advancement of technologies, we can't read still entire book in one go, but what we can do is we can just shred this book information into smaller pieces like this, and then हम लोग इसको वापस जाके, चूंकि हमारे पास ये इन्फॉर्मेशन अवेलेबल है, हम लोग वी कैन ऑलवेज गो बैक एंड पुट दिस इन्फॉर्मेशन बैक. नाउ बिकॉज वी हैव अ रेफरेंस जीनोम, सो कॉल्ड दिस बुक, एंड दिस थ्रेडेड इन्फॉर्मेशन विच इज अ इन्फॉर्मेशन विच वी डोंट नो कंप्लीटली, हम लोग जाके पता कर सकते हैं कि कौन कौन से म्यूटेशंस और चेंजेस इस इन्फॉर्मेशन में है जो कि इससे मैच नहीं कर रहे हैं. और इस तरीके से हम लोग कोई सी भी जीनोम को आज एक दिन में और ऑलमोस्ट इन $1,000 we can get the human genome information in 24 hours.
So the advancement in this sequencing technology has been happening for last couple of decades. So what is the latest thing in genome sequencing? What is the latest technology or advancement that has happened in genome sequencing?
So जो जैसा मैंने मेंशन किया, 1977 में जो फर्स्ट टाइम डेवलप किया था सीक्वेंसिंग, उसको हम लोग फर्स्ट जनरेशन सीक्वेंसिंग होते हैं. जो अभी मैंने आपको बताया श्रेड करके जीनोम को, इसको हम लोग इसमें मल्टीपल सीक्वेंसिंग, मिलियंस ऑफ सीक्वेंसिंग एक साथ होती हैं, इसलिए इसको नेक्स्ट जनरेशन सीक्वेंसिंग बोलते हैं. अभी नेक्स्ट टू नेक्स्ट जनरेशन सीक्वेंसिंग आ गई है, जिसमें डिवाइसेस आर एज बिग एज दिस एंड दे आर एक्चुअली स्मॉलर देन आवर मोबाइल फोन्स. सो यू कैन टेक दिस डिवाइसेस, कनेक्ट देम विथ योर लैपटॉप्स, and you can get the genetic information in few hours now. So that has really transformed the way we look at genomes, particularly the medical aspects of it. We can now identify any infection or any organism just by doing genome sequencing. We don't have to begin with have to have this genome reference genome. We can also just take this threaded information and put them together. It might not be as good as the story what we have in this book, but we can still get the information just by the unknown samples also.
Would you tell us about how genome sequencing is causing a lot of impact on other areas? Maybe say COVID has how does it help us with this COVID situation, and what are the new things happening in genome sequencing?
Particularly COVID has transformed our lives in multiple different ways. One thing it has done is also to bring the genome sequencing at the forefront. Now people have learned the importance of single change or mutation or variants what we read in newspapers, and how they can be important in determining the consequences associated with a particular disease. So आज हमें पता है कि अगर एक सिंगल म्यूटेशन भी होता है तो कैसे वेरिएंट जो होता है वायरस का वो कितना सीवियरिटी या डेडलियर हो सकता है. सो इस पर्टिकुलर चेंज से आज हम देखते हैं कि जीनोमिक्स जो है वो बहुत सारे जो लाइफ साइंस के पर्टिकुलर फील्ड हैं उसमें इसने यूज होने लगा है. वी सी इट इन medicine genomics, we see it in metagenomics. You can also go back and based on the fossil genomes, you can actually research the ancient genomes. You can also see how they were looking actually by just looking at their genome. People are doing now population genomics, agrigenomics, pharmacogenomics. So there is a huge so-called genomics era is now just it's coming now, and we'll see it soon.
Even as a science student, we are always fascinated by this idea of DNA sequencing and the whole genome of an organism being sequenced. So for our viewers who are science students, would you like to tell us what to study or what areas to follow if we want to get into this idea of genome sequencing?
Right. So जो ये divisions हैं metagenomics, population genomics, agrigenomics, so ऐसे और भी बहुत सारे हैं. ये एक पर्टिकुलर क्वेश्चन है, एक साइंटिफिक क्वेश्चन है, बट जो बेसिक प्रिंसिपल है वो जीनोम सीक्वेंसिंग है, वो एक सिंपल मोलिकुलर बायोलॉजी एंड बायोकेमिस्ट्री है. सो व्हाट आई वुड सजेस्ट ऑल आवर व्यूअर्स इज दैट go back to the basics, learn the biochemistry and the molecular biology of DNA and the DNA sequencing. The basic principle is going to be same in all these methods, and that is what is very important. You can develop your own method, you can come up with your own startup based on new method you develop if you know the biochemistry and the molecular biology of DNA.
Thank you, Krish, for the wonderful information, and I hope all of our viewers learned a lot of new things from this session. And I request all of you to check in the description for more links related to genomes and genome DNA sequencing, which we'll try to put in the link description of this video. And please enjoy the rest of the videos in the Science Day celebration. Thank you.
Hi everyone, first of all welcome to this talk, and I'm really thankful to Indian Institute of Science Education and Research and the Science Activity Center here for giving me this opportunity to talk on National Science Day. It's my first time doing this, and I'm very excited. I'm an assistant professor of mathematics here, and I work in probability and I work in combinatorics. So together, I'm often referred to as a discrete probabilist. So I won't be talking about probability in this particular talk, but I thought it would be really nice to sort of introduce you guys to problems that my parents, gave to me to sort of ponder over when I used to be in my 7th, 8th grades. It was they're more like puzzles, and they're supposed to fascinate you, supposed to keep you engaged, and this is how they sort of wanted me to sort of fall in love with mathematics. And I was doing mathematics as a school curriculum, but this is beyond that. This is so I thought that it would be nice to sort of also start, because I guess most of you are high school students, so start with you guys in the same manner, talk about problems that used to keep me engaged for hours on end when I was a high school student. So and as the title suggests, it's colors in mathematics, so I hope we all love colors, and it's going to be a lot of coloring happening that mingles with mathematical arguments. Okay, so I will plunge right in. So as the title of this talk suggests, so there will be colors involved in mathematical problems. So so we start with a typical chessboard. It's an 8x8 chessboard, and probably most of you have seen a chessboard. And it's colored like this, it's colored using this alternative black and white squares. And then the idea is that you are given a bunch of dominoes. Now dominoes, so maybe most of you have also played with jigsaw puzzles. You can think of these dominoes as the little pieces in the jigsaw puzzles. So each domino is this 2x1 piece where you have two squares that are with one side glued to each other, and each square of the domino is congruent to each small square of the chessboard. So if you're looking at this particular domino here, so each of these two squares is congruent to each of the black and white squares of the chessboard. Okay, so now when we talk about covering the chessboard with these dominoes, so first of all, there are a couple of rules, and I also mentioned this later on in one of the slides. The rules are that when you place the dominoes, it cannot be the case that two dominoes overlap. It cannot be the case that there are two dominoes that you have placed like an L, for example. Then the one square of this domino will overlap with one square of the other domino. So you cannot have such a situation. So dominoes must not overlap with each other, and dominoes must not protrude outside of the board. So it cannot be that you have a domino that such that it's placed in one corner of the chessboard, and one of its squares is on the chessboard, the other square is hanging outside the chessboard. This is also not allowed. So dominoes must be contained entirely inside the chessboard, and no two dominoes can overlap with each other. Okay, so given these two rules, you have in an 8x8 chessboard, you have 64 squares, and each domino comprises two squares, so you would require 32 dominoes to cover the chessboard. Okay, so that's what I write in the first slide, that you can, and this is a whole different world of questions. If you ask how many ways are there to place the dominoes so that they cover the chessboard, this is another whole universe of questions. I shouldn't even say a world, it's a whole universe of amazing questions, most of which actually remain unanswered. Okay, so you can place a domino horizontally, you can place a domino vertically, but you cannot place the domino in any other way, because if you place it in any other angle, then its squares will not coincide with two squares of the chessboard, so you must keep that in mind as well. So, but since there is this option of either vertical placement or horizontal placement, that's why it makes sense to ask, okay, how many ways are there that you can cover the chessboard with 32 dominoes? But we are going to go into this counting the number of ways in which you can cover the chessboard with dominoes. That comes under the purview of combinatorics, which is it's a very vast and very intriguing topic in mathematics. But we will talk about something else now. So let's move on to the next slide. So this chessboard is a broken chessboard. It's slightly different in the sense that you have chosen any two black squares from the chessboard and you have removed them, you have cut them out. Okay, so I have denoted that using this red color. So red means that they're simply not there anymore. Okay, or you can color them red as well. That's also allowed. You can do this with any two black squares, or you can do this with any two white squares as well. And it doesn't matter which two black squares you cut out from the board. It doesn't matter. It's up to you. You can choose any two of them and cut them out, or paint them red and put them off limits. Now previously there were 64 squares on the chessboard. Now 2 are gone, so you have 62 squares on the chessboard. And now the question is, so you would need 31 dominoes if you were to try and perfectly cover this broken chessboard. The question is, can you cover this broken chessboard with 31 dominoes? 31 should be enough, because again, you cannot have overlapping dominoes and you cannot have dominoes protruding outside of this chessboard. But is it possible at all to cover this broken chessboard using 31 dominoes? Again, keep in mind you are either placing the dominoes, like each domino you're placing either horizontally or vertically. Okay, because I mean, if you don't place them in such a manner, again, the squares of the dominoes will not coincide with the squares of the chessboard. So that's not an acceptable position. Okay. Now I'll tell you why you actually cannot cover this broken chessboard using 31 dominoes. Okay. So the idea is the following, and this is where coloring plays such a crucial role. So the first couple of bullet points, I just mentioned the rules that we must observe, that must be maintained when you are covering the broken chessboard with the dominoes. But the thing is, when you are placing a domino, whether you place it horizontally or vertically, it will cover one black and one white square. So just going back one more time to this broken chessboard or the original chessboard, whichever you like, you just look at this. Because you have this alternative pattern of black and white, so if you put the domino in a horizontal position, you will cover one black, one white, or one white, one black square. Or if you put it in a vertical position, you would have one white, one black, or one black, one white, covered by the domino. However, in the broken chessboard, since you have removed 2 black squares, okay, so now you have 32 white squares and 30 black squares. Okay, 32 white and 30 black squares. So if you now try covering this broken board with 31 dominoes, those 31 dominoes would require 31 black squares and 31 white squares. So you cannot cover a broken board that has 32 white and 30 black squares with 31 dominoes. So you see, we're not sitting down and trying different kinds of coverings to see whether one of them will satisfy the conditions of perfect covering. What we are doing is coming up with the clever coloring. So in this case, the chessboard is already colored, but there are many other problems where you have to come up with the coloring to see what's going on, and to see that the coloring itself provides you the solution that no, this is not possible. So usually this sort of coloring problems help you answer questions in the negative, because if you do have a covering possible, a perfect covering of the chessboard possible with dominoes or trominos or whatever blocks you're looking at, then of course then comes the question of counting the number of possible coverings and all that. But clever colorings would usually tell you when such a perfect covering is not possible. Okay, so this is one of those examples. Okay, so I'll look at one final example, which is kind of different in flavor from what we have seen so far. In this example, I try to introduce you guys, for those of you who haven't already seen this, to a couple of notions. The first one is that of graphs, and of course then you will say, but I know what a graph is. It's a graph of a function. We plot graphs on these papers, these special graph papers for our school exams and stuff like that. This is a different kind of graph. that's the first topic that I sort of try to give you an introduction to. And the second one is to this amazing, vast theory that's known as Ramsey theory. You just take a piece of paper and you draw 6 points on the paper. And no 3 of them are collinear, meaning you don't want to draw them in such a manner that you can draw a straight line through 3 of them. I mean, even if you do it, it doesn't really make a lot of difference in the arguments, but it's easier to visualize what's going on when you don't draw them in a collinear fashion. Okay, so now what you do is, after you've drawn the points, you connect every 2 of them using a straight line. So that's basically what I had shown in this diagram. So you have the points, you've named the points, you can name them in some other way. I named them A, B, C, D, E, F, and then I have joined every pair of points using a straight line. Now, this sort of structure is known as a graph, where the points that you have drawn are known as vertices of the graph or nodes of the graph. And the straight lines that connect 2 vertices, these are known as edges of the graph. Okay, and this is a very useful way of representing many models. So maybe most of you are on social media, and you can think of this whole structure of social media as a graph where you all are vertices and your friendships are edges. Okay, so that's one way of representing something very complicated as social media networks by graphs. Okay, so graphs are a very useful tool that we make use of in pretty much every branch of mathematics. So now we will talk about coloring this graph. So that's what we are getting to next. And what we want to do is we want to take every edge of the graph, okay, and assign it either the color blue or the color red. And you do it, I'm not saying that I'm doing it. You sit down with the graph and you color it in whatever way you like, as long as you stick to 2 colors, okay? And so again, you're just taking every edge of the graph and you're assigning either the color blue to it or the color red to it. Just you can do this, that you and your friend decide to color the graph in your own ways, and still I would be able to find either a blue triangle or a red triangle in your coloring, and a blue triangle or a red triangle in your friend's coloring. So yeah, so this is like, I know this sounds very weird, however we colored the graph, we'd still be able to guarantee this. And this is why it really became a theory that yes, this is possible. And so how do you go about arguing this? So there is, in fact, in this argument, I didn't mention it because it's a lot of terms, new terms. I didn't want to get you all confused, but when you listen to the video, maybe you can look this up on your own. But there is another underlying principle that gets used in the argument. It's called the pigeonhole principle. Pigeonhole principle, okay? So for those of you who love birds, and this must be exciting for you, so you can actually look up what a pigeonhole principle stands for. So, but not going into the technical terms that are involved, let's just start the argument, So let's look at the vertex, vertex A. So I'm just going back to the previous slide. So look at the vertex A. So how many edges are going out of A, are emanating out of A, radiating out of A? So there is AB, there is AC, there is AD, AE, and AF, okay? So there are 5 edges that are radiating out of the vertex A. Whatever coloring you choose to assign to these edges, it has to be the case that 3 of these edges have the same color, at least 3 of them. Why? Because if not, then you will end up with, let's say you have precisely 2 edges out of these 5 edges, which are blue, and precisely 2 edges out of these 5 edges, which are red. But 2 plus 2 is 4, so what's the 5th edge going to be? It has to be either red or blue. So that tells you that out of these 5 edges, at least 3 have to be of the same color. Okay? And since the argument would be the same no matter which 3 you choose, let's just say that AB, AC, and AD are of the same color, and let's say this color is blue. So that's what I write here. So let's say that AB, AC, and AD, these are the blue edges, I mean, you could also make them red. You could say that, no, I would prefer AD, AE, and AF to be of the same color. It's also fine. But the argument stays the same no matter which three you choose and which common color you assign to these three. Okay, so the argument will stay the same. So now notice that if you have at least one of the edges, BC, BD, and CD blue, then you have yourself a blue triangle. Okay, so that's what I point out in these diagrams. Let's say that BC is blue, then since AB and AC are both blue, you would have the blue triangle ABC. In the second diagram you see, so let's say BD is blue now, so then since AB and AD are both blue, so you have the blue triangle ABD. And in the third picture you see here, let's say CD is blue, then since AC and AD were blue to begin with, so then you have ACD, your blue triangle. So you've seen that. So what have we seen so far? We have seen that looking at the vertex A and looking at all the edges that are coming out of the vertex A, there are 5 of them. And because there are 2 colors, and there are 5 edges that we're looking at right now, so at least 3 of these edges have to be of the same color. Let's say those are AB, AC, and AD, and let's say the common color that they have is blue. If at least one of the edges BC, BD, and CD is blue, then you have a blue triangle for sure. So what is the only possibility left now? That none of BC, BD, and CD is blue. So then you have BC, BD, and CD all red. They're all red because if they're not blue, then they have to be red. But then they form a triangle, and this is your red triangle. You have the triangle BCD, which is completely red. So as I said, I can guarantee you that whatever you're coloring, you will have either a blue triangle or a red triangle. This argument you could do this starting from any other vertex, doesn't have to be A. You could look at any other edge combination that are where, let's say you start with C and you look at the edges going out of C, and let's say you say that, okay, CA, CE, and CF are all red in color. Then you could argue again along the same lines that you would either have a red triangle or a blue triangle. So you can play around with these arguments and see, how whether you're convinced that this is really what's going on. So these are all the examples that I wanted to show you, but I also wanted to show you that instead of 6 points, if you start with 5 points, you can actually guarantee that you can actually color, not guarantee, you can actually color the 5 vertex graph in a clever manner such that you do not have a red triangle and you do not have a blue triangle. So once again, the idea is that you take a piece of paper, you draw 5 points on the paper such that no 3 of them are collinear, and you again draw straight lines connecting these every pair of these points, and then you assign so you take every edge of this graph. So this is also a graph, it's a 5 vertex graph, and you color every edge either blue or red. Again, it's up to you how you color, but in this case I cannot actually guarantee that, no matter what your coloring is, you will end up with either a blue triangle or a red triangle. And I just show you this coloring here in this slide, that in this particular coloring you actually have any triangle that you look at, it's mixed. It has either one red side and 2 blue sides, or it has 2 red sides and 1 blue side. Okay, so that tells you that for 5 vertex graphs, this claim fails. So I just wanted to say that the first couple of examples that we looked at, those come under the purview of covering problems or packing problems, and these are it's again a very vast area of mathematics that not much is known about it, and usually there aren't general methods that apply to every problem in this area. So it's but it's an area that's worth delving into. So whoever is interested, please, we need people to take up the mantle and sort of continue the journey. The second. The third example that we looked at is, as I said, this is sort of the first example that you see when you're trying to get into this area called Ramsey theory, which was propounded by the British mathematician Frank Ramsey. And again, this is a whole wide area. Very little is known. I mean, the moment so here we were looking at triangles, but you could talk about, complete graphs, whatever complete graphs mean, of larger sizes, and immediately, most things are not known, except via, computer programming, but analytically sitting down and working things out, very little is known. So again, something that is worth pondering about. The book that I would suggest, but this is not really a book where that 5th, 6th graders can just plunge into, unless you've already been exposed to this sort of mathematics. But it's definitely suitable for people in the 10th, 11th, 12th grades of high school to sort of start looking at this book. It's fun. You don't have to take it up as like it shouldn't create pressure for you. It should be like it's something that makes you feel happy to go through the book. And this book is called Problem Solving Strategies by Arthur Angel. I'm hoping that I'm pronouncing his name correctly. It's a book that you can. It's available online. It's available. I think there are this Indian subcontinent editions available as well. There are many other kinds of books as well that you can take a look at. Again, they are quite advanced, but the idea is that you sit down and you look at the preliminary examples and you get intrigued, you get fascinated, and you start enjoying yourself. And then, if at some point you feel like this is a little too difficult for me, just stop for the time being. Or you can ask for help, or you can talk to your friends and maybe you guys can form a group and figure it out. Couple other books I will just sort of mention in passing. There is a walk through combinatorics and a path to combinatorics. Those are very amazing books as well, very rich. Teaches you a lot of stuff. I learned a lot from them. So yeah, that's all I wanted to say. I hope that this was a fun session for you guys. Mathematics is a lot of fun. It's nothing to be ever intimidated by. Of course, I mean, every subject is hard in its own way. Every subject, that's whether you're studying mathematics or music, doesn't matter. But the point is how much you love it. And that's all that should really matter. If you really love it, you just go forward with it. And here's, people like me who are just trying to help you fall in love with the subjects that we love. So here's a fun slide for you guys to bid you goodbye for this year, and hopefully I can come back next year and talk more about colorings and other fun stuff in mathematics.
Hello everyone. Welcome to the National Science Day. We are coming to you from IISER Pune. I'm Amrita Hazra, a faculty member in the departments of chemistry and biology, and I'll tell you a little bit about millets today. I study vitamin biosynthesis in my lab, and I'm very interested in the general nutrition because of my research interests in vitamins and consequently food. I'm also very interested in the role that food plays in our lives, and I feel millets are a great topic to talk about in that regard on this occasion of National Science Day. This is actually a very good time to talk about this because the UN recently declared 2023, which is the next year, as the International Year of Millets. This is the headline from a newspaper article 3-4 days back. So what it says is the UN General Assembly recently adopted a resolution sponsored by India and supported by more than 70 countries, declaring 2023 as the International Year of Millets. Now, why would you have an International Year of Millets? And the reason is something that they provide. The resolution is intended to increase public awareness on the health benefits of millets and their suitability for cultivation under tough conditions marked by climate change. Now, this is something that I feel is very relevant because millets are a very, very hardy and climate smart grain, and we don't eat enough of it. So, millets are good for the climate, they are good for the soil, they are good for us, but we don't eat enough of it. And hence, I thought I'll give a talk today on why millets are, what millets are, and why should we be paying more attention to them both in our diet as well as trying to improve or increase production in the fields around us. So what are millets? Millets are basically just cereals. We know a whole variety of grains. Here is some pictures that a very nice illustrator has made. And you can see, the ones that we recognize, corn we recognize, wheat we recognize, rice of course we recognize. Oats अच्छा थोड़ा थोड़ा अभी पता चल रहा है, advertisement आता है TV पे. Barley you've heard about, but then you come across some other grains which are less known. There's something called quinoa, there's something called rye, there's something called sorghum. These other grains that you see in the picture are the ones that are not quinoa but sorghum and what is labeled as millet and what is labeled as proso. These three in this picture actually stand for, are representative of the group of grains that are called millets. Now, sorghum is just basically jawar. Proso is a type of millet that is, also available here with us in India. And what is funny is that there is one grain that they've actually just labeled as millet because there is such little awareness about what millets are. So I'm hoping to be able to clarify that. I pulled out this picture because exactly of this reason, that it's interesting that people label something as millet, but it's unclear what exactly, what are millets. So just a picture, this is, 3 different kinds of millet seeds that, I've worked with. This is proso millet, finger millet, which is nachni, barnyard millet, which is varai. Proso is called china in India. Okay, so these are the, a small subset of the various millets that are available in the market today. So, still, what are these millets? Yes, they are cereal grains. There are multiple types of millets, is what I've told you till now. But what are they? So, millets are a kind of course, cereal grain, but they are slightly different from rice and wheat. They are more similar to plants like corn. Okay, what is the difference? Jawar, which is basically sorghum and which is also grouped with millets for all practical purposes, they are C4 tropical type plants, and their advantage over the other set of plants which are called C3 temperate type plants is that they are more efficient at utilizing the higher solar radiant energy in the tropical latitudes, such as where we live, such as, countries in Africa. C4 plants are more efficient at surviving and being able to absorb the solar energy, the radiant solar energy in those latitudes. Now, I'll give you a very quick primer on what C3 and C4 mean. So, in C3 plants, so we all know that plants are, how do they make food? They take the carbon dioxide that, organisms such as us, humans, breathe out. They take that in, that is their carbon source, and using the energy from the sun, they fix the carbon dioxide to make carbon-based carbohydrates, and then they release oxygen in the process. Now, in the process of fixing carbon dioxide is what is, the process is called fixing carbon dioxide to be able to then make carbohydrates. In that process of fixing carbon dioxide, in C3 plants, the carbon dioxide is fixed directly into what is called a mesophilic cell, whereas in C4 plants, in the mesophilic cell, there's an enzyme called rubisco, which is what is responsible for fixing the carbon dioxide. In C4 plants, what interestingly happens is the mesophilic cell takes in the carbon dioxide and concentrates it as a carbon dioxide pump, and then pumps that CO2 near the rubisco enzyme. Now, how does that help? Is because this is a less efficient way. The C3 way of importing carbon dioxide to rubisco is a less efficient way of bringing in carbon dioxide because you're not concentrating it. So you need a continuous supply. This pore, which is called the stomata, is open, and there's always a loss of water, and there's some amount of oxygen that enters which needs to be pushed out, etc., etc. And so this cavity from which the carbon dioxide enters is open for longer periods of time, which is why when it is a hotter environment, these plants don't do very well. C3 plants don't do very well in higher temperatures. C4 plants actually do quite well because their mechanism is to concentrate carbon dioxide so the stomatal pore can close or become smaller, contract over time when there is enough carbon dioxide that's concentrated, and it leads to less wastage, less evaporation of water. Now, why am I telling you about this difference between C3 and C4 plants? Is it tells you that certain plants are going to be better at withstanding climate change, withstanding higher temperatures, and C4 plants such as corn, such as millets are going to be better at climate change, at facing climate change than wheat and rice will be able to withstand. Okay, so that is why millets are a very important part or a very important player in in us to be able to combat climate change in the future. So what constitutes a millet species? So what are these millets? Now we've learned that they are cereal grains. We've learned that they are C4 plants. What makes up these millet species? So the name millet. So first of all, millets are small or tiny seeded grains. So you can see from the picture that I've shown here that these are the panicles, and you can see little seeds on them, and those are the millet grains. The word millet is derived from the Middle French word mille, which means 1,000, which means that in your palm you can fit in 1,000 seeds of millet. That's where the name comes from. Now, jawar, which is not in this picture, but you know how it's slightly larger as a grain. Sorghum and the millets, sorghum is jawar, they are usually clubbed together when you're talking about these grains because sorghum is also C4, and they're considered together because they have similar agronomic characteristics and they generally grow in the same geographical location. They're used for similar applications, and hence you always talk about jawar and millets in the same conversation. Okay, so that is what millets are. Let's look at it a little bit more scientifically. So just like, this is just a way in which we classify organisms that are around us. So there's something called a kingdom plantae, which is basically where you have all the plants that we see around us, and then you go through phylum, class, order, etc. as you narrow down, and as you come to family, you become even more narrower. Then you come to something called genus, and then you come to species. Now, how are millets related to other grains that we eat? Let's look at that. So all the grains that we eat belong to the family Poaceae. You can see that at the subfamily level, the division starts. So the ones that we eat very commonly, rice and wheat, are the ones that make one branch of the subfamily. And in the Panicoideae branch are where you have corn, jawar, and you start having some millets. And in the other subfamily branch which is called Chloridoideae, you have some other millets. Okay, some other being finger millet is basically ragi or nachni. That is a slightly separate branch. Teff is a very close relative of ragi, which is eaten in the Ethiopian culture. So those make a slightly different subfamily. These grains are typically very rich in minerals. For example, ragi is very rich in calcium. Other than that, these other small grains are in the same family called panicoideae. If you also look at how the plants look for the various subfamily cereals, rice and wheat, we've seen they look, this is rice, this is wheat, they look like grasses. Then corn actually looks, there's a stalk, there's a strong stalk like thing, and then there's the corn that comes out of it. So corn and sorghum, which is basically jawar, look very similar in how the plant morphology looks. And then other millets often look like what wheat or rice or barley would look like. Okay, so the plant also looks different, but that is not very nicely divided as per the subfamilies. But what we need to remember is corn and jawar have a very similar structure, and the other millets look just like other grasses such as rice, wheat, etc. look like in the field. So this is a question that I've always wondered about as a scientist. So, I study vitamin biosynthesis in my lab at IISER Pune. I've studied vitamin biosynthesis during my PhD and my postdoc. And I've always encountered this question when I look at my food plate every day, that if these vitamins, which are micronutrients, you need tiny amounts of these molecules to be able to keep your body healthy. If I need a variety of these every day, then how can I get them if I'm eating the same things over and over again? And by what I mean by eating the same things is not so on this plate, you'll think that there's a decent variety. There's some, there's some cauliflower, some cabbage sabji, then there is another rajma, something ka sabji, there's some koshimbir, this is made up of yogurt and like a salad. But what you notice is approximately up to 35 to 50% of this plate is rice and wheat chapati, right? The rest is there, of course, and which is great. It's amazing that we eat this diversity of food in India. But what still strikes me is that at least maybe 40 to 50% of your plate is made up of rice and wheat. Okay, now imagine every day morning you're eating chapati or bread or something which is made up of wheat. Afternoon you're eating some rice and roti or something, that's again rice and wheat. And evening again you're eating something like that. You're eating, even if you eat some variety, right? You're still eating, if you're eating pav bhaji, you're still eating pav which has wheat in it. Okay, so you're continuously around 40 to 50% of your everyday intake is the same set of grains, and that is something that is a little it's disturbing to me, for the reason that I feel like we are missing out on eating a larger variety of micronutrients, not only vitamins, but also minerals. Like what I said, if you had ragi instead, you would have gotten a lot of calcium in one of your meals, right? We miss out on eating these nutrients if you're eating a plate that looks like this over and over again. And I say this with caution because I do realize the beautiful variety that we get on the side. But the cereal, which makes up a large part of our diet, is very similar on an everyday basis. So today's staple grains are on our everyday plate are rice and wheat. The consequences, as I just discussed, are of course this loss in food variety and consequently nutrients in our diet. What happens in the field then? Because we are eating more rice and wheat, farmers are also growing more rice and wheat, causing monocultures in the fields. Because there are monocultures, the soil is getting depleted of the same nutrients over and over again, and you're needing to give extra irrigation, extra fertilizers, pesticides, because you're growing the same thing over and over in that space, not allowing the soil to regenerate, not allowing the microorganisms to start to be healthy, because you're taking away the same set of things from the soil. So having said this, even though we have healthier diets today, I feel like we are losing out on the opportunity to make our our daily consumptions more, not only varied but also more tasty. So if this is what I showed you on a plate, but if you just look at the numbers for the world, wheat, corn and rice make up about 89% of the worldwide cereal production. So this is data up to 2014. You can see corn, rice and wheat are the highest bars, and then you have millet, you have barley, you have jawar, which are much smaller in number. So 89% of worldwide cereal production is yet rice, wheat and corn. So what is interesting is that even though India dominates millet production worldwide, so if you look at where in the world is millets produced, this is data from 2019. It shows about 36% of all millets produced in the world is produced in India, and then the next largest country that produces millets is Niger, and then other countries make up the rest. So of course millets are the largest producer of millets is indeed India, and this data is well illustrated in the newspaper. This has been this chart from the newspaper. In I think this is 2020, India has reached 38% of millet production, and in India the leading state that is making, say for example, bajra is Rajasthan. So yes, I mean there's a lot of millet activity happening in India. But what I want you to note is, even though we are the largest producer of millets, in the total amount of food grains that we produce, millets make up only about 10% of the production. Okay, so 90% of the grains that we make, and if you look at this, if we were making a whole variety of dals and pulses and all, I would be okay. But we are still making a large amount of rice and wheat. That's what we are growing in India over and over again. And the amount of, say, jawar, bajra, the millets are at the most, they make up about 10% of all the pulses that we produce in India. So that is what I feel requires a change. And the International Year of Millets is a way, is a push for all of us to focus on that, not only on our diets, but also what is being produced in our countries, what is being produced in the fields, and realize why it is important that we draw back the spotlight onto millets. So why is this spotlight on millets, right? Yes, I mean, why do we need to draw back the spotlight? So millets are naturally diverse. Okay, so when I say millets, as I told you, they're not one type of grain. They're a large variety of small grained cereals. So today there are about 10 commonly cultivated varieties worldwide, and there are thousands. And when I say thousands, I literally mean it. I mean like hundreds of thousands of land races. And land races means that these seeds, when they have grown in a certain kind of land for a very long time, they develop their own characteristics. Often they develop different colors, they can develop different nutrition contents, because they've been growing in that soil for a very long period of time. There are thousands of land races of millets all over India and all over the world. In India today, at least 9 varieties of millets are cultivated. As I've illustrated, millets are nutritious, low carbohydrate content. I'll talk a little bit more about this as we go along. They're gluten free. Now, gluten free means that they lack a protein which is present in wheat, which is an allergen for certain people. So they're gluten free. As I've said, they're drought tolerant. They're C4 plants, and they're very good at resisting drought conditions, which is lack of water for a certain period of time. They are more reliable than most grains on poor soils. They are able to grow on very arid soils. They are staple foods in many parts of the world. They have short crop cycles. So seed to grain is often in 100 to 120 days at the most. So it's a short crop cycle. It's efficient to grow these millets on our soils. And millets have a very large variety of uses. They can be used as a cover crop. They can be used for forage for animals, and they can be used for consumption for humans as grain. So why not millets? Why not? Why isn't the focus on millets is the question that I'd now like to pose, given that they are such great grains for the ecology, for our health, for the agroecology, why not millets? So why are millets so much more nutritious? I just thought showing a picture would help. So this is a grain of wheat, and generally a grain will have three main components. One is called the bran, one is called the germ, and one is called the endosperm. The endosperm is where all the starch of the grain resides. Now the bran and the germ are what have a lot of the nutrients, the other micronutrients such as vitamins, such as oils, such as minerals. These are present in the bran and the germ. The endosperm is generally the starchy part of the grain. In wheat, because of the structure of how it is easy enough to strip off the bran and the germ so that you can only get the endosperm. And what maida or all-purpose flour is that it is only the endosperm of the grain. That tells you that you can separate the components easily. And I do want you all to note one thing, that as compared to a whole wheat flour that you would have at your home, maida has a much longer shelf life. So it can stay for much longer without getting spoiled. And that's because it doesn't contain the other complex parts from the germ and the bran. It is purely starch or mostly starch, and hence it starch and of course the protein that is assimilated. And so the shelf life increases if you're just being able to pull out the starch. In the case of millets, the bran, the germ and the endosperm are integrated in a tighter way than what is in the case of wheat or in the case of rice. And hence it is difficult to remove. People are still being able to remove the bran layer entirely, etc. But in traditional practices of milling millets, it's difficult to take away all the parts that easily, and hence millets are generally eaten more as a whole grain. And whole grains are more nutritious because along with the starch, you're also getting the oils, the micronutrients that are present in the bran and the germ layer. And so millets are consumed as whole grains, which is good for us. If you look at the parameters that we usually look for millets and for other cereals, the carbohydrate content of a general millet, of course there are so many kinds of millets, but I've just taken one of them, is generally lower as compared to the fiber content that the millet has. Okay, so if you do a ratio of the carbohydrate to fiber, it's a low ratio, which tells you that you're getting more fiber per carbohydrate that you're eating. Along with that, millets also have a decent amount of proteins and iron, calcium, as I was saying, etc. And so millets have a great nutrient and micronutrient portfolio. And so it's a good idea to think about incorporating these grains into our diet for the reason of our own health. As I just said, millets are drought tolerant, they are climate smart grains, and there are lots of articles, really good articles. I've just pulled out a few on the slide, which you can go back and refer to. But ICRISAT, journal articles, Frontiers in Plant Science, UN Global Perspectives, etc. all are declaring how millets prove tasty solution to climate and food security challenges, etc. So millets are climate smart grains, they are really good, and hence we need to draw the spotlight on millets as soon as we can, given that the next year is going to be when the whole world is going to be looking at these grains. So I'll tell you about this very quick experiment, or I'll briefly tell you about this experiment that we did to test really whether millets are, how good are they? Do they really require less water? What happens? So this is an experiment that I did as a postdoctoral researcher when I was at the University of California at Berkeley. We called it the Millet Project. We had received funding from the university to do it. What we did was we had 5 rows in which we planted 4 types of millets. I'll tell you what we did. So there are 5 rows. They are 200 feet each. In the front part of each row, we planted foxtail millet. Next one, we had planted pearl or bajra millet. Third, we had planted proso millet. And fourth patch, we planted Japanese millet. So each row has each of these 4 millets in them. Okay, so the first is foxtail, next is pearl, third is proso, 4 is Japanese. In the first row, we had 5 rows of this, right? In the first row, we only watered it till the plant sprouted and then we stopped watering, mimicking what would happen in a drought condition. In the second row, we watered it about 6 times in a month. So very little water as compared to what you would give for growing corn, which is a similar C4 plant. So only 6 times in 38 days, and then there was no water in the second row. In rows 3, 4 and 5, we gave it a full water regime like you would give corn, which is another C4 plant, right? Now, what we observed, so we had to cover the rows like this because the birds used to come and eat the millets. Birds really like millets as food. So we had to cover the rows while the plants were growing, and then we had to put a net to make sure that the birds would not enter and eat the seedlings, etc. But at the end of the experiment, what we observed was, except that first row, which was completely droughted, there was only 2 times we had given water in the whole growth regime of 100 days. Everything else seemed to grow to a similar height and have a decent amount of this millet ear or millet panicle as it's called. So that some of the, in this case in the previous slide, bajra is what I'm showing you here. Bajra showed this difference in height for that completely droughted condition versus where it had received some water or regular water. But some experiments didn't work at all. For example, proso millet, none of the 3 rows grew. And this can be because you're trying to grow millet in a different environment. This millet is not probably suited to that environment. So it's not like millets will always grow anywhere, but millets are pretty good at growing. And so of the 4 millets that we experimented with, 3 of them did grow and showed us interesting results. Here I'm just showing you some very representative data. In Japanese millet, which was the last part of our rows, in the droughted condition, reduced water and full water conditions, there was hardly any difference in the length, the height of the plant. Pearl millet, the droughted rows were shorter, but the other rows were pretty good. Importantly, the ear weight, the millet ear, which is the panicle, in the droughted conditions in Japanese millet were small, but under reduced water and full conditions, they were very similar. Whereas in pearl millet, they were almost equivalent to each other, the ear weight. So it tells you that less water, basically these 2 conditions, the red bar and the yellow bar, are okay. Millets can grow under really less water, and that means that they are really good at surviving under drought conditions, which is what are the claims that are made in many occasions when millets are discussed. So this is our own experiment, unpublished data from 2015, of course, but I hope I conveyed to you that indeed these are climate smart, drought friendly grains. So this brings me to the last part of our talk, that yes, so now I think we are all happy with the idea that yes, we should be eating millets. It's a good idea. They bring a lot to ourselves, our environment. Why and how should we eat millets, given that this is how our plates look like today, which is about 35 to 50% of your meal is made up of a particular cereal grain, which happens to be rice or wheat. The problems for us if we eat the same things over and over again are food deficiencies. We are not getting all the nutrients that we could. Allergies such as gluten intolerance, etc., which are arising because we are eating too much of wheat sometimes. Lifestyle diseases because you're eating refined grains. When you eat maida, when you eat polished rice, you're removing all the other fiber, you're removing the vitamins, you're removing the oils, the good stuff which is there in the grain, and you're only eating starch. And this is linked directly to lifestyle diseases that we have today, such as diabetes, high blood pressure, obesity, etc. The problems for the environment are that we are causing more and more monocultures in the soils, and we are using more water, pesticides, fertilizers, and farmers are relying on these external inputs over and over again because we are demanding to eat more of the same thing, which is bad for us, which is bad for them. So how should we eat more millets? Given that we now realize that there is a there's really a great importance for variety in our diet, to eat a lot of grains. So I'm just going to leave you with a few suggestions of what one can eat. How should we eat millets? Traditional recipes include bhakris, which is what you see here. They are hand-pressed rotis. Because there's no gluten, you can't be rolling, you can't be making them with a rolling pan. But hand-pressed rotis, bhakris, these are more difficult to make, but they are one way to eat them. Millet upmas, khichadis, etc., which are easy to make. Instead of rice, you just use millets. Malted millet porridges, which are really good for babies. I have a child, and I wish I was giving more millet to him. He just refuses to eat anyway. But this is really good for kids. Millet idlis, fermenting millet and making idlis and dosas. Ragi or nachni muddes, which is these balls of ragi which are eaten with a side. And popped millets. Instead of popcorn, you could also eat popped millets. Okay, so these are some of the ways. Laddus are other ways of eating millets in today's in our life. So there's already a decent variety. But because millets are slowly coming back into our vocabulary, younger people, entrepreneurs have started coming up with innovative ways of eating millets. There are millet cookies in the market, biscuits in the market. You could be baking them for yourselves. Breads which are made with millets. A very close friend of mine who runs a bakery called the Good Butter Bakery. She makes breads which incorporate a lot of millets in them. In this case, there's ragi in her bread. People are brewing beers with millets, and here is another local company in Pune called the Great State Ale Works, which is brewing beers with bajra in this case. And malted millet powders are available, which you can mix into your milk or and have, like, instead of Horlicks or instead of some other health drink, you can have millet malts as a part of your routine in the day. So these are easy ways to incorporate millets in our diet. I'm going to leave you with the opinions of two people, the two practitioners that I just talked about, who are actually using millets in their food. And let's see what they say. Just before that, I wanted to make a note that mass scale productions of wheat and rice have made it cheaper, which is why we are more drawn to eating these. Let's make that change as soon as we can. Maida and polished rice have long shelf lives, which is why, again, they are more popular as ingredients in our pantries. But now that we know that it is important to also eat millets, along with the rice that we eat and along with the maida, along with the rotis that we eat, let us also start eating millets. And of course, wheat and rice are very versatile as ingredients. We can make a whole variety of things in our everyday lives with it. Let's start to incorporate millets in our diet. So I just wanted to end with this a perspective of a baker who's actually using millet in her everyday work. This is Smita Sharan. She's the co-founder of the Good Butter Bakery. She says that the gluten network that wheat is capable of providing, just when you combine it with water, makes it such a great ingredient to work with. It has a clean flavor, etc. But she feels that incorporating millets in a combination with the wheat flour is the best way to get is a way to get best of both worlds. And I really like that idea that you use wheat, of course, because it's a great ingredient, but you also use millets, so you get the goodness of millets as well as the advantages of wheat. She also says that it's easier to use millet flours in cakes and cookies because they have a unique flavor. Sameer Soni, who's the brewer at the Great State Ale Works, which is right here in Pune, leading the Millet Beer Project, along with Nakul Bhosle, who's the founder of Great State Ale Works, says that unavailability of millet malt makes it necessary to use unmalted millet grains for brewing. So they've even figured out technology that allows them to use unmalted grains, unmalted bajra for brewing their beers. So given that young entrepreneurs, a lot of people around us are already aware of how cool millets are, how versatile they are as ingredients, I think it's a great time for us, now that we know the science, now that we know how to eat them, to start putting more of these excellent grains into our diet and into the fields around us. With that, I would like to end this talk and thank you all for listening and hopefully starting to eat millets from your next meal.
everyone, I'm Shraddha Burkunde and I'm a science communicator at IISER Pune. Our exploration to understand matter is a journey over centuries and is still ongoing. You must have come across terms like neutrino, God particle, Large Hadron Collider, and so on. So let's talk to a particle physicist and inquire about these curiosities further. Hi Saurabh, thank you for joining us today. Could you tell us what is particle physics and how does it correlate to our understanding of matter?
So particle physics is an interesting field. The aim of particle physics is to try to understand what our world is made up of. So as you've heard from sessions before this, most of the times, traditionally we thought that everything around us was made of the 5 elements, air, earth, wind, fire and so on. And then we learned a little bit more, we did a few more experiments, we learned that stuff is made of atoms. We have a nice little periodic table that tells us the different kinds of atoms. If we keep digging towards smaller and smaller pieces, if we break apart an atom is made of a nucleus and other particles, and the nucleus you break apart is made of protons and neutrons, and the protons you break apart and so on. So we can keep doing this. Today, what we think is that the universe is made up of these fundamental particles. These fundamental particles are organized into different sections, depending on the different colors, you can tell that. So some of these consist of matter particles, in other words, stuff around us is made of these, and some of these are gauge bosons. So these gauge bosons are the particles that help other particles interact with each other. So these can be thought of like the languages with which the matter particles talk to each other. Everybody has heard of these forces. So the forces are the electromagnetic force, the strong nuclear force, the weak nuclear force. Everybody's also heard of gravity, but gravity is so weak that it doesn't play any role in what particle physics is. So what is particle physics? There are two answers to this. Particle physics aims to understand what the world around us is made up of and how do these fundamental particles interact with each other. So these are the goals of particle physics. Any study that tries to uncover this is particle physics.
So would it be right to say that this periodic table of particle physics does not explain gravity?
That's right. So gravity is an unanswered question of the standard model. It is so weak that so far we have ideas about how to explain gravity, but it doesn't form any part of the standard model of particle physics.
I'm assuming that along with gravity, there might be other unsolved problems which are not addressed in the table. Can you elaborate on it?
The standard model of particle physics is exceptionally successful. It's actually one of the best tested theories of mankind. Like we have tested it up to 8 decimal places in certain quantities. Nevertheless, there are a few things that the standard model just doesn't address. So I'm going to talk about a couple of examples. One example is we have experimental evidence that something called dark matter exists in our universe. In fact, 24% of the entire universe is dark matter, 70% is dark energy, and only 4% is the regular stuff that we see around us. The primarily experimental evidence for dark matter is in terms of rotation curves of galaxies. So if you measure the velocity of stars as you go away from the center of a galaxy, you expect this velocity to decrease. But it turns out that this stays constant. So that was the first sign that something is amiss. Today we have a lot more concrete evidence in terms of gravitational lensing. So this tells us that galaxies have a lot of stuff in it that is just not visible. It's not your regular luminous matter, stars and so on. It's dark matter. Now what this dark matter is made up of is obviously a question for particle physics. Right? So since particle physics tries to explain what everything in our universe is made up of, we certainly would like to know what 24% of our universe is made of.
So there is visible matter, there is dark matter, and then there is dark energy. Does particle physics address both dark matter and dark energy?
So not dark energy. Dark energy is more of a cosmological, so cosmology is the field that would address what dark energy is. Dark matter, on the other hand, since it's matter, we expect that it's some kind of a particle. If it's some kind of a particle, then we expect particle physics to be able to say something about what it is. To be completely honest, it doesn't even have to be just one particle. Dark matter itself can consist of many particles the way regular matter consists of many particles.
What are these different subatomic particles which are different from the traditional atomic model?
Traditionally, everything is made up of protons and electrons. As I change the number of protons, we all know that is what the periodic table is. I start with hydrogen, helium, lithium and so on. A proton is made up of two kinds of quarks, an up quark and a down quark. If I put two up and one down, then I get a proton. If I take one up and two down, I get a neutron. Now, like these up and down quarks, there are also other quarks called charm, strange, top and bottom. When I include strange quarks into the mix, I get particles such as kaons. Then there are B mesons that include the B quark. With electrons and electron neutrinos, there are other particles such as the muon and the tau lepton. One of the things is that all of these heavier particles, they are unstable. They immediately decay down to the first generation. So if you start with the second generation, then all of these particles are going to subsequently decay down to the first generation. So this means that whatever you're going to observe in the universe is always going to be eventually just the first generation. In our experiments or in high energy astrophysical phenomena such as centers of stars and whatnot, in these high energy environments you're going to produce these heavier particles, but as soon as they're produced, they're going to very quickly decay down to the first generation. So ultimately what you observe is just from the first generation, which is up, down, electron and electron neutrino. So everything that you know around you, like protons, neutrons, thus all of the atoms, everything is just made from the first generation.
So we often hear and read about God particle. Where does it fit in the periodic table?
The story goes in the following way. Leon Lederman, who's a Nobel Prize winner who was the director of Fermilab, wrote a book about the Higgs boson. The reason to write this book was that the Higgs boson was proposed way back in the 60s, and for many years people were looking for it at different experiments. There was a lot of indirect evidence that something like the Higgs must exist, but nobody could ever find it. This is why there was a lot of literature, there were a lot of books, and Leon Lederman thought outreach was fairly important, so he wrote a book to try to explain what this particle is. Because it was so frustrating and it was not found, he wanted to call his book The Goddamn Particle. His editor, who was a fairly religious person, thought that if the book is called The Goddamn Particle, it won't really sell, and the editor proposed to him to rename the book as The God Particle. That's where the Higgs boson gets its name, the God particle. In reality, it is no more or less important than some of the other particles that we have. The Higgs does give mass to the rest of the particles, but I wouldn't think that necessarily mass is a more important property than charge, for example. The fact that an electron is charged one way and a proton is charged the other way gives rise to the binding between electron and proton, gives rise to atoms and thus all of chemistry and biology. So of course the electromagnetic interaction is the most important one for us as humans. The Higgs boson, or the God particle, is the reason why all of the other particles in the standard model get mass. So when they interact with the Higgs field, that's how they get mass. This is why the Higgs boson has captured a lot of imagination, also because it is amongst the most recent particles to be found in 2012. And so given the long history of searching for the Higgs, that is also why it has captured more imagination than the other particles, which maybe were found a bit sooner.
So we often hear about God particle in newspapers and popular science articles. Where does it fit in the periodic table?
So the Higgs boson is a particle that was predicted, and many years later it was actually found. Some particles tend to be found before they are predicted, and then you have to sort of insert them in your theory. You have to explain, okay, now I found something, how do I go about and explain it? The Higgs, on the other hand, was a proposal that turned out to be true.
So was Higgs the only prediction made?
It wasn't the only proposal. At the time when the Higgs was proposed, there were a few other things that were also proposed to try to explain the masses of particles. It just turned out that the Higgs was the correct explanation.
So I would like to draw parallels between the periodic table in chemistry and the one in particle physics. Both tables accommodate the idea of missing links.
Yes, it is true that you have gaps, you would have gaps in the periodic table of particle physics that you would try to fill. Of course, the periodic table of particle physics is a much smaller thing than our periodic table of elements. So here the way you would fill in these holes was that you would go out and observe manifestations of particles. So you go out and observe, say, a kaon, or you observe a upsilon meson, or you observe a J psi meson, which leads you to believe that there is an additional quark or there is additional phenomena, as opposed to actually going out and observing the quark. So in other words, you have evidence of that object, the quark, existing in some other states. So the example for this would be that all atoms tend to be made of protons and neutrons. So it's kind of difficult to give the same analogy, but nevertheless, suppose you had iron and you had uranium, And if you had observed, say, molecules involving uranium, but you didn't actually know uranium existed. So what you would do is you have this, long sort of a polymer or some sort of a large molecule that had uranium in there, and you would be like, okay, this thing doesn't really make sense unless there is an atom of uranium existing. So that would be a prediction for uranium. Then you'd go out and observe it. Of course, in chemistry, that's not how it came about, but here certainly that's sort of what happened. You looked at the bound states, you saw what their properties were, and that caused you to predict that, oh, if this since this particle exists, underlying it there must be a quark with these properties.
In our conversation so far, we mentioned observation, prediction, and analysis of data. But what are our tools to do these experiments?
In the modern world, we do two kinds of particle physics experiments. The first experiment is when we try to produce new particles in the lab. And the second kind of experiment is where we have detectors that aim to detect cosmic particles. So, neutrinos or dark matter particles that are all around us in space, and we try to detect them on Earth. The first kind, which is the lab experiment, the easiest or the most powerful way to sort of do this is with colliders. So in a collider, you have a beam going one way, you have another beam going the other way, and you have these two beams go at high energy and bang into each other. Now everybody knows Einstein's relation E equals mc square. Effectively what this means is that given a certain amount of E, a certain amount of energy of the collision, you can produce particles with a mass corresponding to that energy. So if I collide something at say 100 GeV, some units, then I'll be able to produce a massive particle with a mass of 100 GeV. If I collide something at 500 GeV, then I'll be able to produce 500 GeV. So now this means that if I want to produce heavier and heavier, so more and more massive particles, I need to collide things at higher and higher energies. The LHC is the world's highest energy collider right now.
Is that the Large Hadron Collider?
Correct. So why is it called the Large Hadron Collider? It turns out that for most of the year, the LHC will collide protons with protons, so proton-proton beam, and protons are hadrons. But for a very short time of the year, like a couple of weeks, the LHC will also collide lead ions and lead ions, or a proton with a lead ion. So the lead-lead collisions tell us something else about particle physics, and the proton-proton collisions tell us something else. The most of the stuff happens with the proton-proton collisions. That's more general, tries to address a lot of things. The challenge of building the LHC is that if you want to accelerate particles to a very, very high energy, charged particles, when you tend to accelerate or decelerate them, they radiate energy. So if I have a circular collider, then particles as they're moving in a circle are going to radiate away their energy. This is called as Bremsstrahlung. Now, this is not very nice, right? You put in energy to accelerate the particle, but the particle radiates away that energy. So, you don't really like that. This is the reason why the LHC is L, it's large. If you make it large, then the amount of bending is small, right? So it's like a gentle curve.
Like a small part of a large circle almost appears to be a straight line.
Exactly, it's almost like a straight line. So that helps in reducing the amount of radiation that it's going to waste. The other thing about the LHC was that the LHC is built in the same tunnel as a previous collider there, which was the LEP, the Large Electron-Positron Collider. It turns out that almost half the cost of building a new collider comes from making the tunnel. So by placing the LHC in the LEP tunnel, we could be very frugal and try to sort of use the same sort of things again. So that is as far as collisions go. Now after you collide these particles, you have to go about and detect them.
Why is this detector so complicated?
So I really like this analogy. Think of an object, a 3D object, say your favorite pet, you have a cat at home. So you take a picture of the cat with your camera. Now, if you print out this picture and you look at it, what you actually have is a two-dimensional representation of a three-dimensional object. Now you look at this picture and very obviously you recognize that, hey, that's my cat. In reality, the amount of processing that your brain has done here is phenomenal. So let me give you one example. Suppose you take a picture of your cat during the day or during the night. The picture is going to look pretty different. Nevertheless, you have no problem recognizing your cat. Imagine I take a picture and show it to you on my phone, which is this small, or I make a big poster-sized picture. You still recognize that it's your cat? In other words, somehow your brain already understands that size doesn't matter, the background light doesn't matter, and so on. It focuses on the right things. The two-dimensional representation is also good at allowing you to sort of judge scale and size and these things. If I showed you a picture of an elephant, your brain knows enough information from beforehand to understand that this looks like a fairly massive object. If I show you a feather, your brain, based on its history and what it has learned about life, tells that, oh, this looks like a light object. With particle physics, we don't have that option. We have to do everything right then and there. So this means that the detector has to be pretty complicated because of all the different kinds of particles. There are only a few of them that are stable enough for us to detect. We need to be able to unambiguously detect what those are. We can't afford to be confused, say, between a photon and an electron, or between a muon and a kaon and so on. So to do all of these things, we build a detector from various subcomponents. Each of these subcomponents is designed with a specific purpose in mind. Each of it acts towards one specific goal. And by putting together the information from all of these different subdetectors, we are able to construct a picture of what the event is.
What would you call this kind of experiment? A multivariable problem perhaps?
So the right way to describe it is that CMS, or ATLAS for that matter, is called as a multi-purpose detector, as opposed to a dark matter or a neutrino experiment, which are very, very specific. Let me take you through some of the different pieces of the CMS detector. The detector is kind of like an onion, so it has layers, kind of like Shrek. So the detector has layers like an onion. The collision happens in the center, which would be somewhere here. As you go away from the center, first there is a detector that detects charged particles. So anything that has a charge, you detect the path of that particle and you detect its charge. So you kind of see how and what direction it's going in. After this charged particle detector, you have something called calorimeters. These calorimeters measure the total energy of the particle. Now in particle physics, one of the most important things that you can do to measure for a particle is measure its 4 vector. So 4 vector means you measure its energy and you measure its momentum in the 3 space coordinates, so px, py and pz. So to measure this 4 vector, what you have is that the tracker measures the momentum, so the direction and the path, so you got the vector, and the calorimeter measures the energy. And now you've gotten the full 4 vector of the particle. This really works well for things like electrons. Photons, on the other hand, are not charged particles, so obviously they don't leave a signature in the tracker, but they just show up in the calorimeter. So now what you can do is, you can compare an electron and a photon. If I see a charged particle pointing to something in the calorimeter, that is an electron. If there is nothing pointing to a deposit in the calorimeter, that would be a photon, because a photon is not going to give you a signal. The other sort of particle that CMS detects very effectively is muons. Muons, because they are heavier than electrons, don't actually behave in the same way as electrons and photons. These muons will just go straight through the detector. So what you do is, you have this tracker, then you have the calorimeter, you stick another tracker at the outside. So what this means is that as the muon goes out, it interacts with the tracker, it's charged, so you see a path, then you see nothing, and you see another path in the muon chambers. So now when you see a path in the chambers outside and a path inside, you match them up, this tells you that it was a muon. So this is why the detector has to be pretty complicated. You have these different sub-pieces, you put together the information from all of these. CMS has a wonderful algorithm called particle flow. So this is written in the software. So this particle flow algorithm helps to take all of the different sub-detectors, take all of their information, and from there classify particles into electrons, photons, hadrons, muons, and so on.
I see a date on the top corner. What is the significance of the date?
This is an actual collision event. This was recorded on Monday, August the 6th, 2018. This is a very interesting collision because in this collision we produced 1 electron, 1 muon and 1 tau lepton along with evidence of some quarks. So it's kind of interesting to have all 3 kinds of leptons represented in the same event. It's pretty rare. This gives you an example of what I was talking about. An electron has this track that points to it with a calorimeter deposit. A muon has no deposit, it goes all the way out to the muon chambers. The tau, for example, in this case has decayed into hadron, so it has a slightly different signature. So this is what you see when you actually observe a single collision. Now you have to actually look at many collisions. So, scientists at CMS will look at millions and billions of these collisions to draw statistical inferences about whether we found new particles or measuring the properties of existing particles, and to try to say something about the universe that we live in.
So Saurabh, we as in IISER Pune is a member of the CMS. What is our role in it?
So IISER Pune has been a member of CMS in 2014. There are 2 scientists here who work on CMS. There is Professor Seema Sharma and there's me. Both of us have a bunch of PhD students and many interested undergrads who work with us. Primarily what Seema and I do is we are mostly interested in searching for particles not described by the standard model. There are various theoretical motivations for why there could be, for example, supersymmetric particles that exist. There could be particles that represent something called a type 3 seesaw mechanism. There could be vector-like leptons, which are not the traditional ones, but which are slightly different. So what we do in our research is we help run the experiment, collect the data, try to improve the algorithms by which we can better identify these particles, and then with the collected data, try to look through the collected data to see if there is any evidence for any of these new particles being present in there. And that is primarily what we do. Most of the time we split our work halfway between analyzing the existing data and preparing for the future. So in terms of building better designed detectors and having better designed algorithms so that the data that we collect remains of an extremely good quality.
Apart from enhancing our understanding of matter, why should we explore particle physics?
Particle physics requires significant investment from the country in terms of funding, in terms of human manpower. You need a lot of smart people to work on this. One easy way to look at this is that if we would have never discovered the electron, we would not have electronics today. Now who knows that today if we discover some new kind of particle, what its uses may be tomorrow. So that is of course number one. The second thing is particle physics, just by its very nature, requires us to be at the cutting edge of a lot of different technologies. For example, as you may know, CERN was the place where the World Wide Web was born. So the information to be shared between scientists and the protocol by which this should be done, that is what WWW stands for, that was a fallout of a large amount of research in particle physics. There are other medical benefits that come about by understanding how radiation interacts with bodies. So for example, things like understanding the fundamental properties of electrons and muons can help us when we decide to do, say, radiation therapy, or you want to understand or you want to build cyclotrons that help us to target cancer cells, for example, with specific kinds of radiation and how they interact with biological cells. So there are a lot of these fringe benefits that only happen if we spend considerable effort in trying to understand the fundamental properties of the world that we live in.
Thank you, Saurabh, for addressing our curiosity so wonderfully. IISER Pune has done other videos about and around this topic. You can find them in the description box under the heading Particle Physics. Wish you a happy Science Day. Thank you.
नमस्कार, पुन्हा एकदा सर्वांचं स्वागत आपल्या आयसरच्या विज्ञान दिनानिमित्त. आणि आजहून आपले 3 सेशन आहेत, अतिशय इंटरॅक्टिव्ह सेशन तुमच्यासाठी ठेवलेले आहेत. आता मी जो घेतोय तो एक सेशन आहे. नंतर टॉयफेस्ट ज्या ऍक्टिव्हिटी आपण केलेल्या आहेत मुलांच्या बरोबर त्या पण तुमच्याशी आम्ही शेअर करणार आहोत. आणि त्याच्यानंतर शेवटी अतिशय इंटरेस्टिंग सेशन आहे. आणि व्हाट इज दैट? साइंस क्विज. आणि उनके लिए तो बहुत अट्रैक्टिव प्राइजेस भी आपके लिए. तो स्टे ट्यून अप टू द 5:30, मतलब 5:30 तक ये प्रोग्राम चलेगा. लास्ट जो सेगमेंट होता है वो तो बहुत इंटरेस्टिंग होता है. और उसके लिए हमने आशीष अरोरा जी को बुलाया है टू कंडक्ट द साइंस क्विज फॉर यू. तो मैं थोड़ा सा आपको हाईलाइट देता हूं. वो क्या हाईलाइट है? विद इन 2 डेज हमें इतने ईमेल आ गए, स्टूडेंट के लगभग 1200 ईमेल आ गए और उनको दे वांट टू पार्टिसिपेट इन टुडेज साइंस डे सेलिब्रेशन. टीचर लगभग 400 टीचर के हमें ईमेल आ गए. और जो पेरेंट्स है, साइंस इंटू पीपल है, उनके भी लगभग 125 हमें ईमेल आ गए विद इन 2 डेज. मैं आपको बताता हूं कि मतलब बच्चों के अंदर, टीचर के अंदर, पेरेंट्स के अंदर साइंस जानने में कितनी रुचि है ये हमें समझ में आता है. और मैं अभी आपको मैं एक 3-4 एक्टिविटी दिखाऊंगा. दैट इज वेरी वेरी इंटरेस्टिंग, जो हमारे डेली लाइफ का वो हिस्सा है. और वो हिस्सा क्या है मैं आपको बताता हूं. देखिए मेरे हाथ में एक बॉटल है और दूसरा मेरे हाथ में एक डब्बा भी है. देखिए जस्ट आई एम टेकिंग द 2 थिंग्स. एक डब्बा है, एक लस्सी का डब्बा है और एक बॉटल है. तो मैं आपको बोलूंगा ये दोनों जो है मेरे हाथ में, ये डब्बे का वॉल्यूम ज्यादा है या बॉटल का वॉल्यूम ज्यादा है? और आपको चार्ट में आंसर देना है, ये डब्बे का ज्यादा या बॉटल का ज्यादा. अभी देखिए मैं थोड़ा सा राह देखूंगा, आपकी वेट करूंगा कि आप क्या बोल रहे हैं. एंड आई थिंक देखिए ये लस्सी वाला डब्बा, आपको मालूम है कि ये उसके डायमेंशन फिक्स है, लेंथ, ब्रेड एंड हाइट आपको मेजर करने को आ जाएंगे. और ये तो लगभग सिलिंड्रिकल है और उसका हाइट भी है और बेस का एरिया भी है. तो मुझे बस इतना बता देना कि लस्सी का डब्बा उसका वॉल्यूम ज्यादा है या बॉटल का ज्यादा होगा या दोनों का इक्वल हो गए. आपको 3 ऑप्शंस है और मैं आपको यहाँ दिखा रहा हूं. आपको इसके अंदर जो कुछ लिक्विड है जो कुछ लिक्विड जो है, मैं अभी कोशिश करूंगा आपको दिखाने की कि दोनों का वॉल्यूम में क्या फर्क है। मैं आपके अभी चार्ट देख रहा हूं, आपके कुछ मुझे आंसर भी आ रहे हैं, मैं अभी आंसर देख रहा हूं यहाँ की क्या आपका आंसर है, इसका वॉल्यूम ज्यादा या इसका वॉल्यूम ज्यादा। चलो अभी बॉटल बोल दिया है, बॉक्स बोल दिया है, फिर बॉटल आर्यन बोल रहा है सेम, अभिषेक बोल रहा है बॉटल, श्रेया बोल रही है बॉक्स, लस्सी बॉक्स अमृता बोल रही है, वैदेही बोल रही है सेम, चलो जानकी बोल रहे हैं बॉक्स। चलो बॉक्स एंड बॉटल अभी आपका कंपटीशन है, ये बराबर है, ये बराबर है। दिखने में देखिए हाइट में थोड़ा तो फर्क होगा, और ये तो आपको मालूम है लगभग सिलिंड्रिकल है, और ये जो है 3 डिमेंशनल है। अभी देख रहे हैं हम कि लस्सी वाला बोल रहे हैं। मैं अभी ऐसा करता हूं, इसमें जो कुछ लिक्विड है मैंने कलरफुल वाटर डाल दिया है, अभी इसमें मैं लेता हूं और आपको बताता हूं एक्चुअली किसका वॉल्यूम ज्यादा है या कम है। मैं आंसर आपको देने वाला हूं थ्रू एक्टिविटी। अभी देखिए हो गया पूरा, वेरी वेरी इंटरेस्टिंग। देखिए आपको जिसने आंसर दिया था इक्वल वॉल्यूम, दे आर करेक्ट, और इसमें सही और रॉन्ग का कुछ सवाल नहीं, आपने कोशिश किया, दैट इज मोर इंपॉर्टेंट फॉर अस। तो अभी देखिए दोनों का ही वॉल्यूम सेम है, लेकिन ये ऐसा डिजाइन क्यों करते हैं, ये ऐसा डिजाइन क्यों करते हैं? और ये बॉटल को पकड़ने के लिए देखिए यहाँ बीच में ऐसा वो शेप बनाते हैं, मतलब हैंडल करने के लिए क्या इजी होगा वो डिसाइड करते हैं। अभी देखिए इसे बहुत इजी हो जाता है, ग्रिप भी मिल जाता है ना इस शेप से। और ऐसे जो पैकिंग होता है ना, तो बेसिकली क्या होता है, कैरी करने के लिए बॉक्स में ऐसे यूनिफॉर्म बैठ सकते हैं। ये यदि बॉटल जाएगी तो उसमें गैप रहेगा, लेकिन इसमें गैप नहीं रहेगा। तो मैं आपको और एक इंटरेस्टिंग चीज बताता हूं, ये जो है इसका वॉल्यूम कैसे निकाले। मैथमेटिक्स तो हम स्कूल में बहुत सीखते हैं, ज्योमेट्री तो बहुत सीखते हैं, लेकिन डेली लाइफ उसका एप्लीकेशन कैसे करें, और इसका बहुत इजी है। अभी मैं आपको बताता हूँ, शायद आपको नंबर दिखाई नहीं पड़ेगा, लेकिन यहाँ जो नंबर होता है ना वो लिखा होता है 200 ml, यहाँ 200 ml लिखा है। आप बोलोगे ये कैसे प्रूव करेंगे, ये 200 ml ही है। तो मैं आपको एक सिंपल तरीका बताता हूँ, बिल्कुल सिंपल तरीका बताता हूँ। वो क्या तरीका बताता हूँ, लेंथ मेजर करो, उसका ब्रेड मेजर करो, और बाद में हाइट मेजर करो। अभी इसे यहां मैंने काउंट करके रखा था, ये 12 है, ये 5 है, ये 3.3 है सेंटीमीटर में। 12 मल्टीप्लाई 5, 60 मल्टीप्लाई 3.3 करो आप, आपको लगभग 200 सेंटीमीटर क्यूब मिलेगा आंसर, क्योंकि सेंटीमीटर में मेजर किया है। और यदि 200 सेंटीमीटर क्यूब है और ये लिक्विड के बारे में जो है वही मिलीलीटर है, तो इसका वॉल्यूम जो है बिल्कुल 200 ml, 12 by 5 by 3.3 सेंटीमीटर। तो देखिए कितनी मजे की चीज है, और वॉल्यूम भी आप कंपेयर कर सकते हो। और एक मैं आपको मजे की चीज दिखाता हूं, और वो चीज क्या है, वो तुम्हारे डेली लाइफ का ही एग्जांपल है। अभी देखिए एक मैंने बॉटल लिया है, लगभग सिलिंड्रिकल बॉटल है, और उसके अंदर हमने ऐसे मार्बल डाल दिए हैं। मार्बल देखिए, मार्बल जो हमें कैंचे गोट्या याच्यात एक अशी एक गोटी टाकली आणि आणखी एक गोटी टाकायचा प्रयत्न केला, तर ही वर आलेली आहे। म्हणजे आता याच्यामध्ये गोट्या जास्त बसू शकत नाही। दिस इज द मैक्सिमम वॉल्यूम ऑफ द बॉटल, जो उसके अंदर मार्बल बैठ सकते हैं, उसके ज्यादा मार्बल बैठ नहीं सकते। आता ये तो ज्यादा हो गए मेरे लिए। तो मेरा क्वेश्चन है, ध्यान से सुनो, क्वेश्चन क्या है, ऑफकोर्स दिस इज फिल्ड विद द मार्बल, लेकिन मुझे क्या चाहिए बिटवीन द मार्बल, क्योंकि शेप इंपॉर्टेंट है, बिल्कुल स्फेरिकल शेप्स है, तो ये बिटवीन द मार्बल कितना गैप है आपको ढूंढना है। और मैं आपको 3 ऑप्शन देता हूं, जितना टोटल ये वॉल्यूम होगा बॉटल का, टोटल मैं बोल रहा हूं ना, समझो कि एम्प्टी बॉटल का अंदर हवा है, पानी है, तो आप उसका वॉल्यूम समझो। तो जितना वॉल्यूम है उसका आधा वॉल्यूम मार्बल का होगा, मतलब आधा जो बिटवीन द गैप जो हवा होती है हवा का होगा, मतलब आधा मार्बल आधा हवा। ये एक ऑप्शन है। मार्बल का वॉल्यूम हवा के वॉल्यूम से ज्यादा है, ये दूसरा ऑप्शन। तीसरा ऑप्शन क्या, मार्बल का वॉल्यूम हवा के वॉल्यूम से कम है। अभी देखिए मैं अभी ये करता हूं, आपको चार्ट में देखता हूं। देखिए क्वेश्चन एक बार, ये मार्बल से भरा है और अंदर जो कुछ है गैप, वहां तो हवा होगी, मतलब मैं ऐसा बोल रहा हूं ये हवा से और मार्बल से भरा है। तो उसमें मार्बल का वॉल्यूम कितना, हवा का वॉल्यूम कितना, या हवा का वॉल्यूम ज्यादा है या मार्बल का ज्यादा है या इक्वल है। चलो अभी क्या आंसर आ रहा है आपका, नाइस वीडियो। हाफ वॉल्यूम, आपने किसी ने आंसर दिया, आर्यन बोल रहा है कि हाफ हो सकता है, मतलब हाफ मार्बल का वॉल्यूम है तो हाफ हवा का होना चाहिए। तो ऐसा चेक करेंगे तो हमें तो लगता है कि मार्बल से भरा है, लेकिन बिटवीन द गैप वो जो हवा है वहां, उनका वॉल्यूम कितना है ये मैं आपको बताना चाहता हूं। हाफ वॉल्यूम बोल दिया है, मार्बल मोर बोल दिया है, मार्बल मोर बोल दिया है, हाफ वॉल्यूम बोल दिया है। अनवाज बोल रहा है कि हाफ वॉल्यूम, कामल बोल रहा है कि मार्बल का ज्यादा होगा, प्रवीण बोल रहा है हाफ, बाद में वैदेही बोल रही है हाफ, और एपीएस कारंडे बोल रहे हैं मार्बल मोर। चलो अभी मार्बल मोर और अमृत पाटिल भी बोल रहे हैं। चलो अभी मैं दिखाता हूं बिल्कुल सिंपल से। टेक द 2 आइडेंटिकल बॉटल्स, एक में पानी भरो, ये पानी है और ये मार्बल है। अभी देखिए, और मार्बल के बीच में हवा है, तो अभी मुझे हवा का वॉल्यूम निकलना है, तो कितना है, बहुत इजी, इसमें डालो ये। अभी डालते जाइए, डालते जाइए, डालते जाइए, डालते जाइए, अरे भरने दो, अभी भरने दो। अभी देखिए, ये हाफ से ज्यादा हवा का वॉल्यूम था, तो हमें लग रहा था ये मार्बल से भरा है। तो मैं थोड़ा अदर लैंग्वेज में बोलता हूं, मार्बल का वॉल्यूम कम है, ज्यादा हवा से भरा है, मार्बल का वॉल्यूम कम है। लेकिन सिंपल एक्टिविटी से आपको ये पता चलेगा। दिस इज अ वेरी वेरी इंटरेस्टिंग एक्टिविटी। और बाद में आपको क्या करना है, मार्बल का साइज चेंज करो, छोटा ले लो, बड़ा ले लो, बाद में सैंड ले लो, तो आपको पता चलेगा बिटवीन द मार्बल्स, बिटवीन द सैंड पार्टिकल्स, अंदर जो हवा होती है उसका वॉल्यूम कितना है। तो देखिए, मतलब ये ऐसा बोलना है तो मार्बल का वॉल्यूम कम, हवा का वॉल्यूम ज्यादा, मतलब ज्यादा हवा से भरा है, ये मुझे आपको बताना था। और छोटे छोटे एक्सपेरिमेंट से हमें पता चलता है। देखिए, और एक 2 चीजें मैं आपको बताने वाला हूं। अभी देखिए, इसमें जो चीज है, दिस इज वेरी वेरी इंटरेस्टिंग। वो क्या है, एक सिलेंडर है, ये क्या है, एक कोन है। देखिए, कोन और सिलेंडर आपने दोनों भी देखा। बिल्कुल मैं ट्रांसपेरेंट क्यों इस्तेमाल कर रहा हूं, क्योंकि यू कैन सी एक्चुअली व्हाट इज हैपनिंग ओवर हियर। अभी देखिए, दोनों का हाइट सेम है, हाइट सेम, और दूसरा क्या है, इसका जो एरिया जो है बेस का वो भी सेम है, हाइट सेम, एरिया सेम। देखिए, ऐसा भी मैं आपको बता सकता हूं। तो अभी मुझे आपको, हमेशा हम सीखते हैं क्लास में कि वॉल्यूम ऑफ द सिलेंडर, यू नो द वॉल्यूम ऑफ द सिलेंडर इज इक्वल टू इसका बेस एरिया पाई आर स्क्वायर मल्टीप्लाई हाइट, पाई आर स्क्वायर एच, एच मतलब हाइट, और इसका क्या होगा, फॉर्मूला में क्या है, 1/3 पाई आर स्क्वायर एच। अभी 1/3 मतलब इसके अंदर जितना होगा वॉल्यूम वो कितना होगा, इससे 3 गुना ज्यादा होना चाहिए। बेसिकली ये मीनिंग है। तो देखते हैं, प्रूव करते हैं हम, है या नहीं। बस उसमें पानी भर दो। अभी मैं कोशिश करता हूं, इसमें कलरफुल वाटर लेता हूं और आपके सामने बताता हूं कि एक्चुअली क्या है। मैं थोड़ा सा कैमरे के सामने कर रहा हूं, थोड़ा पानी गिरने का भी चांस है, तो मैं कोशिश करता हूं। देखिए, एक लिया मैंने, इसमें लिया, बाद में मैं क्या करता हूं, देखिए मैं दूसरा लेता हूं, देखिए मैं पूरा भर के दूसरा लेता हूं, दूसरा लेता हूं। अभी देखिए, दूसरा 2/3 हो गया, पहला 1/3, बाद में 2/3, और उसके बाद जो मैं ले रहा हूं लास्ट वाला, अभी देखिए लास्ट वाला मैं ले रहा हूं, देखिए भर गया तुम्हारा। So this is a very very interesting activity. You can prove the formula of the mathematics. Okay, volume of the cylinder is equal to 1/3 of the मतलब volume of the cylinder 3 times more than the volume of the cone. मतलब कोन का कितना होगा, 1/3 होगा, और इसका 1 है तो कोन का कितना होगा, बिल्कुल इससे 1/3 होगा। ये मुझे बताना था, 3 से पता चलता है। और बहुत इंटरेस्टिंग चीज मैं आपको बताना चाहता हूं, इसका थोड़ा सा साइंटिफिक कैसा रिलेटेड है। अभी जो मैंने पहला इस्तेमाल किया था बॉटल का, ये है मेरा 200 ml वाला बॉटल, जो मैंने फ्रूट जूस जैसा इस्तेमाल किया था। बाद में ये है मेरा, जो है ये कितने का है, ये 500 ml का, 500 ml का है। अभी मुझे यही 2 बॉटल से और एक ये एक्टिविटी से एक्सपेरिमेंट भी करना है। अभी देखिए, आई हैव 1 पाइप, देखिए ये मेरे हाथ में पाइप है, ये पाइप है, ये पाइप में यहाँ 2 होल्स है, देखिए 2 होल्स है। अभी देखिए, ये पाइप बिल्कुल ऐसा स्टैंड मतलब खड़ा कर सकता हूं मैं, लेकिन यहाँ जो है स्लांट कट है, देखिए ये स्लांट कट है, और इस स्लांट कट के ऊपर मैं ये बैलेंस कर सकता हूं क्या, नहीं, देखिए वो गिर जाएगा, इट विल फॉल। तो अभी मैं कोशिश करूंगा, यदि मतलब इसका जो मैंने पहले सेशन में बताया था, अभी बॉटल का इस्तेमाल यही कर रहा हूं। देखिए ये बैलेंसिंग पॉइंट जो होता है ना इसका, यहाँ कहाँ होगा, देखिए ये बैलेंसिंग पॉइंट यहाँ कहाँ होगा, देखिए दिस इज बैलेंसिंग पॉइंट, ओके। और इसके सेंटर में उसका सीजी होगा। अभी मैं क्या करूंगा, देखिए ये कोशिश करूंगा, एक छोटा बॉटल लेता हूं और ये मैं फ्लैट सरफेस पे रखता हूं। मैं कोशिश करूंगा फ्लैट सरफेस पे रखने की। हाँ, तो अभी देखिए मैं ऐसा कोशिश करता हूं यहाँ, देखिए ये कोशिश करता हूं मैं यहाँ, क्या हो रहा है, ये गिर जाएगा वहां। लेकिन ये 5 प्लेस 1 बॉटल, अभी देखिए थोड़ा सा ये जो इतना वॉल्यूम वाला, अभी देखिए यू नो द डेंसिटी ऑफ द वाटर क्या है, 1 ग्राम पर सीसी हम बोलते हैं ना, तो ये 200 ml पानी है, कलरफुल पानी है वैसे, तो ऐसा समझो इसका वेट ही 200 ग्राम है, उसका नजदीक है। अभी देखिए, अभी मैं क्या करता हूं, यहाँ बॉटल डालता हूं, हाँ देखिए कितना अच्छा बैलेंस हो गया। और इफ आई यूज, देखिए ये देन अभी मैं कोशिश करता हूं आपको दिखाने की, आई कैन बैलेंस, देखिए अभी कितना अच्छा बैलेंस हो गया। देखिए मैं थोड़ा सा कैमरे की तरफ आपको जाता हूं। सो दिस इज वेरी वेरी इंटरेस्टिंग बैलेंस, मतलब जितना वॉल्यूम का पानी है उतना वेट ही है, ओके। ये हाथ में ले लो, अभी ऐसा वेट है, तो मैंने लगभग 700 ग्राम का वेट इस साइड लगा दिया, तो सीजी समझ लो कि जो कुछ यहां था ओरिजिनली, तो यहां आ गया। एंड इफ यू ड्रॉ द परपेंडिकुलर फ्रॉम हियर, द परपेंडिकुलर इज फॉलिंग इन द बेस, मतलब बेस का जो एरिया है वही एरिया पे परपेंडिकुलर फॉल होना चाहिए। सो दिस इज अ वेरी वेरी इंटरेस्टिंग एक्सपेरिमेंट एंड दिस इज द बेसिक प्रिंसिपल बिहाइंड द लीनिंग टावर ऑफ द पिसा। मतलब लीनिंग टावर ऑफ द पिसा जो है ना, वो गिरता क्यों नहीं, तो लीनिंग कितना है आपको मालूम है, अभी नेट पे इंफॉर्मेशन ले लो। लेकिन यदि सीजी समझ लो कि टावर ऑफ पिसा का यहाँ है, तो उससे परपेंडिकुलर आज भी उसके बेस के एरिया के अंदर ही है, इसलिए वो गिरता नहीं। मतलब यहाँ मैंने 700 ग्राम वेट ऐड किया था। तो ऐसे छोटे छोटे एक्सपेरिमेंट से देखिए ना कितनी मजा आ जाती है। तो मैं आपको ये बोलता हूं कि हमने क्या किया था, नेक्स्ट सेशन, हम ये सेशन नेक्स्ट सेशन के लिए कनेक्टेड है। तो कैसा कनेक्टेड है, हमने लगभग फरवरी के फर्स्ट वीक में बच्चों को ऐसे कि ईमेल लिखा था, टीचर को ईमेल लिखा था, इफ यू हैव दिस काइंड ऑफ द एक्टिविटी, आपने तो बहुत ऐसे कुछ एक्टिविटी करते हैं, तो उसके बारे में साइंस और मैथमेटिक्स लिखकर उसका एक्सप्लेनेशन लिखना है 300 वर्ड में, और वो एक्सपेरिमेंट हमें भेजना है थ्रू वीडियो से। तो हमें लगभग 250 एक्टिविटीज आ गए, 250 एक्टिविटीज, और उससे तो सभी तो विनर ही है, हम सभी बच्चों को विनर ही समझते, सभी टीचर को विनर ही समझते, सभी को पार्टिसिपेशन सर्टिफिकेट भी मिलने वाला है। लेकिन उसमें से रिप्रेजेंटेटिव कुछ बच्चे और टीचर ने जो कुछ एक्टिविटी किया है, नेक्स्ट हमारा जो सेशन है टॉयफेस्ट में आप देख रहे हैं, आप देखने वाले हैं। थैंक यू वेरी मच।
Hello everyone, I am Hello everyone, I am Ankish Tripude from Srimati Indrani Balan Science Activity Center, IISER Pune. We welcome you all to this interesting segment of National Science Day. Toyfest is an online toy making platform where students, teachers, and science enthusiasts from all over the country can submit their ideas in the form of videos or images. Here at Science Activity Center, we are engaged in developing low-cost, interactive science and mathematics ideas that can be used to teach subject in a fun and engaging way. The objective is to strengthen teaching and learning method of science and mathematics through these simple toys and hands-on activities, which students can build in a fun and engaging way. Based on this theme, on 3rd of Feb of this month, we have announced the online toy making event as a key concept for the National Science Day. For this, we have received total 194 projects by the students and total 48 ideas were submitted by the teachers for the Toyfest 2022. However, we have selected some of the unique ideas that reflect basic understanding of science and mathematics. In this segment, participants who have been selected for Toyfest 2022 from all over the country will present their ideas and key concepts for their model. So let's start the session. Welcome, Anika Kanade. Congratulations to being selected for this Toyfest 2022. Let's see the idea that she has presented in the form of a video.
This is my basketball shooter toy. One interesting thing about this toy is that I have made it completely from waste materials, as its main objective was to utilize waste materials in a fun and interesting way. The way this toy works is very simple. When we keep the ball in its place and exert pressure on the back of the stick and then release it, the ball gets flicked forwards. So this is how it happens. I've kept the ball in this place, and when I exert pressure on the popsicle stick, the ball gets flicked forwards.
Basketball shooter toy works on the principle of every action has an equal and opposite reaction. When you apply force to push the shorter stick down, it exerts equal and opposite force that causes the ball to fly in the air.
Would you like to explain, Kanika, about your model?
Yes, though this is the model of the basketball shooter toy. The main idea behind this was when my science teacher, Mrs. Nidhi Jan ma'am, she had told us that we had to make a project, and as sir mentioned, this is made completely out of waste materials. So the idea I got this was from a slingshot, and it works mostly on the principles of how a slingshot works. I would also like to acknowledge and present my thanks to my brother, my dad, and my mom. My brother is in first year in BITS Pilani, and he really helped me and he encouraged me to think about the principles of this toy on my own. And my dad helped me to build this.
This is a very interesting, and I hope that you will keep this journey on and you will make more such interesting models. I thank you very much for sharing your thoughts on this platform, and we wish you all the very best for your future endeavor. Thank you very much.
Thank you.
We have another interesting idea presented by Mahendra Sonoji Nebade from IISER Pune Madhyamik Vidyalaya, Jalgaon, Maharashtra. And we request you if you could brief more about this idea and how you got motivated about it. Over to you, sir.
माझं नाव आहे महेंद्र सोनोजी नेमाडे. मी IISER Pune माध्यमिक विद्यालय जळगाव येथे जवळपास 25 वर्षापासून मॅथमॅटिक्स शिकवत आहे. एवढ्या सर्व वर्षाचा अनुभव विचारात घेता विद्यार्थ्यांमध्ये हँड्स ऑन ऍक्टिव्हिटीचा जर विचार केला तर मॅथमॅटिक्स लवकर अंडरस्टँडिंग होतो. आणि तोच विचार करून मी ही ऍक्टिव्हिटी थोडीशी डिझाईन केली. हे डिझाईन करण्यामागे मला मोटिवेशन मिळालं माझ्या मुलाकडनं. माझा मुलगा लहान असताना तो पेपर बोट बनवायचा. पेपर बोट बनवल्यानंतर मग ती अनफोल्ड करायचा. अनफोल्ड केल्यानंतर मग माझ्या डोक्यात क्लिक झालं की हे अनफोल्ड केल्यानंतर जे काही ट्रायंगल्स तयार होत आहेत, स्क्वेअर्स तयार होत आहेत, याचा आपण मॅथमॅटिक्स मध्ये हँड्स ऑन साठी ऍज अ मॉडेल म्हणून उपयोग करता येईल का.
बरं.
त्यावेळेस मी सर्व ट्रायंगल्सचे लेंथ, साइड्सच्या लेंथ मोजल्या. त्यावरनं मला असं जाणवलं की जे तयार होणारे 32 ट्रायंगल्स आहेत जे या पद्धतीने दिसतात ते सर्वच्या सर्व 32 ट्रायंगल्स हे कॉन्ग्रुएंट आहेत. कॉन्ग्रुएंट म्हणजेच एकरूप आपण मराठीत म्हणतो, आणि जे एकरूप असतात त्यांचा एरिया इक्वल असतो. आणि यात व्हिडिओमध्ये दाखवल्याप्रमाणे अशी फिगर जनरेट होते, आणि त्या फिगरमध्ये आपण बघतो की एका ट्रायंगलचा एरिया आणि हा दुसऱ्या ट्रायंगलचा एरिया. आपण एरिया म्हणताना त्याला युनिट, स्क्वेअर युनिट्स म्हणतो. इथे आपण 2 ट्रायंगल युनिट म्हणू शकतो. म्हणजे इथे अनदर वे टू एक्सप्रेस द युनिट असं म्हणू शकतो. इथं 2 ट्रायंगल्स, इथं 2 ट्रायंगल्स आणि इथं 4 ट्रायंगल्स. आणि मग हा विचार करून मग माझ्या डोक्यात आलं की अरे इथं पायथागोरस थेरम आहे, आणि मग त्यानुसार हे डिझाईन केलं गेलं. आणि ते आपल्यासमोर मांडलं.
So he is being motivated by his child. The interesting story behind this is that while unfolding it, they have found a very interesting pattern in the form of a triangles, and they have related with a concept called congruence of triangle, where we have in a textbooks. And he has pointed out very interestingly that there are total 32 right angle triangles. Okay. And also all the triangles are congruent in nature. So this is a story behind this. And also we thank you, Mahendra sir, for sharing this interesting thought. So next project that has been selected for this event is by Kirti Rahul Gaikwad. She is from Maharashtra, from Rashna Vidyalaya, Nashik. She basically has the domain of chemistry and biology, but of course she is also a sports teacher, and she loves to interact with the students in a form of a subject, but also in a form of games and activities.
This was the geoboard I used in my class, and these are the hydrogens. हे जे हायड्रोजन आहेत ना, हे सगळे मी बिस्लरीचे ज्या बॉटल्स आहेत त्याचे कॅप्स घेतलेले आहेत. यू कॅन ऑलवेज से दॅट इट इज बेस्ट आउट ऑफ वेस्ट.
ओके.
इको फ्रेंडली पण आहे, कारण हे प्लास्टिक आपण असंही कचऱ्याच्या डब्यात टाकतो. तर मुलांना मला ज्यावेळेस हायड्रोकार्बन एक्सप्लेन करायचं असतं, तर त्यावेळेस मी या पद्धतीने हायड्रोकार्बन मुलांना एक्सप्लेन करते. एलिमेंटरी केनाल, तर मग मुलांना शिकवताना एलिमेंटरी केनाल कसं शिकवायचं, तर मग पुन्हा हे पाठ आहे सर. एक साधा ऍप्रन तयार केला सर, मांजरपाटचा कपडा घेतला, खूप खर्च येत नाही, कुणीही वापरू शकतो.
बरोबर.
माझं म्हणणं एवढंच आहे की सगळ्या शिक्षकांनी जर अशा ऍक्टिव्हिटी बेसने शिकवलं तर मुलांना जास्त लक्षात येतं. त्यामध्ये मी काय केलं, टेलरकडे गेले आणि टेलर कडून पिवळ्या रंगाचा कपडा घेतला, त्याच्यामध्ये पुन्हा चिंध्याच भरलेत, त्याला मागच्या साईडला रेक्रॉन लावलं, तोच इथे लावला, आणि हे एका मुलाला ऍप्रन घालून द्यायचं आणि सांगायचं, सांगा पहिलं काय माउथ. मग माउथ कडून कुठे जातं, इसोफेगस. मग जो ज्याच्याकडे इसोफेगस असेल ते सगळे पार्ट्स वाटले जातात वर्गात, आणि मग तो येतो, माझ्याकडे इसोफेगस आहे, इसोफेगस लावतो आणि त्याचं एक्सप्लेन करतो.
And I really congratulate you, ma'am, for submitting this interesting thought in the form of a video. And we really look forward for such interesting toys and also some teaching aid for other upcoming topics. So we have another interesting project submission in this Toyfest 2022 by Himanshu Chandrasekhar Udan. He is from Maharashtra. He has submitted the project on the theme based on mathematics. So let's see how he has explained the model in the form of the video.
मैं आप सबका राष्ट्रीय खेल जत्रा में 2021 में सब स्वागत करता हूँ। और यहाँ पर मैंने ये भागाकार यंत्र बनाया है। इस भागाकार यंत्र से आप भागाकार सीख सकते हो। 16 डिवाइडेड बाय 3, यहाँ पर 16 है, इसलिए मुझे 16 कंचे लेने पड़ेंगे। पर मैंने 16 कंचे लिए हैं और डिवाइडेड बाय 3 मुझे 3 लोगों में बांटना है। तो फिर बांटना होगा 1 2 3, सबको 1 1 मिल गए हैं। 1 2 3, सबको 2 2 मिल गए हैं। फिर से ऐसे ही बांटते चले जाना है। सबको 3 3 मिले हैं और यहाँ पर सबको 4 4, अभी भी 4 बचे हैं। सबको 5 5 मिले हैं और मेरे पास ये 1 बचा है। तो फिर मैंने यहाँ पर 16 कंचे लिए थे, इसलिए यहाँ पर मैंने 16 लिखे हैं और 3 लोगों में बांटना था, इसलिए यहाँ पर मैंने 3 लिखे हैं। सबको कितने मिले हैं 5, इसलिए यहाँ पर मैंने 5 लिखा है। टोटल मैंने इन लोगों को 15 बांटे थे, इसलिए यहाँ पर 15 लिखे हैं। मेरे पास बचा कितना है 1, इसलिए यहाँ पर।
हाँ सर, टीचर है।
थैंक यू, वेलकम टू दिस इवेंट। हम चाहते थे कि स्टूडेंट और टीचर अगर साथ ही रहे तो बहुत ही अच्छा होता है। एंड वी रियली अप्रिशिएट योर एफर्ट सर, दैट यू हैव टेकन दिस बॉय सो मच अहेड एंड यू हैव गिवन हिम चांस टू प्रेजेंट हिज थॉट।
ऍक्च्युअली आहे सर, जे विद्यार्थी म्हणजे भागाकारामध्ये मागे आहे, तर अशा विद्यार्थ्यांना भागाकाराचा संबोध स्पष्ट करण्यासाठी, त्यांना ते सोप्या पद्धतीने शिकवण्यासाठी मग हा यंत्राची कल्पना सुचली। ठीक आहे,
थँक यू व्हेरी मच, थँक यू। So we have next interesting thought, a very creative idea presented by next participant, Aisha Iqbal Nada. She is from Maharashtra, mathematics teacher from Zilla Parishad School, Tujarpur. She has explained a very interesting concept on fractions, basically proper and improper fractions, which is very sometimes difficult to understand by the student. So, madam, thank you very much for submitting this interesting thought.
पहिल्यांदा मी तुमचं अभिनंदन आणि आभार मानेन की मी आम्हाला या महाराष्ट्रातल्या पूर्ण लोकांना संधी तुमच्या मार्फत मिळाली आमच्या. परंतु अलीकडच्या या काळामध्ये शैक्षणिक साहित्याचा वापर सुरू झालाय आणि तुमच्यासारख्या जे आता टॉयफेस्ट वगैरे असेल संस्था त्यांच्या मार्फत शैक्षणिक साहित्य दिल्या पण जातात, घेतल्या पण जातात आणि त्याला उत्तेजना दिली जाते. अशाच एका ट्रेनिंग मधून मी प्रेरित झाले आणि साहित्य बनवायला शिकले. शैक्षणिक साहित्याच्या स्पर्धेमध्ये 3-4 वर्ष मी माझा प्रथम दुसरा क्रमांक मिळवलेला आहे. तर त्यामध्ये मला मुलांसाठी 3री पासून 7वी पर्यंत अपूर्णांक हा घटक मुलांना अवघड जातोय असं वाटायला लागलं. आणि या अपूर्णांक म्हणजे काय, मुलांना ती मूळ संकल्पना एकदा त्यांच्या लक्षात आली की ते अपूर्णांक म्हणजे नेमकं काय असतंय, एकदा लहानपणापासून त्याच्या डोक्यात बसले की अपूर्णांक म्हणजे असं असं आहे, तर त्यावेळेला तो पुढे तो काय करू शकतोय की त्यावर येणारी गणित तो कितीही सोडवू शकतो. घरातील सुतारकाम आमचं चालू होतं त्यावेळेला असं छोटस एक फळ मला तुकडे दिसले आणि ते लक्षात आले की आपण ह्याच्यापासून काहीतरी साहित्य करू शकतोय. आणि याच्या मदतीनं मी हे फक्त छोटस एक साहित्य आणि त्याच्या मदतीला असे छोटे छोटे प्लॅनल हे जे बोर्डचे छोटे असे तुकडे तुकडे तयार करून घेतलेले आहेत. आणि काही लाकडी पण तुकडे आहेत, काही असे टिकाऊ असे भरपूर असे वस्तू आहेत. तर यामध्ये काय केलं मी, मुलांना दोन गट करायचे, एका गटाने प्रश्न विचारायचे आणि दुसऱ्या गटाने उत्तर द्यायचे, असं त्यांनी खेळत खेळत उत्तर याची निर्माण करू शकतात.
मॉडेल खूपच जे मॉडेल मॅडम तुम्ही आणि जे आयडिया तुम्ही जे मांडलेली आहे खूपच अप्रतिम आयडिया आहे. ऑल्सो लेट मी ब्रीफ द थिंग that she has made with the help of that you have seen in the form of a video. The whole idea is to understand the math with the help of doing the things. So that the student should understand about the fraction and also about the puzzles that she is trying to implement in the form of an activity. So I think I personally think that this model can depict the ideology and also the key concept behind the fractions and the other things. Also, to know more about the activity, you can check the description box. So, thank you, madam. तुम्ही जी आयडिया सबमिट केली या टॉयफेस्ट 2022 मध्ये त्यासाठी thank you.
Okay, thank you, sir.
So, another interesting project has been submitted by Mohammad Salik from Maharashtra, Urdu High School, Kidwai, Ratnagiri, and he has submitted very interesting topic on animal scare gun. So, let's see his interesting idea in the form of a video.
Hello sir, myself Mohammad Salik. My project name is Animal Scare Gun. जैसे कि आप यहाँ देख रहे होंगे कि मैंने यहाँ 2 गन बनाई है. दोनों ही गन को हम जानवरों को डराकर भगाने के लिए इस्तेमाल कर सकते हैं. देखिए सर, मैंने यहाँ केमिकल कैल्शियम कार्बाइड का यूज़ किया है. मैं अब इसके अंदर उसे डालता हूँ. फिर मैं इसके अंदर पानी को ऐड करता हूँ. और एज अ बुलेट मैं यहाँ प्लास्टिक की बॉटल का यूज़ कर रहा हूँ. देखिए मैं यहाँ बुलेट किस तरह डाल रहा हूँ. अब इस पाइप के अंदर केमिकल रिएक्शन होता है वाटर और कैल्शियम कार्बाइड का, जिसकी वजह से एसिटिलीन गैस इवॉल्व होती है. और इस वक्त जब हम इस लाइटर को ऑन करते हैं तो विस्फोट होता है इसके अंदर और साउंड प्रोड्यूस होता है. और इसके साथ साथ अंदर जो बॉटल रखी हुई है वो फ्लो हो जाती है. देखिए सर.
So Salik, could you please explain the key concept of this model that you have submitted? या आप कुछ ऐसी बातें हमसे शेयर करना चाहेंगे कि इस मॉडल बनाते समय आपको किस तरह से ये आइडिया आया है और किस तरह से आपने इसे और बिल्ड किया है? Over to you, Salik.
So myself मोहम्मद सालिक. मैं रत्नागिरी के खूबसूरत गांव कड़वई में रहता हूं, जहां आम और नारियल के पेड़ बड़ी तादाद में पाए जाते हैं, जिसकी वजह से जंगली जानवर जैसे कि बंदर वगैरह इन्हें खराब कर देते हैं. इस वजह से बागबानों को बड़ी मुश्किल का सामना करना पड़ता है. इस नुकसान को टालने के लिए मैंने इस गन को बनाया है. और इस गन को मैंने बनाया है. मैं महाराष्ट्र उर्दू हाई स्कूल कड़वई में पढ़ता हूँ, जहाँ के उस टीचर्स ने मेरी बहुत मदद की और हमारे स्कूल के प्रिंसिपल सर रिजवान कारीगर ने मुझे बहुत मोटिवेट किया। सर मेरी गन के फायदे ये हैं कि इन्हें हम जानवरों को डराकर भगा सकते हैं जो हमारे खेतों में आकर हमारी फसलों को बर्बाद कर देते हैं। इसको मैंने बड़े कम खर्च में बनाया है जिसकी वजह से हम इसका यूज बड़ी आसानी से कर सकते हैं।
सालिक, जैसे आपने बताया ये गन जो जानवर रहते हैं जैसे कि बंदर हो गया तो उसे आप डराने के लिए इस्तेमाल कर सकते हैं। इसे और भी किसी लोगों ने यूज किया है, आप बता सकते हैं ऐसा कुछ?
सर मैंने जो गन बनाई थी फर्स्ट टाइम वो 2 लोगों ने लेके उसका यूज भी किया है।
बहुत बढ़िया। आपके टीचर भी आपके साथ है तो क्या हम उनसे भी बात कर सकते हैं?
जी
नमस्ते सर। नमस्ते।
हाँ, गुड आफ्टरनून सर।
गुड आफ्टरनून।
मैं मोहम्मद तौफीक। ये एनिमल स्केल गन बनाई गई है जिससे क्या होता है, इसमें हम कैल्शियम कार्बाइड नाम का केमिकल यूज करते हैं जिस पर पानी डालने के बाद एसिडिन गैस इवॉल्व होती है, खारिज होती है, और जब हम इसको इग्नाइट करते हैं इस लाइटर की मदद से तो एक धमाका होता है और हम ये बॉटल यूज करते हैं एज ए बुलेट। तो धमाके से आवाज से बंदर डर कर भाग जाते हैं।
सर टीचर्स और हमारे प्रिंसिपल को बहुत थैंक्स बोलना चाहता हूँ सर।
ओके, थैंक यू। सो सालिक जी, आप ऐसे ही आगे बढ़ते रहिए, हमारी तरफ से आपको बेस्ट विशेस है और भी ऐसे इंटरेस्टिंग आइडियाज आप और बनाते जाइए और हमें भी शेयर कीजिए। थैंक यू।
थैंक यू सर।
Thank you very much. So I'm very happy that we were very successful to launch this event, and I also congratulate all the participants one more time for joining this session and also for selecting in this event. So we have seen how interestingly and creatively teachers and students from all over the country have submitted their ideas in the form of a video. Also, before concluding this session, I would like to express my deep gratitude to the entire Science Activity Center team for their constant support and motivation for the event success. Also, please check the description box for the Toyfest 2022 gallery where we have collected all the entries for this year. Thank you.
Okay, so I think we are live. At least that's what I heard from Ankish. That's what I heard from the Balan Center team. Let's wait for a few seconds to learn that we are live. I would want to see myself. Yes, I can see myself now. Okay, hello everyone. So जिस मोमेंट का आपको काफी देर से इंतजार था, मैं चैट में देख भी रहा था कि सभी लोग बहुत ही उत्साहित हैं कि यहाँ पर साइंस क्विज होने जा रही है। इंडिया के साइंटिस्ट आज कुछ क्विज कंपटीशन ऑर्गेनाइज कर रहे हैं, तो बहुत लोगों के बहुत सारे क्वेश्चन थे कि क्विज ये किस तरह से खेलेंगे, कहाँ पे पार्टिसिपेट करेंगे, कौन सा लिंक होगा। अभी हम आपके सामने हैं, आपको दिखाई दे गया कि यही लिंक है और इसी में हम आपके सामने 6 लोग की हमारी टीम है। इंडिया साइंस थिएटर हमारा एक ग्रुप है जिसमें इंडिया के बहुत सारे साइंटिस्ट हम एक साथ मिलकर बहुत सारे इवेंट्स करते रहते हैं। यूट्यूब पे हमारा चैनल भी है, फेसबुक पे हमारा एक ग्रुप भी है, बहुत सारी एक्टिविटीज हम साइंस की बड़ी मजेदार एक्टिविटीज हम करते रहते हैं। और हमारा मेन मकसद होता है कि हमारी जो साइंस है उसको इंडिया की आम जनता तक पहुंचाने का, इंडिया की आम जनता तक साइंस की एक्साइटमेंट को पहुंचाने का। तो मेरा नाम आशीष अरोड़ा है और मैं आईसर पुणे में फिजिक्स का फैकल्टी हूँ। आपको मेरी टी शर्ट से नजर आ गया होगा, मैं फिजिसिस्ट। तो मेरे साथ जो टीम है साइंटिस्ट की, उनसे मैं आपको थोड़ा सा पहले क्विकली मिलवाना चाहता हूँ, इससे पहले कि हम क्विज का कंपटीशन जो है आज का शुरू करें। तो सबसे पहले कोई बोल रहा है कि वॉल्यूम बहुत लो है, वॉल्यूम बहुत लो है क्या? ये थोड़ा सा चेक करेंगे हमारे जो टेक्निकल वाले।
I think most people are saying that voice is low.
Yeah.
Okay. Let's see. Maybe the voice will improve. Ankish is taking a look in it. मुझे बोला जा रहा है वॉल्यूम इंक्रीज करने को, तो मेरा माइक का वॉल्यूम तो नॉर्मली जितना होता है उतना ही है। मैं अगर माइक्रोफोन सिस्टम करूं, मेरी आवाज आ रही है सबको?
बिल्कुल सही आ रही है मेरे को।
तो दर्शकों आप मुझे बताइए कि आपको मेरी आवाज आ रही है अभी ठीक? अगर ठीक आ रही है तो मुझे इसमें
I see volume is enough.
Okay, volume is enough. That is very important because if volume is not there, then how will we play the quiz? हमारी शक्लें देख के, हमारा फेस रीड करके, हमारा लिप्स रीड करके तो बता नहीं सकते कि सवाल क्या पूछा गया। ऑल दो सवाल आपकी स्क्रीन पर भी आएगा। ओके, कुछ लोग बोल रहे हैं कि वॉल्यूम इनफ है। सुपरस्टार स्टडी बोल रहे हैं बेस बढ़ाओ। आज यहाँ पर डिस्को नहीं होने जा रहा है, क्विज होने जा रही है। तो ये बढ़िया है। ओके, सुपरस्टार ओपी। ओके, तो हम क्या करेंगे अभी, हमारी टीम का एक छोटा सा इंट्रोडक्शन करेंगे, जल्दी से क्विज शुरू भी करनी है और क्विज के रूल्स भी बताने हैं। तो हमारे साथ हैं डॉक्टर गुरतिंदर कौर। डॉक्टर गुरतिंदर कौर स्कॉटलैंड में पोस्ट डॉक्टरल रिसर्चर हैं। इन्होंने स्विट्जरलैंड से पीएचडी की है अपनी, जहां तक मैं जानता हूं। हमारे साथ हैं डॉक्टर दिव्या ज्योति। डॉक्टर दिव्या ज्योति अभी आईआईटी मद्रास में पोस्ट डॉक्टरल रिसर्चर हैं, ये भी एक फिजिसिस्ट हैं। तो मैं सारे दर्शकों को अनुरोध करूंगा कि हमारी जो टीम है इनका भी स्वागत किया जाए। हमारे साथ है श्रद्धा शर्मा। श्रद्धा शर्मा एक फिजिक्स एंथुसियास्ट हैं, ये मथुरा से हैं। हमारे साथ हैं सार्थक मिश्रा। सार्थक मिश्रा जी एक पीएचडी स्टूडेंट हैं। कहाँ पीएचडी कर रहे हैं? जर्मनी में। जर्मनी में एक सिटी है म्यूंस्टर। म्यूंस्टर जो है वो एक नॉर्थ वेस्ट एकदम उसके नीदरलैंड्स के बाजू में है, तो वहां पर ये पीएचडी कर रहे हैं मेडिसिन में। और फिर हमारे साथ हैं प्रोफेसर प्रीतम भट्टाचार्य जी। प्रीतम भट्टाचार्य जी बिट्स पिलानी क्या जो गोवा कैंपस है, गोवा कैंपस में प्रीतम भट्टाचार्य जी कंप्यूटर साइंस के प्रोफेसर हैं। और मैंने जैसे आपको बताया मैं एक फिजिक्स का असिस्टेंट प्रोफेसर हूँ आईसर पुणे में। ठीक है, हम अपनी क्विज का जो आज मेन चीज है वो शुरू करने जा रहे हैं। तो सबसे पहले चैट में मुझे लिख के बताया कि वॉल्यूम ठीक है अभी और सब कुछ क्लियर हो रहा है। हमारी क्विज जो है वो इंग्लिश और हिंदी दोनों में होने जा रही है। तो चैट में लिख के ये भी बताएंगे कि आपको इंग्लिश और हिंदी समझ आती है तो आप क्विज खेल पाएंगे। तो हम अपनी स्क्रीन शेयर करेंगे अभी और स्क्रीन शेयर करके अपना क्विज का कंपटीशन आज का शुरू करते हैं। चलो स्क्रीन शेयर करेंगे। स्क्रीन शेयर करने के बाद मैं जाऊंगा यहाँ स्लाइड व्यू में, स्लाइड शो में चले गए हैं। तो ये वाला पोस्टर जो है ये शायद आप में से बहुत लोगों ने ऑलरेडी देख लिया होगा। सभी लोग इसमें खेल सकते हैं, तो आप अपने दोस्तों को अभी भी व्हाट्सएप पर लिंक ये पोस्ट कीजिए क्विज कंपटीशन का, ये जो यूट्यूब का लिंक है, और उनको बोलिए कि यहाँ पर हमारे साथ क्विज कंपटीशन ज्वाइन कीजिए, क्योंकि यहाँ पर प्राइजेस भी मिलने वाले हैं और बहुत ही एक्साइटिंग प्राइजेस मिलने वाले हैं। चलिए आगे चलते हैं। मिस्ट्रीज ऑफ द यूनिवर्स, ब्रह्मांड के रहस्य, इस पे आज का क्विज कंपटीशन होने जा रहा है। अगर आपको ब्रह्मांड की बहुत सारी रहस्यमयी चीजों में इंटरेस्ट है, अगर आप उसमें रुचि रखते हैं, तो आप आज के क्विज कंपटीशन में जीत सकते हैं। ये हमारा आपको प्रॉमिस है। तो आपको सिर्फ रुचि चाहिए ब्रह्मांड में, और मेरा ख्याल से बहुत सारे लोगों को ब्रह्मांड में रुचि है। जिन जिन लोगों को ब्रह्मांड में रुचि है चैट में लिख के बताएंगे। इफ यू आर इंटरेस्टेड in universe and its mysteries, please write yes in chat so that we know that we are with us. So आज के जो क्वेश्चंस हैं उनका श्रेय जाता है प्रोफेसर प्रीतम भट्टाचार्य को और मेरे को खुद। हमने क्वेश्चंस आज के प्रिपेयर किए हैं। ओके, लेट्स गो। रूल्स बताएंगे अभी। रूल्स क्या है आज के क्विज के? 12 क्वेश्चंस होंगे। फास्टेस्ट फिंगर फर्स्ट होगा, मीनिंग हम आपसे एक क्वेश्चन पूछेंगे, हमारी टीम का एक मेंबर आपसे क्वेश्चन पूछेगा, वो क्वेश्चन आपकी स्क्रीन पर आएगा, हिंदी में पढ़ा जाएगा पहले, फिर इंग्लिश में भी पढ़ा जाएगा, और आपको इमीडिएटली चैट में फटाफट टाइप करके आंसर देना है। क्वेश्चन का आंसर 1 या 2 वर्ड का मैक्सिमम होगा। जैसे ही आप आंसर देंगे, जिसका आंसर सबसे पहले आएगा, सबसे करेक्ट आंसर सबसे पहले आएगा, उसको एक इनाम दिया जाएगा। उसका मैं नाम अपने पास नोट कर लूंगा। इनाम क्या दिया जाएगा वो मैं आपको दिखाता हूँ। एक बहुत ही इंटरेस्टिंग चीज है मेरे पास, बहुत इंटरेस्टिंग चीज है मेरे हाथ में। मैं पहले स्क्रीन शेयर रोकता हूँ। मेरे हाथ में यहाँ पर एक आईसर पुणे ने एक बड़ा इंटरेस्टिंग सा मॉडल बना रखा है। ये देखो, मेरे पास एक्चुअली 2 कॉपीज है इस मॉडल की। इसमें एक तो ऐसे कोई ट्रांसपेरेंट सी चीज है, इसको परस्पेक्स बोलते हैं, इसके ऊपर बनाया है, और दूसरा लकड़ी के ऊपर बनाया है। चलो आपको परस्पेक्स वाला दिखाते हैं। इसके ऊपर आईसर पुणे साइंस एक्टिविटी सेंटर भी लिखा हुआ है। हाँ, अच्छा, तो इसमें क्या है, इसमें एक यहाँ पे फिजेट स्पिनर लगा है। फिजेट स्पिनर जानते हैं ना, जिसको फिजेट स्पिनर का पता है क्या होता है, वो चैट में लिख के बताइए कि उनको पता है फिजेट स्पिनर क्या होता है। और दूसरा, इसके साथ एक यहाँ पर एक कॉइल लगी है। ये कॉइल क्या है, ये एक तार है कॉपर की तार। ये आप मार्केट में अगर जाएंगे, इलेक्ट्रिशियन की किसी भी शॉप पे जाएंगे, वहां पे बोलेंगे मुझे वाइंडिंग वायर दे दो, वाइंडिंग वायर बोलते हैं इसको। तो ये वो वाली तार है, उसकी एक घुमा घुमा के थोड़ा सा मैं पास करता हूँ कैमरा के, वो एक कॉइल बना रखी है। हाँ, तो ये वाली जो तार होती है, इसके ऊपर एक इंसुलेटर चढ़ा होता है। तो अगर आप बहुत सारे टर्न इस तरह से घुमा के बना भी देंगे, तो वो आपस में ना शॉर्ट नहीं करते हैं। तो यहाँ पर जैसे 2000 टर्न होंगे इसमें बना रखे होंगे, और जो 2 छोर बचते हैं, जो तार के 2 सिरे बचते हैं, वो 2 सिरों के साथ यहाँ पर एक एलईडी लगा रखी है। क्या लगा रखी है? एलईडी जो जलती है ना। अब यहाँ पर आप देखेंगे इसमें कोई बैटरी नहीं है, फिर भी अगर मैं इस फिजेट स्पिनर को घुमाऊंगा तो देखिए यहाँ पर क्या होगा, आपको एलईडी जलती हुई नजर आएगी। क्या आपको एलईडी जलती हुई नजर आ रही है? अगर आपको एलईडी जलती हुई नजर आ रही है तो बताइए। ये फिजेट स्पिनर में फिर से घुमा रहा हूं, थोड़ा नीचे करके घुमाएंगे। जलती हुई नजर आ रही है? थोड़ा कैमरा के पास लाते हैं। तो ये एक जनरेटर बना दिया हमने। अब जनरेटर ये कैसे बना मैं आपको बताता हूँ। ये एक्चुअली जो फिजेट स्पिनर है ना, ये बड़ी मैजिकल चीज है। इसके नीचे एक्चुअली हमने 3 मैग्नेट्स लगा दिए। यहाँ पर एक मैग्नेट है, यहाँ पर एक मैग्नेट, यहाँ पर। और ये मैग्नेट्स जब घूमती हैं इस कॉइल के ऊपर, तो यहाँ पर इस पे एक वोल्टेज प्रोड्यूस होती है। वोल्टेज प्रोड्यूस होती है। इस लॉ को क्या बोलते हैं? इलेक्ट्रोमैग्नेटिक इंडक्शन, फैराडेज लॉ ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन। फैराडे लॉ क्या बोलता है कि जब कोई मैग्नेट एक कॉइल के ऊपर इस तरह से घूमती है, whenever a magnet rotates on a coil, magnetic field associated with the coil changes all the time. It keeps changing. A changing magnetic field produces an induced EMF. इसमें कॉइल पे EMF क्या होता है? वोल्टेज। एक वोल्टेज प्रोड्यूस करेगा। जैसे ही वोल्टेज प्रोड्यूस करेगा, ये एलईडी जलेगी। फिर से देखेंगे, देखिए जनरेटर बना दिया। तो जितने जनरेटर्स होते हैं हमारे, जो जहां से आपको बिजली मिलती है, जो डैम के ऊपर, डैम पे भी बड़ी बड़ी टर्बाइंस लगी हैं, टर्बाइंस में भी कॉइल होती है, वो मैग्नेट्स के बीच में घूमती है। वहां पर इसी सिद्धांत के बेस पर बिजली बनाई जाती है। तो इस तरह से आपको ये वाला प्राइज जो है वो आपको भेज दिया जाएगा। कैसे भेजा जाएगा? पोस्ट किया जाएगा। ठीक है, तो इसका मतलब ये हुआ कि आपको इस कंपटीशन में बहुत एंथुसियास्टिकली पार्टिसिपेट करना है। आप पार्टिसिपेट करेंगे, आप प्राइज जीतेंगे, और आपको ये प्राइज पोस्ट किया जाएगा। जो सबसे पहले आंसर देगा उसको ये प्राइज पोस्ट किया जाएगा। मैं स्क्रीन फिर से शेयर करता हूं। तो ये वाले रूल्स हैं। और आपको प्राइज कैसे मिलेगा? आप पूछेंगे कि मेरे पास एड्रेस कैसे आएगा। एड्रेस आपने क्या करना है, अगर मैं आपका नाम लूंगा कि आपने प्राइज जीता है, तो आपने अपना एड्रेस इस ईमेल आईडी पर ईमेल कर देना है, ashish.arora@iserpune.ac.in। ये ईमेल आईडी आप लिख लीजिए। ईमेल आईडी आप लिख लेंगे तो अच्छा रहेगा, क्योंकि उसके बाद आपको दोबारा से ये वाला जो पेज है खोलने की जरूरत नहीं पड़ेगी। वैसे तो ये वीडियो इसी पर रहेगी, आईसर पुणे के पेज पर रहेगी। आप वीडियो फिर से खोल के ईमेल आईडी देख सकते हैं, लास्ट में भी मैं बताऊंगा, बट आप इसको लिख लीजिए अपने पास। वेरी गुड। तो हम चलते हैं क्विज। हाँ जी, बताइए प्रीतम।
आशीष, ये लोग काफी एक्साइटेड हो गया है ये चीज देख के। एक्चुअली कुछ लोग बोल रहे हैं कि ये घर पे भी बनाने की कोशिश करेंगे। दैट्स ग्रेट। That's exactly the spirit we want to see.
This is what we want. Exactly. Yes. आप ये घर पे बना सकते हैं। इनफैक्ट आईसर पुणे का साइंस एक्टिविटी सेंटर है, उनके आप YouTube चैनल पर अगर जाएंगे तो वहां पर आपको ये कैसे बनाना है बताया भी जाएगा, और यहाँ पर चैट के ऊपर आपके ऊपर एक पिन कर दिया गया है मैसेज, हाँ तो वो भी देखिए, वो पिन कर दिया है, उसमें बताया जाएगा कि फिजिक्स स्पिनर के साथ इलेक्ट्रिसिटी कैसे बनाना है। चलिए तो हम आगे बढ़ते हैं। पहले हम अपनी क्विज की टीम से पूछते हैं कि सभी तैयार हैं? क्विज की टीम बता दीजिए।
बिल्कुल, यस।
एक्सीलेंट एक्सीलेंट एक्सीलेंट, तो हमारी क्विज की टीम तैयार है। अब हम पूछेंगे चैट से। चैट, आर यू रेडी?
आर यू रेडी?
प्लीज बताइए चैट में लिख के आप तैयार हैं। अगर आप तैयार हैं तो बहुत मजा आने वाला है। फिर अपने हाथ पकड़ लीजिए, उंगलियां अंगूठे सब पकड़ लीजिए, फोन कंप्यूटर जहां पर भी आपने टाइप करना है टाइप करने को शुरू हो जाइए। मैं आपको 15 सेकंड का टाइम दूंगा। आप अपनी चाहे तो ये जो स्ट्रीम चल रही है लाइव स्ट्रीम, इसको रिफ्रेश भी कर सकते हैं ताकि हमारे साथ आप उसी समय के लिए उसी टाइम मतलब एग्जैक्ट लाइव जुड़ सके ना। 15 सेकंड का टाइम दूंगा और हम शुरू करेंगे क्विज कंपटीशन बहुत ही जल्दी।
तब तक हम सब एक गहरी सांस भी ले लेते हैं।
तो बहुत सारे लोग रेडी हैं, मैं नाम थोड़े लेता हूँ। अरुण कुमार यस, प्रगन्या गुजराती यस, राहुल नाग यस, आर्यन साइंस यस, राधा गुप्ता यस, सुजीत, सब लोग बोल रहे हैं रेडी हैं, बहुत मजा आने वाला है।
बिल्कुल रेडी है।
चलो तो चैट हम जाएंगे हमारे पहले क्वेश्चन की तरफ। उससे पहले आप फटाफट लाइक का बटन दबा के अपनी अटेंडेंस लगवा दीजिए। जो जो लाइक का बटन दबाएंगे मैं यकीन दिलाता हूँ वो प्राइज जरूर जीतेंगे। जल्दी से जल्दी लाइक का बटन दबा के अपनी प्रेजेंस लगवा दीजिए। मैं यहाँ पे चेक कर रहा हूँ आप लाइक का बटन दबा रहे हैं। उसके बाद हम क्विज कंपटीशन शुरू करेंगे 10 सेकंड में। फटाफट जिसने लाइक का बटन नहीं दबाया दबाइए और प्रेजेंट लगवाइए।
मैं भी दबा दिया।
वेरी गुड। चलिए पहला सवाल आज की शाम का, पहला सवाल इन नेशनल साइंस डे का, आईसर पुणे से लाइव, ये रहा आपकी कंप्यूटर की स्क्रीन पर। 1842 में एक सिद्धांत की खोज की गई थी। इससे हमें यह जानने में मदद मिलती है कि कोई तारा हमारी ओर आ रहा है या दूर जा रहा है। इसे क्या कहते हैं? A phenomena was discovered in 1842. It helps us to know if a particular star is coming towards us or is going away. What is it called? एक ऐसा सिद्धांत, बहुत ही यूजफुल सिद्धांत। यहाँ पे आपको एक मीम दिखाई दे रहा है। अगर आपने ये शो देखा होगा बिग बैंग थियरी तो आपको जरूर पता होगा।
आंसर्स आने स्टार्ट हो गए।
आंसर्स आने स्टार्ट भी हो गए। वाओ, द ऑडियंस इज वेरी स्मार्ट। लुक एट दैट, लुक एट दैट, वेरी फास्ट, वेरी फास्ट। तो मैंने देखा
एक्यूरेट आल्सो।
वेरी नाइस, वेरी नाइस। तो देखते हैं, थोड़ा नाम ले देते हैं कौन कौन क्या क्या लिख रहा है। तो शुरुआत करते हैं। सुयोग लिख रहे हैं डॉपलर इफेक्ट। शौविक दास लिख रहे हैं डॉपलर इफेक्ट। शौविक दास एक बड़े मजे हुए खिलाड़ी है। वो हमारी इंडिया साइंस थिएटर की जो क्विज होती है काफी रेगुलरली होती है हमारे इंडिया साइंस थिएटर के यूट्यूब चैनल पर भी, वहां पर बहुत प्राइज जीत के जाते हैं। वहां पर तो हम कैश प्राइज देते हैं, 200 रुपया 250 रुपया हर क्वेश्चन का। हाँ, अभिषेक सारबुखान डॉपलर इफेक्ट, डॉपलर शिफ्ट। वेंकटेश डॉपलर इफेक्ट। अमन जोरी टेलीस्कोप। आयुषी तरवाड़े एस्ट्रॉइड। इन्फिनिट डॉपलर, प्रथम प्रवार डॉपलर। समृद्धि मोहिते रेड शिफ्ट। दर्शन डॉपलर। वाह, मैं तो बहुत हैरान हूँ, जनता बहुत ही फास्ट आंसर दे रही है। और 294 लोग हमारे साथ जुड़ चुके हैं और मैंने देखा कि 720 लोग थे लाइक किए, अब 792 हो गए हैं। तो लोगों ने लाइक का बटन दबा दिया है। अब जिन्होंने दबाया उनको प्राइज जरूर मिलेगा, ये पक्की बात है। लाइक का फल मीठा होता है। अंगूठा दबाने का एक फल मीठा होता है। तो अभी भी हमारे पास आंसर आते ही जा रहे हैं। तो हम इसके सही आंसर की तरफ चलते हैं। सही आंसर है जी डॉपलर इफेक्ट। और सबसे पहले इसका सही आंसर दिया सुयोग जिन जुड़ते जी ने। सुयोग जिन जुड़ते जी, आपको बहुत बहुत बधाई हमारी टीम की तरफ से। गिव हिम अ राउंड ऑफ अप्लॉज। सुयोग जिन जुड़ते, बहुत बढ़िया खेले आप, बहुत फास्ट आंसर आया था। आपके पास आपका इनाम मिल जाएगा, ये वाला जो फिजिक्स स्पिनर बेस्ड इलेक्ट्रिसिटी जनरेटर है। आप मेरे को अपना एड्रेस ईमेल कर देंगे और साथ में आप अपना नाम और सब कुछ ईमेल में लिख देंगे कि आपने ही ये प्राइज जीता है। और हाँ, पहचान के तौर पर आप अपने चैनल का एक स्क्रीनशॉट भी मुझे भेजेंगे। ठीक है, ताकि हमें पता चले कि ये आप ही हैं। ठीक है, चलो सेकंड क्वेश्चन ये रहा आपकी स्क्रीन पर, श्रद्धा पढ़ेंगी।
ब्रह्मांड या बाहरी अंतरिक्ष का औसत तापमान कितना है? What is the average temperature of the universe or outer space?
जी हाँ, औसतन तापमान कितना है? ब्रह्मांड ठंडा है, गर्म है, क्या है? फ्रिज से ज्यादा ठंडा होगा क्या? क्या लगता है?
सुयोग ने आई थिंक आंसर दिया है सबसे पहले।
हाँ, पर ठीक है या नहीं वो तो देखना होगा ना।
हाँ, वो देखना पड़ेगा। अभिषेक ने 0 केल्विन, and then फहद, हरजीत सिंह
2 million Kelvin also.
2 million Kelvin. Wow.
Yes.
Aryan science is a very hot science.
अनुराधा ने एब्सोल्यूट 0।
ओके, तो थोड़ा थोड़ा नाम लेते हैं। हरजीत सिंह 2.73 केल्विन, कुछ लोग -273 डिग्री सेल्सियस भी लिख रहे हैं। अंशिका -273, रिया जबीन -273, लीना 2.7, अनुराधा एब्सोल्यूट 0, शुभांगी 2.7, आर्यन 2 मिलियन केल्विन, पृथ्वीराज -273। वैसे आर्यन जी 2 मिलियन केल्विन में आप जिंदा कैसे हैं, ये क्वेश्चन होगा हमारा।
और मेजर भी कर चुके हैं,
मेजर भी किया है, न्यूक्लियर फ्यूजन हो रही होगी। हाँ वही तो। दर्शन 2 मिलियन केल्विन, सेजल -273, केके ब्रोस -270। बहुत ही अच्छी ट्राई है, बहुत अच्छा कंपटीशन। प्रीतम लिख रहे 1729 फ़ारेनहाइट। क्या श्रद्धा?
यूनिट्स नहीं लिख रहे हैं।
हाँ चलो कोई बात नहीं, वो हम समझ जाएंगे क्या लिखना चाहते हैं। तो हम इसके सही आंसर के लिए चलते हैं अगली स्क्रीन पर। सही आंसर बताएंगी श्रद्धा।
So the answer is approximately 2.73 Kelvin, and to be like sure, -270.4 degree Celsius.
Exactly. और इसका सबसे पहले आंसर दिया है हरजीत सिंह जी ने। हरजीत सिंह जी आपको बहुत बहुत बधाई, आप इसका सही आंसर देके फिर से एक इनाम जीत गए हैं। आपको ये फिजेट स्पिनर वाला इलेक्ट्रिसिटी जनरेटर भेज दिया जाएगा। हरजीत जी बहुत कूल है, बहुत बढ़िया खेल लिया, एकदम बहुत बढ़िया जवाब था। तो इसका 2.73 केल्विन ऐसा आंसर क्यों? मैं थोड़ी सी इसकी स्टोरी बताना चाहूंगा, क्योंकि आज का हमारा क्विज कंपटीशन का ये भी मकसद है कि हम सीखें, है ना। तो आज से कुछ 13.8 बिलियन ईयर्स अगो, 1380 करोड़ साल पहले बिग बैंग हुआ। बिग बैंग क्या हुआ? वहां से यूनिवर्स की शुरुआत हुई, स्पेस टाइम वहां से बनना शुरू हुआ। बिग बैंग होने के कुछ 377 मिलियन साल बाद, 377 मिलियन ईयर्स आफ्टर बिग बैंग ना, 3,77,000, हाँ मैं थोड़ा सा गलत बोल रहा हूँ, 3,77,000 साल बाद बिग बैंग होने के क्या हुआ कि इलेक्ट्रॉन्स और प्रोटॉन सब आप स्पेस में ऐसे ही घूम रहे थे उस टाइम पर, और यूनिवर्स ठंडा होता जा रहा था, क्योंकि शुरू में यूनिवर्स बहुत गर्म था, फिर ठंडा होता जा रहा था। यूनिवर्स कुछ 4000 केल्विन का हुआ, तो इलेक्ट्रॉन जो इधर उधर घूम रहे थे ना, वो प्रोटॉन्स के साथ आके मिल गए, और इलेक्ट्रॉन प्रोटॉन के साथ जब मिलते हैं तो क्या बनता है? हाइड्रोजन एटम बनता है। जब हाइड्रोजन के अणु बने तो वो एक्साइटेड स्टेट में थे, इलेक्ट्रॉन बाहर वाले ऑर्बिट्स में थे, फिर वो अंदर के ऑर्बिट्स में जंप किए, तो जैसे ही अंदर जंप किए तो लाइट निकली। ये यूनिवर्स की पहली रेडिएशन थी जो यूनिवर्स ने देखी थी। और हुआ ये कि जैसे जैसे यूनिवर्स फिर एक्सपैंड होता गया, फैलता गया, इस रेडिएशन में डॉपलर शिफ्ट होती गई। आपने पिछला क्वेश्चन देखा होगा, डॉपलर इफेक्ट के नाम पे था। डॉपलर इफेक्ट क्या होता है कि जब कोई चीज हमारे से दूर जा रही होती है तो उसकी फ्रीक्वेंसी कम होती जाती है। तो ये रेडिएशन की फ्रीक्वेंसी भी कम होती गई और ये माइक्रोवेव बन गई। पहले विजिबल थी या अल्ट्रावायलेट में थी, फिर माइक्रोवेव बन गई, और आज भी ये रेडिएशन हमारे सब तरफ नजर आती है। और इस रेडिएशन का एक्चुअल में तापमान है 2.73 केल्विन। ये यूनिवर्स में भरी हुई है रेडिएशन। ये आज भी जो यूनिवर्स की सबसे पहली रेडिएशन थी, इसको कॉस्मिक माइक्रोवेव बैकग्राउंड रेडिएशन बोलते हैं। और ये वाली रेडिएशन जो है, ये बिग बैंग थ्योरी का सबसे अच्छा प्रमाण है। आपसे अगर कोई पूछे कि बिग बैंग क्यों हुआ या बिग बैंग हुआ, इसका क्या आपके पास प्रमाण है, क्यों नहीं, क्या प्रमाण है, तो आप बोलेंगे कॉस्मिक माइक्रोवेव बैकग्राउंड रेडिएशन हर तरफ नजर आती है, यूनिवर्स का टेम्परेचर 2.73 केल्विन है, ये सबसे बड़ा प्रमाण है। तो हमने ये सीखा आज कि यूनिवर्स का टेम्परेचर 2.73 केल्विन औसतन है। चलिए मुबारकें देते हुए हम तीसरे क्वेश्चन की तरफ चलेंगे। लाइक का बटन दबाते जाइए, जिन्होंने नहीं दबाया है उनको तभी प्राइज मिलेगा। तीसरा क्वेश्चन ये रहा आपकी कंप्यूटर की स्क्रीन पर, प्रीतम पढ़ेंगे।
ब्रह्मांड में पदार्थ की सबसे प्रचुर अवस्था कौन सी है? What is the most abundant state of matter in the universe?
जी हाँ, स्टेट्स ऑफ मैटर तो आपने जाना होगा, पर ब्रह्मांड में सबसे ज्यादा कौन सा है, कौन सा ओपी है, ये हमने बताना है। कौन सी स्टेट ऑफ मैटर सबसे ज्यादा है?
Okay, answers already आना शुरू हो गए।
प्लाज्मा, प्लाज्मा गैस।
नाम दे दो थोड़े से।
डार्क मैटर।
अभिषेक बोल रहे हैं प्लाज्मा।
इन्फिनिटी वाई कह रहे हैं ब्लैक लाइव्स।
किसी ने डार्क मैटर लिखा हुआ है।
किसी ने
डार्क मैटर डजंट मैटर।
मनमोहन सिंह जी लिख रहे हैं लिक्विड।
ठीक है थोड़े नाम ले दो ना।
मुजफ्फर शेख गैस, अनिका कनाडे गैस, अर्जुन मलिक प्लाज्मा, पृथ्वीराज प्लाज्मा, आर्यन साइंस प्लाज्मा एंड उत्पल सॉलिड। प्रवल कह रहे हैं हाइड्रोजन, श्रेया कुलकर्णी कह रही हैं नाइट्रोजन, पल्लवी भास्कर डार्क मैटर।
कोई मजामा भी कह रहा है।
किसी ने
मजामा?
हाँ
वो पूछते हैं केम छो मजामा।
मजामा
प्रीतम जी बोल रहे हैं नथिंग एल्स मैटर्स।
प्रीतम जी को भेज देते हैं। जहां पर नथिंग एल्स मैटर है, प्रीतम जी को उसका ध्यान रखने के लिए भेजते हैं उसी यूनिवर्स में। तो अभी भी आंसर्स आते जा रहे हैं, बहुत ही एक्साइटिंग क्विज कंपटीशन यहाँ पर। तो प्लाज्मा मोस्टली ऑडियंस पोल अगर हम देखें तो शायद प्लाज्मा की तरफ जा रहा है, क्या बोलते हो आप लोग?
प्लाज्मा एंड ब्लैक लाइव्स।
कृति, हमारे व्यूअर कृति बोल रहे हैं भगवान जाने।
हाँ, ये तो सबसे इम्पोर्टेंट आंसर है। कृति जी से हम प्राइज ले लेंगे। उनको हम बोलेंगे कि आप हमें प्राइज दे दीजिए। चलो हम चलते हैं इसके सही जवाब की तरफ। सही जवाब प्रीतम पढ़ेंगे, ये रहा।
सही जवाब है प्लाज्मा, जो कि यूनिवर्स का 99.9% कवर करता है।
हाँ,
और
तो
ऑडियंस वर्क है, बहुत ही स्मार्ट ऑडियंस है,
बहुत स्मार्ट है। प्लाज्मा क्यों है? क्योंकि यूनिवर्स में मोस्ट ऑफ द मैटर इज लोकेटेड इन स्टार्स, यू नो, इट्स लोकेटेड समवेयर व्हिच इज वेरी वेरी हॉट, इन गैलेक्सीज, इन स्टार्स। तो स्टार्स और गैलेक्सीज में टेम्परेचर इतना ज्यादा होता है कि वहां इलेक्ट्रॉन प्रोटॉन सब अलग अलग हो चुके होते हैं, चार्जेस बन चुके होते हैं। प्लाज्मा क्या होती है? इट्स जस्ट ए कलेक्शन ऑफ चार्जेस, इट्स ए स्टेट ऑफ चार्जेस। तो अगर आप प्रोटॉन्स और इलेक्ट्रॉन्स को अलग अलग कर देंगे बहुत हाई टेम्परेचर पे, तो प्लाज्मा बन जाता है। यहाँ पर आपको दिखाई दे रहा होगा राइट साइड पे एक बॉल सी बनी हुई है, ये प्लाज्मा बॉल है। ये आप कहीं पर ऑनलाइन स्टोर्स में भी खरीद भी सकते हैं, 2-3 हजार की आ जाएगी प्लाज्मा बॉल। इसमें इसेंशियली जैसे लाइटनिंग होती है, जो हम बिजली गिरती है तो प्लाज्मा बनता है वहां पर। बिजली भी जब गिरती है तो प्लाज्मा बनता है। तो यूनिवर्स की सबसे ज्यादा जो स्टेट है वो प्लाज्मा है। चलिए हम आगे बढ़ते हैं। और हाँ, इसका
प्रवल जी पूछ रहे
हैं कि प्लाज्मा ऑप्शन में नहीं था, क्योंकि
हाँ, तो ऑप्शन में नहीं था इसका मतलब ये नहीं है कि सबसे ज्यादा वो प्रचुर स्टेट नहीं है, तो आपको ये बताना था। अच्छा चलो, मैं ये बताना चाहूंगा कि इसका सबसे पहले जो सही जवाब दिया है वो दिया अभिषेक सारभू खान जी ने। अभिषेक सारभू खान जी, आपको बहुत बहुत बधाई। एक राउंड ऑफ अप्लॉज फॉर अभिषेक सारभू खान। अभिषेक ओपी, वेरी गुड, वेरी वेल प्लेड अभिषेक। बहुत फास्ट आंसर आया था, ऑलमोस्ट ओपी वाला आंसर था। चलिए हम चलते हैं आगे। चौथा क्वेश्चन, दिल थाम लीजिए, अपने हाथ में अपने फोन थाम लीजिए, अपने टैबलेट्स, अपने कंप्यूटर, कीबोर्ड सब थाम लीजिए, उंगलियों को शार्प कर लीजिए, नाखून काट लीजिए, तैयार रहिए। चौथा क्वेश्चन आने वाला है, ये रहा आपकी कंप्यूटर की स्क्रीन पर। डीजे पढ़ेंगी दिव्या।
अंतरिक्ष से सूर्य किस रंग का दिखाई देता है? What is the color of sun when looked at from space?
सूर्य किस रंग का दिखाई देता है जब आप स्पेस से देखते हैं, ये बताना है आपको।
सुयोग जी बोल रहे हैं व्हाइट।
अच्छा, ये तो बहुत ही नई इंफॉर्मेशन होगी मेरे लिए।
अंशिका बोल रही है ऑरेंज, मैत्रेयी ऑरेंज, Aryan, white, Riya,
reddish,
black,
प्रिया बोल रही
white,
है अभिषेक
white.
ओपी। यहाँ पर बड़ा ओपी मुकाबला चल रहा है। तो बहुत सारे आंसर्स डिफरेंट डिफरेंट कलर के आंसर्स आ रहे हैं।
बोल रहे हैं काला,
काले रंग का सूर्य नजर ही नहीं आता फिर तो, है ना? ये इंटरेस्टिंग है। पर जिसने काले रंग का सूर्य बोला है वो शायद रेसिस्ट नहीं है, तो ये अच्छी बात है।
ब्लैक बोल रहे हैं।
पीछे वाले से कॉपी किया उन्होंने ये आंसर ब्लैक लाइट से।
हाँ, वहां से कॉपी हुआ है। तो बहुत सारे आंसर्स आ चुके हैं।
इन्फिनाइट वाई कह रहे हैं ब्लू व्हेन क्लोज, रेड फ्रॉम फार रेडशिफ्ट।
हाँ, किरण खुराना बोल रही है टेक माय नेम। किरण जी, आपका नाम हमने लिया है, बढ़िया है। आप यहाँ पर पार्टिसिपेट करते रहिए और मजे लेते रहिए, हमें बहुत कुछ सीखने को भी मिल रहा है। तो हम
नौराज बोल रहे हैं ऑल कलर मिक्स।
इसका हम सही जवाब देने वाले हैं अभी, क्योंकि हमें आगे भी बढ़ना है। सही जवाब के लिए अगली स्क्रीन पर जाते हैं। दिव्या बताएंगी सही जवाब। ये रहा आपकी स्क्रीन पर,
व्हाइट। सो द कलर इज सफेद रंग।
सफेद रंग का दिखाई देता है। यहाँ पर राइट साइड पर आपको एक इमेज दिखाई दे रही है जो कि ISS इंटरनेशनल स्पेस स्टेशन में से ली गई है। इंटरनेशनल स्पेस स्टेशन धरती से काफी हाइट पर है, तो वहां पर क्योंकि कुछ भी एटमॉस्फेयर नहीं है तो आपको वो आसमान से जो सूर्य का असली रंग पता चलेगा, तो वो व्हाइट नजर आता है। अब पॉइंट ये है कि व्हाइट क्यों नजर आता है, इसको थोड़ा सा जानेंगे। इसके पीछे एक रीजन है। आप धरती पर बैठे हैं, है ना? धरती पे आपको येलोइश सा सन नजर आएगा, है ना? येलोइश सा सन वो इसलिए नजर आता है क्योंकि धरती पर जब आपके पास सन की लाइट पहुंचती है ना, तो उसमें से कुछ कुछ रंग जो है वो स्कैटर होके निकल जाते हैं। मैं आपको बताना चाहूंगा इसका मतलब क्या है। एटमॉस्फेयर है, एटमॉस्फेयर में बहुत सारे पार्टिकल हैं। सन की लाइट है, सन की लाइट में सारे तरह के रंग हैं। वो सारे तरह के रंग मिलके आपको सफेद कलर बनाएंगे, पर उनमें से अगर कुछ रंग निकाल दिए तो कलर कुछ अलग सा बन जाएगा। अब होता यूं है कि ब्लू कलर जो है वो सबसे ज्यादा स्कैटर करके बाहर निकल जाता है। ब्लू कलर स्कैटर करके बाहर थोड़ा सा निकल गया तो जो स्पेक्ट्रम है सन का वो येलोइश सा हो जाता है। ये आपको मैं दिखाई देता हूं। यहाँ पर स्पेक्ट्रम है, एक्स एक्सिस पर आपको वेवलेंथ दिखाई दे रही है। जैसे जैसे राइट साइड पे आप जाते जाएंगे तो वेवलेंथ लंबी होती जाएगी और इंफ्रारेड लाइट बनेगी, और बीच में आपको विजिबल नजर आ रहा है जो आपकी आंखें देख सकती हैं। हाँ, और जो सबसे इसके वाई एक्सिस पर है वो है इंटेंसिटी क्या है, उस वेवलेंथ के कोरेस्पॉन्डिंग, उस रंग के कोरेस्पॉन्डिंग कितनी ज्यादा मात्रा है सन की। तो अगर आप स्पेस में देखेंगे तो स्पेस में ये जो लाइन नजर आ रही है ना, जो ऑरेंज कलर से जो जिसको भर रखा है, जिस लाइन को, ये काले रंग की जो लाइन है, वहां पे आपको देखेंगे कि जो ब्लू से लेके रेड कलर तक ऑलमोस्ट सिमिलर सा मतलब आपको इंटेंसिटी देखने को मिलता है। तो इसलिए सारा इंटेंसिटी मिलके एक व्हाइट कलर सा दिखाई देता है। बट जब अगर आप नीचे वाले कर्व को देखेंगे तो नीचे वाले कर्व में आप देखते हैं कि जो एटमॉस्फेयर से लाइट आ रही है, नीचे वाला कर्व एटमॉस्फेयर के थ्रू है सन को देखने वाला, तो जो लेफ्ट साइड पर आप देखेंगे ब्लू लाइट थोड़ी सी कट गई है। तो ब्लू लाइट थोड़ी सी कट जाती है तो आपको सन का जो स्पेक्ट्रम है थोड़ा सा येलो साइड शिफ्ट हो जाता है। तो असली कलर जो सन का वो व्हाइट है। ओके, वेरी नाइस आंसर। तो इसका सबसे पहले आंसर दिया सुयोग जिंजुर्ते जी ने। सुयोग जिंजुर्ते जी
सेकंड टाइम
दूसरा आंसर सही देके 2 प्राइज जीत के हैं। अब हमारा जो साइंस एक्टिविटी सेंटर है आपको 2 तरह के प्राइज देगा। एक तो ये वाला आपको फिजेट स्पिनर वाला जनरेटर देगा, और दूसरा भी आपको कुछ प्राइज मिलेगा, वो आपके लिए सरप्राइज देगा। बिग राउंड ऑफ अप्लॉज फॉर सुयोग। सुयोग बहुत ही बढ़िया खेले हैं, बहुत ही बढ़िया खेले हैं। तो चलिए हम आगे बढ़ते हैं। सुयोग ओपी बढ़िया गेम खेलने के लिए आगे बढ़ते हैं। 5वां क्वेश्चन ये रहा आपकी स्क्रीन पर।
अंतरिक्ष में आकाश किस रंग का दिखाई देता है? What is the color of the sky when looked at from the space?
अंतरिक्ष में से आकाश किस रंग का दिखता है? पहले हमने सन पूछा था, अब
अभी
आकाश। आसमान किस रंग का दिखाई देता है?
पृथ्वीराज बोल रहे हैं ब्लू।
ओके, और आंसर देखते हैं क्या क्या लोग बोलते हैं।
शर्वानी बोल रहे हैं ऑरेंज।
ओके,
अंशिका वाइट,
दर्शन ब्लैक,
प्रथम ब्लैक,
वाओ, ऑडियंस मोस्टली ब्लैक बोल रही है। हाँ,
जिया सिंह ब्लू,
ब्लू ब्लैक, टीना ट्रांसपेरेंट, लीना ब्लू, साई ब्लैक, लर्न इजीली ब्लैक, किरण खुराना ब्लैक, संजीवनी कुलकर्णी ब्लैक, नूतन गंगोटे ब्लैक। बहुत अच्छा कंपटीशन यहाँ पर, ऑडियंस जो है ब्लैक की तरफ जा रही है।
कलरलेस भी बोला है शिशिर ने।
कलरलेस कैसे होगा? कलरलेस का मतलब क्या होगा? हमारे साथ 295 पार्टिसिपेंट्स जुड़ चुके हैं। लाइक का बटन दबा दीजिए जिन्होंने नहीं दबाया है। और हम ये भी बताना चाहेंगे कि हमारा इंडिया साइंस थिएटर का जो यूट्यूब चैनल है, वहां पर इस तरह की क्विज काफी रेगुलरली हम करते हैं। हर महीने एक क्विज कंपटीशन होता है इंडिया साइंस थिएटर के यूट्यूब चैनल पर। तो हमारे चैनल को भी आप सब्सक्राइब कीजिए। अगर आप सब्सक्राइब करेंगे तो आप हर महीने खेल पाएंगे इसी तरह से, और आपको कैश प्राइज भी दिया जाता है।
एग्जैक्टली, वो इम्पोर्टेंट है।
हर क्वेश्चन के लिए आपको 250 रुपया कैश प्राइज। इसी तरह से।
और मोस्टली हम लोग वीकेंड में ही रखते हैं, तो संडेज और सैटरडेज में।
मोस्टली संडे आजकल 9 बजे करते हैं, है ना?
हाँ, संडे रहता है,
या 8:30 या 9 ऐसा रहता है। आपको सूचना मिल जाया करेगी। हमारा फेसबुक ग्रुप जो है उसको ज्वाइन करेंगे, वहां भी आपको सूचना मिल जाएगी। तो अभी भी आंसर्स आते जा रहे हैं। सारा ब्लैक, पूर्वी ब्लू, मेघना ब्लू, माय क्रिएटिविटी ब्लू।
ये बहुत अच्छा आंसर है।
किसी ने ट्रांसपेरेंट लिखा है।
अभी सर ब्लू।
अभी ब्लू।
अभी ब्लू।
अभी तो ब्लू है। ये स्क्रीन पे हमने देख के नहीं बोला है, हमने बोला है कि स्पेस में अगर जाएंगे तो कितना नजर आएगा। एलॉन मस्क को पूछिए कि वो आपको स्पेस में भेजेगा तो आपको स्काई किस रंग का नजर आएगा। बड़ा महंगा सवाल है, स्पेस जाना पड़ेगा। चलो, इसके सही आंसर के लिए आगे बढ़ते हैं। सही आंसर सार्थक जी बताएंगे। ये रहा
सही आंसर है ब्लैक।
जी हाँ, सही आंसर ब्लैक। आपको राइट साइड पर इंटरनेशनल स्पेस स्टेशन से फिर वीडियो एक नजर आ रही है। वहां आप देखिए, आपको धरती तो ब्लू नजर आ रही है, बट आपको स्पेस ब्लैक नजर आ रही है। आसमान आपको काले रंग का नजर आ रहा है। अब आसमान काले रंग का क्यों नजर आता है? इसके पीछे भी वैसा ही रीजन है जैसे आपको जो सन था वो व्हाइट नजर आता है। अब मैं ये आपको बताता हूं बहुत ही क्विकली। एक्चुअली हमें, जब हम अर्थ पे बैठे हैं तो स्काई ब्लू नजर आता है। उसका एक बड़ा सिंपल सा रीजन है। मैंने आपको बताया था कि सन की जो ब्लू लाइट है वो स्कैटर हो जाती है। जब सन की लाइट एटमॉस्फेयर से पास करती है तो वो ब्लू लाइट स्कैटर हो जाती है। अब उससे क्या होगा कि जो सन की लाइट ऊपर आपके ऊपर से पास कर रही है, उसमें से ब्लू लाइट स्कैटर करके आपकी आंखों में आएगी, तो आपको स्काई जो है ब्लू रंग का नजर आएगा। तो स्कैटरिंग की वजह से स्काई ब्लू का नजर आता है। स्कैटरिंग कब होगी? जब एटमॉस्फेयर होगा। अब आप स्पेस में चले गए तो एटमॉस्फेयर है नहीं, स्कैटरिंग कहीं होगी नहीं, तो स्काई क्या नजर आएगा आपको? ब्लैक। तो इसका सबसे पहले आंसर दिया है दर्शन जी ने। दर्शन जी, बहुत बढ़िया आंसर, आपने फटाक से आंसर दिया था। आप सही आंसर देख के फिर से एक फिजेट स्पिनर बेस्ड इलेक्ट्रिसिटी जनरेशन जीती है। दर्शन के लिए बिग राउंड ऑफ अप्लॉज। बहुत बढ़िया खेल दर्शन जी। तो दर्शकों, दर्शन जी को भी बधाई दे दीजिए आप चैट में। चलिए हम चलते हैं 6th क्वेश्चन। हम क्विज कंपटीशन के आधे में पहुंच गए। 6th क्वेश्चन ये रहा आपकी स्क्रीन पर, हमें थोड़ा जल्दी करना पड़ेगा। हाँ, चलिए।
इनमें से कौन सा ग्रह सबसे छोटा है? बृहस्पति, अरुण, पृथ्वी या बुध? Which of these planets is the smallest? जुपिटर, यूरेनस, अर्थ और मर्क्यूरी?
सबसे छोटा प्लेनेट।
और इसके
रिया जबीन बोल रहे हैं, मेरा नाम भी ले लो। ले लिया रिया जबीन जी।
पृथ्वीराज ने बोला है
मर्क्यूरी।
ओके, बाकी भी
किसी ने बोला है अर्थ। अभिषेक कहते हैं अर्थ, अनुराधा कहती हैं अर्थ, किरण खुराना मार्स, दर्शन यूरेनस, विहान मर्क्यूरी, जमशेश्वर बुध, जिया सिंह मर्क्यूरी।
वेरी नाइस, वेरी नाइस।
बहुत सारे मर्क्यूरी।
जल्दी हमें आगे बढ़ना है, तो हम इसका आंसर अभी बता देंगे क्योंकि ये स्ट्रेट फॉरवर्ड क्वेश्चन है। इसमें कुछ बहुत ज्यादा डिस्कस करने की जरूरत नहीं। इसके सही आंसर के लिए दिल थाम लीजिए। सही आंसर गुरतिंदर कौर जी बताएंगी। ये रहा आपकी स्क्रीन पर।
इसका सही आंसर है मर्क्यूरी, जिसका डायमीटर एक्चुअली 1/3 ऑफ द अर्थ होता है अप्रोक्सीमेटली।
एग्जैक्टली। तो अर्थ का हमारा डायमीटर ऑलमोस्ट 12 से 13,000 किलोमीटर के बीच में है, कुछ 13,000 किलोमीटर है। और मरकरी का 4,879 किलोमीटर है जो इसका डायमीटर है। आपको राइट साइड पे मरकरी नजर भी आ रहा है घूमता हुआ। बहुत सुंदर प्लेनेट है पर बहुत छोटा प्लेनेट है। और इसका सबसे सही आंसर दिया था पृथ्वीराज जैन जी ने। पृथ्वीराज जैन जी, बहुत बहुत बधाई आपको। बिग राउंड ऑफ अप्लॉज फ्रॉम आवर टीम। ताली बजाने में हमारी टीम कसर नहीं छोड़ेगी, आप बस आंसर देते रहिए। बहुत बढ़िया खेल रहे हैं आप पृथ्वीराज जी। चलिए हम चलेंगे अगले क्वेश्चन की तरफ। अगले क्वेश्चन के लिए अपने कीबोर्ड के ऊपर नाखून अपने काट के घिसा के उंगलियां रेडी कर लीजिए। हम चलते हैं क्वेश्चन नंबर 7 ये रहा आपकी स्क्रीन पर।
आपके शरीर में से लगभग 100 खरब भूतिया कण हर सेकंड में गुजर रहे हैं। इन कणों को क्या कहते हैं? About 100 trillion of these ghost particles pass through your body every second. What are these particles called? देखते हैं आंसर्स क्या आ रहे हैं। घोस्ट क्वेश्चन, दिव्या ज्योति बोल रहे हैं घोस्ट क्वेश्चन।
ये भूतिया सवाल है।
भुर्गु बोल रहे हैं
न्यूट्रिनोज।
वेरी नाइस।
सेल्स पृथ्वीराज कहते हैं। सोल कह रहा है कोई, अंशिका, सोल आत्मा।
पार्टिकल है वो।
सेल्स, न्यूट्रिनोज, सोल्स कह रहे हैं संजीवनी। कार्तिक मर्क्यूरी, आयुषी सेल्स। गोट, व्हाई गोट? एमी एंड स्टेफनी शो न्यूट्रिनोज, जिया कह रही हैं। सुपरस्टार स्टडी रेडिएशन, पृथ्वीराज सेल्स। मैथ्स बाय मगलानी सर, सेल्स। चंद्रशेखर मोकल, सेल। सो न्यूट्रिनोज, इलेक्ट्रॉन्स, सेल्स। और
राम सेवक बोल रहे हैं हिग्स बोसन।
वाओ, बॉडी से निकल रहे थे।
अच्छा, बाय द वे मैं थोड़ा सा एक्सप्लेन करना चाहूंगा यहाँ पे। प्रथम पवार जी बोल रहे हैं कि लास्ट क्वेश्चन का आंसर मैंने दिया था। प्रथम जी देखिए, होता क्या है कि आप बहुत सारे लोग एक साथ खेल रहे हैं। जैसे ही आप क्वेश्चन का आंसर टाइप करते हैं, उसी टाइम पर विद इन फ्यू मिली सेकेंड, कुछ मिली सेकेंड में बहुत सारे लोग टाइप कर देते हैं और हमारे पास जिसका आंसर सबसे पहले पहुंचता है हम उसका नाम लिख देते हैं। अब पॉइंट ये है कि आपने अपना सेंड का बटन दबा दिया, वो आपको नजर आ जाएगा कि आपने सबसे पहले लिखा, पर आपसे पहले शायद कोई और सेंड का बटन दबा चुका होगा जिसका आंसर आपके पास या मेरे पास नहीं पहुंचा। तो जिसका क्वेश्चन आंसर सबसे पहले हमारे पास पहुंचेगा हम उसका नाम देंगे। तो ये इंटरनेट डिसाइड करता है। तो इसका
व्हाइट ब्लड सेल्स भी आ रहा है अभी एक जवाब।
किसी ने प्लेटलेट्स भी बोला है। वाओ।
अच्छा टीम, हमें थोड़ा जल्दी करना पड़ेगा, समय का भी थोड़ा अभाव है। तो चलते हैं अगले क्वेश्चन। इसके
आंसर पे चलते हैं।
हाँ, आंसर पे चलते हैं। इसका आंसर सही है, सार्थक जी बताएंगे।
न्यूट्रिनोज।
यस, न्यूट्रिनोज ऐसे पार्टिकल हैं जो जब न्यूक्लियर रिएक्शंस होते हैं, जैसे सन में हो रहे हैं, न्यूक्लियर फ्यूजन हो रही है, हाँ, एनर्जी बन रही है, तो न्यूट्रिनोज बहुत सारे निकलते हैं। और इनको घोस्ट पार्टिकल इसलिए बोला जाता है क्योंकि ये इनविजिबल है, ये आपके साथ इंटरेक्ट नहीं करते, और हर टाइम खरबों पार्टिकल्स आपके अंदर से निकल रहे हैं, 100 खरब पार्टिकल। इनफैक्ट न्यूट्रिनो ऐसा पार्टिकल है कि पूरी धरती को पार करके निकल जाता है, ऐसा पार्टिकल है। हाँ? निकलते जा रहे हैं, इसलिए इनको घोस्ट पार्टिकल बोलते हैं। तो सही जवाब है न्यूट्रिनोस। और सबसे पहले इसका सही आंसर दिया अभिषेक सरबू खान जी ने। अभिषेक जी आपको बहुत बहुत बधाई। अ बिग राउंड ऑफ अप्लॉज फॉर अभिषेक सरबू खान। यहाँ पर अभी किसी ने लिखा था वाह बेटे मौज कर दी, तो अभिषेक जी आपने मौज कर दी, बहुत अच्छा आंसर। चलिए हम चलते हैं आगे। क्वेश्चन नंबर 8 ये रहा आपकी स्क्रीन पर, दिव्या पढ़ेंगी।
पृथ्वी का केंद्र यानी कोर किससे बना है? द अर्थ सेंटर which is core is made of?
Yes, अर्थ का सेंटर किससे बना है? आपको राइट साइड पे अर्थ दिखाई भी दे रही है, उसके सेंटर में कुछ ऐसा होता है जिससे चुंबकीय चीजें अर्थ में, मतलब कि अर्थ एक चुंबक की तरह एक्ट करती है, पर अर्थ का सेंटर जो है वो एक सख्त चीज का बना है। तो ये आपने बताना है कौन सी
जी बोल रहे हैं आयरन।
कौन बोल रहे हैं?
प्रथम जी।
अरे वाह।
और पृथ्वीराज
मोस्टली आयरन। निफे कह रहे हैं कोई। प्रथम पवार कह रहे हैं NIFE निफे।
अनुप्रिया वर्मा ने कहा निकल एंड आयरन।
ओह वेरी नाइस,
ये पूरा प्रेशर।
अच्छे आंसर आ रहे हैं।
जी ने मैग्नेट्रॉन्स बोले।
किसी ने मैग्मा भी बोला।
अदिति दाले जी बोल रही है
निफे।
पृथ्वीराज ने बोला है बेडरॉक।
हाँ, मैत्री ने बोला हाइड्रोजन। अभी ने बोला आयरन लिक्विड। लावा लावा लावा।
तो ठीक है, हम इसके आंसर के लिए आगे जाएंगे। तो आंसर के लिए आगे बढ़ते हैं। दिव्या जी आंसर बताएंगी। सही जवाब है, तो
पृथ्वी का जो कोर है वो आयरन और निकल से बना है।
हाँ, और इसका सबसे पहले सही जवाब दिया था वो दिया अदिति धाले जी ने। अदिति धाले जी, मैंने नोटिस किया आपने बहुत फास्ट जवाब दिया था। आयरन निकल NIFE आपने लिखा था, बहुत फास्ट आपने सिंबल्स लिख दिए NIFE। दिस इज वेरी स्मार्ट बिकॉज़ दिस इज हाउ यू राइट एलिमेंट्स फास्टर। You have won this. Very nice. A big round of applause. फॉर अदिति धाले जी। अदिति जी को बधाई दे दीजिए, चैट अदिति जी को बधाई दीजिए। चलिए हम 9वें क्वेश्चन की तरफ जाते हैं। 9th क्वेश्चन ये रहा आपकी स्क्रीन पर, प्रीतम जी पढ़ेंगे।
अंतरराष्ट्रीय खगोलीय संघ आधिकारिक तौर पर सौरमंडल में कुछ बौने ग्रहों को मान्यता देता है, कितने? International Union Astronomical Union officially recognizes some dwarf planets in the solar system. How many?
जी हाँ, कितने प्लैनेट्स हैं जो ड्वार्फ प्लैनेट्स हैं? आपको सिर्फ नंबर बताना है।
2 आ गया है, 1 5
साई
2
बोल रहे हैं A1 5 2 1।
अभिरल 12, दामोदर 8, अंशिका 25, जिया 1, आयुष 5,
2 to 5
अंकिता 3।
ये बहुत अच्छा है, a lot।
गुड वन।
काफी है। इनको प्राइज भी, लॉट ऑफ प्राइज मिलेगा इनको।
साइंटिफिक नोटेशन में लिख दिया है 3E5।
वाह।
नॉट फाउंड।
इनफाइनाइट।
ओके, थोड़े मैं नाम ले देता हूँ। अभिनव गांधी 8, पवन कुमार 1, गुरफरमान कौर 5, नीता देशमुख कुड़े 8, विहान महेश पाटिल 5, आयुषी तनावड़े 2 to 5। वाह, इसके लिए आपको बहुत अच्छा हम शायद ही प्राइज देंगे, क्योंकि आपको भी क्लियर नहीं है कि प्राइज ये मिलना भी चाहिए आपको या नहीं। तो हम चलते हैं इसके सही जवाब की तरफ। प्रीतम जी इसका सही जवाब पढ़ेंगे।
सही जवाब है 5, और मैं वो 5 प्लैनेट्स का, ड्वार्फ प्लैनेट का नाम भी लेता हूँ। प्लूटो, एरिस, सेरेस, माके और हाउमिया।
या तो 5 प्लैनेट्स हैं जो ड्वार्फ प्लैनेट्स हैं। प्लूटो की तरह आपको राइट साइड पे प्लूटो नजर आ रहा है, और इसका सही जवाब दिया सबसे पहले शौविक दास जी ने। शौविक दास जी, आप बहुत ही उम्दा खेले, बहुत बहुत बधाई आपको। अ बिग राउंड ऑफ अप्लॉज फॉर शौविक दास। शौविक जी, आप अपना एड्रेस मुझे ईमेल कर दीजिए, आपको आपका फिजेट स्पिनर वाला प्राइस जो है ये आपको मिल जाएगा। चलिए हम चलते हैं अगले क्वेश्चन की तरफ। 10th क्वेश्चन, 3 क्वेश्चन बाकी हैं, क्विकली करेंगे। 10th क्वेश्चन ये रहा आपकी स्क्रीन पर। श्रद्धा,
पृथ्वी के भीतरी कोर का तापमान लगभग कितना है? व्हाट इज द अप्रोक्सीमेट टेम्परेचर ऑफ द इनर कोर ऑफ अर्थ?
अर्थ के कोर के अंदर कितना टेम्परेचर है, ये क्वेश्चन है। श्रेया लिख रही है मौज कर दी।
प्रतिभा जी बोल रहे हैं 100 सेल्सियस। सारा बोल रहे हैं 4।
माकी थोड़ा सा वो लग रहा है इनको, थोड़ा
फनी लग रहा है लोग। हाँ लोग लिख रहे हैं माकी।
आर्यन ने बोला है 47,000, प्रथम 65,000, सारा 6, जूई 80,
मनमोहन
5,000 केल्विन,
50,000 केल्विन मनमोहन कह रहे हैं।
तो आपको अप्रोक्सीमेटली बताना है, एग्जैक्ट नहीं हमें चाहिए। अप्रोक्सीमेटली बताइए, आपको प्राइस हम दे देंगे। तो जिसका पास हुआ अर्थ के सेंटर के जो टेम्परेचर उसके आसपास हुआ, 200-300 के मतलब केल्विन उसके आसपास हुआ, चलेगा।
लास्या ने 2 मिलियन बोले।
पढ़िए क्विकली नाम ले दीजिए जो भी।
समृद्धि 999 बोल रहे हैं। मनमोहन सिंह जी बोल रहे हैं 50,000 के एल्विन। आगरी बोल रहे हैं 0। रौनक बोल रहे हैं 1000। लीना बोल रहे हैं 5200। फिर सरवाणी बोल रहे हैं 1000 सेल्सियस। सारा मंत्री बोल रहे हैं 9।
बहुत अच्छा मुकाबला।
समृद्धि ने बोला सो मच।
या
किसी ने बोला बहुत है भाई, किसी ने ऐसे भी लिखा है।
हाँ, टेम्परेचर ओपी। ठीक है, तो आगे बढ़ते हैं। सही जवाब के लिए हम जाएंगे श्रद्धा के पास। सही जवाब
तो इसका करेक्ट
आंसर है 5200 डिग्री सेल्सियस। और इसका सबसे पहले सही जवाब दिया है प्रधन्या सरनीकार जी ने। प्रधन्या सरनीकार जी, बहुत बहुत बधाई, आपने इसका सही जवाब दिया। 5000 आपने लिखा था। अ बिग राउंड ऑफ अप्लॉज फॉर प्रधन्या। आप अपना मुझे एड्रेस ईमेल कर दीजिए और आपको आपका इलेक्ट्रिसिटी जनरेटर पहुंच जाएगा। चलेंगे आगे। क्वेश्चन नंबर 11 ये रहा आपकी स्क्रीन पर। 2 क्वेश्चन बाकी हैं, ये सेकंड लास्ट क्वेश्चन है। ध्यान दीजिए, 2 अभी भी आप प्राइजेस जीत सकते हैं। ये रहा 1919 में सूर्य ग्रहण के दौरान सूर्य के और प्रकाश के झुकाव को मापकर आइंस्टाइन की सापेक्षता के सामान्य सिद्धांत की पुष्टि करने वाला पहला खगोल शास्त्री कौन था? इंग्लिश में सुनिए. Which astronomer was the first to confirm Einstein's general theory of relativity by measuring the bending of light around sun during a solar eclipse in 1919? सोलर एक्लिप्स एक लगा था 1919 में. आइंस्टाइन की जनरल थ्योरी ऑफ रिलेटिविटी आई थी 1915-16 के आसपास. तो एक एस्ट्रोनॉमर ऐसे थे जिन्होंने सन के अराउंड एक स्टार की लाइट को बेंड होते देखा था. ये आइंस्टाइन की जनरल थ्योरी ऑफ रिलेटिविटी को वेरीफाई कर रहा था. तो इनका नाम बताइए.
अंजलि बोल रहे हैं, गैलीलियो वगैरह बोल रहे हैं, नील आर्मस्ट्रॉन्ग, आरकेजे बोल रहे हैं, आर्थर एडिंगटन, रौनक बोल रहे हैं यंग, पृथ्वीराज जैन बोल रहे हैं सर आर्थर एडिंगटन. वो काफी प्रिसाइज हो गए, सर लगा रहे हैं. शिवनाथ ढाके बोल रहे हैं मैं थी.
हाँ शिवनाथ जी आप ही थे. वो आपका पिछला जन्म. आप वेरी नाइस. आपको ऑलरेडी हम क्लैप कर देंगे.
तो और आयुष जी बोल रहे हैं नहीं पता.
न्यूटन जी तो.
और सबसे इंटरेस्टिंग आंसर यहाँ पे आ रहा है प्रीतम जी से, टोनी स्टार्क बोल रहे हैं.
ये तो ऑब्वियसली प्रीतम ओपी.
कोपरनिकस भी किसी ने लिखा, गैलीलियो ने बहुत सारे ने लिखा, स्टीफन हॉकिंस भी लिखा.
सुचित्रा जी बोल रहे हैं प्लीज एनीबॉडी प्लीज लिसन टू मी. सुचित्रा जी हमसे मैसेज पढ़ सकते हैं, सुन नहीं सकते आपको.
मांगी माय नियर थुर स्टेनली एडिंगटन, आर्थर एडिंगटन, सिमरन हॉकिंग, वेंकटेश आर्थर, अरुण कुमार आर्थर, विशाल गैलीलियो, गार्गी गैलीलियो. गैलीलियो बहुत आंसर आ रहा है. गैलीलियो तो बहुत पुरानी बात है, 17वीं शताब्दी में गैलीलियो हुए थे. आपको ये थोड़ा सा ध्यान देना होगा. ये 20वीं शताब्दी की बात चल रही है. चलिए हम
पुनर्जन्म था.
जैसे किसी का अभी जन्म हुआ है जो अभी बता रहे थे कि वो थी. तो हम चलते हैं इसके सही आंसर की तरफ. सही आंसर है इसका सर आर्थर एडिंगटन. और सर आर्थर एडिंगटन बहुत ही फेमस एस्ट्रोनॉमर जिन्होंने ये आइंस्टाइन की जनरल थ्योरी ऑफ रिलेटिविटी प्रूव की थी. इनफैक्ट 1919 का ये जो सोलर इक्लिप्स लगा था इसको देखने के लिए, क्योंकि लाइट आपने मेजर करनी थी स्टार की, मतलब पीछे वाले स्टार्स हैं वो कहाँ पे नजर आ रहे हैं, उससे आइंस्टाइन थ्योरी जनरल रिलेटिविटी थी जो वो प्रूव होनी थी. इसको देखने के लिए बहुत सारी टीमें दुनिया के जगह जगह पर गई थी जहां एक्लिप्स नजर आया था. इनफैक्ट इंडिया से भी एक टीम गई थी. तब ब्रिटिश राज था, पर ब्रिटिश ने एक इंडिया से भी टीम भेजी थी ऑस्ट्रेलिया में, वहां पर क्योंकि एक्लिप्स नजर आया था. तो बहुत बड़ा इवेंट था ये. और इसका सबसे पहले सही जवाब दिया है आरकेजे जी ने. आरकेजे जी आपको बहुत बहुत बधाई ये प्राइज जीतने के लिए. अ बिग राउंड ऑफ अप्लॉज फॉर यू. आप अपना एड्रेस और अपने चैनल का स्क्रीनशॉट जहां से आपने ये आंसर दिया है मेरे को ईमेल करेंगे, आपको आपका प्राइज पहुंच जाएगा. हम चलेंगे आज के आखिरी सवाल की तरफ. अंशिका जी बोल रहे हैं कितने डिफिकल्ट क्वेश्चन हैं. सी अंकिता जी आप अंशिका जी आप घबराइए मत. हमें आज का क्विज कंपटीशन में सीखना हमारा मेन पर्पस है. आप इससे कुछ सीख कर जाएंगे, हम बहुत खुश होंगे. हम चलते हैं अगले क्वेश्चन की तरफ. आखिरी क्वेश्चन गुरतिंदर.
सौरमंडल का सबसे गर्म ग्रह कौन सा है? Which is the hottest planet of the solar system?
शीतल बोल रही है कैन यू गिव क्वेश्चन फॉर 6th स्टैंडर्ड. शीतल जी ये 6th स्टैंडर्ड का ही क्वेश्चन है. सबसे गर्म प्लेनेट कौन सा है ये बताइए. आपको प्लेनेट के नाम
जी
तो
बोल रहे हैं वेनस. पृथ्वीराज जी बोल रहे हैं मर्क्यूरी. शीतल बोल रही हैं सर कैन यू गिव आंसर्स क्वेश्चंस. दर्शन जी वेनस. जिया बोल रहे हैं वेनस. जूई मार्स. विहान लिख रहे हैं वेनस. यश लिख रहे हैं जुपिटर. उर्वशी वेनस. सिमरन वेनस. संजीवनी वेनस. इनफाइनाइट वेनस. काफी लोग विनस लिख रहे हैं.
सचिन लिख रहे हैं सन.
सुभांगी लिख रहे हैं विनस. शावनिक मर्क्यूरी वेनस.
वीनस की तरफ है.
हाँ अच्छा. तो ये आज की शाम का आखिरी क्वेश्चन है और ये हमारा इनफैक्ट आईसर पुणे की तरफ से जो प्रोग्राम चल रहा है उसके भी ये आखिरी चैप्टर है प्रोग्राम का. तो हम अपने दर्शकों के साथ यहाँ पर 270 दर्शक अभी भी जुड़े हुए हैं. बहुत मजा आ रहा है. उम्मीद है सब बहुत एंजॉय कर रहे होंगे. अगर आप एंजॉय कर रहे हैं तो चैट में लिख के बताइए कि आप एंजॉय कर रहे हैं. एक इमोजी डालिए चैट में, जो आपकी फेवरेट इमोजी है वो आप चैट में डालिए और बताइए कि आप एंजॉय कर रहे हैं, तभी ताकि हमें पता चले कि हमारा आज का प्रोग्राम आपको अच्छा लग रहा है. तो 12वां क्वेश्चन, इसका सही जवाब के लिए हम चलते हैं गुरतिंदर जी के पास. सही जवाब
वीनस.
जी हाँ, सही जवाब है वीनस। तो सबसे पहले इसका आंसर दिया है अभिषेक सरपू खान जी ने। अभिषेक सरपू खान जी, आपको बहुत बहुत बधाई, आपने तीसरा क्वेश्चन का जवाब सही दिया सबसे पहले। तो अभिषेक जी तो ये सारा क्विज कंपटीशन ही
डोमिनेट कर गए
हैं, अपना बना लिए हैं अभिषेक जी ने एकदम। तो इसका हम आपको थोड़ा सा रीजन बताएंगे। इसका रीजन है ग्रीन हाउस इफेक्ट। हुआ ये था कि आज से कुछ आई डोंट नो 2 billion years before or something, lots of time, like many years before, ऐसा माना जाता है कि वीनस जो था ये ऐसा प्लेनेट था जिसके सतह के ऊपर नदियां तक बहती थी, उसका एक एटमॉस्फेयर था अपना। इसको अर्थ की सिस्टर भी बोला जाता है, इस पे शायद लाइफ भी हुआ करती थी, ऐसा भी माना जाता है। फिर हुआ यूं, सूर्य जैसे जैसे गर्म हुआ थोड़ा, क्योंकि सूर्य तब नया नया ही था, जब सूर्य गर्म हुआ थोड़ा तो उसने वो पानी को वेपराइज करना शुरू किया, वीनस के पानी को वेपराइज करना शुरू किया। तो पानी वेपर बना। पानी भी एक ग्रीन हाउस गैस है, तो वो अपने अंदर हीट संजो लेती है। ग्रीन हाउस गैस है तो वीनस का एटमॉस्फेयर गर्म होने लगा। दूसरा, वीनस की सतह पर बहुत सारी वोल्केनिक एक्टिविटी होने लगी उस टाइम पर। वोल्केनोस फटने लगे। वोल्केनोस फटने तो कार्बन डाइऑक्साइड निकली, बहुत सारी कार्बन डाइऑक्साइड निकली। तो कार्बन डाइऑक्साइड भी ग्रीन हाउस गैस है। ग्रीन हाउस गैस क्या करती है? गर्म करती है। ग्रीन हाउस गैस अपने अंदर सन की हीट को संजो लेती है और फिर छोड़ती है प्लेनेट के एटमॉस्फेयर में, तो गर्म करती है। तो वीनस का टेम्परेचर बहुत बढ़ गया, सारा का सारे समंदर वेपोराइज करके, जैसे वेपोराइज किए फिर से और ग्रीन हाउस इफेक्ट हुआ, क्योंकि पानी का वेपर भी ग्रीन हाउस है। ग्रीन हाउस इफेक्ट हुआ, टेम्परेचर और बढ़ता गया, वीनस एकदम फ्राई हो गया, एकदम रोस्ट हो गया, प्लेनेट कुक हो गया अच्छे से। इसलिए ग्रीन हाउस इफेक्ट की वजह से वीनस का टेम्परेचर सबसे ज्यादा है। आप देख रहे हैं यहाँ पर कुछ 470 डिग्री के आसपास वीनस का एवरेज टेम्परेचर है। उसके मुकाबले अर्थ का 15-16 डिग्री है। और अर्थ का अगर एवरेज टेम्परेचर बढ़ता जाएगा, जैसे अभी क्लाइमेट चेंज की वजह से बढ़ता जा रहा है, हमने कितनी सारी कार्बन डाइऑक्साइड और ग्रीन हाउस गैसेस अर्थ के एटमॉस्फेयर में छोड़ते जा रही हैं, ये बहुत हानिकारक चीज है। इसलिए क्लाइमेट चेंज की वजह से जो जो हो रहा है उसको हमें रोकना होगा। आप अपने आसपास क्लाइमेट चेंज की, ग्रीन हाउस इफेक्ट की ये सब बातें कीजिए, अपने दोस्तों के साथ भी कीजिए, अपने पेरेंट्स के साथ भी कीजिए कि जितनी कम ऊर्जा का हम इस्तेमाल करेंगे, हमारा अर्थ का प्लेनेट जो है उतना ज्यादा सर्वाइव करेगा। हम नहीं चाहते कि हमारा अर्थ जो है वीनस की तरह गर्म होके एकदम रोस्ट हो जाए, क्योंकि हम जिंदा नहीं रहेंगे धरती पर, कोई लाइफ नहीं बचेगी इसकी वजह से। आप ये सोचिए कि अगर 2 डिग्री अर्थ का टेम्परेचर औसतन बढ़ जाता है, अभी तो कुछ 1 डिग्री बढ़ा है, 2 या 2.5 डिग्री बढ़ जाता है, बहुत बड़े बड़े तूफान आएंगे अर्थ के ऊपर। अभी ऑलरेडी जगह जगह बहुत सारे तूफान आ रहे हैं, फ्लडिंग हो रही है जगह जगह। तो ये सब चीजें हमने रोकनी है। ग्रीन हाउस इफेक्ट बहुत ज्यादा नहीं होना चाहिए। ऑल्दो ग्रीन हाउस इफेक्ट यूजफुल भी है, क्योंकि अर्थ का टेम्परेचर अगर 15 डिग्री औसतन है तो ग्रीन हाउस इफेक्ट की वजह से है। अगर ना होता तो अर्थ का टेम्परेचर -15 या ऐसा कुछ होता, अर्थ बहुत ठंडी होती है। तो इसलिए बहुत बहुत शुक्रिया आपका। जिन जिन लोगों ने प्राइज जीते हैं उनके लिए कॉन्ग्रेचुलेशंस, ये आपके लिए इमोट रहा। और आप अपना एड्रेस जो है जिन्होंने प्राइज देते हैं ashish.arora@iiserpune.ac.in पर ईमेल कीजिए, और इंडिया साइंस थिएटर के चैनल को भी सब्सक्राइब कीजिए। आपको लिंक डिस्क्रिप्शन में मिल जाएगा, आप हमारे साथ वहां पर क्विज खेल सकते हैं। ओके, इंडिया साइंस थिएटर जो है हमारा ग्रुप है, ये क्विज हर महीने करवाता रहता है। तो आईसर पुणे की तरफ से हमारी टीम आपको बहुत बहुत बधाई देती है, जिन्होंने हमारे साथ क्विज भी खेली और जो हमारे साथ जुड़े भी रहे। आज का प्रोग्राम आपको सारा दिन, आज का प्रोग्राम चला है, सुबह से ही चल रहा है। हमारी टीम जो आईसर पुणे की है, बालन सेंटर की, बालन साइंस एक्टिविटी सेंटर की, बहुत मेहनत करती है सारा दिन। उन्होंने आपको आज कुछ कुछ प्रोग्राम दिखाते रहे। आईसर पुणे के बहुत सारे प्रोफेसर्स भी थे उनमें, जिन्होंने आपके साथ प्रोग्राम अपने शेयर किए, अपनी साइंस की एक्साइटमेंट शेयर की। हमें उम्मीद है कि आपको बहुत कुछ सीखने को भी मिला होगा। आईसर पुणे की फैमिली की तरफ से आपको बहुत बहुत शुभकामनाएं। नेशनल साइंस डे जो मनाया जा रहा है, सीवी रामन जी जो हमारे नोबेल लॉरिएट हुआ करते थे, जिन्होंने रामन रिसर्च इंस्टीट्यूट, इंडियन इंस्टीट्यूट ऑफ साइंस, बहुत सारी इंस्टीट्यूशंस भी बनाई, आज उनका रामन इफेक्ट जो है उसको सेलिब्रेट करने का दिन था। तो हम सब ने मिलकर साइंस डे बहुत ही अच्छे से मनाया और बहुत इंजॉय किया, काफी कुछ सीखने को मिला। चलिए, हमारी टीम की तरफ से बहुत बहुत शुभकामनाएं।
आशीष जी, एक चीज रौनक पूछ रहे हैं कि नेक्स्ट क्विज किस डेट को है?
नेक्स्ट क्विज हम जो है आपको अनाउंस करेंगे, हमारा इंडिया साइंस थिएटर चैनल है उसके ऊपर अनाउंस करेंगे, फेसबुक पर भी इंडिया साइंस थिएटर का ग्रुप है वहां भी अनाउंस करेंगे और चैनल पर भी अनाउंस करेंगे। आप हमारे चैनल को सब्सक्राइब कीजिए तो आपको इमीडिएटली वहां पर अनाउंसमेंट दिखाई दे जाएगी। चलिए ठीक है, चलते हैं फिर आज के शाम के लिए। बाय बाय,
क्विज बहुत ही ओपी रहा। बाय बाय।
बिल्कुल ओपी, क्विज ओपी।
I think